because of the water vapor.
Percentage, do you want to just respond to him, please?
Sorry, I wasn't listening. What's up?
I'll tell you what,
He's
dude.
like, I won. I'm sitting here having
I got
a cook. I don't care.
I got
I already made my point.
I tried to say it like a few times. I mean, and I think like, you know, Kosho understands it and stuff, but he's just like disagreeing because he just dug his heels in.
Yeah.
Let me ask you one last question. Percentage. Just, I mean, is it your contention that there's a consistent reverse in the pressure gradient? You know, over, I guess, that whatever waters, you know, ocean, whatever beach we're talking about, or part of the ocean, there's a consistent reversal in the pressure gradient. Is this your contention? If
by reversal of the pressure gradient you mean that there's,
I mean, a reversal as opposed to there's a general
yes
pattern, right? Yeah. And you're saying that there's a consistent reversal in these areas.
Always over the surface of the water, you have vapor causing less dense medium than the more dense medium above.
But that's not a measurement. That's just you insisting that it must change it. And
no, that's the only logical deduction you can make, given that vapor is less dense than air, and that we always have vapor.
And I'm saying that does have a slight change on like the overall pressure, but it's not going to reverse the density. And I just linked experiment. Hold on.
You mean that it's going to be less dense than the air above? It absolutely must, because vapor
is
less dense than the air.
It's not just the water vapor there. It's also the air, and the pressure gradient is measurable to be more dense the lower you are. And I just linked a experiment showing with the barometer, it measures the pressure, and the higher you go, the higher you go, the less density.
I agree.
Is it over water?
If you go closer down to the surface, you will see that the pressure will get less at some point.
And Godric, barometers work over water too. They tell you your altitude, and they still work over. Hold on. I'm not done. Godric. No, the experiment is not over water, but there's still.
That's the fallacious example.
No, hold on, Godric.
Only over the water.
Hey, Godric, don't overtalk him. Godric, don't overtalk him. Let him.
Godric,
let him respond.
If the whole basis of a barometer still works over water, which it does, that you have to show that it doesn't work whenever it works over water, and they use it in everything. Even like, go ahead.
Ollie,
what?
For an hour, you've been completely ignoring percentage. He's talking about evaporation over water, Polly, not over the ground. So no fallacious example.
No, because I'm saying, I just.
To be fair, Godric, there is evaporation over the ground as well. There's obviously a lot less, but I imagine there's still going to be this layer of less dense air above colder. It's just going to be a much smaller layer, and it might be hard.
So that's the first problem you have now.
No, that's not
my point. Beyond that,
I'm trying to explain to you that barometers still work over water.
You're making a positive claim that directly over the surface of the water, it's going to be more pressure than above, and I'm saying you're wrong. Like, that goes against the only logical deduction you can make given the premises that we have.
Hold on,
Paul, you have a fallacious example.
Godric, I already explained
only over the water, not over the land. You get this?
Godric, I just explained that to you.
Yeah, you're wrong.
You're insisting that.
I'm telling you, we need to check over the water where it's evaporating.
And I'm telling you again that when people use barometers, they can use them over water, and they still function the same way.
You did not do that. You did not.
I'm trying to find. Hold on, Godric. I'm trying to find measurements right now.
That's your first problem. Let me tell you my point. Let me tell you my point.
It's not a problem because you're misunderstanding what I'm saying.
It's a problem because you're not considering.
Godric, percentage is winning this argument until he finds his information that he's coming up with to make his point.
Well, listen,
he's not lying. He's just trying to find out something that makes sense.
Why isn't it up to you guys to find the data, dude?
Hang on. I really want to help Polly understand. Okay,
I understand just fine.
Completely ignoring the point. He's making salacious samples,
just let him make his point,
showing science tricks that will never happen in reality. He's showing barometer readings that are not over the water, and he's saying it works over water. But he can't.
Where's your pressure, dude?
Okay, let me give you my point.
No, dude. Where's your data, dude? You have no data over the water.
I don't have data. I'm using common sense. He's not addressing the issue.
I just explained that
is evaporation over water. He's not addressing that.
Okay, gotcha. Do you think that people using barometers would notice that it stops working over water?
Polly, you're completely ignoring my point.
Polly, let me ask you a quick question. Forgive me, Godric. But let's say you're boiling water, right? You're boiling water, and you have steam, you have vapor rising from that water. Is that right where that vapor is that going to be less or more pressure than the air above?
If it's enough to reverse the pressure gradient.
I didn't say anything about reversing. I'm just asking you, the air where that vapor is, where that vapor is rising. That steam,
I'd have to know.
You see it visibly rising. Is it less?
I'd have to know the exact difference in altitude and also the amount of humidity of that right above it.
You see it being buoyant. You see it rising, and you're saying you can't make a claim as to whether it's less or more dense or less or more pressure?
You'd have to measure it. That's what I'm saying.
I guess
he's afraid to admit
rest my case on that.
The globe is destroyed. Let me.
Patrick, you completely misunderstood my point. So you don't really have room to say anything.
You have no rebuttal.
How does this destroy the globe? What do you
have? Zero rebuttal.
I just told you. I gave you a rebuttal, which you completely ignored.
You just wait a second. Okay, wait, Godric, don't pile on right now. Listen, I just want to ask him one question. Okay, so is water vapor less dense than the air?
Is what water
vapor less dense than air?
Yes, it is, but it's not going. It needs to be significant enough to change the overall density, and that's what I'm saying.
If it was just very little water vapor, that little bit of water vapor would still be less dense than the air.
Say that one more time.
Even just a little bit of water vapor will still be less dense than the air.
Yeah, but that's not changing the overall pressure gradient, is what I'm saying. It's not enough.
Well, what's this pressure gradient caused by then? Because the density of the air layers
is caused by the air on top of it. So,
okay,
continue.
Okay, percentage, does that make sense to you?
Okay, I'm talking about if let's assume there's no the temperature is the same at all altitudes, and so is the humidity. There'd still be I'm not saying that is reality. I'm saying that there would still be a pressure because there's kind of like with water, like if pressure gradient with water, it's because you have all that water on top of you, and I'm saying that the overall pressure is going to be affected by those three factors: the humidity and the temperature, but as well as all the weight on top of you, and that would give you the overall pressure.
But right at the surface, that air is going to be more dense than the water vapor that's right at the surface to some degree always.
Wait, so
the water's always evaporating, so there's always going to be a little bit of water vapor in the air.
I know, I'm saying that
right at the bottom, right where we're talking about. So if there's just a little bit, why would we expect the opposite effect that light would behave like, rather than just a little bit less of the same upward bending of light that we would expect with less dense layers?
Can you rephrase that? Because
even if it was just a little bit, like 2%, 2% water vapor, it's still that 2% of water vapor right at the surface of the water is going to be less dense. And why would that be considered more dense, which would be the opposite effect on light? Couldn't consider it less dense and more dense at the same time. You see the contradiction?
No, that's not what I said. I said the overall density is going to be affected both by your altitude, the weight
So wait, you're saying the pressure gradient is making the water vapor more dense than the air?
No, I'm not saying that. I'm saying the average, like in it, because it's not just the water vapor in the air. I'm talking about like the overall pressure from the air will be changed.
We're talking about right at the surface, though. Right at the surface.
I know. I'm talking about this right at the surface. I'm saying the overall pressure.
Wait, how does this affect the ball model in such a harsh way? Why is it so important that this is more dense? Explain that to me, could you?
What do you mean?
It's not a debate about
I can explain that.
What does this mean? Why is it so important for you guys to have it?
Because they have to have the air bending downwards for
to
claim that it's
that's not
the curvature of the Earth
right.
that's causing this
Gotcha.
thing.
Yeah, that's kind of where we're at, right? So do you understand why we're suspecting that you're just being emphatic for maybe
nobody
no
was
reason,
even
but maybe you have a good reason. I don't know.
Like nobody was thinking.
I'm
disagreeing with it on the fact that I've never heard this to be observed. Yeah, that is a consistent pressure gradient that's in reverse in this area. I know that there's a lot of flux. That's why you don't take observations that are close to the water because of the refraction is can behave wildly here. But that doesn't mean that there's a consistent reversal in the pressure gradient at anywhere like that.
It has to be. It has to be because hot air expands and rises, and cooled air contracts and gets denser and sinks eventually. So, like that, you have to have this layer in which you have this vapor from evaporation turning into colder, more dense air.
I
don't know. It's not revolutionary. It's the water cycle.
The first chart I linked it below. It's for mariners specifically, so that would be in over water. It's from marine. It's from a book on marine weather. I don't know if I can download it or not.
I'm
just using that.
What, 3 weren't enough?
What?
Let me make my point for the Globers. Like, you guys are saying that refraction is causing light to bend up. Like in the example previous, the light's bending up 2,000 feet in the long distance example. So
no one's saying that. No one's saying that.
Beam, when you just show a laser actually bending up like
Christ,
that,
dude. Listen, Godric, you gotta stop yourself, dude. No one's saying that. No one's claiming that light's spinning upwards, and that's what we're expecting.
I am.
Yeah. He's claiming that's our argument, and we're not arguing that, dude.
That's the only way that you would get this refraction.
No, it bends downward, Godric, is how you would get the observation.
I'm sorry.
The fact that it bends upwards, you're right. It introduces reasonable doubt into their claim that it always bends downward, and that's how they could explain like the black swan and stuff like that.
No, nobody claims that it always bends downward. Nobody claims it.
Tosha, I said it wrong. The light's bending downward, which makes it look like it's flat 2,000 feet higher than it should be.
Well, I mean, the amount of feet is whatever, but yeah, refraction. In the case of the density being downward, or the density being lower and the pressure being lower, yeah, you'd expect the light to bend downwards, and it can do that. It can indeed do that, just like it can indeed bend upwards.
Can you show
wouldn't you agree that the less dense water vapor would make it bend upwards?
No, and that's not the only property. Like there's a lot of other factors. Like Paulie was saying, like the overall density is going to be much more. I mean, you're gonna have to determine if there's an overall effect there, because of course any given small amount of arbitrary volume of air, if it's water vapor, it's going to be less dense than some other arbitrary small value of air. But we're talking about the entire a visual corridor or something like that. You know what I mean?
Something like that, huh?
Yeah, we're not talking about the principle of these two densities and what happens in the case where they come into contact with each other. We're talking about the entirety of an environment at some local region, right?
No, we're talking about over water. Talking about over water. Kosho.
Yeah, exactly. So
where there's always evaporation.
Every time you ask that question, Paulie keeps saying, the overall density, meaning the entirety of this mixture, it would have to be described this way to do this like reversal or whatever.
Yeah, it sounds pretty important percentage that they convince themselves that light bends downward instead of upward, even though the less dense.
No one's saying it does this instead of this. I just told you it does. It can do both. I just said that.
Well, why would it do both if there's always just a little bit of water vapor there?
No one's saying there's only just a little bit of water vapor there, dude.
Well, if there's a little bit, it would still be less dense.
Listen, I am not at all committed to anything in this argument. It has nothing to do with the globe or whatsoever. I disagree that there's a consistent one-way direction, that it always goes upwards. But I have nothing. I don't want to invest into this argument anymore. I really don't.
No worries.
I understand why you wouldn't want to. That makes sense.
It's a silly argument. I mean,
well, you don't have anything to argue.
No,
you don't know what it is.
Right now, what's being suggested
you want Ruhif to come back in and argue
based on your idea of how it works. There's no evidence that there's this barometric pressure is measured this way.
We're just asking if you see the contradiction he's pointing out. Doesn't mean he's right or wrong. We're just seeing if you at least understand what his point is about the less.
I understand what his point. I understand what his point is, but again, I'm saying that the difference in humidity isn't going to affect the overall pressure enough to reverse it.
The humidity is just the point where it becomes, where it saturates and becomes dew point and stuff. Let me ask you the same question I asked him. When you have a pot of water on the stove.
Yeah, right. Yeah, I remember the question. Yeah, that question is not one that that can be answered just simply, right? There's a lot of factors.
You need to measure it.
Yeah, if you're boiling water, of course there's gonna be flux there, which you can see whenever you're observing it. And there's a lot of things going on there.
You're creating a lot more. You're causing a lot more. You're causing a whole lot more evaporation there than there is normally. For one, two, I need to see measurements of the overall pressure at different heights above this boiling water.
No, I'm asking Kosha right now because no offense, but you're a little out of touch with your.
No, but dude, but here's the complete answer.
Let me just expound on the question, or let me just expound on the commentary or the preamble or what have you. You have vapor, water that because of heat has evaporated, right? This vapor is hot. It has energy. It's buoyant, right? It's expanding. That entails a force upwards, right? Buoyancy. So how could you tell me that the pressure where that is going to be more or the same as the pressure a meter above?
What I'm telling to you is that your predictions on what's happening where is going to be worth dick when you actually realize that there's so much going on here that it's like a dynamic. This is it's a very messy dynamic medium. You could probably have a barometer and at some instances observe that there's a higher pressure in one exact location, and then the same location there's a lower pressure. You know what I mean? So I don't think that it's a fair question. There's an absolute rule that's happening.
For argument's sake, let's say that a meter above the vapor has dispersed and it's basically standard temperature and pressure, right? A meter above or a couple meters above. At where the pressure is, where the vapor is, would you agree that there's less pressure than standard temperature and pressure?
They're most likely in this column. If there was some column of very hot, dense air, then yeah, I would expect there to be. Well, that's what I'm saying. It's kind of difficult because I would expect it to be less dense. I would expect it to be less dense, but I would also expect it to be a higher pressure. So it's kind of it's a difficult assertion to make.
I guess.
You would agree that there would be an abnormal amount of pressure acting in this column of rising air, right? Even though there's more water vapor there, there's also more heated gas there, and there's also rising gas there, right?
That is the water vapor. You just said water vapor in two different ways.
No, there's water vapor there, but there's also the air is also heated, which is going to increase the pressure there.
But
you mean from the combustion of
that's what I'm saying. There's a lot going on that I don't think there's a simple answer.
Either way, that would all work to my favor. It's just more heat causing force upwards, causing buoyancy, causing less pressure.
I don't think that means less pressure. That's what I'm saying.
It does though.
Yeah, but it doesn't. If depending on what the temperature of that heat is in that column, there could absolutely be higher pressure. I mean,
no, but if pressure down is positive pressure, then pressure up is negative pressure. Just like you have acceleration viewing it from different, from your reference. It's negative 9.8 meters per second squared if it's going down, positive 9.8 meters per second if, something is shooting up in the air, like at the speed of gravity or whatever.
Yeah, but this is what I'm saying. Like, these principles that we're talking about is based on, hypothetical and whatever. When I think in practice, these numbers are going to overtake. I think at some points you're right. There would be a lower pressure, and at other points, that same column there'll be higher pressure. I think it's just it's not something that you can just pinpoint because there's a lot going on there. There's like it's a huge temperature differences between inside that heat column and outside of it. So it's not just the fact that there's water vapor there. I think there's a lot going on. So.
Okay, would you say the same if it was just on a hot day, evaporation?
Yeah,
like, you know how you can see the kind of distorted air because of a hot day and the evaporation.
We're not saying it's not going to be distorted. We're saying that it's not enough to make the density different at the make it lower density at lower altitude. And again, there's barometer readings at those lower altitudes or like only a few feet. I just linked an average from a site, and I also linked
what height?
There's a chart there.
Which one?
The first one, and it's David navigation. David I can't talk. David Birch navigation link.
And I just want to assert that just to be clear that I'm not stating that's something that can never happen or something like that, or that you would never observe that. Because obviously in a place where there's a lot of flux and a lot of different, properties of, that are varying and, for whatever degree, then yeah, you could have strange things where the densities are inverted in, specific areas briefly. What I'm saying is that the thing you're describing as being consistent and something that you could, consistently rely on, I don't think is the case at all. I think that it's, only in these places where there's a high flux of variables are you going to possibly sometimes get those results, but not on the regular.
No, it's going to.
I just looked this up. It says since water vapor is less dense than dry air, if both have the same temperature, the addition of water vapor decreases the overall density of the air and lowers its pressure.
But you would be able to measure that, is what I'm saying.
Well, yeah, but then because it rises up, and the air is drier above, then that's where they get the pressure gradient from. I think is that because it gets as it goes higher, it gets the air gets drier. So they're saying that pressure would even be less above, even higher up.
Pressure gradient is simply a product of the weight of the air above any given
or the density of the air.
It's the overall density, which is affected by the pressure and the humidity and the temperature.
But the pressure gradient's caused by the density. And if the density of the water vapor is less dense than the air, then it's lower pressure.
But the water, the reason why there's I'm not saying what gives you the value. I'm saying the reason why it exists in the first place is because there's weight of air above it. That's what gives it. That's what's giving it the pressure.
Yeah, but the weight of the air above it is determined by the condensation in the air.
No, it's dependent on the amount of air. Just like the ocean, it's like the pressure in the ocean is dependent on the amount of ocean above you.
Yeah, but it's not about the amount of air like as a layer on top of the where the water vapor is. The water vapor is making the air less dense. So right at the surface, the volume of the water, having it be such a massive volume of water, you'd think because it's always evaporating to some degree, there would always be a layer of less dense air at the surface.
The point is not that it doesn't affect the overall density. The point is that it is minor compared to the pressure from the weight of the atmosphere on top of it.
It couldn't even be there if it wasn't less dense than the air. And if it's less dense than the air, then the light bends upward.
What?
At the surface, the light would bend upward.
If the overall density was
but if there's always water vapor, to some degree, it's always going to be
it's not going to. It's going to be the overall density is affected by that, but also other factors.
Yo, Paulie,
right. So then you're saying that the water vapor at the surface then is going to be more dense because of the pressure gradient, which doesn't make any sense because water vapor is less dense by definition. That's the point.
I didn't say that. That wasn't the case.
Yo, Paulie, I'm looking at this graph. I'm not convinced they're measurements.
They're averages of measurements. There's
I'm not convinced.
I mean, you could if you want to go measure
satiation for that.
I'm trying to find a different one because the book that it's from I don't want to have to buy, so I don't have a hard copy of that.
I appreciate that you're pulling it up, but that's what I'm saying is, we're going back and forth about this, and you guys are making these claims, but you guys haven't provided any data for it.
We're just talking common sense.
Providing the logical argument based on the premises that we've agreed on.
No, we didn't agree.
We didn't agree on because you were saying
that vapor is less dense than air.
Yes.
Yes, but that doesn't. We didn't agree on how it overall affects the overall.
Is there ever a time where there would be no water vapor?
What is
I'm
that?
not saying that. I didn't say that.
So there would always be water vapor, right?
I'm reading this thing about the air, the moisture in the air, and all that kind of stuff. There's a lot of variables that go into and a lot of different properties too. So it's not just a simple effect. It's not a simple fact that there's just happens to be water vapor there at any amount of it. It doesn't matter what amount of it, but there's water vapor there, so that means that this thing's going to occur. There's a lot of factors that go into
the overall density. The overall pressure is what I'm talking about. Would need to be reversed than what is measurably. Because if this density, this reverse of the density, like percentage was saying, is true, then barometers should not work whatsoever over water.
They would still work. They just wouldn't give you the readings you need.
They would work in the sense of measuring the density, but they would not give the measurements to determine your altitude correctly. It should be all over the place. Or, well, it should be the reverse, but that's not... I mean, I'm sure... what's the word? The readings, like how it gives you your elevation would be wrong constantly, is what I'm saying.
Yeah, most altimeters are strictly just barometers, you know.
That's what I'm saying is that if the pressure gradient was in reverse, then you should be able to see that the altimeter doesn't work over water.
You wouldn't be able to rely on things like that.
And planes use that altimeters to give them their elevation. I don't know if how low you'd have to be for it to sort.
I have a question for you guys. If light was bending down, right, because of the pressure over this supposed curve,
yes,
wouldn't we see it all distorted? Because it's bent, but it's a bent beam. No, if it comes back to our eyes,
that's not a strict rule or whatever.
Or how would we see it? Actually,
the light could be bending and still be you'd still be able to There's no rule that says it has to be it's harder to see or something like that, or distorted.
Because the distortion is more of the unevenness of the air, if that makes sense. The uneven. What's the word?
Are you guys equating this to like
I can't even think of simple
if
words.
I put a mirror, like you know how you can see around the wall. If you put like a couple mirrors up, you can see like put a couple mirrors, you can see around the wall.
Sure.
Is that how you're saying that the light's bending around the curve? Is that what you're saying?
No,
like mirrors,
I mean
looking through mirrors.
It's not a mirror. It's just slightly bending the light, and it only works to an extent. And it also depends on.
I'm saying I'm making an example. Like, are you saying that you can see around the wall? Let's say you want to see around the wall, so you put mirrors there. The light's bending, correct? This is exactly the same thing that's happening with your medium.
That would be
that's
a direct
going around the sphere.
bending, right? But sort of, yes, sort of.
So is that what you're saying? You're saying it's bending down, and then because
curving.
it's bending down, we're seeing the ground on the other side of the globe. Is that what you're saying?
We're seeing it slightly at
a slight angle. Yeah, Paul, you made a good point.
Angle.
Made a good point earlier when he corrected that somebody was expressing it as a distance or height or something, and when it expresses an angle, it makes a lot more sense because it's a very small angle.
Yeah, because if you map out the difference in like a 2 scale, it is very minor.
When you say very minor, what do you mean?
Like in terms of the overall angle, it would need to slightly bend. It would be extremely small. It's less than a degree.
Right. So like, we don't have to belay this, right? But that's a good way of saying I want to cover it up. How much is bending?
No, that's not. That's not covering up anything. That's just how stuff works. We are going over the very specific details of how light works.
In the previous example, your light would have to bend up 2,000 feet over several miles.
Do you not understand that is the overall angle that matters?
Instead of saying it's going to bend 2,000 feet, let's just use the degrees. That way you can't tell. You see?
No, because the degrees is how much. No, I'm telling you that you measuring it in feet and going, well, it's this amount of feet, so that's impossible, is not the logical way of saying that is or is not possible.
It's exactly the same.
No, dude.
That's not equivalent.
It's exactly the same.
Take the Sears Tower in Chicago.
No, because the overall angle is what matters. It's not about the feet. It's about the overall angle because that's how.
Same measurement. You're just going in feet.
No, Godric. I'm saying so. Like, sorry, how do I illustrate this?
What does Kosha want to say about the Sears Tower? Go ahead, Kosha. Just hold that thought. What do you want to say about the Sears Tower, Kosha?
I posted this picture so I can describe it in this, but it doesn't matter. Imagine this green thing is this green light is the top point of the highest building in Chicago or something like that. And normally it would be hidden by this brick, which we'll say is the curve of the earth or something like that. Okay. All that has to happen is the light that is going up anyways. All it has to do is some of that light has to be bent at a small degree back downwards, a lot smaller than this angle, because the distance is pretty far. So if that angle is 1 degree, which is a very small angle, which is it's not
less than a degree
possible to imagine the fraction can do that. Then you can expect to see something that's that far away and that tall.
And also, again, with a gradient, the bending of light is a it's the overall angle is based on the distance rather than just a set angle no matter the distance because it's constantly refracting.
Kosho, your picture here with the green light is good because it shows my example. Remember I said mirrors? So like you see we have the eyeball?
There's no mirrors here though.
Listen. You see we have the eyeball?
Yeah.
And you have a green line going on. So all you would need is a mirror, right? Yeah. Right on top of that red brick wall. And then the light can bounce off the mirror and then come
Believe it
back
or not,
to your target.
I didn't draw that green line. So that green thing on the left, I drew that as a whole bunch of light. But that green light that's going into the eye, I did not draw that. That's the real refraction happening in this picture. I drew that brick because the light is, and if there was a brick there, it would still be doing exactly this. The eye would be on one side of it, the source would be on the other side, and the refraction is allowing it to curve back down over the obstruction and be able to be seen.
You didn't care for my mirror example?
Yeah, but the mirror is not necessary.
Well, that's what's happening here. So the light's bending through the air, right?
It's not reflecting. Yeah.
Isn't it the same kind of idea?
It's a similar idea, but it's not. They're not the same.
Because if it wasn't reflecting through the air, then how can you see it?
Oh, it's bending. It's bending as it's moving through the air, but it's not the same thing. It's just two different properties.
That was my other idea. If it was really bending, it would be distorted by the time I got to your eyes. It'd be very distorted.
Well, the thing is, it's not. Well, I mean, it's not. What's the word? Precisely even. But when you look, hold on. When you look, when refraction happens, you can still get a clear image, even if it's bending or refracting, as if it's even. Does that make sense to you? Like if the refraction is the same for every point of light, then you're still gonna get a clear image. The distortion is caused by wind movements and the variations in each altitude. If that makes sense.
You're saying wind causes refraction?
No, I'm saying the difference, like the mixture of the air, because it's we're talking about averages here. Like in each specific point, the difference in those specific points is what would be caused distortion. If it was a flat, even density gradient, then you would still get a clear image. The distortion is not caused by the refraction itself, but more of the variations in the air and the variations in the refraction indexes depending on where the light travels.
This is why I keep on bringing up the flux, is because in these situations, in these environments, you're experiencing a lot of that. You're experiencing a lot of turbulence and exchanging of where the gases are, and what's heated and what's not and stuff like that. So it's a very dynamic fluctuating environment. So
one second, Paul. Kosher is this picture from a real example, or is this like
I just told you that. I just told you that, dude.
You said the Sears Towers?
No,
I'm looking at a cartoon, so that's what I'm asking.
Dude,
it's just an illustration.
No. That's what I'm saying is I illustrated something over a real observation. That green laser on the right side of the picture, the one going into the eyeball, that's a real light. That's a real light. I did not.
And tell me the setup. This is where in a lab.
What I did was there was a source of light, and there was a path of light, and all I did was over the source of light I drew a light so that you can see that if it was going in all directions, like a source of light or something like that, okay, or like an object, because an object is going to reflect light in all directions, or whatever. So that's all I did was put that where the source is, and all I did was there really is a curved or a bent path from it goes up and then it goes down into the thing. I just drew an eye there and an obstruction.
Yeah, this is a good idea, but how do you know that's really happening?
Because what are you talking about? I saw I've seen this from a video, first of all, and I told you I drew.
Can you just show the original photo so that he can understand?
Yeah.
Are you saying that you can see over a wall?
Yes. Whenever refraction happens, this is why.
What was the object you're looking at?
The source of light, like let's say it's a laser or something like that. This is an example. In reality,
because
that source could be in any object that's reflecting light.
It's not the laser you want to look at. It's an actual object.
I just addressed it. Hold on, man.
the laser is illustrating the light path. So if you were to look at the end of the laser, you'd be looking at where
you can look into a kaleidoscope, right? You know what a kaleidoscope is?
Gotcha. That's not the point at all.
No, I know
what a
that's my point.
kaleidoscope is.
What is a kaleidoscope?
It's usually a bunch of.
It's a telescope that somebody put fucking dumb shit in, with confetti in or something.
I just want to see the.
It depends on the kaleidoscope because they make them different ways.
I want to see the object you saw over the wall just to see what you were looking at.
I mean, Godric, I've shown you. I mean, Kickin' Chicken before has shown you someone pour, I think it was butane, over a pipe, and then they could see the red from an object.
And you know how I debunked them, right? You heard the debate.
I was there. That was the debate you had, and your argument was that it's not atmosphere. It's not the atmosphere, but that is not the point because it's not about what the chemical composition is. It's about the density.
Butane does not happen naturally in observation, so that would never happen.
Godric. The whole point of the experiment is that more dense, gradient pressure with low density at a higher altitude and a higher density at a lower altitude would bend light like that.
If you agree with that.
Hold on. It's not about the chemical composition. It's about the overall density of that, whatever chemical it is. Because
you agree that
it's always about
density,
it's not about
the observation. You have
no,
to
I'm not.
It's a fallacious example.
No, it's not a fallacious example because it's illustrating the density difference. You're not able to disconnect the chemical from the density, and that's your issue right there.
So just so you're clear, so we did a little debate, and Kick Chicken showed butane poured over an observation makes the light. You can see it, move over an object.
I've seen this. Yes.
And I'm saying, listen, that's just a great science trick, but butane's not happening in reality.
And again,
you can't use that.
Again, hold on, Godric.
My point is that will never happen in your life.
And your point is invalid because the refraction is not dependent on the chemical composition. It is dependent on the density.
It's dependent on the chemical composition in your observation. In your science trick, it is.
No, it isn't because it's always based on the density.
It wouldn't bend without it. So yes, it is dependent on that.
Godric.
And
Godric.
Butane. I mean, why don't you take a real life example? Like this is like common sense, man.
Oh my goodness,
if I blew a flame torch in between your observation, that would cause refraction. I wouldn't do that. That's interfering with a natural.
Also,
what you want to do, probably, is take a natural observation.
Really quick,
no science tricks.
Godric, again, it's about the density. Refraction is dependent on density, not the chemical composition.
That would never happen in your life. Okay, go.
Godric, really quick, Kosho, or
yes.
I don't know how you pronounce your name. I'm sorry.
That's fine. There's a different name in there now, but Kosho.
Okay, Kosho. I'm working on 2-scale diagram of the Chicago skyline thing. The whole this is a completely different topic, but I've noticed whenever someone tries to calculate curvature is the 8 inches per mile squared is not what they think it is.
Yes.
Is the miles is not of your horizontal, because that is what it is. It's put off your horizontal, the 8 inches. The horizontal is not the same distance as the ground beneath it. It's the ground beneath it's going to be a larger distance. And what am I trying to say here? Let me pull up a diagram of what I mean.
No, I totally understand. Yeah.
So it curves actually more than you say. So now you have more proof.
Hold on,
no, Godric, that's not what I'm saying. Here, let me put it in the chat so I can explain to you, Godric. Okay, Godric, look at the diagram. So you see the 1 mile tangent part?
Okay, I'm looking. When you say drop, do you mean?
Okay, so see where it says
line? Yeah.
See that where it says 1 mile tangent, right?
Mm-hmm.
So the 8 inches per square, 8 inches per mile squared is that 1 mile tangent to that green dot. You see that green dot? Yes, that's how the math is formed. That's if you've ever seen the diagram. That is what the 8 inches per mile squared is. It's calculating the drop for your horizontal straight down.
That's right.
No, it's not.
Yeah, that's your insistence. If you want to say
It's
otherwise,
that line on the bottom, that black line.
What?
No, that's not what it is.
It's occlusion.
No,
it's occlusion.
That's
What's
not.
in your way? It's occlusion between point A and point B.
No, that's not what that is. That is obstruction. No, no, Godric. When you calculate 8 inches drop per mile squared, that is the 1 mile tangent down.
What you're measuring is the difference between flat to sphere, right?
I'm explaining
that's
to
not
you.
the measurement.
I'm explaining to you the 8 inches per mile squared is not what you think it is.
It's almost never used correctly.
But you're saying it's the distance between straight and sphere. That's what you're saying.
Oh,
no, that's not what I'm saying.
Real quick, Paulie, another way, because what you said is correct, and another way that I don't know, people, I usually express it also, is like if you want to use that equation from your observation, then ultimately you want to
figure out
start doing it from the horizon, basically, because that's where the tangent, that's where you're like, basically you're going to be, if you're looking at the horizon, you're going to be making that tangent. And so if you do it that way, then you can describe that 8 inches per mile squared is describing what's beyond the horizon, what the drop. And so it's like people describe it as a hidden or something like that. So you have to start the calculation from where the horizon starts, though. Just another way.
People have tried to interpret the measurement different ways.
No, Godric.
And it ends up being they need to account for more curvature, not less.
No, Godric. Look at this last diagram I just sent now. The 8 inches per mile squared.
I'm looking for my diagram. Hang on.
What I just showed, the next diagram I just showed is demonstrating what it means by inches per mile squared. Is not talking about the ground, the distance on the ground. It's talking about the distance of your horizontal, your horizontal, from your horizontal. So when you say usually when I see the wrong calculations, they usually use 8 inches per mile squared as obstruction, or they'll use it as if the distance from you to the object is the 1 mile. But that is not how that works, is my point. And so that diagram of the Chicago city skyline is sort of wrong because it's giving you the 60 miles as if it's your horizontal when it should be the actual ground.
I'm going back into the Discord now to see what you posted.
I posted
what's your point?
So the 8 inches per mile squared is from the drop from your horizontal. Like if you were to imagine a line out of your horizontal.
That's what I said. The distance between flat to sphere. The difference between.
Yeah, but you pointed out you're talking about the wrong line. In the diagram that I showed, here, let me just open the diagram and edit so I can point out what I'm talking about.
Okay, but isn't that, let's say we're gonna go to the diagram you put, and let's say did you see what's this 542 at 2000, which is at 230.
Say that again.
Let me see, 1, 2, 3, 4, 5, 6. At 4 o'clock, it says 542 miles.
So the distance right there, you see the 2000.
Yeah.
So that's the distance from you outwards, like how long of I don't know how to word this. But
isn't
how
all of
long?
that occluded, right? If it was a sphere, isn't
What do you
all
mean?
that area occluded?
Occluded? What do you mean?
Well, you can't see it if it's a sphere, right?
I'm saying that
it'd be behind the curve of the Earth, effectively, right?
sort of, but that's not the actual how you would determine obstruction. Is what I'm saying, and that's also not what's the word? So like
So let me put
going
another
back,
way.
going back.
1 second. 1 second. Let me see this. Let's put a building, right? So let's look at where it says miles and thousands, where you posted your thing. Probably it says imaginary ball Earth, right? So the first triangle it says 542 miles, right?
Right.
So if you had a building right on that first line of the triangle, above
But
it says L. Hang on.
Good.
Above it says L2000, right?
Right.
So you put a building up on there. That building would have to be, let me just look, 542 miles. Let me just correct me if I'm wrong. It would have to be 31 miles high to see it, because that would make it hit that straight line if it was 31 miles high. And it was not that high. It's occluded from because it's behind the curve of the Earth.
I'm confused as to what you're trying to say here, because that isn't.
I'm just showing you that this is correct. That's all.
Hold on.
Let me hear your presentation. Go ahead. You're saying this is not correct. Okay, so start from the beginning.
1 second.
I just showed you that building would have to be that much taller to see it, and since we don't see it, it's
No,
behind
because
the curve of
when
the
you
Earth according
calculate
to these
obstruction,
measurements.
you're not you don't. It's not the drop that is the obstruction.
I think I know what you're saying. You have a diagram up here, and it has the line that says 1 mile distance, right? That could be also known as a dip, right?
Yeah. The 1
So
mile.
let me tell you what's wrong with that. Okay, can I tell you what's wrong with that?
What?
So you can't go by that, because what that's saying is there's less dip. Do you see where it says, when you say drop, do you mean? Okay, now you have 1 mile tangent on the top, and then you have just go straight across. You have this. You have a green ball, right?
Right.
So go down. So go back where it says this question mark on the tangent. Go down to the Earth, and then you have another. Hang on. You have another, or this, another green ball, or this, that other green ball. The problem with this is you're saying there's less curve on the second or this than on the first or this. That's your problem, because you have a mile distance in the middle, but no distance on the right side of it. So that's where you're gonna run into problems. So you do have to go by the top measurement, not the bottom measurement.
The top.
Which is a tangent.
I'm saying that the 8 inches per squat meter. Sorry, excuse me. I'm really tired and I stumble over words sometimes. I'm saying the 8 inches per mile squared is referencing to the 1 mile tangent. That is all I'm saying. And look at the diagram.
Yes. Yes, it is.
Okay.
Yes, it is.
Yeah, I know. I'm saying that that's what the 8 inches per mile squared is. Now look at the diagram of Lake Michigan. When you say that
Lake Michigan. Okay, go ahead.
When you say there's 60 miles in between you, the camera, and the Chicago city skyline, you're referencing to the surface, not to the horizontal. And so I'm saying
I'm looking at what? 1 second. Let me look at this diagram above. You have 60 observer, good. 60 miles across, good.
But that's
I have Chicago skyline, good. So what's the question?
No, my point is, if you look at, I drew over the diagram, the 60 miles is the wrong measurement, because the 60 miles is referencing to the distance on the surface, not to the distance on the horizontal. Is all my point is that calculation is a little bit wrong.
I see 2,166 feet. Okay, at 60 miles.
I'm saying that.
Let me check that with the Glober's calculator. Hang on a second. Let me check this. If it's going to be 6 feet, I'm testing your measurements here. Hang on 1 second. Let me plug it in. Okay, area code calculator. 6 feet observer height. 6 feet observer height. Hang on. There's a math behind this. And we're going to go 60 miles. 60 miles. It's correct. 2,166 feet.
I'm saying. Hold on.
And if the buildings weren't that tall, you couldn't see them. That's what we're saying.
Hold on.
Now,
give me a second here.
Now, I think for your benefit,
you're using.
Skyline was taking about 200 feet of height, I think, but still, it would be okay to go. Go ahead.
Hold on here. I'm looking at something.
The other guy which was trying to talk. Sorry, I just wanted to get that out. You can say something. Go ahead.
No, what I'm saying is that if the distance to the object is 60 miles, the actual horizontal line is going to be slightly different in how many miles it should be.
Are you trying to say the bottom line is really the dip and not the top line? Is that what you're trying to say?
No, look at my correction to the diagram again. The 60 miles
you corrected it?
I crossed out. I just drew over it really quick to simplify what I'm saying here. If you look at the most recent one, the 60 miles is from you to the target.
In blue, 60 miles in blue.
Yes, because it's 60 miles on the surface, not above the surface. Does that make sense to you? So in actuality, the top measurement should be less than 60 miles because the actual distance is going to be greater. And I'm going to illustrate that in just a second. I'm inputting the distances to scale, and then I'm going to...
No, because it's really 60 miles away.
No, the 60 miles away is from you to that point. It is not 60 miles on the horizontal. So the 60 miles is the surface distance, not the horizontal distance. Does that make sense to you?
I think I see what you're saying.
Yes.
You're saying it's curving over a sphere 60 miles away and not going into the sky.
Yes, because the above measurement would be the horizontal, like the drop from your horizontal. That 8 inches per mile squared would not be applying to 60 miles. It would be slightly less than 60 miles. I'm going to try to figure out that exact.
Probably it would be more.
No, because there would be less. Because there would be a less. Like with the illustration I showed with the what do you mean by drop?
Probably it would be more.
No, gotcha. Look, the 1 mile distance. What?
This has been done. It would be more.
No,
because look, you're going from the tangent across like you would do in the sextant, to the horizon, just straight across into the air. I'm glad we did that because now this is the same thing here, and it's a measurement going into the air, right? So you're going to go out.
I'm saying
miles,
that
right?
that is what they.
But if you brought that down to the earth, right? The reason why it's more is because now you have a hump to deal with. Because that hump is curving, it's going to cause more distance in this line. A straight line would
no, the 1 mile.
Hang on, Polly. Just let me finish my point. A straight line through the earth is going to get to your city. But here's the problem: we can't tunnel through the earth, Polly. You know this. So we have to travel around the sphere. So as you know in pi, hang on. As you know in pi and geometry, it takes longer to go around the sphere than it does to go straight through. Okay. So it's actually longer than 60 miles if you count you're going around the sphere.
I know what you're saying, and I'm saying that the surface of the distance would be the surface measurement, not the straight line through the Earth. See the blue line I drew over the curve? That would be the 60 miles, is what I'm saying.
Yes.
Does that make sense to you?
Yes.
Okay. So when you calculate the horizontal distance you need to do for the drop, it would be slightly less than 60 miles. I'm not saying it's a huge difference, but it's still a slight difference that you need to be wary about.
I don't see how you don't see it more.
Look at the green diagram again.
First of all, let's confirm.
Hold on.
Before we go on, let's confirm. 60 miles is 60 miles. Okay, period. Okay?
I know.
That's just a fact. Well, hang on. That's just a fact, right? Agreed?
Yeah.
Okay, now, so the actual distance is the same. Let's agree on that. What we're questioning is if we're measuring it right with the global calculator. That's the question. And according to the diagram, you do appear to be correct. It looks like the diagram is going straight out, measuring as if it was in the air. Right?
I know, and I'm saying that
hang on. But we know that the building's not in the air; it's down below, right? And if you move that bar, if you move that bar to the ground, it's not going to make it to the other city. Probably, it won't reach. That's why it's actually farther than the measurement we have.
What?
So you have to account for more curvature, not less. That's what I'm saying.
Go over that one more time. Because
I get your point. We could be wrong with this measurement.
Okay,
right?
let's look at.
Hang on. Let me finish this. It's I want you to hear this.
Okay, sure.
Just open your mind for a second. Okay, I get your point. We may be wrong with this measurement because we're going out into the sky. We know the distant city is Chicago. It's not in the sky. It's on the ground. Okay,
right.
So we're measuring. Probably here's the magic of what I'm saying. We're measuring as if it was right across in the sky, Polly. And all this would be behind the curve of the Earth. You would agree so far, okay? So here's the thing. Because the Earth is curving, okay, it'd be more distant because if you bring this 60 mile, if you put it down on the Earth, it won't make it because now it has to account for a curve when in reality this measurement we have, which may be incorrect, is straight. So because it's straight, it's not going to make it to the city because it's going to be stuck on this ball. It has to go around the ball now. So if you take this 60 mile, let's say it's an inch in reality, right? And my phone it's about an inch, 2 inches. If we move that line directly through the Earth, that would be the exact distance, 60 miles. But it has to go through the Earth.
No,
that's how you get to Chicago.
That's where
and that's
your
why
confusion.
It's actually
that's where I think
more
you're
distant, not less. Okay, now I'm done. Go.
No, the 60 miles is on the surface. Is not the lines.
It's on the surface in reality. It's on the surface.
I know,
reality.
and I'm saying the 60 miles is
in this
the curve.
The 60 miles in the sky. We have to bring that down to Earth. When we do that, it can't reach. Probably, it won't reach.
No, that's not what I'm saying at all.
I'm saying if we bring this measurement that's in the sky to the ground, it will not reach Chicago. You're gonna fall short.
Gotcha. Again, I'm telling you that the 60 miles is following the ground, is not the straight line in between the two targets. It's following the ground measurement because that is what you measure distance with on the ground.
Polly, that's correct in reality. But
I know. I'm saying so.
You may have made a point. Global calculator is not measuring on the ground; it's measuring in the sky. Yes or no?
Yes, it's using the ground, but that's why I'm saying that the disconnect.
You made a point. This global calculator is not measuring on the ground. It's measuring in the sky, Paulie. You have to agree. Okay.
I know, and I'm saying so you need to convert the 60 miles to the
and bring it.
distance.
Just do this in your mind. You can do it like a ruler or a piece of pencil or something. Bring that bar down to the ground, okay? And you're gonna fall short of Chicago.
I know, and I'm saying that the curve right there is the actual 60 miles, not the distance above it. And really quick, let's go back to the green Earth diagram. The 1 mile distance is following the curve, and then the 1 mile tangent is going overshooting. Does that make sense?
Before I get into that, if you go back on my point, we would have to measure, let's say, like 65 miles to get to Chicago on the global calculator.
Yes. Or no, that's not what would happen. No, I'm saying it'd be less.
65 miles.
Okay, hold on, Godric. Look at the green diagram again.
I'm looking at
the 1 mile is on the surface. The 1 mile is from you.
I'm not there. Hang on. Where are you?
The green diagram that I showed you with the drop thing. If you look at it,
I'm here. So
the 1 mile distance is following the curve.
The problem with this, Paul, is it's completely fallacious. Okay,
it's not.
It's 100% fallacious, Paul, because you're putting 1 mile. This is about 3,000 miles, by the way. Distance.
No, this is just this isn't supposed to be to scale. It's just
right. You have it like you're doing it on a baseball. Probably this is not a good example. You should track this example and put the right scale of Earth, because I'm
trying to do that right now with the Chicago skyline, and I'm telling you that
this is a really bad example. It's about 3,000 miles from left to right.
The principle is the same no matter the scale. The 1 mile tangent will overshoot what the actual distance is my point. Do you see that?
Probably.
You can convert the 1 mile to whatever distance you want.
It's not measuring going into the Earth. We know we can't go to the Earth, Polly. We know we can't do that.
I'm not saying that.
I'm saying that.
No, I'm not saying that that distance
going to the Earth.
I'm saying that distance is not going into the Earth. The distance is following the surface.
It is going to the Earth.
No, the distance is following the curve. It is not following. It's not through the Earth. That is a different distance. That dip.
But let's disagree. The lowest dip you have on your fallacious example, which I'm telling fallacious is not to scale, is going through the Earth. Yes or no?
That is not the dip I'm talking about.
But the lowest line is going. See, if we can't agree on anything, it's like there's no point in discussion at all. I'm trying to just make a point, and we have to agree on something. Otherwise, we're just talking different language. The lowest line you have on your fallacious example, and if you can make the scale, it's much better, is going through the Earth. Yes or no?
That is not what I'm talking about at all, though.
You can't even answer.
No, because that's the shortest distance on the variety of things where it's asking about drop.
Here's a question.
Because the reason... Hold on.
If you're not talking about that, then why did you put it?
What? I'm not, because I'm talking about the other distances. Here, let me.
Why show me this measurement if you're not going to use it, Colin? This is the confusion we're having. We were talking about in the sky. I think. Okay, I don't know. Maybe you don't even agree with me. Maybe you don't think we're in the sky. Maybe you think it's, I don't know, somewhere else.
No, I didn't say
I
it
went
was
to the
in the sky.
ground. You don't agree with me in the ground. So it's like, it's like, here, you talk, you present it, and I'll listen. Go ahead.
Give me 1 second. I'm going to illustrate this for you.
Yeah. While you do that, I'm just talking out loud. Battle Mod, who I don't really respect, especially because I think he's a goofer.
Who?
His name's Battle Mod. He's one of the mods in 24/7. He several times he said no matter how you measure it, it's going to actually be more curved. I never knew what he meant until now. Until you question the Goldberg calculator, you bring it to light. Okay, let's say you're correct, and it's going to be more curved, not less.
No, it's going to be less curved because look at my diagram. Okay, I just put a new one.
Okay.
The purple line is what the distance is, the 1 mile distance.
Do you mean red line, Polly?
No, the purple line is the distance from you to the
Hang
object.
on, I'm in the wrong picture. Oh, I'm in the last picture.
See the purple line?
No, I
It's
see a red
following.
line. I see a. Oh wait. Now I see it.
Okay, the
Okay,
purple
what about
line.
this purple line? Yes.
The purple line is the surface distance. So in the case of the Chicago skyline, that'd be 60
Before
miles.
we continue, please don't show this example to anybody else because it's completely wrong. You want to do it to scale. The distance of this
no,
Earth
because
would be
hold on,
around 3,000 miles.
gotcha.
Okay?
The scale does not matter because no matter what.
Oh boy, here it is. The scale doesn't matter.
No, I'm telling you, it
Okay.
matters for the individual examples. I'm telling you that for this illustration of what drop is, when you do the 8 inches per when you do the 8 inches per mile squared, it does not matter the scale. It's always going to be shorter on the 1 mile, the tangent. So look at the purple line. So that is from you to the okay. That is from you to the object. The red line is what you need to find. That would be the drop. The drop is not the blue line, which would if you just inputted the distance.
You just went from red to blue right now.
I just told you why. I told you the red line is not the blue line because if you inputted the distance on the surface into the tangent, it would be greater. It'd be a greater drop. Do you see how the blue line is longer than the red line? So if you inputted 60 miles, let's say.
The blue line, listen, watch me answer your question. Just pay attention. The blue line is farther than the red line. That wasn't hard. You see how I did that?
I know, and I'm telling you, that means that the calculations are over adjusting. That you're talking about, the 8 inches per square. So if you, I just demonstrated how. Is the blue line not longer? Is the blue line longer than the red line?
The blue line is farther than the red line.
Is the blue line longer than the red line?
It's farther. It's farther and longer.
Okay. So when we calculate drop to a target, we need to find the red line, not the blue line. Does that make sense?
No, that part doesn't make sense. That part you lost me. You've drawn two lines, and a really bad example, by the way.
I'm telling you again.
And you're saying one is more correct than the other one. How do you know?
What?
You're saying one is more correct than the other one, but how do you know?
Because I just illustrated that. The purple line. Hold on. Shush. Can you just be quiet for just 2 seconds, please? I want to go over this so you understand it better.
You can go over as much as you want.
Hold on. The purple line is the actual distance, right?
The purple line is the actual distance, yes.
Okay. So, if you put that into the 8 inches per mile squared, you are calculating wrongly. Instead of finding the red line, you are finding the blue line. It should be the...
Let me go back to the calculator. Hang on.
Is it? That's an interesting thing. So,
hey, Shells, how are you, Shells?
Hey, man.
It's going across into the sky, right?
The horizontal.
Measuring miles into the sky.
Yes, and I'm saying that measurement is not what you need.
The distance would be on ground would be farther.
And if you just wait just a few seconds, I'm converting. I'm still
back on my point. It would be more curvature to account for because
I'm saying
the calculator. Hang on, the Goldberg calculator is measuring in the sky. It's measuring the difference. I know you get this. The difference between a flat and a globe. That's the difference. Is the measurement that we're looking. Is the measurement that you're showing. Okay, to be fair.
Okay.
And if we took that length, that ruler that's going across the top of the globe into the sky, and put it on the ground, you will not reach Chicago. Okay, because now you have to deal with a curving surface, which is farther. The only way you can reach Chicago is if you go through the Earth.
Yeah, you're doing the wrong. You're doing the wrong. You're still confusing the
so
two
it's
distances.
farther, not shorter. Now,
you're still confusing these
let me just answer your point. You did make two lines, a red line and a blue line. But I don't see how you can say that the red line's correct and blue line's wrong, and then say that we're using that. That's the point I don't get.
Again, because the drop from you to from the horizontal to the target would be the red line. Do you understand that? The target is at where the red line is. Does that make sense to you?
I think I understand what's happening because I'm just using induction. Okay, look, Paulie. Probably what you're trying to say. Let me help you out here. What you're trying to say is that the blue line's correct and the red line's wrong, and this is why.
That's why I've been saying.
This is my point I just showed you, but I don't think you heard me. Let's say it again. If you're we know that Chicago's 60 miles away. We know that. That's a fact. Okay, but the Goldberg calculator may be showing it wrong because they're just showing a line in the sky. They're going 60 miles out on that line. That's all they're doing. And then that line has to go down to the Earth. Okay, as it goes down to the Earth, it has to cover more distance because the Earth is actually curving. Okay, now on the red line you're picking, right? That's the distance from 60 miles in the sky in the horizontal tangent from the top. But if you take that top measurement, that's the horizontal tangent, up to the red line and bring it down to Earth, you will not reach Chicago, Paulie. This is the problem you're going to have. The blue line is what. Listen. The blue line is what you need to reach Chicago. Hang on, Paulie. Hang on. Listen. You will not reach Chicago with the red line. The only way you can reach. Hang on, Paulie. Listen. The only way you can reach Chicago with the red line is if you go through the Earth, and we know that you can't go through the Earth.
Again,
so you have to use the blue line. The blue line is farther.
The blue line is incorrect.
More curvature, not less. And
no, the blue line is wrong.
And I'm done.
You're
eggshells. Help us out here.
Again, the purple line is the actual distance. The red line is the drop you're trying to find. The blue line is what happens when you input the surface distance into the 8 inches per mile squared, which is wrong. You need to. I'm not saying that 8 inches per mile squared is wrong. I'm saying that converting the surface distance directly to the 8 inches, that formula is wrong. Doing that is a mistake.
I just want to be clear that you're here.
So let's do it. The maths then, like work it out.
Hold that 1 second, Excel. I just want to make sure you're understanding me. Are you saying that if you go a tangent line across horizontal, just like that sextant measurement you were showing me across in the sky, not touching the ground, which curves?
That's your horizontal.
We go with the horizontal measurement from that blue dot on the top of the globe out into the sky. If we did 1 mile, wait, hang on. If we did 1 mile tangent into the sky to the red line, you're saying that would reach Chicago?
No, that's not what I'm saying. The red line, no, because that is not supposed to be equivalent.
It would not reach Chicago. Let's disagree. It would not reach Chicago. The red line does not reach Chicago.
Because the purple line is the distance to Chicago. The red line is the difference. Cedric, yes, I am telling you that the purple line is the distance.
Paulie, listen.
Red line is the drop.
We know the purple line is the distance to Chicago. That's in reality.
And the blue line is wrong.
Paulie, that's not a question, Paulie. That's not a question.
And I'm telling you,
don't have to repeat
you're
it.
doing it wrong because you keep on.
Paulie, listen. Purple line is to Chicago. We know that. We know this. Don't repeat it. Okay.
I know, and you're completely misunderstanding.
We can measure from Michigan to Chicago. That's not a problem, Paulie. The problem is the Goldberg calculator correctly measuring the distance as far as the curve? Isn't that what we're talking about? Hang on. Isn't that what we're talking about?
I'm talking about inputting
correctly measuring the distance.
It is correct in the sense that the 1 mile or whatever distance you put in on the horizontal is correct, but it is not the right distance. When if you put in the surface distance, it will be a different distance horizontally.
Which is the correct distance, the red line or the blue line, Paul? You tell me.
Again, the purple distance is the actual
Or is that a bad
distance.
question? Is that the wrong question? That's the wrong question.
The red one's the correct one, he's saying.
The red one is the correct amount of drop. It is not the correct distance to the object because that is not what it is equivalent to. We are talking about the drop.
Okay, the drop. Okay, see. So now we're talking about something else. Now we're talking
No,
about the drop.
I've always said the drop. I always said the red line is the drop in the 8 inches per mile squared.
The red line is the drop.
Yes, because that is the correct drop if you input the correct distance for the 8 inches per mile squared, which is what I've been saying.
Well, the truth be told, I don't know what the correct drop is because I didn't do that formula myself.
I just illustrated the formula. The formula is the distance on your horizontal and then finding the drop from that distance is not equivalent to the surface distance.
Actually, no, Paul. Can we agree though? In my point, the red line, the tangent in the sky, the red line will not get you to Chicago if it's curved.
That's right.
If you bring that,
yeah,
you bring
we've
that
both
line
been on
down.
the same page about that.
No, we're not. He never agrees with me, Eggshell. This is the thing. He's afraid to lose the argument. He will never agree with me. That's the problem I have with Paul.
You agreed that the red line wouldn't get you to Chicago, right? If you were traveling
Yeah,
by walk?
I never said that. It would get you to Chicago, and that's not the point.
And he didn't. Can you just be clear? The red line will not get you to Chicago. Yes.
Yeah, it's not supposed to get you to Chicago.
Okay, good.
That's not the point of it.
You should ask me a different question. The drop. I don't know the drop because I don't know if the formula is correct or how to do it. Actually, I know what the formula is.
Hold on.
I don't know how to get that from a sphere. You have to do some geometry.
I'm doing geometry right now. Give me just a second. My computer is slowing down because making a 2-scale diagram is extremely tolling in CAD.
Polly, if the red line's not going to get you to Chicago, then why would you use it?
Hold on 1 second. My computer's crashing or trying not to crash.
But Polly, if the red line's not going to get you to Chicago, why would you use it?
Because the red line is the drop.
Oh, okay, the drop. Actually, the drop is what we're looking at. Sorry. Let me look again.
That is what I'm telling you. That the drop is the red line, not the blue line.
So the distance. I'm looking at the
was
original
making a
Glover
2-scale
calculator.
diagram, but it's glitching out. So give me just a second here.
I'm looking at the original Glover calculator.
Can you link the calculator, please?
What you're saying? No. This is the one that you posted. I'm looking at the diagram. It says 3959 miles radius. Hey Don, what's up, man?
Yeah, that diagram.
Imaginary colors, exactly. Let me see.
I'm telling you, the distance on the surface is different than the distance on the horizontal, and that is all my point was. If you count for that correctly, you would get what am I saying?
The way I see it, Paul, is you have it flipped, man. That's the only way I can see it. You have it flipped around.
No, I'm saying
where the globe Earth is measuring a tangent straight across. That's correct.
I know,
it's
and I'm telling you
in the sky. That is correct.
I'm telling you that is not equivalent to the surface distance.
No, it's not. It's a shorter distance.
So you agree that the tangent or the horizontal distance is smaller than the surface distance?
Yes, Paul, it's smaller.
Yeah, man.
See how I agree with you? That wasn't hard.
He's agreed to all of it.
That wasn't hard, Polly.
Would you be happy, Godric, to admit that some people measure drop wrong? and including some flat earthers.
Listen, Don. I'm not an expert at this. I went over this several times. I actually
that's
don't
what
know.
I'm saying. You're not an expert.
I actually don't know what the drop is.
Paulie's done a good job trying to explain
There's a couple ways to explain it, right? Because look, just think of a tangent going out into the sky, right? Which is
I don't want to
like
debate it. I don't want to debate it with you because it's confusing for me. I don't really care about how people measure drop. I just know that I believe they do find drop. So I just thought, would you be willing to admit that some people measure drop wrong?
Yes,
that's Paulie's issue because flat earthers
they measure it differently.
Yeah,
and you know what? It's fucking confusing because we're looking at models, and if the calculations are correct.
It's confusing because people are putting the surface distance into the 8 inches per mile squared as if that is the actual drop. When I'm telling you,
with Nathan and QE basically decided to lie about measuring drop, and now we've been confused ever since. And people like Paulie have to put effort in to explain how it's
to be fair, I don't know who made this global calculator. For all I know, it was made by the CIA, so they can confuse us.
Definitely QE and Nathan is the ones who started the lie in the flat Earth community.
And I'm telling you, the 8 inches per mile squared is accurate in the sense that the mile is referring to the horizontal distance, but I'm telling you that the horizontal distance is not the surface distance.
There's a physical curve of 8 inches per mile square, not a refraction, not an observation, a physical curve on the surface.
And
yes?
I'm telling you, hold on, I'm telling you that surface.
Like, give me an agreement.
The mile is not referring to the surface.
Not gonna do it.
Distance.
Not gonna do it. Great.
Again, I'm telling you that
you have the floor, Paulie. Go ahead.
Here, give me 1 second. I'm gonna try to boot up into Fusion 360 again.
The measurement in the sky is shorter, Paulie. It is shorter.
Yes, and it should be shorter. So that would mean that
you're saying
the drop is going to be less, because if you have 1 mile distance, like let's just go back to the example, the 1 mile distance on the surface is going to be greater than the horizontal distance when you calculate for drop. The red line is the drop from your horizontal, and the point at which here, let me mark.
When you say horizontal, you're talking about the measurement in the sky.
Yeah, I'm talking about the tangent. Okay. So really quick, let me do one more thing here. Here we go.
It actually is kind of confusing because I actually
Okay, here I'm gonna put the new, or well, not the new, but the updated version right here. Okay, look at see the yellow line. The yellow line I added on top from the red line to your observer.
Oh my god, we got another line now. How many lines is this?
This should be enough to hopefully get a point across.
The yellow line is the tangent, and the purple line is the surface.
Right, and so the green dot where the blue line connects to, that is 1 mile in the horizontal, the tangent, right? The yellow line is less than that, which means it is less than a mile. Does that make sense?
Yes.
Okay, so if you have 60 miles on the surface, that the 8 inches per mile squared, you need to put in less miles than 60 miles, because the yellow line will always be shorter than the purple line, because the purple line curving is going to be longer than the yellow line.
But Paul, you have to consider that will the line get you to Chicago?
Because again, that is not what the point of the yellow line is. The point of the yellow line is to measure the drop, not the distance to
so here's where it gets confusing, Paul. Look, what you're measuring is a building on the surface of the Earth, Paul. On the surface of the Earth,
I know, and I'm telling you, the purple line.
Hang on. The building, is going to go up straight. You actually have a zenith angle, a zenith line, I guess, which is going straight to Polaris. At the end of the red line, there's a green circle, and I'm going to say an arrow like to Polaris, and it ends in or this question mark, and it's a line that goes past the blue. It goes right to the blue line. You follow me?
Sure.
That is your building. It goes straight up that way. That's why you can't use the red line, because that doesn't
see what
cover.
You're trying to talk about, but
any.
It's about the drop is talking about from these horizontal to the surface, not to the building.
Yeah, it's going to the surface.
Okay.
I'm just showing you what the building would look like, just so you understand.
Give me just a second here. I'm trying to convert all this.
You know what would help you? Put the actual distance for the red and for the blue. That would help you, I think. And then knowing that the purple is 60 distance, put the actual distance to the red and to the blue. Drop. Yeah, that's the measuring the drop. All right.
The drop that
I'll
we're needing to calculate.
Because this is confusing, because it looks like if you look at this globe and you measure distant buildings, this particular measurement is at an angle. It's not looking at the building straight on. It's at an angle. So I guess that's where it fails. It should show an angle straight up and
the
down.
drop is not from you to the top of the building. The drop is to the baseline of the building, and it's to the ground. The drop you're calculating is to the ground. It's not to the building specifically.
I don't want to throw a curveball in probably, but I think the actual drop is supposed to be the last angle where it says or this, the furthest to the right. I think that's the actual drop. Sorry for putting a wedge in it. Not the red, not the blue, but the final one, because that's the only one that's going to get you to the surface from the. And like I said, it's measuring the difference between a straight line and a sphere. That's all it's doing. That would be the amount.
I know, but I'm telling you the difference.
Curve of the Earth. That's the amount behind the curve of the Earth, probably.
Again,
so do me a favor. Do me a favor. You're drawing all these here. Actually, I'm going to do it for you. I know how to do some work here. I can do some work here for you.
Doing what work?
I'm going to edit your picture here. Now, I'm not for certain, probably. This has to be discussed with people more than me and you, but I'm going to do something for you. Okay, watch what I do.
31668. 31668.
Let's do. Can I do a orange line? Let me do an orange line. That'd be good, right? Done.
Hold on, just a second.
Are you ready, Polly?
1 second. 31668 000.
Okay, I think I got it, Polly. Don't get mad at me now. This is for Eggshells and Dawn and Polly. Actual actual distance. Orange line. Okay. You got your code, man.
That is not what the drop is supposed to be.
That's the distance, Polly.
That is not the 8 inches per mile squared. And that is my whole point.
That's the drop, Polly.
No, because the drop is talking about the drop from your horizontals as it would be down from as the diagram shows before.
But this again, let's see if we can agree on something. The earthquake calculator is done a certain way. It's measuring a tangent line going across.
Depends on which one you're talking about.
Hang on. The only one you're showing. Don't do this, Polly. The only one you're showing is only one. Okay. Don't say it depends on which one. There's only one we're talking about. Yes or no?
Yes, and the drop is the red line.
Hang on. The one that you posted. Okay. Now.
I know, and that drop it shows you is what the red line would be. So I'm not sure what you're talking about, because it would not be the orange line, because that is not what the 8 inches per mile squared is referring to. Because again, when we mean drop,
the orange
we're
line
talking about
is the difference between a straight line and a sphere.
Again, that is
That's
not
what
what
that
that is. That's not what that is. That is not the correct drop line. The drop
Well, I'll
line
tell you
is the
what, I'm
red
not
line.
really sure, but let me tell you, your red line will not make it to Chicago, so you can't use that one. That's a 10
Again,
power.
that's not supposed to make it to Chicago. It's measuring drop, not the distance to Chicago.
Okay, but if it's not 60 miles, then you're not measuring enough drop. I mean, if you're not measuring 60 miles, then the measurement's not correct, Paul.
Give me just a second here, because I'm going to try to show you what I'm talking about.
Are you there, Eggshells?
Yeah.
We're done. I just put the orange line, thinking that that's the drop. But I don't know what the drop is, honestly.
I know. So it is the red line. I am telling you, it is the red line. That is what the formula is referring to. Is the red line. Or well, if you're doing it for 1 mile, it would be the blue line. But the 1 mile is different than the actual distance to the object, is what I'm saying, and I've said multiple times. And give me just a second, because I'm trying to make this to scale.
The buildings don't go sideways like you're suggesting. I think the buildings go up and down, so you can't say that they go sideways like that. You have to look at from the surface. The buildings go straight up. If you're looking from the surface, you go straight up. You would hit the orange line. That's what you have to do. Unless I'm wrong. I could be wrong. I'm not saying I'm not wrong, but and if I am right,
just a second here.
Then there's a lot more curve than it says.
Okay, hold on. No, because again, you're misunderstanding. I'm still working on this diagram. I'm trying to convert all the distances.
I'm proud of my orange edit. I'm kind of proud of that. So let me have my little victory.
You're proud of what?
My orange line.
The orange line is wrong.
Shall we bring some real drop and see if you can convince Godric of actual drop?
You tell me, Don. Where's the drop? If you've been listening, Don, just tell us where the drop is.
I'm saying, Godric, if you were to get this nerdy as Paulie is, and you went out and did it over the water and the earth, you'd find some type of thing that people call drop. Yeah.
You know what, Don? The drop could be that lower line that says 1 mile distance that goes through there. That actually could be the drop. You know why? Because that would be the amount that's occluded.
Okay, Paulie, can you tell us one last time which one is the real drop?
The red line.
Red line. Boom. So we all know now. You can remember that, Godric.
But Don, let me rebuttal that, Don. The buildings don't go that direction. They go the direction of the orange line. So why would it be the red?
Yeah.
Just saying.
Why do you think the drop ain't the red line, Godric? Can you explain that to me?
There's two reasons why. Okay.
Yeah.
And the first reason I was telling Paulie that if you take that distance of 1 mile across, because measuring distance, right? Yes or no?
Yeah.
We know. Okay, if you look closely, there's a purple line that shows the actual distance on the surface of the Earth.
And that's what I've said.
Hang on, Paulie. See, don't do this, Paulie. Let me explain. Okay.
Yeah.
And we know that purple line is the actual true distance, bona fide, true fact distance between Chicago and what's the other one?
Doesn't matter.
Milwaukee. Where the fuck are we going? Over the lake, right? Between Chicago and Lake Michigan. Over Lake Michigan, between Chicago is really, in this case, 1 mile. Okay, in this example, which is a bad example. So here's the thing: the global Earth calculator. If you look at the actual diagram, it is showing a tangent in the sky from your target, the blue, which is a blue dot, and it goes all the way out to the blue line, which is the other green dot here. There's 2 green dots. Okay, so there's
Yeah.
a tangent in the
Yeah.
sky. It goes 1 mile, and that's the blue dot. But here's the thing. So the blue line is an actual mile from the globe with a calculator. Okay. And it's bigger than the 1 mile distance on the sphere, because we know the 1 mile distance on the sphere, which is how the red line connects to the purple line. We know if we go by that measurement, okay, and we lower that distance down to the Earth, we cannot get to Chicago. It won't reach because it has to bend around a curve, which makes it it needs to go farther.
Right.
So that's why you have to use, that's why you have to use the blue line, because the blue line is more than a mile, yes, but when you bring that line down from a straight to a curve, you have to account for more distance, and that's why you have to use the blue line. That's my
Okay. Now,
Okay,
just 2 seconds. Yeah, just 2 seconds, Dawn. But that distance between the line that's chopping through the Earth and the red line, which is the surface of the Earth, what is the difference there? Where it's not a great deal of distance.
Actually less than a mile. That's actually less
Yeah,
than a mile.
it's
Straight away.
less than a mile. Yeah. So it's not a.
90%
So
of a mile.
yeah, but regardless, there's going to be drop. Yeah, there's going to be drop regardless, whether
Yes.
it's less than a mile or a mile. So
Yes.
does it make a huge deal of difference for the argument? Like, what's the kicker? I'm trying to get the kicker.
Well,
here.
Paulie brought this to my attention. What he's saying is, he's saying that the global, if I understand him right, that the global measurement measures the blue line, which I know it does. I agree with him on that. And it should be measuring the red line, because the red line is the distance on the surface of the Earth.
It's the distance of the drop.
Correct. I don't think that's correct. I think if you were going to be picky about it, you should pick the orange line, because that one goes from the surface to the tangent.
The formula, if you want to find the formula, so the point of the formula is to find the drop, right? You want to find the drop to the object. You don't want to find the
But Polly, with the red line, you're not taking a direct path. You're taking the closest path. That's why you're cheating.
I'm not cheating. I'm telling you the red
closest path from the tangent.
No, the red line, the 8 inches per mile squared is calculating the drop, which is from the horizontal to the object.
The reason, Roderick, can I try?
Go ahead, Don. Go ahead.
The reason that you don't use the orange one is because you can't measure that angle out in space back to the Earth. So it's easier to imagine a 90 degrees straight down. And the point is, you don't know how much Earth is curving. You're not really assuming a globe. You're trying to prove.
Hang on, Don.
Hang on, wait. So you do your tangent out into space. The drop is straight down 90 degrees from the tangent to wherever it hits Earth.
Yes, that's
not out into space and then a random angle back to where you think Earth is.
Oh, I'm sorry, Don. I'm the one that's doing 90 degrees. He's not doing 90 degrees. He's doing the shortest distance.
No, 90 degrees from the tangent in space, the imaginary tangent. Down, not 90 degrees from where you imagine Earth is on a globe.
Yeah, I'm doing 90 degrees from the globe into the space. That's what I'm doing.
Yeah, that's wrong.
With the orange line.
The reason that's wrong is because you can't estimate that angle and you don't know where Earth is, so it's easier to imagine straight down from the hypothetical tangent.
So which line do we measure by, Don?
The red one is drop, which most people use when trying to say, "Oh look,
do you realize though that measurement will get you to the front it will get you to the foot of the building? You won't see past the building.
It's the same for any observation. It's just looking for drop. So you want a line straight down from the tangent. That's how people do it.
It's not going to get. It's not. You're not going to be able to see past the building though.
It's not for seeing past. It's just for measuring drop and saying yes, this matches a globe model, or it's slightly different, so it must be a refracted day, or I don't believe it because I'm a flat earther.
You can't really measure that. Well, you can measure the drop to the horizon, the horizontal to the horizon, but that's a different matter.
Okay, well, I think Don's agreeing with you, Paul. I just don't know. I honestly don't know.
Well, if you don't know, then I don't understand how you're having an opinion.
My opinion was the orange. I don't see what's wrong with that.
I know, and I'm saying, can you?
I don't know where you and Don are getting that from. How can
because
that
the drop in the
it
8
doesn't
inches
even
per
reach
mile
there?
squared is 90 degrees from the tangent. Does that make sense to you?
You're measuring a distance in the sky. Okay.
Again, this isn't there isn't much of a way to measure this. You can measure obstruction.
Yeah, I'm gonna rebuttal.
In the sky. It is imaginary distance in the sky. That's how you.
I'm
have
gonna
to measure
rebuttal
drop
by doing this.
if
I'm
you're
gonna do
not.
it one more time. I'm gonna do it one more time for you guys. This is for both Don and Polly. I had to disagree with both of you. Watch what I do. You don't like this. You don't like this. Okay. Watch what I do. This is what you guys are thinking. This is why I think a little bit backwards. This is my opinion. And by the way, you can have an opinion if you don't know. Trust me. There's nothing wrong with that.
But you're basing an opinion on what you want to base it on.
I think your calculations are completely wrong. That's what I think.
Yeah, but you're not backing that, and and it's a complete misunderstanding of what the calculations are about.
You don't have to know math. You just have to be intuitive. I'm gonna show you what right now.
What? That doesn't make any sense.
You don't have to know math. You just have to be intuitive.
Again, that doesn't make any sense because
now I'm gonna do an orange line. Now we're gonna get the orange line. I'm sorry, green. Are you ready?
Go ahead.
This is what would happen if you use your red line. This is what would happen. I'm gonna show you. There you go. Done. Send it to you. This is where you'd be if you used your red line, and this is the only fair way to do it. Red line measures this.
Can you post that in the live stream, Godric, so we can see it too?
Yes. If you measure the red line, you would get not even to Chicago. It's the green.
All right.
You
can do this, Godric. You could try and estimate the green and the orange, but you understand that you'd be doing it different to everyone else.
Yeah, you'd be doing it. That wouldn't be the 8 inches. That wouldn't be the 8 inches per mile squared. That wouldn't be the drop you're talking about. That's my point.
That's wrong. That's why you can't use the red line.
No,
that's what I'm saying. I'm agreeing with you. You can't use the red line because
and that's not what I'm saying. I'm saying your red, orange, and green lines are not 8 inches. What the formula is referring to.
They precisely are because they start at the tip of the green line and the tip of the orange line. When you cut down like that.
No, because the drop is 90 degrees from the tangent. That is what we are referring to.
When you cut down like that, I think you're making the shortest path. It's like going through the earth. You can't go through the earth.
That's not what the topic is at all. It's about the drop from the tangent to the point you're observing.
Now, I don't want to throw a wrench in it, guys, but we're arguing about this, right? I think the actual dip is that measurement on the bottom because that would be really what's included. That measurement through the earth. That's actually your dip.
I guess. Godric. So, really quick, let me illustrate this for you. It's what 60.
Oh no, it wouldn't be your dip. Yeah, it wouldn't be. Well, hang on. Let's see.
That's not right. I have something wrong here.
Yeah.
How did I get that? Oh wait, is it 600?
Don.
Hold on, I'm trying to.
Don, you there?
Here.
Oh yeah.
What do you think about this? The dip is actually that lower line that's going through the earth because that would be what's included between A and B. How about that? Can we do that?
I don't know the actual terms for these exact lines in the Odyssey. I just have my own idea about what makes sense, what matches what other people do.
It's called the Stygia. The Stygia.
Okay. What are you saying?
The actual occlusion of objects, the blockage that's supposed to be hidden height.
Yeah, but the hidden height
that arrow through the earth.
Yeah, but that's not drop. That's not drop. Obstruction is not drop.
That is another thing to look at if you want to look at it.
What do you call that?
Hidden, I think people call it.
Well, first
if
off,
you're
that's
if
just
you're in, listen, if you're in the North Pole, you're looking towards the equator. You want to see what's hidden. That would be the height. The Earth that's in the way
No,
would
that
be the height that's hidden.
no, that wouldn't be the height that's hidden. That would be the height of the hump in between you and the object. Because if you draw, hold on, no,
my point.
no, hold on. The actual obstruction is going to be different than the amount of obstruction is going to be different than that middle line.
I know what you're saying. Because you're measuring a building from the surface into the air, and that is actual the thing that's behind the Earth. The whole not under the Earth. I think maybe that's why. I'm just throwing stuff out there. I don't know what the hell I'm talking about.
So do I have to be the one to say that there is no the fact that what we're looking at doesn't look like obstruction at all, and that if we're just seeing the city that's 60 miles away, then that's just the city 60 miles away.
Actually, I want new perspective. Wait, hang on, new perspective. Clarify what's happening here. Do you know what we're talking about?
Yeah, he's trying to make the shortest path between the viewer and where the city would actually be a shorter distance.
No, that's not what I'm doing.
Well, if it was actually over the curve, like Godric was saying, he's right. It would be a longer line than
no,
the
it wouldn't
one
be.
that's up in the
no,
air.
That's not my point.
The curved surface would be longer than the one that's up in the air.
Yes, the curved surface would be longer. So the 60 miles is the curved surface, not the tangent distance. And that's what I've been repeating, but Godric doesn't understand.
Okay, well that's because you put a straight line through the Earth, and you were actually designating the length of that curve. Is what you're saying,
no,
right?
That's not what I'm saying. If you look at my last,
hang on a second. Hang on, Paulie. New perspective. Paulie's final answer is that the distance that we're supposed to be measuring on the global calculator is the red line from the
yeah, he's shortening it. So he's saying, so if it was 60 miles away, if the city was 60 miles away, you're saying that we're supposed to subtract how much on a regular basis to start our 8 inches per mile squared?
Okay, so see the purple line?
Yeah.
Right?
I get it.
Okay, the purple line is the 60 miles. That is the drop would be the red line. And so the yellow line, if you just input 60 miles into that, you get the wrong line. Does that make sense? You get the wrong drop, the wrong distance for the drop. Does that make sense?
I'm looking. Do it with the original picture though. It just has a line out to where the 60
1
mile
mile
straight down, right?
Wait, what do you mean? I'm talking about the diagram that with the 1 mile. It's not obviously to scale, but it's just a unit.
So are you saying that the line that goes straight from the viewer to the place through the Earth, that's the distance the line you're just...
No, that's not what I'm saying. The distance to the object is the purple line, and the latest I just repasted it so that you can see it. That would be the 60 miles. The drop is the red line. The drop is 90 degrees from your horizontal, it just says tangent in the diagram. The 8 inches per mile squared is referring to your horizontal. Does that make sense?
Right, but it looks like you've the green dot that you put on there. You're saying that's the claim of the distance when it should actually be in a little bit.
Yes, that is what I'm saying.
And the reason for that is because it meets the drop at the bottom in a hypotenuse triangle in the way that it's supposed to.
I think I understand what you're saying. The correct distance for calculating the dip or the drop would be the yellow line, and that's what I'm trying to explain to Godric.
Well, but are you saying that because the people are seeing it at the green dot and they're going straight down from there,
they're trying to calculate it wrong.
They're making a longer distance because it goes over the curve,
yes,
rather than dropping down from where you would cut through the Earth and meet it?
No,
for the hypotenuse triangle to work out?
The drop you're trying to find is from your horizontal to the object, is my point, and that would be
So
the
what's
red
your
line.
standard way of calculating what you would subtract from 60 miles? What would
he's trying to get down to the business now, past the theory.
I mean, I'm trying to
how would you know what to subtract? How would you know how to make sure that you're doing it right every time? If you're correct.
That's what I was trying to make a 2-scale diagram of the Chicago city line and the.
Can you hear me, Paulie?
Go ahead.
So, like, let's say, as we know over the plane, right, straight across, like on the flat Earth, it'd be 60 miles to the city, right?
Right, but on a globe, it'd be the curved line.
Paulie.
So it would be, but the curved line would be longer, not shorter.
Yes, the curved line would be not in terms of it would be a longer distance, but in terms of the.
But because it curves down, it comes in. I see what you're saying.
Can I say something?
Go ahead.
Go ahead, Don. I have some mistake. Go ahead.
New perspective. I think what Paulie's saying, or what I would add to what Paulie's saying, is that we think some flat earthers have been doing it wrong on purpose and coming up with the wrong numbers, and that's how they manage not to find drop and carry on convincing people the Earth's flat. So Paulie's trying to say this is how you're supposed to do it, and if you were to do it this proper way, you would end up finding drop.
And
I see what you're saying.
And
okay.
Another thing, really quick, Godric. Another thing is they are trying to find obstruction, like how many feet should be obstructed, with the drop, but that is not what the what's the word? Here, let me put what it should be.
The drop in this case is the sky tangent to the ground.
Yes.
The point would be, rather than flat earthers saying, no, we'd like to do it like this, you're wrong. It's, oh yeah, there's more than one way. Some people are saying it needs to be like this.
Well, I'm
just go out and try this.
I'm saying that what they're trying to determine is they're deriving that from the wrong formula.
Well, do you let me ask you this: when you figure out your hidden value, do you use the actual height of the building in an orthographic view like this to calculate it?
That's what the advanced Earth calculator does.
Right, but does it use the actual height of the building?
Yes.
That's the problem.
Here, if you can adjust the target height in the calculator.
Paul, everybody. Paul, did you do this yourself, or did someone give it to you?
Do what?
This red line, blue line.
On the diagram that I drew over.
Paul, did somebody give it to you, or did you find it yourself? This is important because I think you actually.
Which one are you talking about?
Is this something you're coming up with, or somebody tell you about this?
I'm deriving that. I'm explaining how the 8 inches per mile squared formula works.
But did this come from Mick West, or who did it come from?
I didn't come from anyone. I'm using existing diagrams and to explain.
So is this your idea, or is this something the ballers are talking about now?
What do you mean? I'm talking
about a
about
topic that was introduced to you, or did you come up with this on your own?
It's a topic that I've found and I've learned. But
where did you find it? Where did you find it? What's your source?
It wrong. That's what it is.
What's your primary source for this information?
With which information? Because I got the chart from just Googling.
Who gave it to you, Polly? Who gave it to you?
So you came up with this idea. It wasn't something another baller came up with, and you're repeating what he said.
I kind of came up with it. I'm taking existing formulas and explaining them myself. That makes sense.
Yeah, but I know. But I'm saying it's not something that people are saying that in a general sense on the baller side. The flat earthers are doing it wrong.
I would say that
ever since Nathan and QE told flat earthers how to measure obstruction, we've been telling them you're doing it wrong.
Okay, Polly.
For 2 years at least, or 3.
For this reason,
I would say some people might do it wrong, even if no matter the side, because they don't understand it first.
Flat earth is the one that's hiding. That's the new one. Yeah. Okay. Thank you, Don. Now,
wait. What's interesting is do you guys know about Mick West going on Nathan Oakley's and having to change his calculator, his curvature calculator, because they busted him on how he was reverse engineering it?
Yeah, that did happen, but he had added an extra thing to it.
changed it because he was using the full height of a distant building.
But
And
I also like to tell you that
using orthographic. Hold on, don't cut me off. He was using the orthographic view like you are here, and saying that the distant building is 20 feet high or whatever, however it was, and they were getting their hidden height, which always seemed to match the observation, but they didn't take into account from the perspective of the viewer that's seeing the object in the distance. Things get smaller as they go further in the distance.
yeah, angular perspective.
Yeah.
He did only invent that because flat earthers were moaning that they wanted one. And
Okay, now, Paulie.
they couldn't make their own, so the Globe had to make it for them.
Well, no. Why would they make their own? They don't think the Earth curves.
Because they're obsessed with measuring obstruction.
No, they're obsessed with they're obsessed with showing how there's no obstruction and refraction can't answer for the obstruction that's not there.
Yeah, same thing.
But wait a minute, I have another important question real quick. When we were talking about the light bending up, that's maybe I'm confused about something now because it seems like according to the original picture that I posted with the 22,000 miles, right? Wouldn't the light have to bend up to bring the building up, to refract up?
What do you mean bring it up?
Doesn't the light have to bend up off of the surface for the refraction in this case to
What he's saying is if the light bent down, we would never see it. That's what he's saying.
No, because
right?
What? No, they would.
Yeah, wouldn't the light have to bend up like we were talking about with the condensation?
Depends round
doesn't percentages argument work in your guys' favor because it bends light up?
No, that's not the case.
Which causes. Okay, why wouldn't it? Why is this not bending light up? Because it's showing us the skyline off of a surface that's below where our sight should see.
No, I'm saying.
Let's reverse it. Let me explain what he's saying, Paulie. You see how you have this global calculator and there's a tangent line above the Earth straight away,
yes.
And then there's the sphere of the Earth is below. What he's saying is, if light bent from Chicago all the way up in the air, if it bent upwards to that tangent line, then you can see it straight across like it appears.
So
in this case,
the tangent line isn't what you're seeing, though.
In this case, the light is bending from the surface, moving all the way to the tangent line, and we're seeing it straight away. Right across. That's what he's saying. Understand?
Your claim is that the whole skyline that we see there is not there. That's just a mirage, it's a mirage.
Yes.
It's just an optical illusion of the skyline being bent up from the water from below the surface.
We're talking
below our
It's
sight.
not a mirage in the sense of like a sort of illusion. It's just slightly bent. Like if you look through water,
the buildings aren't actually there, right?
No, not that physical. Like their optical position isn't exactly.
So it's an optical illusion that they're there.
In the case of Chicago skyline, it's 2,166 feet upwards.
No, you see, that's probably the wrong number, Godric.
Because you're determined. Okay.
Yeah.
But regardless, you're saying it's not a mirage in the sense that it's either there or it's not there. If the city's not there, then
we're agreeing it's not there. It's looming up.
Right. So that's the ridiculous claim.
But the huge number Godric threw out is just a made-up huge number.
The skyline just happens to appear right exactly where we expect to see it if it was a flat Earth.
Well, flat Earth has got weird refraction as well, hasn't it? Making things go hidden.
Not this weird, man. This is an extreme claim.
Well, they're both weird. They just work differently to convince us of our worldview, don't they?
Well, yeah, but your extreme weird is not even close to what flat Earthers try.
Light reflects on the city, and then it bends around the surface of the Earth a bit.
It brings it up just level with the eye. Like you're just looking right at buildings. It looks like you see the buildings.
Not just
I see the buildings.
Hold on, really quick.
I'm saying I see buildings. You're saying I'm seeing an illusion of buildings.
Really quick.
I don't think you're right.
Hold on.
I don't think it would look like this if it was just an illusion.
It's got a new perspective. When you look through the water at something, it is always offset from its physical position because of refraction. It's the same way. It's similar in that sense.
Did you say
water? That's why it needs to bend down. I get it now. So you're saying because I'm looking over the water, the light's bending down to show me the city.
Not all of
city.
it. It's not. Oh, okay. First off, the Chicago is 500. I think it's 570 feet. The street level. Those buildings.
You mean the tallest building?
No, like the actual elevation of Chicago
Oh, okay.
is 5. So from the base of the building to sea level is 570 feet. Does that make sense to you?
Yeah.
It's 500. Oh no, I'm sorry. It's 597
it's already,
feet.
So it's already above. The base of the building's already above sea level by 500.
No, there's already obstruction right there that you can see clearly. It just makes it slightly above. You can see slightly more because of refraction.
You've heard of seeing an oasis in the desert, right? It's not there, but you see it.
And that's what he's saying. That's what he's saying.
With light in the atmosphere.
He's saying it's not a mirage, but it is.
No, he's not.
No, I'm not saying it's
loomed and bent.
It's loomed, but it's not like a complete mirage where it just is a jumbled mess. I'm saying.
Do you agree? We could just be seeing the city, right?
I'm saying we're seeing the top half of the city. Can you see the streets?
You're requiring it. Like you could say, oh, well, that's what it might look like on a flat Earth. But actually, I believe it's a ball, so I have to use these refraction things.
Again, refraction. You can see that varies depending on the day.
I'd say this. Sorry, I can't. New perspective. I'd quickly say this. Why can't we see the bottom? If it's 500 foot above sea level, the streets. Why can't we see that?
Because of our angle of attack. Because of our angle of attack.
See, so everyone's got an excuse.
Again,
not an excuse, just your perspective.
No, again, perspective does not explain that away, because if you measure, say at the top, like let's take like a.
Well, we also have to take into account that
building.
Water has a bulge to it in general, especially at this level. You're looking straight across.
Again, what's the word? The angular size of like those details you can see on the building, those are smaller than the obstruction, and that rules out the angle of attack where it's like a because of it being too like a blending of the water and the sky, the city.
Angle of attack as an excuse goes against the
very idea that because you don't see sharp edges.
Wait, it goes against the idea that flat earthers just see things because they're there. And then the next sentence, you have to make up a reason why you can't see things that are there. So I just wanted to point that out.
Well,
yeah.
Well, yeah, but I'm not making up anything about perspective. That's just the way it works.
Can you repost that diagram of it?
Sure.
That you have? Well, yeah. I want to make a few points about it.
Is this the Chicago skyline?
No, not that one. The person, the people. Here, let me find it. Go ahead again. Say what you're gonna say again.
No, I was just saying, were you guys talking about the Chicago skyline before?
We were talking about a variety. Yeah, we were talking about a variety of things.
This one. But he's saying that he was saying that the 60-mile line at the top is not accurate, because if you drew a straight line to where it would end up on a curved line, that it should be actually a shorter distance that we should be calculating than 60 miles.
But it's a shorter drop, but that is an obstruction.
How much shorter, Paulie?
Not very much, but I'm talking about drop.
Well, you've worked it out. You've worked it out, and you say not very much. It's 60 miles, so if you've worked it out, you should have that number off the top of your head.
Because I was trying to make it to scale, but my diagram keeps crashing because my computer can't handle.
Handle complex mathematics.
No, I'm using it in CAD and making it in whenever I am rendering this, or the lines, it's trying to measure what's the word? Render the smallest measurement that I have, and whenever I have a very small measurement, it just crashes the whole thing.
So you also too got angular size, don't you? It comes into all this.
And my point was that the angular size, the smallest angular detail you can see, is smaller than the obstruction.
Yeah, but the angular size too varies from the top of the buildings to the top of the buildings.
To
Right.
to the bottom, you mean?
Yeah, 100%. Yep, it varies.
The bottom
The bottom of the
would be
buildings,
closer.
angular. Yeah. So
That
the
would
bottom of
work
the
against
building,
your favor.
angular size should be less than the top of those buildings as well, because the
Yeah,
top of those buildings
It should be
further away.
no, because the top of the buildings are further away, so it
The
doesn't
angular
work in your
size
favor.
will be smaller.
The difference is going to be very minimal, but
It
would be.
doesn't matter.
Yeah,
Minimal.
top and the bottom doesn't matter,
Everything
mate.
comes into the equations.
I know, but I'm talking about the angular size of, like, let's say 1 foot at the bottom of the building is going to be larger than 1 foot at the top of the building, because the top of the building will be further away. But in that sense, the angular size being hidden would be that's being hidden is what's the word? Greater per feet. I don't know how to describe that.
Well, the angular size is going to be greater, so the top of the building is going to appear smaller than the bottom of the building, because it's further away.
So it's obstructing more.
Yeah.
So it's obstructing more in angular size.
And so I want you to weigh in on this. I just posted a picture.
Yep.
And we have a red line, a blue line, an orange line, and a green line. And the mile. This is just a model. A mile tangent across the surface of a globe, and then do you see all these colors? Now on the surface is a purple line. It says 1 mile distance, and the surface, that line is supposed to be the actual distance between A and B. Okay, on the surface, the purple is correct. Now, how do we measure from the top? Because the global calculator is measuring from a horizontal tangent in the sky, correct? And then it drops down to the surface of the Earth. So, would you use the green, orange, red, or blue line from the tangent to measure the actual drop at distance? Which one?
The drop. Well, the drop.
And this is based on the global calculator, the one that everybody uses.
Okay.
Which makes a parabola, which does work at 4 distances.
Well, okay, hold on. Now,
so which point would you go by to measure the drop? There's 4 different colors here. There's 5 if you include the purple, but we know the purple is correct because we know Chicago is X distance from our target. But then if we're gonna measure the drop as the global calculator dictates, which line would you go by?
Well, the base of the building, at the base of that orangey fat line that you've got there, that's the base of the building. Okay.
Yes.
So I'm looking straight out. Okay. And for me to see the base of that building, right, the distance would be, I don't
There's
know.
4 choices.
I'm probably gonna. I know. Yeah, I know. I'm gonna say the red line.
The red.
Yep, the red line. Yep.
That's the distance. That's the shortest distance between the line and the sphere.
Yeah. I'm gonna say the red line.
Okay, that's what Polly said.
Yeah. Godric was trying to insist that it would be the orange line, and I was trying to explain to him that the 8 inches per mile squared is not applying to that.
The orange line, right, would be the distance from the top of the building, right? So if you look,
that's assuming that the top of the building is going to be directly at your horizontal, which I don't think it would be tall enough for that. It's following the path of the top of the building.
Yeah,
that's the only way you can tilt backwards. That's why.
Yeah, which has probably confused me a little bit. But if we're trying to see the bottom of the building, right, which is what we're concerned about, the bottom of the building, not the top of the building. That
to the
distance
ground.
That distance, it would be the
red
line. The red line. Yeah.
And my point was that the yellow line is going to be shorter than the actual distance to the bottom of the building. Does that make sense? Because
what
you
yellow
would be
line?
following the surface. The yellow.
Yeah, let me explain further. So Benza, let me explain to Benza what Polly's saying is go back to the Glober calculator, which is a little bit up. What he's saying is the distance that we're measuring in the horizontal, which goes across from the tip of the globe into the sky like a ruler over the sphere. He's saying that distance of 1 mile, okay, doesn't hit the mile on the surface. So because of that, it needs to be a shorter measurement.
It's just clicked in my mind. Everything,
which is the red, and not the
This is what's happening. You helped it click for me, Bansaw. So when you were saying the orange line's the top of the building sticking out, I was thinking what? But yeah, so the building's tilted, and what flat earthers are doing when they study obstruction and drop, they're on a flat centric worldview, so they're measuring straight up from their up, and they're not measuring straight down from the tangent. So globers and flat earthers just do it completely differently, and that's why we're always debating for years.
Well, I think the most
probably a little bit. But I just want to jump in there. The most important point is that we're always trying to see the bottom of the building, right?
Yeah.
Which is at the base of that red squiggly line, that red lining, whatever it is. That's where the base of the building is. So
also at the base of the orange line, though, isn't it?
Yeah, it's the base of both. It's the base of both. But yeah, so you'd have to do a different calculation to work out where the top of the building would be. But see, we're not trying to see the top of the building. Yeah, and this is what's confusing about this picture to me. It's like these two big fat lines are buildings, right? That are tilted backwards, and we're not trying to see the tops of them at all. We're trying to see the base of those buildings, not the tops.
They're not that high, are they? We're just trying to spot them on the horizon.
Yeah,
my point regarding this was that whenever I see someone go 8 inches per mile squared and then they try to convert that to the amount there should be obstructed, they are trying to calculate the red line and then they use the wrong distance for the tangent.
Do they? I don't know what they try and.
Okay.
Calculate.
Well, I mean,
this is why I think talking about images, images really, like, and I can see the flat side of it. I think it's, to me, it's almost ludicrous. Right, because we're talking about a medium that we're looking through that you guys say there's refracting and looming, Fata Morganas and all this other sort of stuff, but then when we see the see something that we shouldn't, you throw in refraction, we throw in refraction, everyone does the same kinds of things without really knowing at all too much about the corridor that we're looking for, because the calculations that we use, right, for all these things are worked out over such short distances, like Godric was bringing up before about refraction and fish tanks, lasers in a fish tank with sugar water and stuff like that. We can demonstrate light being bent, and it fits these perfect equations on, but these are perfect mediums that we're testing these things in, which isn't the reality.
That isn't the only.
It made me think quickly. So we can agree that some light does move around in our atmosphere on both models, right? Because we both use it as an excuse. We must all agree it happens. We just use it as an excuse for different situations.
But the whole sugar water demonstration was just to demonstrate how refraction behaves in a gradient. The actual formulas for refraction through the atmosphere are based on measurements of
but that gradient that you're talking about, this consistent formula that we can apply something to, Paulie, right? This light is traveling consistently, right, through a medium, right? And consistently all the way along, right, it is changing and is moving through this medium. So it is getting refracted up and down all over the place. It is not.
The average.
Not consistent. Yeah, but see, this is what is wrong with calculations when we're taking long distance observations, right? These averages don't work in reality. We cannot calculate what we see. We can't do it. It's impossible. And anyone that thinks it's possible to calculate what we can see, I think is completely off their rocker, to be honest with you.
You
It's
can
completely off their
Hold on.
rocker.
And
You can
Paulie, your criticism is wrong as well.
With what?
With the when you say that the curve they're using the curve distance, not the straight distance.
Yeah.
Well, okay. So in a way, you are correct. But the thing is that the two distances will differ by like 0.027%. Like it's virtually virtually what's the word?
That wasn't my only
It really
point.
doesn't matter
And
whether you use.
I said that is a very minor distance. Difference. My main point was that they're using that drop to calculate obstruction. That was my main point. I understand.
I thought you said your main concern was that they used the curve distance, not the straight distance.
Well, I said that's for calculating the drop. They do it wrong as well, but that's a very minor difference.
Okay. Sorry, I misunderstood you then.
Look at the last picture I sent. Are you saying that the red line is the correct one? I'm sorry. Are you saying that the purple line is the correct one, and the globers
that is what the
orange line?
That is what
look at the last.
I'm looking at. That is what the 8 inches per. The purple one.
Did I do it right?
The purple one is the drop that you're calculating with 8 inches per mile squared formula.
Okay, so if it's such a negligible measurement, let me ask you this, Paulie. Is it important for this observation to happen that we're looking at with the Chicago skyline? Is it important that the light bends down or up for this observation to take place?
Down. Because it's following the surface of the Earth slightly. There's still obstruction, but
Bandsaw, you missed an interesting thing that happened before you came on, where Percentage was pointing out that it's interesting that if there's water vapor coming off the surface of the Earth, which there always would be because of evaporation,
effect.
Yeah, right. So and that would always be lighter than the air. Yeah. And according to the laws of refraction, if it goes through a less dense medium, light bends upwards instead of downwards. Mm-hmm. So therefore, anytime we're looking over the surface of water, we should actually expect the light to consistently bend upwards somewhat, depending on the amount of water vapor, right? But there's always going to be some, was his point. And then Ruhif was on. And he was saying, yeah, it's always going to bend upwards through a less dense.
No, he didn't say that.
Yeah, he did. He said it.
He said if there was
less dense in the air, if the water vapor is less dense in the air, it'll refract upwards. But
he said,
but then the pressure gradient makes a difference.
No, hold on. The overall density, if it was reversed, then yes, it would bend upwards. But that is not the case. You can measure the pressure difference at different altitudes.
Well, you kept saying that, but you didn't address the problem, which was that if we always have water vapor,
because the water vapor
is always going to be less dense.
There's
always going to be a less dense layer. There's always going to be a less dense layer on the surface.
But the water
than
density.
The air.
Hold on. The water density is not equivalent to the overall density of the air plus the water. And that
wasn't the question though. Is that there's always water vapor at the surface. There's always going to be a layer of less dense water vapor at the surface.
That will lower
no matter what.
That will lower the average density of that air, but that is not going to change the pressure gradient. The density gradient is what we should say.
Yeah, but then the point that Percentage kept making, Bandsaw, is that the
he's
pressure
assuming that the water
is created by the hold on, cut me off. The pressure gradient is created by the density, right? So if that's the case, the contradiction seems to be that we shouldn't expect water to bend downwards if there's always a little bit of a lighter, denser air right at the surface.
If there's less dense
air.
Water, air plus water at the surface, then we should see the reverse of what the barometers detect.
Well, you failed to come up with the barometer testing that showed the surface.
I showed some averages of measurements from.
Yeah, that was the best you had, but it didn't really test
hold on,
Percentage or I.
really quick, hold on.
I'm just explaining to you what happened.
I know what happened. And again, barometers work over water. Do you agree?
I'm not arguing anything about barometers. I'm just saying it seems to be an inherent. I'm not even saying that percentage is right and you're wrong. I'm saying it seems to be a logical contradiction that there will always be water vapor because there's always evaporation. So how could you ever say that there's more dense air causing it to bend down when we know it has to be less dense due to the fact that there's always going to be water vapor? That was a good point. You're dictating that. That's all I'm trying to. I'm not even arguing with you right now. I'm just telling Bandsaw what happened with the point of the contradiction that percentage pointed out, and his claim was we should always see the water bend up, the light bend up to some degree, because even if it's just 1% evaporation or very little evaporation on certain days, it's going to be some evaporation, which is which creates a less dense water
medium.
Less dense medium. So it should always bend upwards to some degree. These guys had this guy, and then Rui have left without arguing. He just left.
I don't know about you, Dave, but I actually find it quite almost bordering on arrogant, but I'm going to call it arrogant to say that we can mathematically calculate what we should and should not be seeing. It's borders on arrogance.
We can get a rough.
No, we can't
hold on.
get.
We can get an average. We cannot. Yeah, we can get a rough idea because we know how.
Depending on the day.
We want to talk about photos. I just posted one. Okay, then. So we've got windmills, right? We've got 6 windmills, right? One at 8.4, 8.8, 9.3, 9.8, 10.8, and 11.2 miles away. And I can see the bases of all those windmills in that photograph, and I can see the horizon clearly behind those windmills. So you want to get arrogant about your calculations or all that sort of stuff. You want to put it down to refraction and say that you can calculate, and this is the exception to the rule because we've got refraction and it's lifted up, so now it's hitting my eyeball and we can see it. Like, it's absolutely ludicrous to say that you can mathematically bloody well calculate anything and put these calculations on.
That's correct.
For things that we can and can't see. Like,
That's
you haven't tangibly measured it at all.
That's correct, Benson. Let me say this. This is the Rampion windmills. Hang on. This is the Rampion windmills from in England, off of England.
Yeah.
And this is a measurement done by several people over the water. It goes 8 to 11 miles, and there is no curvature on this observation. And I've done this presentation, and no one has ever even tried to debunk me. All they can say is refraction. But like you said, they can't measure it, they can't show it, they can't demonstrate it. We're looking at 8 to 11 miles of distant observation with no curvature. So this is like one of the best. This is one of the best.
The beauty about that particular photograph is that every single windmill, you can see the base of them. You can see the base of every single one of them. That's the beauty about it.
I have a presentation about this. I'm going to add your picture, which I didn't have that, your measurements to that presentation because it's awesome.
Again, going back to the assumption of upwards refraction, we can find if it's upward, should be upwards or downwards because we know about the density gradient. We can measure that. And my point again is that there is a downwards refraction. There must be one because there is more dense air plus and water vapor. The water vapor is a factor. But the issue is that what percentage and New Perspective are arguing about, or argue, their point is wrong because it is assuming that the water vapor directly is the density of the overall air and the water vapor together, when it's not. It's measurably not.
So well, no, the water vapor is always going to be less dense than air, right?
Yeah, and when
but that affects the average.
When you're working out these calculations, whether or not it's for the photo that I posted, the one that Dave posted, any photo that's posted, right? What things are you taking into account? And then when you tell me what things you are taking into account, I'll tell you. I'll respond and I'll tell you what you aren't taking into account.
Which like what do you mean by that?
What are you taking into account, right, to tell me what I should be seeing in that
I'm
photo?
telling you that it would be
Right?
a downwards refraction.
I know what you're telling me, but what are you taking into account to make this calculation, to make this prediction?
I mean,
I am seeing what I am seeing because of
again,
these things.
Again, I'm simply
how much information are you using to tell me what I'm seeing?
Well, you can figure out that you can measure the difference in height at different densities, and that would mean that it's curving downwards. Is my only point. And how much so depends on specific conditions, but those are almost impossible to simulate perfectly. In which I do agree with you in a sense that you can't find the very, very, very specific. What I will tell you though is that you can calculate how much using a simulation. You can calculate the difference in how much overall the path would deviate in angle. Let's say. So like, I will say that you can kind of reverse it in a sense, in the way like you can figure out the overall angle that the path would need to change to match.
So in that simulation, how many variables do you put in that simulation that you're accounting for in the simulating?
It's just the overall refraction deviation. So
exactly right. So you're applying one simple calculation
but again,
to the whole image that I'm
but
looking
again,
at.
And again, I'm just telling you that that is how you could say, okay, well, in order to match the like to be accurate with the globe, or like for our observations.
Right.
Hold on, but hold on. When I talk about downwards refraction, though, we can determine if it's downwards or upwards based on the density gradient. And I'm telling you that you can measure that it should get curved downwards. I can't tell you exactly how much because it won't be an it won't be precise.
Okay, let me answer when you're done. Let me answer when you're done, Polly. Are you done?
I'm not done.
Hang on. I want to say something.
I want to reply to him, Godric, because I said
Can I say something first?
Right, jump in.
He has no idea how to measure it, nor can he measure it. He's just saying that you can measure it.
Measure what?
No way he can do it. There's no way he knows how to do it.
Which measurement are you talking about?
Do it in real life.
Godric, which measurement are you talking about?
This refraction you're talking about. That must be happening.
Anyway,
I'm telling you that I can't measure the
You can't. You can't.
Hold on,
get
I'm
any
still.
Godric, don't make those accusations in the middle of Bansod trying to reply to the whole point.
Okay, now go, Bansod.
Yeah. Now, okay, then I'll tell you what you're not taking into account, right? You're not taking into account everything that is through that corridor of vision.
I didn't say that.
Everything. Okay, and this is what, and this is why I'm going to tell you why it's absolutely ridiculous to think that you can make any sort of predictions and calculations to match your globe model, which is what you do in a simulation. You try and match it, and it marries
again.
And this is what you don't do. All right. So let me finish, and then you can respond to me. All right. So we have a corridor of vision that is over water at the moment. Right now, firstly, you haven't taken into consideration the depths of those waters, all the different temperatures of those waters, which is going to affect all the different evaporation all the way along that corridor. Right, all the different pressures all the way along that corridor, the wind speeds, all these type of things, different gases that are in there, whale farts, you name it. I could list off a billion different variables that you do not take into consideration, and to think that you can apply a 7/6 refraction calculator into your simulation is absolutely ludicrous. And I don't see why you can't actually see that it is a ludicrous proposition just because it meets your model and marries up with your of this curve
again
amen
is absolutely ridiculous.
Because you're misrepresenting what I'm talking about.
No.
Yes, you are, because I told you multiple times that you cannot know like all the exact conditions. I am telling you, however, that the overall direction will be downwards based on the fact that it is measurably more dense towards the surface, no matter even accounting for humidity and temperature. And again, with the simulation I'm talking about you can calculate how much the overall angle the path would change over that distance. I did not say that you can calculate that angle based on, measuring every little tiny point. Which was, again, my point that you can calculate the overall deviation the light would take, but you can't calculate every specific point.
You
And-
don't even know the speed of light over that distance, Paulie. You got no idea even what the speed of light is.
I mean, you could say that's about a number. The difference
Yeah.
between when you measured the speed of light in like normal air and then in a obviously not a perfect vacuum, but somewhat of a vacuum, the difference is very minor, and that doesn't really affect this.
There are huge differences in the speed of light. The speed of light in a vacuum is 300 kilometers per square second. The speed of light in water is 225,000
Talking about air.
meters per
Talking
second.
about the atmosphere.
And the air and the atmosphere is made up of water molecules that it is constantly going through. So
You realize
it is constantly slowing down the more it moves through that air. So the more it slows down, right, the greater effect it's going to have.
You're taking the slow down as if it's constantly slowing down.
Of course it is.
So no, because if you measure, it doesn't matter that. So if water was slowing it down, like what's the word? Totally, like light, whenever it exits the medium that it's slowed down in, will go back to being full speed.
Really?
There's a difference between saying that something is slowing it down and that it moves slower in that thing.
Yeah, that's what I'm trying to say.
Light doesn't get slowed down; it just moves slower when it's in that medium.
And I can find an illustration of this.
Oh my goodness!
Hold on.
Playing word games with me.
No,
Gummy.
hold on.
It is going through a medium. That medium is slowing the light down.
Hold on.
All right?
No, it wasn't slowing it down. It was just moving slower through the medium.
Yeah.
I know.
Good, Ben.
Paulie, when you're done, I want to reply. When you're done, Paulie.
Okay, then. Hold on. Let's go with this ludicrous idea, right? That the medium is only slowing it down. So then all of a sudden, right, it goes through less of a medium. Or does the light speed up again, Gummy?
Yes, because again.
Really?
Hold on. Wait. Bandsaw.
Citation. I need a citation for that. No, hold on.
I'm trying to tell you. I'm trying to tell you what experiment shows that. I mean, I'm going to try to find it again. But if you put lasers through a crystal that makes it go slower through it. When we say slow down, we mean whenever it enters that medium, the overall speed it takes to travel through that medium is slower than it would be.
No way. That's what you mean by slow down?
Yes, I'm explaining what that is referring to.
Okay. It just sounded like
I think Bandsaw.
When we say slow down, we mean that the light is moving slower.
Well, I mean in the sense that Bandsaw thinks that light slows down the more it goes through the medium. Does that make sense? Would you agree there?
Of course it does.
And that's not true that's not true in the understanding that everyone has in mainstream science.
And I don't care. I mean, it is going through a medium, right? The medium is going to have an effect on that object, right? That is going through it, and it is.
So you guys are saying there's a constant to that slowing down?
Yeah, no, that's what Bandsaw is trying to say.
What we're saying.
No, I thought you were saying that he was saying that it actually keeps getting slower.
Yeah, that's what he was saying.
So what we're saying.
You're saying there's a constant. It doesn't keep
so
getting slower.
let me give you a quick example. So let's say we somehow have air and then water and then air. Now, when it's in air, it's almost speed of light, like c. When it enters the water, it slows down to like 70%, and then when it leaves, it's back to 100%. It's not like full C and then it slows down while it's in the water and then whatever. It's 100%, 70%, 100%. It's It never goes slowing down and then going faster. It's just hops between 100%, 70%, 100%.
And
that's not 100%.
So
Well,
I want to rebut when you're
so
done,
for
guys.
is light isolated from, I don't know, is it one of those Einstein theories that something can energy can never be destroyed nor created, or whatever the case may be? Like, how does this light, right, create energy, right, to once again speed up after it leaves, right, the
well,
medium
Okay,
that
so
it has traveled through, right, to then again speed up again? How does it do that? Light is completely different to everything else, is
no,
it?
so one example that you can see with another example where this actually happens is when you speak. Now the air has a certain speed of sound, and then let's say you have a piece of metal in front of you that's resonating with that. The speed of sound in metal is actually faster, so your voice actually goes slow in the air, then fast through the metal, and then when it leaves the metal on the other side, it'll actually go slow again. It is the exact same kind of thing with sound waves. And you can actually see the same thing with waves going through liquid. If you have a wave that's going through water and then goes through a more viscous liquid and then back to water, you can have this exact same kind of thing. This isn't some magical thing that only happens with light. It happens with all kinds of waves, sound waves, waves in water, all of these things, mechanical waves.
Okay.
And also you can measure that the speed of light speeds, well, I'd say speeds back up, but it goes back into that faster constant through air. When it exits the medium, it moves slower.
So the speed of light through a vacuum compared to the speed of light through water, for argument's sake, which is a dramatic difference.
Yeah.
Right? They've measured this in a vacuum. Now I presume that these are only small areas that they have measured it. Like, have they put a laser beam down the bottom of Port Phillip Bay and shone it from one side of Port Phillip Bay to the other, all the way through water, right, to measure what the speed of light is when it gets to the other side? Have they done those sort of experiments, or
Well,
have they just measured this slowing down of light through, say, a fish tank full of water? That'd be my first question.
Well, there's lots of experiments that measured it, but one of them I found was they measured it over like a mile, I think. I don't remember. They used mirrors to make the basically bounce around through a vacuum for greater than a few miles to measure the speed of light.
They had a vacuum a mile big. Where's this vacuum a mile big?
It's like more like a tunnel. I can find it again. I can try to find it.
They have a vacuum. They have a vacuum that is a mile long.
It was what's the word? It was like a tunnel thing.
So it's a tunnel. It's not a vacuum.
Well, it's a tunnel, but it's not like a large open vacuum like a square. I'm saying it's like a tunnel that they made. That is a vacuum. I can try to find it again for you if you want.
This would want to be some impressive tunnel. Even a small tunnel would have to be pretty substantially built, right, to create a vacuum inside of it. Otherwise, the thing would collapse on itself.
Yeah.
Okay.
That's correct, Bamsaw. And let me respond now because I'm going to turn in for the night, guys.
Yeah, go for it.
You guys can rebut this if you want when I'm done, but like this whole thing about refraction, bending light down, that's a completely wrong example for your model. That will not get you over a curve. That will not let you see over a curve. Okay, because if you're looking from A to B, let's say to Chicago from Lake Michigan, right? If you're saying that the atmosphere is denser on the ground and light will bend down, that won't get you around the curve. It only gets you basically to see a straight line, and then you see right into the ground. What you'd have to do to see over a curve is that light would have to stay in the exact distance, in the exact same distance from the ground. So it would have to go through a medium in a perfect curved line. It can't go up and it can't go down. have to stay in a perfect curved line to see around this curve, and then arrive at your target. So if it did go down, it would just go into the ground. You wouldn't see distant objects at all. So that whole thing about light bending down completely destroys distant object observations.
That's not true whatsoever. Just look at the simple or not demonstration. What's it called?
Just take a ruler and draw a line downwards from your eyes downwards, and you'll see that you can never get that over a curve. It will never go over a curve.
Look at the very simple drawing in chat, and you can see that by it bending down, it can go further along the curve. It's very simple geometry. I don't know how you're not.
Is this Gummy Bear?
Yes.
Where is it bending down? I have a round Earth in blue.
Let me find another. That was
where are these lines
the first
bending down?
thing I found.
This is not working for your model.
It very much is. I'm not sure how you're not seeing this.
It's not bending down.
How is it not bending down?
You're not seeing distant objects with these light rays. The way you can see around the curve, like I said, it couldn't go down or up. You'd have to keep it at the same, let's say 6 feet above the ground, and the light would have to stay 6 feet all around your curve until you finally met this distant object, right?
And if that were to happen, that would be the same.
Completely destroyed.
If that were to happen, that would be the same as saying it's bending down.
No, it's not bending down. It's not bending. If it's going around the curve, it's staying in the same distance from the Earth to your object. Bending down means it would go into the ground, not bend in the C form. It would just go straight, like a ruler straight.
Right.
It wouldn't curve because the atmosphere, right, is heavier at the bottom. Correct.
So you're saying that none of these pictures. I hate
you wouldn't be able to get around the curve if it bent down. That's what I'm saying. The only way you can get around the curve if it stayed in the same medium. That would get you around. You'd see farther that way, right?
Are you saying that these circles? Are you saying these circles don't curve?
Do you have another observation?
Are you saying these circles aren't curved?
Listen, pay attention. These circles do not go down. They stay in the same distance from the Earth, in the same medium. They do not go down even a little bit. That's why your whole thing is debunked.
So does that mean they're not curving?
They're curving, but they don't go down into the medium.
And what's the direction of curvature?
It's in the same distance in the medium. They're not going down.
Just follow the question. What's the direction of curving? Because it is curving. You agree on that. What's the direction of curving?
It does curve, but it stays the same distance from the Earth.
So what's the direction of curving?
If it went down, it would have to angle down. There's no angle. There's no place where your light gets closer. Hang on.
Avoiding the question. What direction is it curving?
There's no place where your light gets closer to the ground in your circular example.
So what direction is it curving? It's a simple question. What direction is it curving?
If in your example, your light is curving around the globe.
Okay.
But staying in the same distance in the medium, not going down.
So what you would say is it's curving inwards, right? Do you agree on this?
It is curving around in your example. It's like curving around the globe, but they're not going into a denser medium. They're staying in the same level of medium.
Is it curving inwards or outwards?
It's curving around the globe.
Is it curving inwards or outwards?
Your light rays are staying in the same density of medium.
So you're completely unable to interact with my question because you know that it shows you're wrong.
Just confirm it's the same density. Just confirm it's the same density. A circle will not get you closer to the Earth. It's the same density.
What direction is it curving? It's curving inwards.
In a circular shape.
There you go.
In a circular shape.
Inwards.
So never going into a denser medium.
curving inwards, is it not?
Listen, it can't go down and it can't go up. It's like a plane going around
curving inwards
your
or
psychological,
outwards?
like a plane going your psychological ball. It
Is
can
it
never
curving inwards
go
or
down or
outwards?
up. If it went down, it would crash.
Is it curving inwards or outwards?
It's going in a circle.
Is it curving inwards or outwards?
It's going in a circle.
Inwards or outwards?
Your argument is that it's going into a denser medium. But as you can see, your circles are not going into a denser medium. They're staying in the same medium.
Is it curving inwards or outwards?
It's going to the same medium.
Why are you unable to interact with the question?
Because it's a non sequitur. You're asking a different question.
Is it curving inwards or outwards?
Is it curving into the circle or outwards?
It's just an object. It's not. That's the thing. The circle is not curving down to the sphere. It's staying around the sphere, never touching the sphere, not going higher or lower. So to see this an object, and to say that where it's curved, the light's going through a denser medium, it would just hit the Earth. It wouldn't go farther because it's going down. It would go shorter. Your observations would be much shorter because it would just go right into the Earth.
Okay, on this picture, you can see
it would never go
lines,
around. It would never stay in the same medium.
Both lines from that lighthouse are from the same spot, but the straight line is hitting the ground before the curved line because the curved line is bending down around Earth. So the curved line you see further.
Did it occur to you that we'd see farther on the flat plane?
What does that have to do with what direction that curve?
Why are you again incapable of interacting with the point? I've shown you a picture. I've asked you a question about it, and you're diverting again. On the picture, you can see that the light. So the two lines, they're equivalent of where the light is moving.
Okay, so let me
they
explain.
Start out on the lighthouse. Both lines start on the same spot on the lighthouse, but the straight line hits the ground before the curved line because the curved line is curving around the Earth and it can be seen from further away.
Right, so it would just go down like the first line. That's my point, like the ruler. That would be going into a denser medium.
Both of the lines are going into the denser medium, but the purple line is curving like refraction does, which shows that it reaches further than the straight line.
Okay, but this is my whole point. This is my rebuttal to your argument. It wouldn't curve in a circular motion. It would just go straight down. There'd be no curve. It would just go straight down.
That's not how refraction works.
Denser medium.
That's not how refraction works.
I guess then you'd have to show me a laser beam curving through a real medium without a fish tank, without sugar water. And
so is water not a real medium?
Water's a medium, but there's no fish tank between object A and object B. So that's the fallacious example.
Because you just said I need to show you an example with a real medium, but not one with a fish tank.
A real observation, no science tricks.
The butane experiment.
No science. A real experiment, no science.
A real observation with no science. No fish tanks, no sugar water.
By making the observation,
obviously that doesn't happen in reality.
By definition, science. Because you're changing.
You get that right. You can do a science trick. I could blow a blowtorch and get some refraction. So we don't want to do blowtorches or butane gas in natural observation.
The medium is now what matters. It's the density.
Trying to see distant objects. So it would have to be a natural. So you'd have to shoot your laser through a natural observation and tell me if it's either curving or going straight.
These experiments that are done, Gummy.
Yeah.
To work
and
out.
I'm done.
All right, Godric, you done?
Good night.
All right, Godric, catch you later.
Thank
you. These experiments that are done, because I've kind of opened up that link that you kind of gave me, and I was having a brief look. about how photons are swallowed up by particles and then create new photons, and they kind of spit them out. But anyway, but these experiments that are done to work out refraction and all that sort of stuff that you're applying to all these diagrams, not only you but everyone applies them to these diagrams. My question is the experiments themselves, right, whether it's the laser in the fish tank of sugar water, whether they're in vacuums, whether they're in a container full of nitrogen, whatever the case, they're all done over planar surfaces, aren't they?
In what
Not
sense?
necessarily. Like, depends on what. Yeah, like in what sense do you mean over planar surfaces?
Well,
Like,
they're done in straight tubes, straight fish tanks, straight everything. Nothing's done in a curved medium that apparently the Earth is, right? That you say, like as you say, you know, big sphere, medium is spherical. It's always curving all over the place, right? So none of these experiments that I see actually apply to what you're saying that we should see, because none of these experiments are done around a spherical surface or over a curved surface. They're all done over planar surfaces, and you are applying these experiments to a spherical object. That's what you're doing. And I don't think you can compare the two. And I would like to see an experiment that is done over a non-planar surface to say that it is even slightly closer to the same. I think that would be a fair request, personally.
well, when you say over planar, so for example, if I were to do an experiment where I have a curving tube and I shine my laser through that, is that like enough to say it's not a planar surface, or I'm not quite sure what you're.
Well, are you going to get the light to be able to bend around that curved tube, for argument's sake?
Yeah, sure. So let's say I create a curve, a curving tube of water, and it like the entrance is 90 degrees off the exit, so it's a full
Can we put Dawn
turn
on
like
a tricycle somewhere in there?
like, and then
Please.
you shine light in through the one end. Is that enough to say it's not a planar experiment?
Well, you're able to show this curving light in the sugar water, right? Which shows this beautiful curved line, okay? Which apparently, okay, and let's just say this curved line, right, meets all the 7/6R mathematical equations, right?
Yeah.
Can you show me the same perfectly curved laser line that has been done over a spherical surface? Because my point still remains that all these experiments are done over planar surfaces or planar environments, whether they are fish tanks, tubes, whatever the case may be.
Okay.
Nothing is done over a spherical or curved surface, from what I can find. And I've actually asked this question many times, but I can't find it.
So so another example then, say I have a fish tank, and then I put this little curved ramp in the bottom. So essentially the bottom of the fish tank is now curved. Is that enough to call it not planar?
I think the issue here is that you need it to be longer so that assuming the Earth is a globe,
and
hold on, wait, give me just a second.
Yeah.
I just want to explain something. The surface is not going to dictate, like if you put a hump in a small fish tank, it's not going to make the density gradient curved.
No, but the medium that it's traveling through has to be curved, Paulie.
If it's following the Earth's surface and the Earth is a globe, then it would be curving.
The medium it is traveling through has to be curved. So if you were to fill up a fish tank and put a curve on the bottom of it and then fill it up with sugar water, that medium ain't going to be curved.
I know, and I'm saying that you'd have to make it a few miles long to follow what would be the Earth curvature in order to have the density gradient be stay at the same altitude.
That would be begging the question, right?
That's with a
Well,
fluid,
no, but
fluid density gradient.
Even if the Earth is flat, it would still prove that whatever whatever shape the atmosphere is still bending downwards.
The thing is, that's for a fluid density gradient. You can create density crystals or prisms that are like that, what you're saying. I'm not sure if that would even qualify to what you're saying.
Well, a prism isn't a curved density gradient like what we're told is around the Earth, is it?
No, you can create you can create gradient index prisms, as in they have like denser at the bottom than at the top. And if you want to, you can make one that's also curving.
You know my question, Gummy, right? You know exactly what I'm saying. And then Paulie jumped in there and said, well, the only way to do it is doing it over a couple of mile or a couple of kilometer, probably mile.
Well, I'm saying if you're doing it with I'm saying if you do it with like water or air to make it follow the shape of the Earth, you'd need over a few miles, at least to be a major curve, if that makes sense.
A major curve? Well, you can get a minor curve in a fish tank.
Yeah, I'm saying that whatever shape of the Earth, like if it's flat, it would automatically be flat, and if it's curved, it would automatically be curved. So I'm saying that if it's downwards, no matter what, that is something we should expect.
So can you get a curved or spherical density gradient on a small scale? Say in a fish tank?
I mean, if the Earth is a globe, then it would automatically be doing that. It would just be very, very tiny amount.
I'm talking about showing an experiment.
I know, and I'm saying that it would be so minor of a difference in a fish tank that you wouldn't be able to tell the difference.
Okay, then. So, but this major difference that we can show in a fish tank with sugar water and stuff, we can apply these refractive indexes that have been conducted over a planar surface, right? And we can apply these to a spherical surface. Which I think is which I think is wrong. Right off the bat, that experiment is flawed right off the bat.
Well, if it's following the curve, then it is going downward in the curve.
Well, you don't know. You don't know because you've never conducted a curved or spherical experiment to demonstrate this. You've only ever conducted planar experiments. That's all you've conducted.
I'm telling you that even curved versus flat in this case of a fish tank would be so minor it wouldn't make a difference.
Oh, so minor. That is just not an honest position to take, to say that we can conduct things over a planar surface and we can apply it to a spherical surface.
I'm telling you that if whatever surface of the Earth, whatever shape the surface of the Earth is, it's following. It's going downwards in that same fashion. So if the Earth is a globe, it's curving downwards. If the Earth is flat, it's still curving downwards.
You can't say anything about the rate of refraction over a curved surface because you've never tested for
it. If you had a mile long fish tank and you had a horizontal line as the halfway point from one end to the other, and then filled the fish tank a mile long to the water line, you could see all the way along the water line, the water would be plush with it to the surface.
And how would you measure? How would you measure it horizontal?
What did you just say?
I love that word, plush. I love it.
And do you know how many? Do you know how many degrees you would expect the start to be off from the end over that 1 mile?
Yeah, we should have a drop of.
It would be 0.015 degrees of difference.
Over 1 mile. Over 1 mile.
Yeah.
Over 1
0.
mile. Hold on. hold on.
Yep.
From 1 mile from the very center, right, to the very end, right, we should see 4 inches of drop.
Yeah, but
or
there's
the
no need.
equivalent is 0.015 degrees.
Yeah, but see, I like the way you did that, Gummy. I like the way you did that because 4 inches is very, very, very easily measured.
No,
Right?
not
guys-
over a mile.
But how do you,
100%.
Yo, please, man.
Go
come on.
Fleric, go Fleric.
There's no need to expect any drop. It's a fluid. It will display a level surface. It's a fluid. There's no drop. It's a fluid, man. Come on.
When they say drop, it means a drop from horizontal, not a drop from vertical or level.
But
Yeah, right.
measuring
Still you have
Gummy,
drop, right?
yeah, contradicts it.
No,
the
that's not
liquid,
contradicting.
The liquid dictates.
No, because on a globe, horizontal and level are not the same.
And I noticed what you did there, Gummy, by going, do you know what we'd expect to see is 0.000032% of a thing to make it sound very, very minute, which is exactly the same, right? It's
In a
exactly
fish
the
tank,
same.
a little one.
Yeah, which is exactly the same as you guys turning around and saying, you know what? It's not 1,000 miles per hour at the equator. It's only 1 rotation per 24 hours.
Brilliant.
Right?
Yes.
It's exactly
because
the
it's
same word. It's exactly the same word games. How you try and make things sound so minute.
Have you considered that maybe you're doing the word games because the map?
And what Merle just said about his mile-long fish tank, because the example was a mile-long fish tank, right? That's the example that he gave. And from one end to the other, from the middle, you should be able to register 4 inches, right? Which is the width of my hand.
And how are you going to measure that difference?
With my hand. I'll measure
over
with my
a
hand.
mile.
I'm asking you, how do you measure that it is different? There's a 4-inch drop. How are you going to measure that?
Merle gave the example of a fish tank, and you draw a perfectly horizontal line from the center, and then you fill it up to
How
that
are you going
line.
to how are you going to measure
How do you
that?
draw? Wait, no. How do you draw a perfectly horizontal line?
It was a bloody hypothetical.
Yeah, but
Gummy.
it's like
the question is, how do you draw a perfectly horizontal line over a
You just
mile?
find the midpoint.
Over a mile.
Follow it to the other end.
I'll get a builder's line. I'll get a builder's line, and I'll snap a line. That's how I'll do it.
Do they work over a mile? Do they work over a mile?
Seriously, go Crypto. Jump in, Crypto.
Yeah, surely a more pertinent question would be: is if you can't measure it, see it, find it, how do you know it's there? Like it's not like,
that's what we're asking you.
You just couldn't find it because reasons. Right, this is kind of a scale fallacy, right? It's too big to see. Okay, cool. If it's too big to see, how do you know it's there in the first place? That's really the question you should ask.
But we didn't say that. We said, how are you gonna we were telling you that you can't measure 4 inches.
Doesn't matter who's doing it.
Of course
the reason we know it's there.
How am I going to do it? Doesn't matter who's doing
again,
it.
The way we know.
Hold on. You guys are talking 9 miles an hour.
You're talking through me, so I can't be sure that you've heard me if you're talking through me, right?
I
You're
heard
asking
you
questions and then not letting anyone answer.
That's fantastic. That's amazing. Doesn't matter who's doing it. What matters is if it can be done, right?
I told you it can't be done. We said that it can't be done. We said you can't measure that 4 inches because there's no way to measure it. Unless you're assuming that you drew that horizontal line somehow with a vacuum. That would be the only way to do so.
Not assuming anything. I'm asking
with a vacuum.
I'm saying the only way to determine the horizontal line would be through
Crypto,
one which refraction is an issue.
Hold on, Crypto, you're really low, buddy. That's probably why you're getting talked over. I just heard you in the background there. That's probably why you're getting talked over.
Fair enough. I just think that they're ignoring the question. Like, if you can't measure it, how do you know it's there? It doesn't matter who's measuring. Doesn't matter. Like, I'm not making any assumptions. This is a very basic question. If you can't measure it, how do you know it's there?
And the answer is we don't do the measurements over a 1 mile long fish tank. That's the answer.
And again,
Go ahead.
We didn't say that you could determine that 4 inches. We said you can't.
Well, then have you there? You're not answering the
Hey,
question.
yo, dude, they're all brain dead anyway, dude. Let's not even deal with it. It's like, it reminds me of like Jen Psaki, like got asked about like Hunter Biden's laptop, and she's like, he doesn't work for the United States. Next question. Like,
Next question, please. Next question.
Okay, now it's just going to ridicule.
Seriously, it's like,
insult.
whatever. What up, Chris? What up, Bandsaw?
You guys are.
Hey, buddy.
Shut up, bro. Nobody cares.
It's just like you haven't measured the refraction of light over a sphere or a curved surface that has a medium that is curved as well. You haven't done it
kind of strong
because you can't do it. You can't do it. All right, it's exactly the same thing. Right?
I didn't
you
say
say
you
that
can.
well, then do it. Where's it been done? Because if it's been done, I would like to see the evidence of where it's been done, how it's been done, who did it. Show me the paper. Show me something. Show me an Instagram pic of it. I don't care what it is. Just show it to me because it hasn't been done, Paul.
Gummy bear. All you've got to do, Gummy bear. All you've got to do is just walk 10,000 miles in one heading, and then make another right. Make a 90-degree turn, and then walk another 10,000 miles. Then make another 90-degree turn, and walk another 10,000 miles. And when you come back to the same location to prove the globe, get at us.
So I would walk 500 miles, and I would walk another 500 miles.
No, it's 10,000 miles.
I will walk.
You got a long way to go.
This kind of you guys are going 9 miles an hour and insulting and trying to ignore it.
10,000 miles. It's 10,000 miles, and you just got to make a 90-degree turn, and you better get started right now.
But here's the question. Here's the question. What kind of tool do I use to make sure?
No, 10,000 miles, gummy.
Yeah, but how do I make sure it's a straight line? How do I make sure it's a straight line?
That's up to you, bud. You can figure that out. Just get going on it.
You get a builder's line, you snap a line, and you follow the line.
Why don't we get 8 people in there?
Yeah, just build a fish tank. You're heading in the right direction.
We need roof here for the mile-long fish tank, mate.
Gummy Bear, do you still think that air escaping into a vacuum violates the second law of thermodynamics?
Just some air? No, of course not. But expecting all the air to just suddenly do it? Yes, that is.
Okay. So if I could demonstrate air filling a vacuum, like what do we do then?
That's not.
It's going to
what that
depressure
means.
something else, isn't it?
Air will fill a vacuum in most circumstances here on the surface of Earth. Yes, that's true.
Yes, in all circumstances, yeah.
But that's not the same as saying
Crypto, what
air
divides
would escape into the vacuum of space instantaneously for no apparent reason.
Crypto, what divides Crypto?
You're chopping in and out, Crypto. Hold on, you're chopping in and out, Crypto. You've got bad reception, buddy.
And I find it funny how he says for no apparent reason, as if.
Crypto.
Yeah, what's up?
What is dividing the more dense air at the surface of the Earth and the less dense air higher up in the atmosphere? What is dividing that?
I don't care.
And that's the problem. If you don't care, then why are you even talking about it?
Well, no, because you made the claim
I could state
is
that
contrary to everyone's experience.
Hold on. If I could claim, okay, if I have a less dense container next to like a higher pressurized system, and I open it. Hold on. I'm still talking. You guys can't stop for interrupt.
Gummy-based claim. Because you obviously don't understand the context, otherwise you wouldn't be coming at me with a red herring.
I'm not coming up with a red herring. I'm coming at you with a...
And I know it's a red herring because I know the context because I brought it up. Okay? Now, this is why it's a red herring. You don't seem to be interested why it's a red herring. This is why it's a red herring, because Gummy Bear said that air escaping into a vacuum violates the second law. This is what he said the other day in this VC, right? Do you agree with that?
In what sense?
So he's saying that Earth, we have the atmosphere. It's contained by gravity. If air just suddenly, if air just suddenly rushed out to the vacuum of space, well, then the entropy would be decreasing, which is a violation.
Crypto,
You'd have an increase of. Yeah, go ahead.
Really quick, Crypto. I have a question. So if you hold on, wait, please let me answer. You know those.
There's a question on the table that you're walking past. So
I'm
that's
trying
why
to answer by asking you questions to determine things about containers and forces.
I'll have to insist that you actually answer the question. Do you agree with Gummy Bear?
What's the statement one more time?
For fuck's sake. This will be the third time I've said it.
Go ahead.
You listen this time, yeah? Okay, so Gummy Bear is of the impression that if the air of Earth filled the vacuum of space, that would be a violation of the second law of thermodynamics. Do you agree with this statement?
I would probably agree, yeah, because it wouldn't.
All right, fine. There's no point talking to you guys then. No worries.
The entropy would be decreasing in a closed system, which is it was just breaking the second law of thermodynamics.
I would like to get two things across here. Crypto, you are avoiding them. Again,
I'm not avoiding anything.
Hold on. Can you just listen for like 2 seconds? All you guys do is insult.
Nobody gives a fuck. We've heard everything you're going to say from Google. We don't get it.
No, I didn't Google.
No, actually,
I'm
you don't even have to say it. Check it out. You don't even have to say it.
Okay, then tell me what I'm going to say. Tell me what I'm going to say, Issa. You guys are rude as fuck, and you can't shut the fuck up in a second.
Let him right? You don't have to poison the well before you even ask the question. I'm obviously going to leap in if you do that.
All right, let him get it out though. Let him get
I'm
it out.
trying to ask you a question. Can you tell me what question I'm going to ask?
Just ask her, please. Just ask her, please.
But I would like not to poison the well before you do it. So please go ahead.
Again, I'm trying to just get a sentence out.
Go ahead.
Or multiple. If you swing if you dump a container of water upside down, it's gonna fall, right?
Right. Yeah.
Okay, so if you spin that container, rotate it, and you use centrifugal force to keep it in the container, is the force then pulling? Is it making the water, preventing it from coming out the top?
So you're talking about the forces acting from the bottom of the container on the bottom of the water, right?
Well, in terms of the centrifugal force is making the water stay, keeping it from escaping. Yeah.
So you're swinging the bucket, and instead of it just kind of pouring out because there's a force acting,
yes,
outward.
So the force is pulling on the said thing. And another thing is with the atmosphere. If you have on, let's say, just the surface of the Earth, right next to each other, you have a container that's less higher pressure than the other container, and you open the barrier between them. What the higher pressure is going to fill in the lower pressure container, right? But we don't see that with the atmosphere on the larger scale, because there's more the air at the lower altitude is at higher density.
Yeah, so there's a gradient quality to the Earth, right? There's a gradient quality to the atmosphere. The problem is, of course, that we seem to have a very condensed area of air around Earth, and then there's all of this vacuum, right? If it was the case that we had just a gradient going all the way to space, I would expect the gradient to be more or less consistent from the surface of Earth to the edge of wherever space exists, right? And that would mean that the air pressure we had here basically wouldn't exist.
The air pressure. Go ahead.
I would expect.
Was someone else talking?
Can you swing that bucket and water slowly escapes over time? Like you're swinging the bucket, and eventually the bucket's just empty.
What do you mean? I mean, assuming
if a little bit escapes, the force isn't that good, and a little bit escapes, but not
if it's a constant.
No. When you do that, you constantly have to be tugging on the thing for it to stay in the bucket. Now, if you stand still and you have a center point and that's swiveling around, you can't keep it constant because you need to be pulling it sideways as well.
Yeah, but if the force
There
is
it is.
constant, then it wouldn't escape.
Yeah, but it's not going to be constant enough. It's always going to spill.
What? How is it? That doesn't make any sense.
Well, obviously, how fast do you think you can spin that bucket?
Well, not. You don't have to spin it. Sorry, you just have to. If the RPM is this continues to be the same, it won't leak. So I'm not sure what your
So
point is.
you have to break the grip, don't you? You have to break the grip that's keeping it or moving it and pulling it.
No, the force would be constant. I'm not sure what you're
Is
saying.
No. When you got your kids, right, or you're trying to swing someone round, you constantly have to move your steppage, right, in different angles, so that you're always pulling on the person that you're thinking. If you're not pulling on it, it'll drop to the ground. So yes, you can spin it, but it's gonna drip.
If you keep it at the same the same speed, it won't.
If you go fast enough, you'll end up pulling the water through the other side of the bucket.
What? Well, you wouldn't need to speed up any more than it would take to keep it in the bucket. So I'm not sure what you're saying there. Gomi, did you have something to say? I don't know if you were talking just a second ago or not.
No, I didn't say anything.
I'm going to go now. I've spent enough time on here.
I was actually also gonna go, so gonna leave them.
Bandsaw, you're a little bit more polite. Thank you for that.
No, you're right. And I just want you to think of this, Paulie, and if you can come up with an answer or an experiment or something to show me, I would appreciate it. But what I said about this curved example of a medium that the light is traveling through, because we're told that this is what the light does traveling through. So this, because light always wants to travel in a straight line, yeah. Always wants to travel in straight. Always wants to travel in a straight line. So this light that is always constantly wanting to travel in a straight line is constantly being affected by a curved medium, constantly being affected by a curved medium as well. And this is why I would like to see some sort of representation, some sort of experiment of some sort that shows what you say is happening on a curved surface, right, rather than a planar surface, which is what is demonstrated time and time again. All the things that we see are demonstrated over a planar surface, right? And I can accept that a fish tank with a laser light going through sugar water will curve, right? No dramas, you can see it happening, but we've never seen what I've just brought up now and what I've brought up in the past in regards to these demonstrations. We can show them on a small scale, but on a reasonable scale to show that it is even similar to what you guys are saying. I don't think that has been demonstrated. Maybe you've got other people on other servers that you can pose the same sort of question to, but I think you know what I'm getting at this curved medium and the light traveling through it. And refracting exactly the same way.
I understand what you're saying, and I think the only feasible way I can see being able to measure what's the word, that the container or the water is indeed curving would to have a vacuum next to it, like a separate container, and have a like a laser or something through that vacuum, so it's straight. If that makes sense, and to make that the length of whatever your the water, the container is, to see if it deviates.
Look, I'm not even asking for it in a vacuum, right?
I know what you're saying. I'm just saying that the only way to determine if the medium's curving is somehow to establish a perfect horizontal line.
Well, the light travels in a straight line. A laser light travels in a straight line, doesn't it?
Well, except if it's through a vacuum. So I'm saying if you could put a let's say mile long tube a vacuum tube that goes a mile long, and then put it like what's the word, same height as the water, then you could find if it deviates.
Yeah, but we know the light travels straight in a vacuum, for argument's sake. Yes.
Yeah.
Okay, then so we don't need the vacuum next to it, right?
I'm saying that's the only way to establish a horizontal line, a perfectly horizontal line.
Okay, then we'll then establish the perfectly straight horizontal line. So basically, what you're saying is what you're basically saying is it can't be done.
No, I'm saying that you'd need some way to establish a perfect horizontal line to see how much it curves.
Okay, then. Well, maybe you should talk to your guys and get onto it and get it done. I reckon.
If I had money, I'd do it. But another thing I just want to point out is that if it curves downward, over distance, no matter, like if it's like let's say a mile long, then whether it's flat or not, it's still curving downwards. Is my point.
It makes a huge difference, Paulie. A huge difference if that medium is curved.
I know, and I'm saying if it's following the shape of the Earth, so level or equal altitude medium would then be curved. Does that make sense? I'm saying that for argument's sake that if it curves downward over a mile, it's curved downward regardless of if it's curved or planar.
Well, maybe over a curved medium, it would curve down far quicker, far slower. I've got no idea. I don't think the test has been done. So to say it does without actually having done the experiment.
Well, I'm not saying that I know the exact amount it'd be different. I'm saying that no matter the shape, like if it's curved or planar, it's still going downwards. I don't know how much the difference would be, but I'm telling you that like if it's curving downwards over that distance, then no matter the shape of the Earth, it's curving downwards to the medium, and regardless if the medium is curved or not, it still will be curving downwards in that medium.
Well, I don't think you can make that statement without actually testing it.
Well, I mean, I'm saying that no matter the shape or the side.
No, I know the shape that it curves down in, and that's a planar shape, right? I don't know how light acts over a spherical shape or a curved shape because it hasn't been tested. That's what I'm saying. I know already what it does over a planar shape. I'm not arguing with you.
I know. I'm saying that you can't tell. I mean, unless you did establish horizontal perfectly, the curving downwards would be either way. Curving downwards is my only point. But I'm not saying that you can know the difference. I'm just stating that
it might be way more dramatic over a curved medium. Maybe
I know.
Way more dramatic.
I know that.
I don't know. I've got no idea. Right. So we can presume all we want, right? But until it's actually tested, that's all we've got is assumptions. You would have to agree with that. We've only got assumptions.
I mean, yeah, but I just pointed out that is sort of an assumption, but is one that is saying that no matter if it's curved or planar, it still is curving downwards.
Look, all right. Well, I think thank you for agreeing with me that it is an assumption, and thanks for the chat.
I wouldn't say what's the word? That I'm trying to think of a way to say this.
I know
like if it were
you're trying to cover all bases. I know what you're trying to do.
No, I'm just trying to say that I'm trying to explain it in a way that makes sense, but
I get what you're saying, mate. I get what you're saying.
Yeah, I can't measure the deviation, but I know we can know that it curves downwards.
Well, we don't know. We don't know it curves down over a spherical or a curved medium. We don't know that yet because we haven't tested it.
Well, you don't know how much the difference would be.
I don't know even if it would refract, right? Got no idea whatsoever because it hasn't been tested.
I mean, I'm sure we can find some tests that are similar, but because I know
I'm keen to see them. I'm keen to see them.
I'll try to find some similar stuff online.
Cool, buddy.
But yeah, I don't see a way to establish a horizontal line to measure the difference unless it's in a vacuum, and that's my only point. All right, I'm gonna go.
Cool.
See ya.
Enjoy you, man. All right, take it easy.
Hey, good night, Paulie, man. Good talking to you, man.
Good talking to you. Bye.
Cohan.
Cohen. Probably spelled it wrong, man, but it's a Jewish thing, dude. Don't worry about it. Hey, yeah, we were in Gems talking about the terms of
service.
Yeah, I would give it a once over. You know what I mean? As mods, just because you guys are already big on the whole Vax thing. Which in VC, I don't think that it's a big deal, but in
YouTube.
Well, yeah, for YouTube it is, but I mean, as far as Discord is concerned, they're not gonna actively be checking VCs really, but yeah, I would worry about the people posting stuff, and then the other stuff is like the harassment and what was the other thing? Oh, the trans or homosexual thing,
Well, we do try and keep on top of that, as you know.
Well, yeah, I mean, there's been times, but yeah, that's in the past. So I just
they're going after cyberbullying altogether, like all of it, all cyberbullying.
Well, not entirely
like
because
all the shit you guys do, that's all going to be violations.
No, it's not actually because it says parodies and whatever else is okay.
Yeah, that's fine. So now you've had to deny. You actually have to fully deny science. You're not presenting science. You're presenting a parody.
So Kosho, so every single meme that's put up, and I won't use a name, but say there's a face of a particular person, and then obviously something's written on that meme to poke fun at that person. Is that considered a parody? Is it?
Yeah, that's what we were talking about in there, and so I'll just read for you what it says exactly. It says, "Do not coordinate or participate in malicious impersonation of an individual or an organization," and it says satire and parody are okay. And I think that
that's only
last part is basically saying that memes and that kind of stuff is not what they're talking about.
Well,
that's only public figures, though. You can't do that to a regular person.
Yeah, I think if you're poking fun at someone deliberately, right, which is what they are doing, those memes, that technically could be considered bullying, in my opinion. Like, I'm not a lawyer, but and me, I wouldn't really lose any sleep over it myself. That's just me.
Right.
But there are people in the community that are targeted all the time, relentlessly, and then what happens then is people download them and people repost them, right?
Yeah.
So now all of a sudden we have a gang mentality happening, right? And these things are posted over and over and over and over again. So that would be bullying. It's not parody, it's bullying.
Well, that's a different that would be there's another thing that says do not harass others or organize, promote, or participate in harassment, and it says disagreements happen all the time, but any repetitive, continuous, or negative comments or circumventing a block or ban can cross the line into harassment. Is not okay. So I think that's like there's a lot of gray areas where especially in Gems that's probably a bigger deal, but yeah, I think as long as like multiple people aren't like picking on a person, but yeah, I think you're right in making memes and stuff like that could apply to this one.
Yeah. So what? Jem's going to have to change the behavior of his server, is he?
No, we were just talking about it in there about how to circumvent whatever we need to circumvent, and then also certain things like memes and stuff like that. I don't think. I think if somebody doesn't have thick skin, they're just not going to be allowed on the server. You know.
Yeah.
At least that's the way they were making it sound like. They're saying like if people are like threatening to, report, or if they're, causing any kind of trouble like that, then it's just better to get rid of them.
Yeah, don't change your behavior to what you.
My behavior is fine. Yeah. Thank you, Chris. Yeah. I did make a couple of memes of you though, but they're funny. I thought.
I think the problem I had with the new Discord TOS is that it's so vague in places. It talks about like misleading information. I mean, there's no. Sure, I mean, misleading in context makes sense if you already know the facts, but the fundamentals of Flat Earth is that we disagree with the facts themselves. So it's not as if everyone agrees that it's a globe and we're misleading people for some financial gain. Like, we disagree with the fundamental information that you think it's a globe. And so we're not misleading anyone. But of course, it'll be interpreted as misleading by those who think it's a globe. So that in itself is very vague, dangerous language, in my opinion.
I thought so too at first. Like that's why I was I was concerned about the most was the way they. But after I read the full thing, I think Flat Earth for the most part is safe. I guess the only sort of talk would be maybe when it gets to like a kind of extreme. Like sometimes it gets a little dark sometimes, but as long as if it's just about the shape of the Earth, it does kind of it states explicitly that if it's false or misleading, and it can lead to risk of physical harm. So.
Oh, I see.
But yeah, so I think it's mostly COVID and related stuff.
Yeah, but again, like for instance, if you were to say, and look, I'm not really particularly big on the vax topic; it's not really my thing. But like, you could make an argument that vaccines cause injury, and then they would say, well, that's misleading, and you're leading to the harm of people by, lying to them, even though it could be true. Well, then where'd you go with that? Like, because I mean, I don't know. For me, the vaccine conversation is not one I'm really into. But I just think it seems to be a cop out for people who want to just censor people. Oh, what you're saying is dangerous and it could hurt people. Well, yeah, but that could be true for the mainstream narrative. Like no one's censoring that shit. So
I'm the same way. It's not my topic, but I don't like the feeling of like not having I don't like the feeling of it being off the table. You know what I mean? Like you're not even allowed to talk about it almost anywhere. You know what I mean?
Somewhat, I think that if you're in these places, if you don't have a thick skin, I would probably say that it's probably not the place for you.
Well, yeah, that's the thing, isn't it? It's like, don't ban us, just don't come in. Like, if you don't like the subject matter, leave the Discord. Like, Discord doesn't need to make you leave Discord if you are discussing things it doesn't like. It doesn't make any sense to me. It's like, come on, man.
I wonder why they have to. Go ahead. You go ahead, Crypto.
And I was just going to say, like, I'm not particularly interested in flower arranging, so I don't join any flower arranging Discord servers. It seems really obvious to me that I shouldn't be petitioning Discord to remove flower arranging Discord servers just because I don't like it.
Yeah, right, and that's what I was going to say is I'm kind of thinking about it now. It's like I wonder what's the push, like what do they gain or risk at not policing that? You know what I mean? Like allowing it to be presented. I guess I mean are they going to be somewhat liable in some sort of way if it's if their servers are they're posting it? Like I don't see why they would have any incentive to need to police that. Yeah.
My daughter, one of her friends at school was cyberbullied to the point where unfortunately she took her own life.
Oh shit.
Yeah, it was pretty bad, Kosho. But she went through extreme bullying online, and I was talking to my daughter, about it, because for the life of me, I could not understand why she continued to go into these places where she was getting bullied, and she was subjecting herself to this total negativity all the time. But my daughter said, she found a need to respond, like, to kind of defend herself in these places. But yeah, these sort of things can have effects on people. I'm not gonna deny that at all. But to me, it's the click of a button too, Kosho. Like, you choose to click onto it, and if you don't like to do something, like Crypto said, I don't, I'm not going to force myself to go into a flower arranging group when I don't like flower arranging. It's probably not quite the same, but it kind of almost is too the same.
Well, it's also. Go ahead, Kurt.
Twitch said it best. The people on Gem Pandas want flat earthers to either shut up or die, or they think they're here to teach something to some people that they've deemed unable to learn because they're just animals. That's good. People on Discord are going to pick that up. What they'll do is they'll just take the word flat earth out of it, and just replace any other ideology or identity, and realize what a bunch of psychopaths these people are.
Sorry, Crypto, go. You're dropping in and out, Crypto. Sorry, buddy.
There you
go. Oh, he's gone. He was dropping in and out.
I bet you he's at work.
Sorry, buddy?
He's probably at work.
Oh, yeah. I don't, I get how people get annoyed at some other service or whatever, but leave it there. Leave it at the front door, type of thing. Don't bring it somewhere else.
I'm with you about the personal thing, because like I was on board with it, because it happened so much last night actually. What was it? It was with Jeremy, and we were arguing about something, but we were actually arguing about a thing, and then people want to start talking about like other servers and stuff like that, and I guess that's it's a topic, but I mean it's just kind of like, I don't know. I guess if you want to vent or whatever. But what you were saying though about the bullying sort of thing, I mean I haven't been I've been a victim of it in some of these servers. Not as bad as a couple other people in here though. Like I know, especially in certain other servers, Crit and Merle, like just multiple people, like a bunch of people like straight up harassing, like it says here, like the harassing part. Yeah, I know, I know they hadn't gotten driven to anything as dark as that thing, but I know whenever it's happening to me or whatever, like when I was banned from 24/7, like that's probably the only reason I'm still on Discord actually, is because I was banned, and you don't want to. It's hard to walk away whenever you don't want to walk away as someone who's like as a loser. You know what I mean? You want to come back and like show them or whatever.
Kind of defend.
Yeah,
I kind of get it.
All that sock account and keep coming back with sock after sock after sock. Those will be violations.
Technically, but they also have a thing now for having multiple accounts. But yeah, when I was originally making sock accounts at 24/7, I wasn't doing it to troll them. I was doing it to hang out with my friends, because that's what sucked about it. It's like I'd made a bunch of friends, and then next thing I was just blacklisted from the server. And I was like, it was just a weird feeling.
I just feel a bit sorry for people that have to experience that somewhat, or feel that they have to continue to experience it, or even defend it. Kind of save their name, save their honor type of thing. It's I can't really understand it. because I can only talk from my point of view because I'm not that sort of person.
Yeah.
You take the abuse. Well, but if I don't want it anymore, though, Kosho, I'll step away. Like I used to be over there quite a bit. A few years ago, I was there, quite a bit. And then I kind of checked out of there. I didn't quite, even though this, I still get on with some of the people that are still over there, but in general, it wasn't the experience that I was looking for. So I decided to step away from that experience and find different experiences. But luckily I still, have contact with some of the people over there, whether it's through here or other servers that I'm on. I still see them, still DM them, and whatnot. So it's all's good in the hood type of thing.
You know what I think positive that might come from this is it possibly slightly will kind of transform some of the normal behavior in Gem server, like because there is a lot, like I don't like it when people are kind of ganging up, like people gang up on people so quickly and don't realize that they're doing it, I guess, you know what I mean? And that runs people off, and I think hopefully that maybe at least we'll have a better opportunity to get people to stop doing that so much.
You're back, Crypto. You got a better line?
Someone tried calling me, that's why I had to go suddenly. Yeah, so I've got a new job, funnily enough.
Oh, nice.
Because my old one's coming to a close. Don't know if you guys know, but I was working in COVID testing.
Oh, nice. Happy days.
Clover testing?
Yeah.
I don't know.
So, basically, because all of my businesses got shut down by COVID, so I was like, well, I might as well go and work in the belly of the beast, because at least I know, when my businesses are back up and running, this job's going to be gone. So it's kind of seemed like made sense.
Oh shit! What's Clover again?
Sorry?
I forget what Clover. What's Clover?
No, COVID.
Oh, never mind. Okay.
I've been doing that for just over a year, and it's less said about it, the better.
Wait, so you work in that? You work doing that for real?
Yeah.
That's funny.
So it's funny when I kind of give my opinion on COVID and I say that it's massively overblown. It's like I've got direct experience of working in it in like a year. But it's what it is. Like I needed a job because of my businesses, and everything's back to normal now. So I'm leaving that job, and they're going to stop the funding at the end of the month anyway. So I just stayed on to the end.
There you go. Honestly, man, to me that's one of the most. We're not really supposed to talk about all this so much, but I mean, I thought that should be the focus, is the testing. It's like if people are that worried about it, then sort of just making those more available and easier to do and easier to get done and that kind of stuff. It seems like that's a safer route than the the V thing, or it's even for a community thing, like for everybody, it's better to just for testing versus the V thing.
Yeah, I agree with you, and also like and because I don't really believe the narrative, but like if you believe in the whole narrative, then I would agree with you, because at least you allow people to have their freedoms, and you can kind of combat this quote unquote horrible virus without kind of the risk of injuring people, because people are going to get the virus anyway, and that's going to confer natural immunity to them anyway, right? The argument was about viral load, and if people get like a large dose of it, then they could die from it and all the rest. But then, like there's the science on that is very hit and miss. It's very all over the place. And the problem is as well, when you're working with genetics, you're working with basically every single human is a different experiment every time. It's not like you can take pure water and boil it, and it's going to do that every time, because genetics doesn't work like that. Like my genetics are going to be different to yours, are going to be different to Bansaw's. And so when they make these claims like, oh yeah, well this is an efficacy of X, Y, and Z. I mean, there's a whole bunch of issues around when they compare the relative risk rate, risk reduction, to the absolute risk reduction, all this kind of stuff. Like,
yeah,
obviously we can go into all of that if you want, but even just the very basic format, the basic idea is that you're testing a different person every time, and these people are genetically different and they react to different things. So it's actually very difficult to say that it has an efficacy at all, because you're not testing like the same thing every time. You're testing fundamentally different things every time.
You know, those Canadians, or the whole Canadian thing, and what they were ultimately, protesting for. It seemed to me that it would be much simpler. Like it's a simpler solution would just be to, like I said, like overload these things with tests. Because if you have people tested, then them traveling back and forth or whatever, it's actually less of a risk than being having the V, because that doesn't actually protect you or anybody from anything. It just kind of makes it less severe, but it doesn't mean that you can't transmit it or anything. And then
there's no. Sorry.
Oh, the only other thing I was going to say is I had a lady in my car, and she actually worked. I think she worked at some kind of medical field, but she was telling. I don't know why she told me this, but she told me that her and her friend had taken the test. What is it called? The antibody test, which I think I wish I could take that test, because I think that test is actually important, because it'll tell you if you have the, what the V is supposed to be giving you, or what the virus would have given you. And she told me that she took the antibody test, and her friend took the antibody test, and she had the virus at one point, and her friend only had the vax or whatever. And she said that her antibodies were high, like they showed up and they were high and whatever. And her friend, who had the V, didn't even show up as her having antibodies.
Oh, really?
So I was like, what the hell?
He cut out. That doesn't surprise me, because the V isn't actually, it's not very good. And when you actually read the list of ingredients and you read what it claims to do, you're actually far better just getting COVID, right? Even by the kind of official, narrative. So, do you guys remember? I always get this confused. It's either bird flu or swine flu. One of those two was effectively the first iteration of this, SARS-CoV-1.
Yes. Yeah.
And anyone who had SARS-CoV-1 would be, because it's about 80% genetically similar, the virus, allegedly. I don't know how they measured this, but this is what they say. Fuck. You're right, Mansour.
Sorry, mate. That was an ad.
You listen to Spice Girls or something?
Sorry, buddy. Sorry, buddy.
Because they're 80% similar, the theory is that anyone who had SARS-CoV-1 would either have enormously reduced symptoms or absolutely no symptoms if they were to, say, catch COVID. Now, the funny thing is that when we did our computer modelling in the UK, I don't know about the US, but when we did our computer modelling in the UK, our mathematical modelling, they assumed that no one had any prior exposure at all to SARS-CoV-2, which is why the numbers were so much higher in the models than they were in real life. And I think that is deliberate. I don't think that a very intelligent computer modeler wouldn't know that was the case. Right? I think he would definitely know that was the case. I think he was probably told to increase the numbers by as much as possible in order to justify certain draconian actions. Another thing I would say to Kosho is that I agree with you if you believe the narrative and you believe that the government is benevolent, that testing is the way forward. However, the problem is that with more tests come more cases, right? And with more cases comes a justification for more draconian actions. So if you don't believe that your government is benevolent, then more testing is actually the problem and not the solution.
Yeah, I see that how that makes sense. But I guess for me, it seems like it's because I do believe that is real. I believe that there's at least there's something, even if it was something made by China or the U.S. and China, and it's a bit, I think that there is a real thing, and that you can get you can get harmed from it, and it just seems like knowing about it as early as possible is definitely a benefit. But yeah, I see your point. Like, definitely the more cases, the more numbers they can rank up, the more they can justify, doing whatever. That makes sense.
Yeah. And the other thing I would say to you, do you really think that the billionaires of the world who run the world didn't notice that the lockdowns were massively benefiting their businesses? The Walmart family, Jeff Bezos, and all the rest, their profits soared. So, I mean, obviously they noticed that was happening. So where is their incentive not to lock us down? If they have disproportional influence, which we know they do.
Well, I mean, it goes two ways though, too. Because I mean, for those two people, which there's probably plenty of more. There's probably a small group. I can, you can think of all the people that were very much what do you call it, detrimented or whatever from it, like Vegas or any sort of tourist community or tourist thing, I guess they're not really that big, but yeah, certainly tech companies and definitely Jeff Bezos in a huge way.
They've made a killing, haven't they? Really?
Yeah.
Everything's now, they all these online businesses, which they have, majority shares in and stuff, are making absolute fortunes now because everyone's at home and now everyone's online. Like spending what little that they don't have because they don't have jobs now. They can't stop clicking and buying all the knickknacks.
Yeah, and wealth isn't having a certain amount of money. Wealth is actually having a disproportionate amount of money relative to other people. So actually, they're not just increasing their own wealth; they're increasing their own wealth kind of twice because everyone else is getting poorer, right? So yeah, I mean, this stuff seems obvious to me, and probably obvious to everyone in here, but doesn't seem obvious to the general public.
Hey, let me ask you a question. It's kind of because you kind of segued it to this, and it's just kind of a change in tone, but which might be for the better, anyways. But based on what you just said, I thought it was interesting what you just said about the because it's true what you said. Like it's some people think that wealth is about having enough money to be comfortable, but in reality, like what you said, it's like it's a comparison between the haves and the have-nots. You know what I mean? Like I think that's what you're getting at, basically. So do you ultimately, do you think that that's because there's a lot of people who talk in here about a like a altruistic universe where everybody is allotted universal basic income. Do you think that the world can never work like a model like that? Like it would always be this way you described it, like the disproportionate. You see what I'm getting at?
It's quite a difficult question to answer because it depends on a couple of things. Like, first of all, are you saying that, for instance, in a world where like nobody has to work and everyone has the same amount of money, like could that work? Is that what you're asking, or are you?
Yeah, I mean, I guess. I mean, I probably know what your answer is going to be because it's probably the same as mine. But yeah, sure, yeah. Like, do you think that the model? Do you think that there could ever be a reality where it's not the disproportionate thing, but it is some sort of thing where, yeah, you could just have as much as you need to survive, and everyone's happy. I personally don't think so, but what do you think?
No, I don't. I think that's it's a fairy tale thing that children believe. I don't think it's reality. That's not to say that there can't be some kind of existence where everyone's happy, but I don't think that happiness comes from equality. I actually think that happiness comes from the, let's just say, the disproportion. Okay, it's difficult to make this argument succinctly. It's quite a technical, complicated argument. Some people are much happier doing absolutely nothing with their lives, but the problem is that then that brings no economic benefit to other people. So you need to have this balance where people are doing what they like to do and what they want to do, but also contributing enough to the happiness of other people. So, but then the problem is that, like, for instance, the way you contribute happiness might be making coffee for £10 an hour, and the way someone else contributes happiness is, I don't know, entertaining their children. Just as an example, at a kid's birthday party, but that's going to be worth a lot more money because you have you have to invest a lot of money in the equipment and all the rest, and so you might get paid £50 an hour. So then you've created equal happiness but an unequal wealth distribution. See what I'm saying?
Yeah, but
everyone's happy. So then the question is the wealth even a factor? Does it even matter? As long as the very poorest in society are rich enough to have basic housing, clothes, and food, does it matter that there is a disparity?
You know what? Because I used to. I mean, I'm not for the government or the status quo. More than anybody else. But at the same time, I like our model or the way it's supposed to be. At least the way it's supposed to be, because what you were describing, basically with opportunity, as long as you have the opportunity to make something of yourself or do nothing, whatever whatever floats your boat. In our at least in the Western world, this is you get the opportunity to do that. And I think that's I don't mind that model. I think that the model where you try to give everybody this equal thing and you get rid of this gap, I think that doesn't exist, and that what would happen is you would create an invisible gap, a gap between everybody who's now subjected to this free money from the government, and then some class of people who run the government and are going to decide who gets what and all this type of stuff. So I don't think that model will ever go away. I think that just making it fair and giving everyone the opportunity to participate in it, I think is the best way to go.
Well, yeah, possibly, but also there's another issue you have, and so we have kind of what I would call like a social democratic model in the UK, so maybe social democracy capitalism, where like you can go and work and you can make some money, cool, and then there's like a certain class of people who don't work and they just kind of stay at home and they get their rent paid and all the rest. Problem is, and people don't really consider this, but there's inflationary pressure from the government paying the.
Oh damn!
You cut out, man.
And so, the problem you have there is that now the people who are working and actually
you're cutting out crypto
producing have to work harder just to provide basic provisions to themselves. So, I mean, is that better? Is it better that you then create more stress and more workload for those who are actually productive to the point where you can work them to the point of breaking? Or would it be better to force the people at the bottom who aren't really working to just work a little bit? And so it's a difficult one, because you could make arguments, maybe they're injured, or maybe they've got some sort of illness which stops them from working, yada yada yada. But I do think that in this country, a lot of the people who are on what's called benefits just can't be bothered. I'm genuinely that. I know people like that.
Yeah,
and so, but
definitely the case.
Problem is that creates an inflationary pressure on the people in kind of my bracket who are trying to work for a living, and like rents in London are absolutely mad now. Like, you can't find a room for less than £700 a month. It's ridiculous. And if you want to rent a flat, it's like £1,300 a month. Like, it's just not affordable.
That is crazy.
That's funny, because you just got to warn you. You broke up a lot there, but I got everything you said. Okay, but just might want to be aware that whatever was happening, you cut up a little bit. But you know what though? Back to because what I was saying about the opportunity kind of goes along with what you're saying. Is I think that the ultimate duty, like if you really want to make it, you have to really align yourself with the market. So there's people who like you said who want to go to be and work at kids' birthday parties or whatever the hell they want to do. But if there's no market for what you are trying to provide to people, then don't be surprised that nobody's going to pay you anything, because you're not very valuable. But if you align yourself with what seems to be in the market and, give yourself some value, then, you can kind of work in the system, instead of just being like kind of being a cog in the system, but in a way that benefits you, as much as it does the system. But it's all about finding that balance.
Yeah, 100% agree. And like, as I say, growing up, like, I never thought, oh yeah, I'm gonna, like, the 4 businesses that I currently run, I never thought I would be involved in any of them when I grew up. But and I do like children's birthday parties, one of my businesses, and I've done very well from it. I certainly don't think that it doesn't challenge me intellectually. It's not stimulating in any way, but the money's good. So I do it to make I throw all of that money into a savings account, and that's what I do with it. I don't think anyone really wants to do that with their life, and I do have more intellectual pursuits, such as coming onto Discord and discussing various topics. I think is an intellectual pursuit, which is something I prefer to do, but that no one's paying me for. Right? So you have to have that balance.
That's funny. So you, because I do magic, and I remember you hosted trivia. I remember back in the day. You said you did that on the side. Do you do something like that for these parties, like some sort of like host or something like that?
Yeah. So I've just come from one actually now. So I do a little bit of magic and I do some disco and all that kind of stuff.
Oh, wow.
And I've literally just joined. I've just joined the company, so I'm going to be getting a lot busier. And it's so I do quiz nights. I do sort of 4 quiz nights a week. I'm a DJ as well. I do karaoke nights, all sorts of stuff. But
are you any good at magic?
I wouldn't say that I'm a magician. I can do magic for kids because kids can't see how easy the tricks are, but I probably couldn't do it for adults.
I don't know if you know Zan.
Rub it out of my hat.
I've been doing magic most of my life because I like I like doing magic. But I'm kind of the same way though with like when you have this multiple streams, and actually that is what that is how I envisioned. I don't know, maybe 15 years ago, maybe I always envisioned multiple revenue streams, and maybe not that way. It's not like I'm obligated for one specific thing, but then also I'm free to. I can have a bunch of different. Some of the things I do, but most of the things I do actually don't pay anything. Most of the things I've worked the hardest on don't pay anything at all. But at least I have the freedom to kind of put myself in those directions at the same time as getting paid doing other stuff. I kind of like that. I like a multiple revenue stream model.
Yeah, it's nice, and it's what I call a bluebird job. So instead of going out making £10 an hour, but you're doing sort of like 50 hours a week, it's better for me to find like 3 or 4 incomes which are all like £50 to £60 an hour, but they're kind of sporadic. So you do them here, there, and everywhere. And what I found is that I actually work a lot less and I earn a lot more, and it's actually really nice.
Yeah, right.
So, and it was something I would advise everyone to do. Like, as I say, as a kids entertainer, I go out and make £100 an hour. Look, I don't know anyone else who makes £100 an hour who's not working either as a lawyer or a banker.
£100. That's like a pound is like twice $1. So yeah, it's a lot.
Plumbers.
Let me have a look.
Like said was like 1.5 times $1. I don't know what it is.
Yeah, I mean the thing, it changes so much. 1.3. So I mean I charge sort of $230 for a 2-hour party. That's about $300. Maybe $350. Yeah. As I say, and it's just because it's not a lot of people want to do it. It's not very trendy. If you go and say, "Oh yeah, I dance around in front of 6-year-olds and play fucking musical statues," like that's not impressing anyone. But people pay well, so it's like, okay, cool, I'll do it.
There's probably plenty of moms that does things, dude. But yeah, but I mean, I guess it's different over there, but because I wanted to set up this camp, like a science camp, actually, I was going to use the flat Earth to teach it. It was going to be like a 2-week camp thing, and I was going to kind of like have a sort of a simulated flat earther character that would challenge these, so they basically would use the flat Earth help them learn about these topics, but it's hard to find the advertise for something like that. So I wonder how you advertise for these birthday parties or whatever.
All right. Well, to be honest, the most effective way that I've found to advertise is through Facebook. But I kind of, even Facebook can be a little bit hit and miss. One thing I would suggest is find a really good company. And there are some companies that will rip you off. They might charge like $400 and they only give you like 150 or something. But there'll be a couple of companies probably in your area that will charge maybe 400-ish. I don't know what the going rate is where you are. Are you in Texas, right?
Yeah.
Yeah, I don't know what the going rate is. You probably need to be near like a large city. So I don't know if you're near like Houston or. Yeah,
I'm
okay,
like the fastest growing city in the States right now.
Oh, well, being near a big city is important because you need to have. There basically needs to be a lot of people with middle class incomes. That's the way you make money off of these kind of luxury incomes. And that's why I moved to London, because I'm not originally from London. But where I was from, there was no, like, what I was doing was, there was half the work and it was half the money, so there's no point. So you're in a good area. There will be companies in your area for sure that will do like science parties.
Yeah.
But there will be some that will try and rip you off. They'll try and take like 60% of your money. Try and find an entertainment company that will do, say, like a 15% cut, because they do exist. And then you can make good money from it, and they'll put you out as often as you want a lot of the time.
Yeah, there actually is a company that I don't know if they do exactly, like if they're set up to do exactly that, but what they do is they basically have these science sort of camp, the 2-week camp or 3, programs for these kids. And I was gonna basically pitch them this class thing and kind of sell it to them and hopefully work with them or whatever. But I didn't get a good pitch together, so I may get on that. But actually, my girlfriend, she's got this real estate thing, and there's like a part of her business that she hasn't done in a while, but she says it's lucrative. It's like where you basically you find people who just had their houses foreclosed on, and you go through the listings and see who the lender actually ended up selling the house. I'm sorry, the bid, like during the bidding, they actually paid more than what the lender owed, and so that money is actually can be claimed by that person. And if you just go and get in touch with those people and get them to sign a contract, you can get a huge portion of that. So I'm gonna see if that is as lucrative as she says.
Well, I mean, the thing is, if it's free money for them, then they'll probably pay you a nice chunk of it anyway. So it's like, what I've noticed is the easiest way to make good money is to, like you say, you make yourself a conduit through which money flows. So when I was younger, I was like, oh yeah, I'm going to go out and I'm going to do all the advertising myself. And I'm going to take all the fees myself, and it's going to be great. It's not the way to do it. You want to find 2 or 3 companies where their fees aren't too ridiculous, but they will get you all the work, because getting the work is actually the hardest bit of doing any of these jobs. Like, if you can reliably have work, this is why I love doing weekly quizzes, weekly DJ sets, and all the rest. A lot of my mates think I'm mad because I only charge about £200 a night DJing when they can go get 350, 400 a night. But they're working twice a month and I'm working every week. So for me, I know my Saturday's filled, my Friday's filled, my Sunday's filled. I'm done. I don't have to do anything else to make enough money to survive. But if I go and get 3 quizzes, then I'm doing 4 or 5 kids parties a week. It's a lot of money at that point, and then you never ever have to worry about money, and you're not really working that many hours because you're kind of working 3 hours in the evening here and there. You got most of your days free, and for me, it suits my lifestyle.
Yeah, I'm the same kind of way, man. Because I know what you mean. Because I do software, and I used to work with this dude who was an executive at Dell, but now he just kind of sets people up, like people like me, up with projects. So he was kind of like the liaison between these big companies that need contract workers, and so yeah, I would just he would set me up with a thing, and he would get a huge. I don't even know how much he was getting. He probably was taking half of it for all I know, but But yeah, but it's definitely works out like that because you don't have to worry about going out and finding it yourself. So they set everything up. So
yeah, exactly. And the thing is, they then make it their business. And the thing is, you want to give them a percentage cut because then they are incentivized to get you as much work as possible as well. So then you're kind of just like turning up, doing your thing, going home, and then you find by the end of the week you've made 3 times as much as when you were fully employed. You've done less hours. It's more enjoyable work. It's like, for me, it's a win-win.
definitely the project-based thing, because yeah, it's like I'm at my own schedule. But that's my problem is like with this, like honestly, like sometimes like Jeremy or somebody in here will ask about something Flat Earth related, and then I end up spending fucking I don't know a lot of my time working on some fucking model or some picture, some experiment that is going to absolutely pay fucking nothing whatsoever. So most of my time is actually spent doing these. Just like remember Bandsaw, I was getting into that whittling and the fucking
Yes,
all that
yeah,
woodwork.
yeah.
I still have all those. I still have all that shit. But I mean, none of that shit was. I'm not getting any money for that. It's just like
You're your own worst enemy, Kosho.
Yeah,
you are really.
If stock accounts could pay.
Yeah, actually, they
Yeah.
do.
They
Very
do.
interesting.
You know,
Yeah.
with your 200 stock accounts, you could probably have 200 phones. And then if you get in contact with them, you could be making $200 a day just from your 200 stock accounts.
Damn.
Well, no, it's not just that, but I mean, like shit, like YouTube. Like I get free YouTube Premium because I have like 1,000 YouTube accounts. So I mean, a Google account. So there's a bunch of different shit that had that many emails. There's a lot of free shit you can get your hands on. So
well, that's actually now that I think about it. If you have a Google account, every now and then Google accounts they'll send you like a $75 free AdWords thing. And so if you're thinking about like setting up science parties, and you've got all these Google accounts, you could probably just rinse all of the free AdWords advertising just to get yourself some parties, and then you'd never have to spend a penny.
I've never seen that before.
Oh, really?
Yeah, they offer that somewhere.
Yeah, every now and then I get offered free AdWords. It might be because I've already spent money on it, and maybe it wouldn't work for you if you haven't. But I often get like, oh, why don't you spend? Here's a $75 AdWords voucher, and then I'll just throw it into my account sort of thing. I don't really use AdWords anymore, but I did used to a lot.
Yeah, what's funny? That's me and my brother. We started a company where we basically do SEO work. Like search engine optimization, and get people who don't have an online presence, websites and all that kind of shit. So it's weird that they don't offer me that shit because I definitely. I mean, it's probably because I would use it. It's probably the reason. I don't know.
Maybe. Interesting.
See, that's what I'm saying is I'm actually, because my girlfriend, she'd give me all this paperwork for this shit. And I tell you, it's actually been my worst vice in, last 4 years really is just flat earth, dude. Is sometimes I'll literally neglect things that I'm supposed to do, put things off for nothing, dude, just to make some stupid, just to get some argument, I'm making some fucking, gravity model or some dumb shit.
Do you know what I found? Because I used to be the same. I used to waste so much time discussing flat Earth. And now all I do is literally, because I drive a lot. So obviously because 4 quiz nights a week, 3 DJ sets a week or whatever, and doing a lot of kids parties and stuff I do during the day. I'm driving all the time, and so I mean, I'm not driving now because I've only just got back from an hour drive. But the only reason I came onto the VC was because I was driving. So I thought, well, I'll just be on the VC driving for a bit.
Right.
And that way, you feel like you can still be in the conversation without wasting time.
That's actually.
The problem there is that it's not Flat Earth's fault. It's your own asphalt. This is your road that you've walked. No one's to blame for it but you. You've done you. If you feel like you've wasted time, it's because that's what you wanted to do. No one forced you. Even more so after you've made all these soccer accounts to keep into it. This is
You're correct, man. They're definitely not blaming Bandsaw or anybody. It's
okay. I was getting that vibe that you were.
I was about to blame you for it.
Yeah, no, I didn't definitely get that vibe at all. From
I was getting the vibe of misspent youth rather than anyone else.
Yeah,
to blame.
yeah.
It's like, I could have spent time making millions, and instead I argued with Jeremy.
Well, no, I mean, fuck. I mean, honestly, that's not even a joke. And actually, last year when I was still single and I was kind of going on dates and stuff, I remember one night I was supposed to go meet up with some girl at 8 o'clock, and next thing I know, it's like 11 o'clock, and I'm still sitting there talking to Don, Press Don or whatever, about some dumb shit. Like I remember it being the dumbest thing we were talking about, or we were playing some game or something like that. I'm like, dude, I could have just won out with a woman, dude. I'm sitting here fucking talking to you right now.
Well, she can't have been that if you were like, yeah, I'd rather talk to Dawn.
Yeah. So I was at least sane enough to realize that I was being crazy. You know what I mean?
To be honest, I did something retarded the other day because I'm recently single. And I went out and I DJ'd a DJ set, and I got in at about maybe 2 in the morning, something like that. And I was meeting this really, really beautiful girl for lunch. For coffee, sorry. And I didn't set an alarm, thinking, oh yeah, I'll sleep like 8 hours. I'll get up at 10. It's fine. I was meeting her at 1. I ended up sleeping for 14 hours.
Yeah,
I got off at 4 p.m. I was just like, oh shit. So I messaged her. I was like, I'm so sorry. And she was like, yeah, this is not acceptable. She's like, easily the most attractive girl I've dated in a long time, and it's completely ruined it.
Oh, ouch.
You were up like, because you said you were up DJing, so you probably hadn't slept. You probably had lost some sleep before that, right? Like you're catching up on some sleep.
Yeah, exactly. So, I mean, where I've been working for Tesco Trace as well, previous day, I had to get up at 6 a.m. after having, so I DJ'd the Friday night, and then I had to get up at 6 a.m. and then I DJ'd the Saturday night. So this was the Sunday. And so, yeah, I was still catching up from the previous day as well. But I just didn't think to set an alarm. I got off at like 3:30 or 4, something like that. It wasn't great.
Oh,
I really got to stop myself though. I don't know how the best to do it or whatever, but just maybe not allow myself. Like what you said about the driving. Actually, that's what I was doing because I was renting my car through Lyft, so I was also driving Lyft, so I could pay for. So it's basically having a free car, but because I was spending a lot of time with my girlfriend, I would really only come in these servers when I was in my car. But now I don't have the car anymore, so. I think I need to get a new car so I can only get on Discord in the car.
Yeah, so it's a good idea. Honestly, it's the way I regulate my time. And to be honest, the only reason I'm still on this call is because I'm waiting for a mate, and we're going to be playing some FIFA in a minute. So as soon as he's online, I'm going to be going. Because it's like you. I found that I was wasting way too much time. So let's be honest, man. I'm never going to convince you that the Earth's a globe, right? And you're never going to convince me. Sorry, that the Earth's flat, and you're never going to convince me it's a globe. So this is an interesting time for me because you get to have these kind of intellectual jousts, and you get to discuss things that are kind of interesting, and maybe some of the topics are less interesting, whatever. But you're never actually going to make any ground. So why waste time that wasn't wasted anyway?
Yeah.
Did you actually think crypto at one stage that you would convince people or change their mind?
Yeah, I mean, to be honest, I thought that by presenting factual information in a logical manner, people would at least consider it. I didn't think that everyone would accept it, but what I certainly didn't expect, and this is nothing to do with Coach Show, but this is like a lot of other Globers, I didn't expect the visceral reactions. I thought that was really weird. Because it's like if I'm say a messenger, and I'm telling you this message that the government's lied to you, I would expect most people to at least be like, you know what, I don't trust the government. Anyway, they're fucking liars. Let me look at this. That would be what I expect. And instead, what you get is, oh, you're stupid, and then you appeal to majority, or appeal to authority, and all this stuff. And it's just like, that I didn't expect when I first got into this.
Yeah, this is I think in maybe 10 years from now, who knows when, I think we're going to realize that we were part of something brand new, like something that we took for granted, you know what I mean? Because this is definitely like, there's some of us like Gio or Nathan Thompson. It's like we're part, like they're in flat Earth movies, you know what I mean? And it's almost I call it like augmented reality TV kind of, because it's like it's a community that we're a part of, that we participate in, that we're also watching entertainment. And I'm the same way you are, dude. Spurs Chemo said that a long time ago, that nobody's here to change anybody's mind. That's not going to happen, and that's the truth. But I'm in it for a conversation, man. I just like I like talking about all the things we talk about. So, yeah, I don't know. I don't think anyone's mind is gonna change.
Flat Earth ain't going anywhere. That's the best part. In the 2016 shot, again, Flat Earthers were just fine, doing their own thing, being left alone. And a bunch of atheist Karens thought they could get a quick kill to remain relevant. And they destroyed their own movement.
For some of them, it's true. I think for me, what really, what brought me into the movement was that I thought, oh yeah, the government's lying. We need to tell everyone, and maybe we can have some sort of intellectual revolution. But really, when I realised that wasn't going to happen, because a lot of people, let's be honest, 99% of people who believe in the globe have absolutely no reason to do so other than the TV said so, right? Mm-hmm. So whether you think it is or not, that is the basis of most people's belief. And I realised that I can't out propaganda the TV. So what kind of kept me around in the discussion wasn't that topic specifically, but it was just that I was learning so much about kind of adjacent topics. So I know so much more about physics now. I know so much more about, mainly physics, to be honest, but I certainly have a deeper appreciation for what I think about the creator, and a lot of other kind of, as I say, adjacent topics. And I still learn more every single time I come onto the Discord. So I think
exactly,
that's really
absolutely. 1,000%. I was gonna say something what Crit said, but Scott Veach, he copies off everything I say. But it's true. I said it before he did, but he said the same thing, and he's a real smart guy. He went to college for 15 years and already has a PhD, and still said the same thing I said, which was because I've studied my whole life also, but I learned so much more in a condensed, like in a very dense learning in a dense amount of time, but with a deeper appreciation and understanding of the actual, maybe even the same topics I've known. So I already knew the topics before, I already knew the subjects, but because we're engaged in these sometimes rigorous debates or whatever, and you're being challenged by somebody to absolutely show them the truth of something, or they, whatever the case is, you're actually really invested in learning a lot of this different stuff every single day. So yeah.
Well, you want to co-show, don't you? You want to. That's the difference between when you're at school to now. Like at school, like you're put in an environment where you're sort of like, okay, you have to go learn ABC, right? Because you have to be able to do ABC with this knowledge, right? But then all of a sudden you're out of that. You're out of that completely. Now the things that you learn, the things that you put your time into, it's a choice from then onwards, and that's where that condensed, sped up learning process comes from, because you are making a choice, a commitment to learn something in the quickest amount of time as possible.
Yeah, well, very quickly, I just have to tell you, because that what you're talking about is true, and that's exactly why I was creating that camp thing for the kids, the science, because it's actually it's probably the best model for learning that I've ever come across. But for me, it's not. For me, it wasn't like that. Like I was kind of like, I was like I'm not a nerd, but like I always like to fucking, like, I didn't go to high school, you know what I mean? So actually everything that I'd learned because I actually was interested in like seeking out the information and stuff like that.
Mm-hmm.
But but you're right though. Like most other people, they have no incentive to learn the things they're taught in school, and they have more incentive to forget it and then never worry about it again. And that's what's cool about this community is it gives you that incentive. No matter who you are. So.
Well, to be quite honest with you, I probably spent more time trying to skip class at school, go wag off with my friends, go down the street, go to the ice cream parlor or whatever, than in the class. Going playing footy and cricket, these sorts of things. Because they're the things I was interested at the time.
Yeah. That's why I didn't go to high schools, because in middle school, I wasn't. I was more worried about the girls and hanging out with my friends and stuff.
Yeah.
But that's why I brought up Scott Veach, is because as I said that, he said the same thing, that like, in 1 or 2 years, even though he'd already has a PhD in science and studied all this stuff, he's learned more in the short amount of time he's been in this community, in the entirety of his educational career or education. So yeah, I mean, even like, because you are, that's why I like talking to you, because you ask some of the fucking silliest things. You put things in a silly way that you just never thought of before, and so it forces you to have to think in like this, think in this different way, like figure this shit out. And Percentage is the same way. Like it used to piss me off to some of the things he would argue, because I was like, there was no way that like nobody else would make that argument. But at the same time, he would argue things that I'd never ever even thought of before, and so it's like you're forced to like really dive deep into some something that you never even had any interest in before.
Well, seems you like silly questions, Kosho. Seems you like silly questions. Did you hear what I was talking about before with Paulie?
Slightly. I was here earlier with Paul, and I don't know if he was carrying on the same.
No, I was still talking about photos and refraction and what we can expect from refraction and all that sort of stuff. And I posed a question to him in regards to refraction and what we can expect with refraction and how it has been tested, right? So the refraction has been tested through vacuums, through sugar water, through all these different mediums, right? And so it's through this testing that we've come to our conclusions that we've been able to apply a mathematical equation to. Yeah, would you agree with that? Yep. So all these tests that we have done in regards to refraction have all been done in a planar environment, on a plane surface.
Okay. All right, goofball. Go ahead.
All right. They've all been done. So they've all been done in a fish tank or in a vacuum. It's all been done in a planar surface, right? Or in a planar surface, right? That's how they've been done, right? So all I asked for, and you may have the answer to this, have you got any of these refractive tests that have been done through a curved medium or spherical medium rather than a planar medium? So then we can now see if it acts the same way, because you are applying planar results to a spherical model.
No, and your question, that's why you and Jeremy, you guys could be related or something, dude. Because
get out of town.
That's the same fucking stuff that he used to say something like he wanted an example of refraction. What did he say? Something like a house, like I don't know. It's something that's almost impossible to reproduce, because you need the full scale. You need like the environment to do what you're asking for, basically. And it's something I don't know, because George told me one time. I forgot what he told me, and I know Rumpus. Those are only two people I know that kind of know refraction on a on the curved Earth. You know what I mean? Like the way in which it behaves, all that kind of stuff. Which exactly what Jeremy was asking for before is this is something I could never come across because there's no way to experiment with that. You know what I'm talking about? Like, of course, it's all done in a flat plane, in a flat lab or whatever.
Exactly right. So we are applying planar experiments to a spherical model, right? Which is flawed right from the outset. So you need to throw out all those experiments for the globe, get rid of the globe altogether because it's not there.
Yeah, you're right about that, man. Except for the fact that you forget about the annoying model, like the models that you can make in a computer program, you know, that most people don't respect or whatever, but you could model all that stuff in there and, you know, come out with the conclusions.
You can't really because you haven't applied all the variables to those simulations.
How do you know?
Okay then. Have you?
I personally haven't because I don't spend money on those programs, but the programs I put, you know, some refraction in there and stuff. But I know that, you know, actual people who model this stuff, yeah, they do try to put everything in there, sure.
Okay.
Like real atmospheric shit, yeah.
Like real atmosphere, like different temperatures and stuff. They've got different evaporation rates over the water or over the earth.
Whatever that's worth.
What do you mean? Whatever that's
Whatever that's, I don't know. Honestly, that's what I was saying about percentage. Percentage was talking about this shit earlier, and I had me reading all this stuff about evaporation and yeah.
Then you have different water depths, different water temperatures, different soil temperatures, different densities of rocks, pebbles, soil. You got all these different variables, and then you got the whale farts on top of all
Oh
that.
my
That you haven't
fucking god!
got
You think
in
the
there.
whale farts and the pebbles are fucking making this difference, dude? Why would you put that in a simulation?
Make a difference. If you want to simulate reality, right, you got to account for everything, Kosho.
Yeah, dude.
Come on.
No, but that I know the basic principle. So it's like I'm certain like the people who are like if you wanted to see how something would work, like if you imagine that the Earth is a sphere, then I know the curved model of the atmosphere and the fact that the light would be having to travel like at a curved path and increasingly going into, you know, more angled atmosphere. Yeah, it certainly is something that you could model that basic idea, but sure, if you want to bring in, you know, details like whale farts and shit, then you might miss something.
So we haven't modeled it. We've only simulated it in a computer program. That's cool.
I haven't modeled it, but I'm not a geologist or
not a modeler or a light person. You need to get your peoples onto it, Kosho. Get your peoples onto it. All right. Jeremy gets his peoples onto everything. You need to get your peoples onto it and model this light, right, on a spherical atmosphere. So get a fish tank, right? Make a spherical atmosphere in it and bounce a laser through it.
I can do that in a computer, man. I'm not going to do that in a fish tank. Yeah.
Oh, come on. Where's your commitment?
That's a waste, man. Yeah, you know, you've seen those fish tank laser refraction things. I don't like them because they're, you know, nobody respects that because it's not a real analogy for atmosphere. It's like the different densities are, you know, starkly different, and then yeah, it's like the light will sometimes bounce off the top layer of the water, like it's a mirror or something.
Yeah. I respect it as far as it shows us the refraction of light, okay, in a certain controlled medium, and I've got no problems with that. But it's not showing us the refractive properties of what we're looking through that corridor of sight from point A to point B, because that's changing, it's dynamic and always moving and always changing, right? And it's also too not showing us, like I said, the refractive properties over a spherical or a curved surface. It's not showing us that.
Well, I mean, I disagree with that. Like I said, isn't that that's what's modeled? Like, I don't understand. I gotta tell you something, man. I actually didn't sleep last night, and
you need to hook up with your girlfriend, mate, and get some sleep.
Well, that's the problem, though, dude. That's what I'm saying is I spend too much time on here, and I'm then working on my computer, and then by the time I realize it, she has like a deadline. Like if I don't reach out to her early enough, she doesn't want to seem like she has like a person coming over late at night. You know what I mean?
I thought you guys were engaged.
She did. I left my ring at her house, man.
What?
Well, because I take it off and I go in the shower, and I forgot it.
Oh my goodness gracious!
I still have to get her a ring too, you know.
You have to get her one.
Yeah, she proposed to me, you know.
Yeah, no, I remember that in the bra with a card and all that sort of stuff.
Right. But I don't have her, you know. And she actually asked me a couple of days before. She said, you know, what would you do if I proposed to you, or whatever. And I was like, I wonder, she really gonna do that? But then she did.
God. And you let her do it. You didn't get in first. Like, she gave you the heads up. It was a test. It was a test, Kosho, to see what you were going to do. And she waited, and then
she makes a lot more. She makes a lot more money than I do at the moment. So
that's all right. You want to be Mr. Mum, right? You can be Mr. Mum, right?
I'm gonna. Yeah, it's gonna turn around. She's in real estate, so she, you know, she's investing money and making returns pretty good. So
cool.
You know, I'm not in the same business. So, but anyhow, yeah, you know, she was gambling online, and she was at one day she won $37,000, but she doesn't stop, and
she lost it again.
She probably lost that, and probably lost more than that, and she wouldn't tell me, you know what I mean? So that's when I was worried, but she shared with me that she used to have like a gambling problem, so she has to kind of stay away from all of it now, you know.
Damn.
So I might be richer than her pretty soon. Who knows?
I knew a fellow when I was back in Victoria, and he was quite well off, extremely well off. He owned a pizza parlor shop thing, and back in the day it was like all cash money, and he was absolutely loaded. And Crown Casino had just opened up, and all the lights and whistles. But you go into Crown Casino through the front door, and they've generally got, you know, a really fancy car like a Mercedes convertible or Porsche or whatever. You too can win this. You know, put your money in the machine. Anyway, he'd spent the night gambling and whatnot, and I don't know, he dropped whatever money he dropped. He didn't really care about that. And on his way out, he bought a packet of smokes. Right, and he hated loose change in his pocket. And this is back to when the pokies or slot machines were coin operated. Okay.
Oh, no shit.
Yeah. Anyway, so he's got the change in his pocket, and he's walked past this machine and put some money into it and had a couple of spins, and he ended up winning a convertible BMW. Bang.
No fucking way.
Yes way. It was insane. And like, this guy didn't need it. He already drove some fancy car, so he didn't actually really need to win it. But it's just like, no way. You
It's like
actually won.
Scott Beach, man. Some people are already lucky and they just keep on getting. It just goes their way, man. That's cool as fuck. More power to them. But you know, I don't play stupid games like slots, dude. I really don't. My girlfriend's so dumb for playing online slots. You know what I mean? But at the casino, you know, if you play randomly like that, you actually be surprised, how lucky you can get. As long as if you're not sitting in there all day like an old person just fucking sitting at the same machine. If you're like sporadically going around after people on random machines, then you actually got a good chance of not winning a bunch of small games, but getting one of those big jackpots. Yeah.
Okay.
But I mean, actually, I do not take that advice. I do not recommend playing fucking slots, dude. Any day of the week.
I don't. No, I don't. I don't play them. I don't actually like them. To be honest with you.
You don't play anything?
I look when we do go to the casino, because occasionally we do go, because my partner doesn't mind the slot machines, so I'll play Texas Hold'em.
I didn't know you were gay.
Yeah, I don't mind that, but yeah, I only play on the cheap tables, like the $5 tables.
Vance, I don't think you heard me. I was messing with you, but yeah. You said blackjack. Or Hold'em. Sorry, Hold'em.
Oh yeah, Hold'em. Yeah, no.
Well, that's kind of like that's one step in the casino, but it's more like playing with other people. I play Hold'em sometimes at the casino, but when I was going to the casino like recreationally, like regularly or whatever, I played craps. Craps is always my game.
Oh, okay then. Yeah.
It's fun. It's a fun game. I probably told this story.
Go.
Because I used to have a good method of like, coming in with maybe 300 and then winning 1,000 or 1,500, and then going back to my room and come back down with 300. And this way, I would make positive money almost every time. But one time we went down there to Atlantic City to the Trump casino, the Taj Mahal, and I won $15,000 over the course of the weekend from 300. But I ended up losing it all on this Sunday because I didn't sleep. I didn't sleep that night either. Yeah, and then some guy I almost got in a fight with this guy at the table, and so I started playing like a fucking dumbass. And yeah. Anyway.
Such is life, huh?
Yeah, I'm not gonna I'm hogging up the fucking. I know why Merle was mad at me earlier, and now dude's fucking blabbering. What did you?
Merle was mad. No, he was a little bit.
But he had every right, man, because I really was choking up the chat, man, with some dumb shit.
Was that earlier this morning? Was that when I was here? I kind of.
You.
Yeah, no. Yeah,
No,
that's when. No, I think that's when I tried to. I know people came in from the other server and wanted to have a bit of a wine.
Oh yeah, that was going.
Yeah.
No, it was when Chronic was here, and Merle's just being, he was funny because I don't know. Chronic wanted to explain something, but he was like telling him Chronic was trolling, so it was funny. But
actually, yeah, I was here because Merle told me that I was getting trolled, or don't I know when I'm getting trolled? Actually, yeah, I was here.
I was the one trolling you, dude. I don't know if you remember, but
I don't really care if I'm getting trolled.
Yeah.
To be honest with you, I don't take it that seriously. If people want to waste their time trolling me for whatever reason, well, good luck to them.
I mean, I wasn't trolling. Everybody says everything is trolling. Like everything's always trolling for some reason. Like if I guess just Globers being in here, I guess, are trolling regardless why they're in here. That's what it seems like. I mean, I'm not in here. I don't think I ever really troll. Maybe rarely or something. I don't even know what trolling is. You know what I mean? Yeah.
I actually think Chronic's got an interesting job, actually, doing what he does, looking at the stars. I reckon that's pretty interesting.
Yeah, of course.
That's a troll.
Why is that a troll?
Because he doesn't have that job.
Okay, dude.
No, because he can't look. I'll show you. I'll tell you why. He
Because
told
he
me
gets stuff
the
wrong
other day that he observed Brandon as a globalist. So I went over to Brandon's server, took a screenshot, Brandon Flat Earther, with a date and timestamp and everything. I said, so if you observe somebody with a name Brandon Flat Earther on a Flat Earth Discord, you will then say you observe that as a globalist. And he's like, yes. So right there, his observations are in question. And it supposedly works in a job that's all about observations.
Yeah.
I mean, come on, think about that.
Well, think about what? He looks at stuff through a telescope. Like, hello, it's pretty self-explanatory.
Oh, no, he doesn't do that. He says he looks at data presented by someone else who looked at a telescope that he's never met.
I gotta write the fucking code. Fucking free.
He probably looks at pictures of stuff that comes through a telescope. I don't know. It sounds pretty interesting, though.
Yeah, he's got one of those dream jobs.
Okay, then he's a troll. Whatever.
Just like Giggles works for NASA.
Okay.
All these people, they're just goofy.
He told me that too. Gambino or no, Giggles. Yeah, Giggles is Gambino, right? But I'm inclined to believe him. You know what I mean? I don't know. I just.
I get that you don't like his profession or what he says that he does. I get that. But my boys will probably want to work for you.
Why don't I like what he does?
I don't know. Well, you keep on calling him out and calling out his profession, then he doesn't do this and he doesn't do that.
Oh, this is why. Okay, it's not. If he actually had that profession, he wouldn't be on Discord 24 hours a day with an army of sock accounts, completely obsessed with somebody who thinks differently than him. I've listened to actual
Chronic's on Discord with a heap of sock
accounts.
I
thought about Giggles.
He followed my. Well, see, I wasn't trolling 24/7. I was going in there over and over. And I don't know if he actually beat my record, but he could have, because the thing is, he was very much sloppy about it, and he was actually just doing it to argue with him and troll with him. So he would get found out and banned almost instantly, and then do it again. But he wouldn't even make a different picture. So I had to coach him on how to make good new accounts. You know, you got to make a creative name, and you got to at least make a picture. You can't have the fucking default picture. That's like a giveaway.
Everyone
Yeah,
needs
does
a
that
hobby.
sound okay? Just hypothetically, in your mind's eye, picture you've got a rocket scientist who works at NASA, who's been in charge of some of the biggest explorations of space. Does that person also command an army of sock accounts completely obsessed with flat Earth and spends 24 hours a day for years trolling flat earthers? Are those two things mutually exclusive? I think yes.
You'd be surprised, man. You gotta remember there was Gold Steel. Gold Steel worked at CERN, right? Scott Veach, he writes for in Hollywood, or Netflix and stuff. There's people who have done shit out in the world, and they still this is their entertainment. So
yeah, entertainment, not 24 hours a day for years. I've listened to science communicators on YouTube. They're fascinated by flat earthers. They reach out to flat earthers and talk to them and wondering, hey, how does this work? What's your idea on this? They're interested. They're not entertained. This idea of entertainment, like Giggles has said that this is just going to the zoo for him, looking at farm animals. So that's the scientific thinking for you. You go to the zoo to mock and ridicule animals. Who does that?
Well,
not a rocket scientist. I'll tell you that. Not a rocket scientist.
People need hobbies. At the end of the day, they've got to keep themselves entertained.
Yeah, and if you've got this high vocation, this very high calling in life, you would have very high calling, complex hobbies that would take, like when you watch, I can't remember the one movie where this guy was like designed trains and all kinds of stuff, and he had these real elaborate, complex mazes that were where he'd drop a ball and the ball would move through this pattern. The guy who played Hannibal Lecter, the same actor, but it was a different
Anthony Hopkins.
Yeah, a different murder mystery. And he set up this chain of events that made it look like his wife's boyfriend, police officer, actually killed her in a jealous rage. Anyway, I'm not going to spoil the movie, but this guy was a genius. he wasn't going on Discord arguing with people who do not like pineapple on pizza.
My boy, we've just opened up our own space agency.
That's why I would say he would be working towards
here in
Hold
South Australia.
You said say again. You said your boy, so a friend of yours, he's starting up his own space agency.
No. We've just opened up our own space agency, and my boys actually heard about it, or they read an article, and now one of them wants to maybe get a job there.
Huh.
How
You know
about
what?
those?
Hey, I'm gonna go for it, dude. I mean,
100% go for it, even though he won't get to space. I've told him that he won't get to space because it ain't up there. You'll never get to the moon. But yeah, go for it.
you never know, dude. They might have like an affirmative action type of thing with Australians, because like it's not like they're gonna. There's no Australians gonna actually qualify for anything that a real astronaut could do, but they want to make sure that you guys have your presence there. You know what I mean? So they'll probably send a couple of you goofy fools up there, and it'll be funny at least, you know. Especially, you know what? You guys will replace the Russians because we're not going to be up there with Russia anymore. So you can do.
Well, we've already had one Aussie go to space, so.
You said there was one. You said.
Yeah.
Yeah, right. He probably didn't have an Australian accent.
He's an Aussie. He lives here in Aussie land.
Is he from like a different country though, but lives there now?
No. He's always lived here.
Oh. All right, man.
Google
it. 2022, man. The world's changing, dude. Australians are going to space.
Yeah, well, this was in, I think, 2000 and something, 2015, I'm going to say. 15,
well, you know what then?
Hey, earlier your people are talking about the goal, right? What's the goal of people here? And crypto had said like, hey, to move the conversation about government transparency and accountability. I feel like my goal is to at least have science return to humanity. Logical thinking, step by step, and maybe even diffusing the situation so people who they've deemed to possess wrong thing are still human. They're not just a zoo animal to laugh at. Like having some sort of recognition of humanity, if humans are humans. What you see is a reverse.
Too idealistic. It's too idealistic.
But maybe
agree
you
with that. I
change
think
just
it's
one
important,
person. Man. Change one person and change the world.
That's exactly why I don't like Discord taking away any sort of speech or anything like that, because I think everything should be on the table. Because some people have novel ideas that no one's ever heard of. I like talking to those people.
Yeah, a lot of these people over at Gem Panda server, they've been banned everywhere. They just ended up at Discord. It's like the lowest possible level they could get to in life. Discord mod. Twitter, Facebook, all these platforms banned. They're banned.
I don't know if that I would. You know, it's kind of like the crow calling the raven black, right? You know, talking about people getting banned and stuff. But.
Yeah, I'm talking about banned by the platform, not banned by server admin or server moderators. That's basically, if you get banned there, the people who run the server are just telling you no, thank you. I do not wish to associate with you. And then to circumvent that and to make a stock account and keep coming back, that's cringe. That's another level of cringe.
It seems so, man. But you have to understand my position, and 24/7 at least. That was probably the first time I went into 24/7. I found I found what I was looking on the internet for, because I was looking all over the internet for actual flat Earth proofs and stuff, and there was so much wealth of conspiracy theory and all that kind of stuff. I made a lot of friends and shit, and so when they banned me like 2 months later because I was just being nice and they thought I was gonna eventually collect data on them or something.
It rocked your world, Kosho.
Yeah, it did. Yeah, actually,
rocked your world.
I joined Gems on a sock account with a text to speech kind of AI, kind of female Indian kind of voice, and it was just saying run heliocentrism exe, and just was repeating things like that. I got muted eventually, but at the time it was hilarious.
Like
Yeah, I
actually,
remember that.
that makes sense
really
because
laughing.
you're given Merle. That makes sense because in a way, you were giving them just a small taste of their own medicine, and they didn't like it. And look how they
Yeah, it was
responded
fun.
to it. They'll do the
Yeah,
same thing to other people and think they're cloaked. You
yeah,
do
but
it back to them, and they act like a victim.
but it's kind of hypocritical to say that you don't like something and then go, but it's okay that you kind of did it to give them a taste of their own medicine. It's a little
No,
bit
it's not okay.
hypocritical.
It's understandable. That's what I'm saying. It makes sense on a human level. It makes sense that they're constantly banning Merle. A couple days later, let him back in, ban him again. It's a spiraling. At some point, he's like, okay, I don't know what to do. I just come back, try to be me, and they ban you. See, that's what they really want to do. They just want to ban flat earthers.
Yeah,
So
but
he tried something new. He tried to meet them at their level, and even that didn't work because they're
well,
just triggered.
generally you get banned for your behavior.
Yeah.
Generally,
I called
all
Gem a
right.
goblin. I
Yeah,
called Gem a goblin. That was
yeah,
it.
and you've got to in a lot of these places, you've got to really push the line, right? Yeah, and you know too, Mel, yourself. You've had some pretty erratic behaviour at times that
Yeah.
you haven't been banned for, too.
Yep.
All right, so
Yeah. Yeah.
you know, if you're getting banned, you got to look at yourself rather than pointing the fingers at anyone else. And that's what everyone wants to do all the time, Crit. They want to point the finger at someone else for problems rather than themselves.
Yeah, that's the best part. When you've got no agency, they'll tell you you've got no control here. But yet they'll tell you you've got full agency and responsibility.
Yeah,
Which one is
but
it? If you've got no agency whatsoever, you're just there for them to laugh at you, and then they get that. They get to laugh at you, but they ban you anyway. Is that really your fault? How could that be your fault? They told you right from the very beginning, there's nothing here that you can do or say that has any impact on anything. You're only there to dance like a monkey for them. Then
Yeah, say
supposedly
something stupid. Say something
in their
stupid.
epistemology, you did that, and they ban you anyway.
So why would you want to put yourself in that environment?
Well, because you get to make a choice about it, right? If you want to do that, and you think that somehow that if you go into the lizard's den, right? You go in there and you try to change at least one person because there's a whole room full of people all like that. But if you can just crack the shell of just one egg and let a little bit of
that's
sunlight
funny you
in.
say that, because there was a guy in Gems. His name was Rizzler, and to most people, he was just awful, right? But we somehow found this bridge, and I could talk to him. It was really strange, but to most people, he was really quite awful.
Yeah, and that's exactly what I'm talking about. It's a perfect showcase. But some
it's
of these
like we
Discord
balanced
mods,
each other.
yeah, so two people, you guys are yin and yang. You found each other on the line and have had communication. Yep. But some Discord mod is going to make the decision that you two cannot communicate anymore because they're worked up that you did exactly what they wanted you to do.
Okay.
Yeah, I kind of miss
Is that
him
based
in
in
a
reality
way.
though?
Yeah, but you kind of, I don't know.
It was like a challenge sometimes, initially. and when I first went in Gems, Kosho, Chris, Gem, a lot of them, Veach, were really kind of kind and welcoming. So it took a while to get crazy, if you know what I mean. I even went like with Brummy one time. I didn't know Brummy was Brummy, but fucking some of the things I said to him, looking back,
dude,
crazy.
So crazy how volatile he used to be to flat earthers, and then it became, he changed his mind because he was one of the most hardcore, ready to pounce on people. You know what I mean? But that's just, he likes to do that. He's a fighter. You know what I mean? But I just think it's funny that he was like bullying people, and then turned coat.
started listening. That's the thing. Once people start listening,
being a journey. I know it gets used that word, but
it's a path he walked.
Yeah.
So a lot of times people aren't listening to flat earthers at all, but they think they know what it is, but they don't. And then they just flip out at anything. You can even present to them globe stuff, and they'll trigger about that, thinking it's flat earth.
Funny,
you have your own definition of what flat earth is, Crit. Right? Because I quite often hear you say, well, what is flat earth? Right?
A description of the surface of Earth. Flat Earth. It'd be a description of the surface. And the surface, I would describe the surface as flat.
As flat. Right?
Yeah, that would be my understanding of flat Earth.
Which it ain't.
Yeah, if you go off a benchmark.
Right, which it ain't. Right.
I've seen it flat.
Sorry, you've seen it flat.
I've seen it flat. Yeah.
Where?
Like in northern Minnesota, you can see as far as the eye can see. It's flat.
No, it's not. No, it's not. No, it's not. There'll be even as flat as it looks, it still ain't flat. To me, a piece of glass isn't even flat if you look at it underneath the microscope. You know, the flattest surface available, it still ain't flat. All right.
So it's curved?
No, but there's imperfections in it. Right. Just
you call that that's a different word. That's called topography.
But the salt plains, for argument's sake, right, which I would describe them as flat. But when you walk along them, right, you can see what looks like these little corrugations, if you know what I mean, right? Little itsy bitsy corrugations everywhere. So it really ain't flat, right? But it, over the bigger picture, it's flat. Right? I kind of get that. But I've heard you say flat Earth is more about a state of mind. I think I heard you say.
No, environmental. It's the environment.
That state is off.
Like the human environment, if you will. So Earth would be the environment, and I would go with environmental conditioning. So the organisms or life forms inside this environment will conduct themselves as how they perceive the environment to be. And what I'm seeing here is no change whatsoever. If anything, what you're doing is all the nasties growing to some sort of extinction level event.
Mm-hmm.
Like right now, if some of the news articles I posted today, they've stopped the search for life on Mars because Ukraine.
Yeah,
I've heard a lot of people. Sorry.
No, go ahead.
I was just going to say I've heard a lot of people describe like they almost reclaimed their mind going through this.
Really?
Yeah.
I bet you on both sides. But yeah, I bet you there's flat earthers who. I mean, there's. I mean, yeah. But go ahead, Merle. You explain yourself, man.
Almost like we given our trust and our attention to the mainstream, and we're just going on the assumption that we were being told the truth, and there was no doubt there. There was like actually faith in science. And I'm not using words intentionally there, but then when we addressed it and started to really hone our scopes on it, and we had it in the crosshairs, it was like, hang on a second. So that was a shift for people. I think that's what the paradigm shift is about, that it went from religion to science, and we can see we're in our own subjectivity and trying to find what the objective is. So
I must be the exception to that rule, Merle, because I've heard that quite a bit. Like my life has just like changed so much since I realised the trueness of my reality, so to speak. I don't know. Like I really don't see how it's really changed my life that much. I still look at things the same. Still live my life, pretty much the same. There's been no dramatic change whatsoever. In fact, because I've never had faith in the governments or these kind of systems that are around me. So I've never had belief in those. I've never believed the news or the narrative and stuff. I've always considered it bullshit for whatever particular reason. I just have, because it's just a story you're being told. As far as history is concerned, I've never really believed that, because we're told that a fellow sat underneath a bloody olive tree and God whispered in his ear, "Here's the word of God, write it down in a book, and I've got a Bible for you, and this is the word of the Lord," all that sort of stuff. I've never believed in any of that sort of stuff whatsoever. The only thing that's changed for me now, that what I live on, right? I have a different idea of what I live on and what I perhaps live in. But it doesn't change my life and how I go about my day-to-day existence or experiences. You know what I mean? And this is what I can't understand when I hear, it's just changed my life like so dramatically. We've all still got to work. We've all still got to get up. We've got families. We're looking for girlfriends or whatever the case may be. We're still doing all these kind of things. So I don't really get what the dramatic change is, apart from maybe a realization of maybe where you are, and maybe looking into a few more conspiracies or trying to find a bit more truth behind the so-called truth that we're being told. But anyway, yeah, sorry, go Crit.
Yeah, I thread the needle here. I think what Merle's saying is it's not that it changes anything. What it does is the world starts to make more sense. You can look around and you see things like before, like you'd be like, America went to the moon for peace and then carpet bombed Cambodia because Nixon was upset by the way Vietnam spends their government funding. And at first you just kind of, whatever, and you shrug it off. Like it's not your problem. There's a Monty Python skit called Someone Else's Problem. So like people don't see the problem anymore because they don't have any agency in the world. But once you start looking around and you realize the earth is flat and stationary, all these dominoes, they line up. The picture becomes clear. You see the world is being run by a bunch of psychopaths who live on a flat earth.
I've already seen the world run by a bunch of psychopaths anyway, Crit.
Yeah.
Like I really have. And this is only just for me, right? I only speak for myself, no one else. Like I expose people to things I know and whatnot, and most of the time they'll listen. They don't really kind of care, but they get on doing exactly what they're doing. But even having the realization that the world is run by psychopaths, Crit, like even knowing this, right? How does it change your life in any way, shape, or form other than knowing that the world is run by psychopaths?
Well, it pumps the brakes.
It's going to change.
Yeah, like if you're that far ahead of the 8 ball, that's really impressive. Because I was that far behind the 8 ball when I was younger. I thought it was just I would look at the lunar mission and be like, that's proof of American exceptionalism. The rest of the world is decades, centuries behind America. America's that great and that powerful that no other nation can do what America does. Until I started thinking it's not true, right? It's all propaganda. It was really about capitalism versus communism. Then the picture gets a little more clear. Then you look at the motivations. They say they do these things for peace, but they just offer war. Then the picture gets a little more clear, and eventually you see the world for what it is. That man behind the curtain is just another psychopathic idiot trying to fool people.
I wanted to ask all of you guys that, but go ahead, Ben. So, I was going to ask all of you guys a question, but for sure.
No, go.
Well, I was going to ask all 4 of you, and I guess anybody else. I'm just curious, because you said the thing about the world is run by I forget the word you used, Crip, but evil people or something, whatever it was. And actually, I am on board with that. And I was more so in the past. But anyways, but my question is, what year was it for each of you that maybe that realization became apparent?
Yeah, I could actually pick an actual day, but actual pluck out the year. It'd probably be around maybe like 2005 or 2006 when I got involved with the anti-war protest, and I kind of dipped my toe into atheism. I started doing like the flying spaghetti monster church, and I really, because I would go around to people like house to house and campaign that, hey, this a war in Iraq needs to end, right? There was no weapons of mass destruction. People are dying over there. You know, it's like it's completely, this is deranged, right? They're using depleted uraniums on supposedly the cradle of civilization. And you would get people would throw eggs at you. They'd call you a traitor. They would call you like a Muslim sympathizer. And these are all like, I live in a right wing area, and these sort of Southern evangelical or Baptists or born again, evangelicals. And I'm like, these people are nasty, man. And it made me question even the creation, even God. I go, I can't square what I know about God and about Jesus with what these people are doing. And they're telling me they're the moral majority.
2005, 2006.
Yeah, somewhere around there is when I really kind of said, something's not right. There's something terribly wrong with this, epistemology or this paradigm I've set up to make what life is, because it wasn't adding up anymore. It didn't make sense. Onward Christian soldiers bombed the cradle of civilization. I was just thinking it was just Bush, just being a cowboy. I didn't work into it that it connected it all the way back.
Fair enough. Okay. What about the?
What about you, Mel? Mel, jump in. Give us your answer. Mel.
You remember the year? I don't know if you remember the year or not, Mel, but just curious.
Yeah, it was a similar time because I went back to school in 2005, funnily enough, and a lot of I was around a lot of younger people too, and Zeitgeist came in.
Yeah, exactly.
And I had my first YouTube channel in 2007, but it was just like for art and what I was doing, like with film and shit. But then I went to England, and I don't know. I knew something was off, but I think I kind of had a gift, I reckon. Like, I was in a park one day, and the wind stopped, and everything just went like pin drop silent. And I can't explain it, but just this feeling came over, and I just felt so still and anchored. And sort of from there, like, I think it was a profound thing. Like, I felt like for the first time in my life that I was anchored, and I wasn't necessarily moving through space and time.
Wow.
And so what Flat Earth has done for me is it's made me reassess everything that I've been told and assumed to be true. And I'm grateful for that now. It's been hard because it's not something you can just do in a day or something.
Yeah.
But
that's definitely interesting though. Yeah, because the actual the leader thing or the government thing, but yeah, a lot of people in the flat Earth got into it from YouTube videos, maybe this or that, but yeah, actually having that realization sort of thing, that's got to be eerie.
Like even
yeah,
today,
it was like an experience. No, that's it. It was actually an experience I had. So,
like the duality of life, right? So you're looking at here, if they find life on Mars, I would say that would mean something, right? It would mean something for peace, world peace, that there is life in the, or if they don't find life on Mars, like if you give them their model and you pretend there's I'm trying to remember the short circuit, robot or whatever they call it.
Yeah, Johnny Five.
Yeah, Johnny Five. If you believe Johnny Five is on Mars right now looking for life, they would continue that mission, because either answer, if they find no life, that would offer world peace, because then they would show you that life here on Earth is extremely rare and precious, unique in the universe. If they did find life, you would still find a pathway to world peace, because that would mean you have to have peace, so you contact these other life forms and you're offering and you're showing a peaceful civilization. But what do? A war starts and they just cancel the mission. If they continue the mission, they would find some sort of peace. But they cancel it because it's not about peace. It was about a flex. It's some sort of cringe flex that they can control you and can control each other, and they can't. They can't even control themselves.
Well, not many people can.
Can you repeat your question again, Kosho?
Well, no, I was just curious. And actually, as I'm repeating it, I'll just go ahead just because I'm not going to tell a whole story. But I'm in the same time frame as both Crit and Merle. Actually, same reason as Merle. Actually, I think I saw the same movie. But the question was earlier. You were describing your evolution, I suppose, into this community and how it was different from everybody else's story. But one thing that you guys agreed on when you were saying that was about the evil. I don't remember the term that Merle used or somebody used, Crit used, but it was like, the evil controllers or whatever it is. You know what I'm talking about? Psychopaths, yes.
When did I realize the world?
When did you have that paradigm shift?
Yeah. It was round about when I was 16.
Oh wow!
That I knew that the world was run by psychopaths, right? Because I was given an article to read about the wealth of the Catholic Church, because I was brought up very strict Catholic, very, very strict. Church, Sunday school, Catholic schools, the whole nine, Bible studies, the whole nine yards. Parents used to volunteer in soup kitchens and the poor and homeless and all that sort of stuff. And I read this article on the wealth of the Catholic Church. And from that moment on, I knew that the world was run by psychopaths that did not give a fuck about anyone else but themselves. Yep.
It's in the article.
Well, it basically just showed the wealth of the Catholic Church. And back then, the Catholic Church, or the organisation of the Catholic Church, was the richest organisation on the face of the planet, the richest by far. And yet you have little old ladies out running fete stalls and fairs, trying to raise enough money to scrape together so they can go and buy some fruit and vegetables, so they can cook up meals in a dilapidated kitchen. They've got to raise funds to get ovens fixed and all that sort of stuff. When the Catholic Church themselves, which these same people used to donate money to, right, for the Catholic Church, so the Catholic Church could help the underprivileged, right? All they were doing was stuffing it away, right? Holding on to their little shekels as tightly as I can, and not helping the underprivileged at all.
Yeah.
That was the moment that I realized the world was run by nothing but a bunch of psychopaths in every single aspect. It was like a nasty spider web, from religion to government to whatever organization you want to associate to. It was from that moment on that I realized it myself.
So you would say, sorry, go ahead, Don, go ahead.
I just real quick wanted to say, I guess he's talking about a recent era, but dude, priests don't have no time to be working or farming or building. They got praying to do, man. They can't be helping a little old lady.
Well, Don, actually, you're next, man, because I was asking all four of you guys and whoever else also. But I was going to ask you, Bandsaw, because I see what you're saying, but maybe there's something like it must have been a real realization, because it seems like it's a huge jump from, I guess, not thinking all that, and then then you're talking about past the Catholic Church, but when we talk about things like the government having this agenda that has nothing to do with the voters or the Congress, but there's some shadow government and malicious things that people who are even more powerful than the government. Like, so at this time, you kind of had that idea as well. Like you jumped there to there.
It's all an agenda. It's all of an agenda about self-interest. Everything. It's all interconnected, right?
That's that's interesting, man. That was, I mean, you definitely beat the rest of us as far as year-wise.
Well, it wasn't a competition, but that's just kind of when I realised that the world is just full of psychopaths. Really.
I mean, that's cool. That's probably why you have a different story than everybody, like evolution, like you said, like, because I think for me, for instance, a lot of flat earthers stories or whatever, like how they got into this and this and this. I actually went through the same sort of thing, but with just different conspiracies, like not flat earth. And I also, I dropped some of the crazier ideas, but I held on to the ones I felt were true or whatever. But I think you if you already had this idea, like this this worldview or this paradigm in your head, then I think that it kind of wasn't that big of a jump. Like, it wasn't that big of a, like, it's not like it's new information, I guess, like that. It's not like a groundbreaking information that they're lying about something as big as the earth. You know what I mean?
Yeah. And I'm a very trusting person, Kojo. Very, very trusting. You can get my trust very, very easily, right? But that trust is for my family and friends, right? My loved ones, right? They've got it unconditionally, and they can break my trust over and over again, and I still give it back to them, right? But these are the intimate people that I know, right? But I've never been one to give my trust to an outer source for no particular reason.
I do, yeah. I kind of do see that. That's it. Yeah, that makes a little sense, because I do notice that. Yeah, sometimes you disagree with things purely based on just because it's like it's maybe an established fact to me or something, but it's like the information is not. It didn't come from somebody that it didn't come from a trusting source. It just came from whatever. So I kind of see that thing, but Don jumped in there. I just was curious if he was around the same time frame as me, or if it was years ago. Did you remember the year, Don, that you fucking? I don't even know where you're at, Don. Like, fucking, because you don't believe the Earth is flat, but you do know the people are crooked. Don's one of those fucking people who will talk over you all fucking day, and then when you fucking Xanax does the same thing, and you fucking call his name, he's fucking MIA, dude. Anyways, but yeah, that's all I was gonna say. Though it was the same with me. Like 2006, and it was because of that Zeitgeist movie. That was probably one of the catalysts, and then I started to watch more. And back then, conspiracy movies were kind of like, it was like the internet. Like, the internet had just started to come out with that kind of stuff. So it was like you can get your hands on these type of fresh videos of shit that you thought maybe other people don't even know about.
My grandmother told me a very, very sound piece of advice. Well, lots of things she told me, but one very particular piece of advice that she gave me was about the truth, right? And she always said, listen to one story, you listen to another story, right, and divide it by two. And she says that's somewhere where the truth lays, generally.
No, you've said this before, man. I remember it. Yeah. Okay.
Yeah.
And you're right about that, dude. That's actually such a simple way, because I'm into this community now. But when when I was in the conspiracies, especially, I would go on like news binges, like where I would be cycling through the news and then conspiracy, news networks, and just getting as much information as I can, so I can try to get a picture of what's really happening. And the reason why I would watch the news like that is because you can't just watch one station. You have to watch Fox News and CNN, like, left and the right, and then Iran and Russia and UK and everybody's perspective, because everybody is lying or telling their story, or the story that they want to say. And so you have to be able to take their stories at the same time and then find the truth that's found in like the parallels between their stories or contradictions or whatever.
Yep, exactly.
That's interesting. Yeah. Take the two truths and cut it in half.
Yep, pretty much.
That's exactly that. Yeah.
Or how many sources you get, you divide it evenly.
I mean, like I said, that's my method. Actually, that's a pretty cool quote, though. Yeah. I do history. I'm the same exact way with history too. Like, if you get as many sources as possible, I think that gives you the best chance of having an accurate or close representation of the truth.
It worked well with kids. That piece of advice, having so many kids. You know what I mean?
Yeah.
One would come and be complaining about the other, and then you go to the other, and they tell you a completely different story. So it was divided down the middle, and they both get grounded.
Exactly. But that's exactly. I mean, people don't realize how simple that is. Like when you're like, that's why I believe some of the conspiracies I do, is because I witnessed some of them firsthand in the military, and then you may be biased when you watch the news and you're a conspiracy theorist or whatever, but if you are literally watching, networks that are opposed to each other, and then you hear them say the same thing or flirt at the same thing, but then they are expressing it in their, in a way that would kind of galvanize their specific base or whatever. It's like you can kind of see like what really is the message that it may not be the truth. It may just be that they're propagandizing together or something like that. You know what I mean? Yeah, you just see the world differently when you paranoid way of thinking, I guess. Let me ask you that question, the same people and everybody, because I think about this sometimes. There's conspiracy theories I still think are true, but some of them I dropped. But I honestly do give myself a check. Like I have to sit down and check myself sometimes and say, like, is the evidence that I have for this thing, is it really as full proof as I hold it to be, or is it possible I've deluded myself in some sort of paranoid way? Like, do you ever have like a thought like that where you're like, you could be wrong about this thing that you're almost absolutely certain of?
Yeah, look, I'm gonna use the classic conspiracy 9/11 co-show. That I did go down, that rabbit hole like a little bit, and you were kind of convinced that there were some shenanigans going on, right? Because something didn't pass the sniff test, right? But I think there was just as many shenanigans with the theories given about what the shenanigans were. Actually, I think I've just lost the essence of your question.
No, I know. That I actually I actually I was warning against that last night because I don't talk about 9/11 that much, but there's the truths that I know about it, like the evidences I know about it. But all the other stuff I kind of dropped. I used to argue this, argue that, but some things when you argue them, you're not going to get anywhere with the person you're arguing with, because nobody can prove either one. You don't have hard evidence for it. And then you could also, and then the other problem is you might say something or argue something that is so crazy that you're going to turn people off from the actual truths of it.
To me, with 9/11 co-show, the bigger conspiracy, even if say the conspiracy of 9/11 is completely 100% true, or some of them, right? It doesn't change what's going on now and what 9/11 is used for now as a tool. It's used as a tool, right, to commit some pretty atrocious kinds of acts on innocent people that had absolutely nothing to do with it. And the fact that people get caught in the rabbit hole of if there were planes, if there weren't planes, if people died or didn't die, is actually it's pretty vile, to be quite honest with you, Kosho, because a blind eye is being turned to what it's actually being used for, as a tool for perpetual war. That's what it's being used for, regardless of what happened or if it didn't happen. That's what it's being used for. So instead of people standing up and going, "Oh my God," or what they want is the conspiracy of 9/11 revealed, and they think that everything will stop, which is just rubbish, because something else will come along. Right? But you don't see people marching on the streets, and you don't see a whole nation, right, jumping up in arms saying, enough is enough. Just stop doing what you're doing, right?
You're 100% correct. Yeah. You got a good way of thinking about things, because I'm in the same boat with you, but for a different reason. That's why every time people bring up the planes or this or that, I just tell them there's no point in doing that, and it's definitely it's a waste of an argument, because you're not going to convince people by arguing that. First of all, and second of all, there's nobody has that. All that is speculation. You know what I mean? Like, there's like speculation based on physics and blah, this or that. But there's actually hard evidence, and not only that, but what you've stated is exactly right. Like the fact that they had this, no matter if they were a part of it or not, they had this plan in place and utilized it to do their agenda is real. Like, they have a real agenda, whether they orchestrated this event so they can perpetuate their agenda, or if they just did it, but they have a real agenda that they're doing. And so I don't know what the solution is, but that's actually kind of why I stopped with conspiracy theories, being as obsessed as I was before. So there's not really a lot you can do with this kind of stuff,
No. I remember getting into it one day with Pete Shea, because he was actually suggesting that no one died. Yeah, no one died. Exactly right. And I said to him, people are dying, right, and are continuing to die. And he said it was all bullshit, 9/11, paid actors, rah, 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 all this sort of stuff. And I reiterated my statement. I said, Pete, people are dying, right now, right underneath your nose. People are dying right this very second, right, because of 9/11, and it's quite vile to which I use that word quite a lot. That word vile. Your protest against 9/11, because it is not changing the fact that people aren't dying because of it, whether it was in a building or on the battlefield.
It's funny, because I'm from New York City, and actually, even though I know that it's like watching the footage and stuff still bothers me and stuff like that, but actually I bought death certificates just to show I told Pete, like, name 3 random people from the death list or something, and I bought their death certificate just to show it to him, but there was really no point in doing that, because I was the same way. I just I don't know. There's no point in claiming that, because it's like it really just tarnishes the what was done. What was done by the even if our government was involved, or if they were complicit or utilized it or whatever. I don't know. It just kind of it turns it into a cartoon almost, especially at some point. There's a lot like it's not even, it's like a fantasy now. It's like a fantasy where there's nobody ever worked in the buildings ever. Like what? But yeah. You know what Johnny told me? I believe Johnny though. I don't care if people think he's a liar. I believe him. But Johnny said that because he writes music, and he said that there was a dude who worked in the building who had listened to one of his songs, and he sent him an email saying, like thanking him, saying, "Hey, I listen to your song on the way home every day. It gives me inspiration. I love your music." Something like all along these lines. He said this was like the day or a couple days before, 9/11, and the dude worked in the building, and he didn't hear from him again after that. So he says, he must have died in the the buildings fell or whatever. But I believe him. So I don't think it's an amazing story, but I don't I don't think he lies like that. So. I mean, that's just cool. I mean, I wish somebody will, thank me like that. Tell me I inspire them in that way.
Be nice, wouldn't it?
Just get shit from everybody.
Well, it's kind of self-inflicted.
No, dude. It's people in my position. People don't realize this, but I get shit from everybody because I'm. They say flat Earth adjacent is what people say or something. So all flat earthers, because I disagree with them, they're gonna give me shit. But all the globe earthers also, because some people confuse me as a flat earther, in the past. So I'm just like in the middle. I get shit from both directions, man.
Like there's a delicate aspect to this. I think, like say if you are a baller and you're skeptical, you still have this security that you have all this truth and evidence and the world's a certain way, if you will. But on the other side, and where it extends out of flat Earth, like, because if history isn't true either, then you look at things like museums and like there'll be like a dinosaur or libraries themselves, and then about the printing press, and you just start to reassess everything, and in a way it starts to become like a house of cards. Like you remove one card and things don't feel as solid anymore.
Do you remember the quote?
Yeah.
Oh, go ahead. Yeah.
I mean, I don't know. Like I can only talk for myself, but I've actually really been through this. Like reassess this to the point where it leads to us. Like if you go all the way to the end of the hallway, you get to a door. What the door is the creator.
Like in the Matrix.
And no one knows what's on the other side. But it's about us, like whatever's behind that door, that's where we really come from.
Oh yeah,
and
right.
For some reason, it's a secret.
Mm-hmm.
Like I have no idea.
Did you not believe in a creator prior to Flat Earth Mill?
Yeah, but not. It wasn't. I followed it all the way through. Like it was literally like there's a scene in I think it's Yellow Submarine. It's like a Beatles cartoon.
Mm-hmm.
But there's basically this hallway and all these doors.
Mm-hmm.
So you basically open all the sometimes you'll open a room and it'll be like, what's this? Like that's the rabbit hole, right? The maze.
Yeah.
But if you open all the door, you get to a point where you almost can't go any further. And that's what I've found. That's why some of my frustration was, this is much bigger than flat Earth. This is the whole, from evolution to the Big Bang to dinosaurs. The whole story about us is a creation story. And what now a lot of us feel is we haven't been told the truth about it. So it's exciting and kind of scary at the same time. But I feel there's this anticipation in a lot of us, like we're waiting for the next move.
Okay. So you believed in the
all of it, all of it.
Dust, explosion, slime onto rock, then standing up straight. You believed in all that, Mil?
At different stages of my life, like, yeah, you know, I bought into it.
Okay.
I bought into a lot of things.
Yeah. No.
Again, because kind of science wasn't on my radar. For some, it was like stealth. That was the one thing I didn't have doubt, because where I think science is clever is people used to be religious, right? They had, at one stage, they had faith in the church.
Yeah.
And then that changed, and public sentiment changed.
Yeah.
And that's when you see science emerge. And science was meant, in its purest form, it was meant to be that thing where you go from faith or belief to the actual.
Yeah.
Like reality, like you get down to the nuts and atoms.
Yeah.
Right?
What's an
atom? You know what I mean?
What's an atom?
So all that, I thought science was legit.
Yeah.
And
No,
I'm not embarrassed or ashamed to say that.
No, neither you should be. Neither you should be. But yeah, I'm lucky. I never believed in slime standing upright. Well, thank goodness.
Yeah.
Science still has a high faith component, though. Have people really seen an atom? No, it's a starting axiom, a starting philosophical position that the world breaks down to these atomic units. It's just a philosophical statement that they say at the start to guide the rest of their investigation in the hope that they discover evidence for that proposition. Have we really discovered atoms? I mean, or rather, have we found this indivisible unit that everything breaks down into? No, we haven't. We've broken the atom, we've split the atom, we've gone beyond the atom, supposedly with quarks, muons, leptons, and we're finding 1,000,000,001 different particles, like, you know, every couple of years or so. So, I mean, have they found the stuff that really goes with what they're saying? No, they just stated their, you know, position philosophically and just went from there.
Do you mind if I ask you, because we all answered a question just a little bit ago, just I was curious. Don didn't answer it because he's an asshole, but everybody else, we were just, because somebody said something about, like, you know, how psychopaths kind of run the world, you know, secretly behind the scenes, or, you know, because this is something I believe too. Maybe I don't use those words, but I know there's an agenda in this kind of thing, and I'm just curious, like, do you remember what year it was that you maybe had that paradigm shift where you did not think this way, and then you suddenly came across this idea and then started thinking this way? Do you remember what year that was?
About the shape of the Earth?
No, not the shape of the Earth specifically, but I guess, like, about the a malicious, you know, secret kind of shadow government or shadow agenda, you know, Illuminati type of entity. You know what I mean?
It was a while ago. I mean, I guess the main thing that showed me how evil the governments were, probably 9/11.
Were you right on top of it when it happened? Like, you were there, or was it like a couple years after or something?
I mean, governments have always been pretty evil and foul. I mean, you could always see that the narrative just doesn't add up. I mean, the moment the narrative has the story that they're telling you on the news to try to wrap everything up with a bow doesn't quite work with Waco or with the Clintons, you know, and you have, you know, no real resolution of the narrative, you just stop trusting them. You know, you don't trust them with the history that you're told, or, you know, you're told one version of history, and then later you find out some stuff that changes, you know, your interpretation of history dramatically. You know, people, you know, on some level always know that someone's bullshitting them.
Yeah. That's interesting. It's unique. You know, you've always been a unique flat earther, but yeah, Bandsaw also had a kind of unique like much further than because I think me, Merle, and Crit it's like almost the same year almost, around the same time, like 2005, 2006, 2007. But yeah, you must have seen it, I guess, all throughout your life, I guess. Which makes sense. Like, if you see something happen like a 9/11 or a Waco type of a thing, and you live through it happening, and you observe the narrative that's given to you, and it doesn't, jive. Like there's like they're you know what I mean? It's like they're obviously orchestrating some story to hide something or something. You get like an eerie feeling. So I kind of see what you're saying.
We've never really had any big conspiracies here. Hey, Merle, actually thinking about one, what do you think about the Port Arthur massacre, Merle?
I think, not to go Pete Shea, I think it happened.
Yeah.
I actually know someone who apparently knew that dude.
Uh-huh.
But what happened afterwards, like with Johnny Howard and the bulletproof vest, if you know what I mean?
Yeah.
And the way Australia kind of, I mean, a lot of Americans have pointed out to me how cocked Australia is for that. And I've had some pretty visceral kind of anger sessions about America and their freedom and how we gave ours over in a way. But it's an awful event. But again, it's what happened out of the back of that that's a concern for me.
And I don't really associate guns with freedom myself.
Yeah, I'm similar way, I think. But my dad had guns, and he was part of the Melbourne Shooters Association. So I grew up around guns, and my dad was always like, don't touch them; they're dangerous. And so I was always a bit scared of them. But I've been hunting and seen all that. But yeah, the American flat earthers on like Hitch. Different people. They almost had like just almost like gangster. DQ, like they pulled gun on me, like they weren't loaded, but they were just like blam blam into the camera.
Oh, funny. Yeah, I grew up around guns. I was part of the Sporting Shooters Association. I've done a lot of shooting when I was younger and whatnot. But yeah, I think Australia is a lot different to America when it comes to gun mentality, isn't it? Like it's not part of our vernacular, so to speak. Because but unless you were really a farmer, type of thing, or a sporting shooter, you probably weren't really exposed to guns, too much. And we really haven't had. Apart from Port Arthur, gun violence is pretty much unheard of.
Where are you with that thing though, the Port Arthur thing? Because you asked Merle, but were you? I don't know.
There seems to be a lot of conflicting stories about where he was at what particular time and could he have done exactly what he did. He was definitely there. He definitely had guns. He was definitely crazy, and he probably did, shoot a lot of people. I think he could have been, if he was responsible for killing everyone, I think he could have been stopped a hell of a lot quicker than what he was. A hell of a lot quicker than what he was.
The cops used to have have armed weapons, like they used to be armed or whatever.
Well, back in the day, back when that happened, it wasn't a common thing. Our police were probably more like the bobbies, exactly right. Whereas now the coppers are like SWAT. You know,
they have guns now.
Yeah, they're like SWAT. You see a normal copper walking around the street. They've got bulletproof vests on. They've got guns. They've got tasers. They've got mace. Everything. The whole body cams, the whole 9 yards. And that's just a normal copper, pretty much walking around the street these days. They're
They're
fully.
like Batman,
Yeah,
like
yeah,
a
they are.
utility belt.
Yeah, they're fully kitted up. 100%, they are fully kitted up, and they're actually quite intimidating. Wouldn't you say, Mel? You know, the look of them with the way they're sort of all kitted up there. It's an intimidating kind of appearance that they do
Yeah.
have.
All they need is some grenades and a bazooka.
Yeah. Well, it's not going to be far away with the.
That would bother me big time.
Yeah, but
I mean,
back.
Just the contrast of them not having them then, right? And then now that they've, I guess, you have these strict laws because of that event or whatever. Now the cops do have guns. I mean, less people have them. It's just a weird.
Yeah, but I think as far as the gun handback, so to speak, I think a lot has been made about it, especially by Merle brought it up, like like Hitch and whatnot, like Americans, like we kind of cucked to the system. There wasn't that many guns to give up in the first place. In all seriousness, there weren't that many out there. So who really cuck? Maybe a few people, perhaps maybe, but maybe they didn't really want them or need them either. They didn't see the need to have them. Like we were founded a little bit differently, Kosho, to what America was. Like your
You guys were
history.
criminals, yeah.
Yeah, pretty much. And criminals can't have guns, all right? As we all know, we're in handcuffs. But you guys were founded on rebellion, civil war type of thing. So it's a completely different mentality. It's written into your constitution and everything. This gun mentality. So
well, we think that the guns are the only things that keep us free from a tyrannical government. The government has the force of the military, the laws, and other things that allow them to potentially tyrannize the people. The guns that we have allow us to keep them in check and keep them from busting down our door and taking us off to some FEMA camp potentially.
At least keep them at arm's length. Yeah.
Essential to keep a free people free from a tyrannical military or government.
Perhaps they may. Perhaps they may not. Who knows? I don't think it's ever really been tested either.
I think it might have been tested, though.
You think it might have been tested?
Well, let me suggest something very quickly, because I was just thinking, like, why would this happened in the early 90s, right? I don't remember exactly when the Port Arthur thing was. That the 90s or okay, so it's not. It doesn't seem like that was necessary, because for it's not like they, then put all you guys in martial law or something. But what is true is we do have our weapons in America. We do have a base that is, there's people who are anti-federal government, and so because there's even a base and there is weaponized people, there's certain things that we can't, the government can't get away with. And if I was going to think of some examples, I would probably think of some of the examples of what the Australian government was doing in the past 2 years. I know there's a lot of people complaining about it, and it almost seemed like there's nothing you could do about it. You know what I mean? Like the kind of curfews, and like you couldn't even like go for a walk with somebody and stuff like that.
You're talking about the recent curfews.
Yeah. Like this is the restrictions and all that. Yeah.
Yeah.
I think they can get away with that in certain places in America because people just wouldn't. They I don't know. It's just like they would fight back.
Perhaps not. But didn't some states in America too also have curfews and lockdowns and restrictions as well?
California.
Yeah, there you go. So
California's
California. They did get away with it in certain places, and I don't think having a gun really prevents these things from being implemented, really. So what are you going to do? You go, you know what? I'm not going to obey these laws. I'm going to walk out on the street with my gun because I'm a free man, and I'm going to walk the streets, and I'm not going to be locked down because you tell me I can't go out there because of some fictitious, mysterious disease that is floating around, and you're gonna take that risk because you have a gun.
Well, no, it's not. It's not that. Really, that's not the way I'm framing it. I think it's more of what like they're gonna test their boundaries of like let's just say let's pretend there's a completely malicious event and it's actually orchestrated and it may not it's that based on no truth, which I don't believe. I think it's a real thing, but let's just say it's based on no. So all of these different governments are going to want to test their boundaries, like see what they could get away with as far as restricting the people, martial law, this kind of stuff. And I just think that they didn't even, like in Texas, for example, they're not going to attempt the same sort of thing. And it's not because they're worried about people with guns, but it's just people are not going to stand for it. Like they really would just go out and, go on some protest, which we did. There's protests in Minnesota at least, or Michigan and shit like that for all that kind of shit. So, but yeah, I don't know. That theory's not. I'm not actually. I've only theorized that because I'm just curious, like why. What is the reason why they did that in the 90s in Australia? Like, why did they take advantage of that to take away the guns of the Australian people? You know what I mean? Like, what? Like, it doesn't make sense to me. Without a big picture.
Well, Fiona Barnett takes a different look at the massacre. She basically implies very heavily that it was some sort of orchestrated, nefarious plot by, to basically take away guns or something like that. I think it was the Port McCarthy massacre that she talks about where the patsy that was labeled as the gunman couldn't possibly have been the gunman based off of his IQ. She talks about the number of headshots versus the number of shots that were put out from the gun, showing a very high degree of accuracy. And she talks about how only people with a high spatial intelligence and highly, smart people could deliver that sort of a ratio. And the person who was, given up as the patsy was a fairly non-intelligent kind of dumb person who wouldn't have that sort of spatial IQ to make those headshots or to make those shots accurately. If I'm pointing to the right massacre here, she mentions it in her book Eyes Wide Open, but she talks about inconsistencies like that show her at least that what we're being given as the narrative is probably bullshit on some level. But I need to look at the book and see what she says specifically about it. But I think she's talking about the Port Macquarie massacre specifically. But I might have to
Port Arthur or whatever. But yeah,
the Port Arthur one, and you're spot on, Lemon. But and like I said to Kosho before, like it obviously did happen. Now, how many people this person was actually responsible for killing? Because they attribute 35 to him.
Wow.
Now, he may have only killed one, right? I don't know, but I'm sure he killed at least one. Right? He was there. The guy was bloody loopy.
Wow. What kind of gun was this?
Sorry?
What kind of weapon was he using?
Oh, yeah, he had a few, Kosho. He had a few, and he was a member of of a shooting club and stuff. So he did partake in shooting. So he probably could shoot. Now, could he shoot 35 people in the time that he did, and apparently the different locations that he went to? Well, all these things are up in the air, and maybe there were other people involved in it. But and the end result was to hand in your weapons,
Right.
But it really ain't that hard. And look, all they did was restrict a certain kind of weapon, semi-automatic, right? A semi-automatic weapon. It is still pretty damn easy. It's still just as easy now to get yourself a weapon as it was back then. It's no more difficult to get yourself a gun. It's a very easy process. You have to go through the same sort of system, and bang, you're approved. The same regulations are still in place. You have to store your gun and your ammunition separately. You can't have loaded guns in your house or anything like that. These sort of things have always been in place. These laws haven't changed.
You guys are not going to beat any birds the next war, I'll tell you that. But just very quickly, I'm just curious about this shooter. Like, what was that? What? How did that end with him? Like, what happened with him? Did he die in the event, or
No. He was caught and he's still in jail under protective custody. The guy looks a mess. Yeah, he's been in jail ever since. So what's that? That's 28 years he's been in jail. Thereabouts.
What was his response? Like how like when he was like, I don't know. I'm just curious if you remember the kind of how he behaved in court or on the news or whatever it was. Like was he seem remorseful, or did he seem like he had an agenda, or what?
No, the guy does look like he has mental deficiencies.
Yeah.
to put it like he doesn't seem all there. To be quite honest with you, yeah, it doesn't seem all there. But I'm only basing my opinion, Kosho, on a few snippets on the news, things I've read in the paper, about him. I don't really know too much, but once again, it doesn't pass the pub test. Yeah, the sniff test. So you get one story, get the other story divided by two, Kosho.
Well, yeah, you're right about that. Look at the outcome. Look at what the outcome was. It doesn't matter who. It doesn't matter if he was a patsy or if he did it and they took advantage of it. The outcome's the outcome. But because with stories like that, like all we're left with is a speculation. But I'm reminded of the guy who killed JFK's brother, I think in 68 or 67 or something. He first of all, he didn't someone who was there witnessing it said that seemed like he was glazed, his eyes were glazed over, and he shot the gun like aimlessly almost, not even at that Bobby was it Bobby Kennedy or whatever. And so, and he also said he said himself that he was hypnotized. And he had no idea what after he woke up for days, he didn't know what he was doing. So it's like, I sometimes wonder if, people like that, like if you're simple-minded or if you kind of could be influenced or whatever, because there definitely were programs like MK Ultra and stuff like that where they purposely, did these sort of exercises on people. And,
yeah.
It could have just been a coincidence also that they took advantage of. Who knows? Yeah.
Yeah, who knows? I don't know. I don't know. Do you think it's changed this country much, Merle? Apart from the regulations of our guns? If you're there.
Yeah.
In what way? What way? Like we can't have semi-automatic weapons, but how else?
Well, let's go to Ned Kelly. And the Eureka Stockade kind of time.
Okay. If that's the truth about that story too. But anyway, go on.
I think just like say the unions and when they all get together, or say the bikies, I get the impression that say King's Cross, certain places, the nightclubs, crime, guns, weapons, drugs, alcohol, cigarettes, them coming off the docks. There's something going on that in Australia that it's happening everywhere, but we're so far south still kind of ruled over by the Queen. It just,
yeah, I know.
we're just sort of in a weird time warp, and I don't feel like we've really got independence and what's happening here. Like, I tried to join like a dance sort of crew, like even get like play music and be around that, but I can't even get in the door unless I've had 4, coming up to 4. So I'm a bit worried about it, and I'm thinking like I've got to I'll go back to England because I've got a passport to England. Like, if I can't do what I need to do to survive, and the things I want to participate in, I can't participate in because I haven't, played the game. I've got to go somewhere else. That's what it feels like. And I hate that. I hate feeling like that. And that's why I've been getting a bit triggered, because I'm worried about it, if I'm being honest. Not to make it about me, but I'm just saying like that just as a citizen of Australia at the moment, I
You're
don't
obviously,
feel like...
I'm not trying to analyze you or anything like that, Mel, but you obviously got, a few financial issues going on because of work and all that sort of stuff. Yeah.
Yeah. Yeah.
Like I gave you some advice the other day, mate.
Yeah.
Just in regards to a forklift license, where just quickly, you can make yourself some good coin, right? And with that coin, right, you can then, right, go, you know what, I'll save that coin, and what I want to do with that, I want to go over to England. I'm going to pack up all my stuff, and I'm going to go over to England, and I'm going to pursue what I want to do. But you can't really do that unless you got coin to do it. You know that,
Right.
right?
Yeah.
And you can, in the right warehouse, cool room or whatever, you can earn $40-50 an hour quite easily, Mel. Right,
Yeah.
no dramas
Yeah.
whatsoever.
I just got to
I know
find somewhere not too hectic,
Well, what do you mean hectic?
I just don't want to... Oh, well, it can be dangerous. I've seen some mad forklift drivers in my time.
Yeah, it's not as bad as what you're making out to be. I don't think they're fairly safe environments to work in. You're not going to have too many people skewing you with the forks as you're walking past them. I think
I
that's
almost killed somebody, dude.
God, now when I'm trying to encourage Merle into getting his forklift license. Thanks,
No,
guys.
you should get it, dude, for sure, because they're versatile, and definitely it's no, but it was this dude that was he was actually higher ranking than me, but he was working for me, and we were pulling some boxes out of the trash, but we had like like those wraps that you, like if you have like a Jeep or a truck or something, you wrap these bands around so you can tie something to the roof, and they have like kind of these heavy metal hooks. You know what I'm talking about? Yeah. So we were using that to pull this giant box out of the fucking the trash bin, and next thing I know, the box broke, and this thing was like super tight, and it literally, like, the metal thing flew like as fast as a bullet, it seemed, and it went like right next to his face, but there was like a 2 bars right in front of the forklift, and so just barely, if it was like a little bit to the left or something, it would went right through his head, and yeah, dude, but
funny but not funny.
no, it was funny. We were both. I mean, I was like, "Holy shit, dude!"
I can assure you, Mel, you're not allowed to do those sorts of things. They've got OH&S regulations, so you're not allowed to do them.
I got some videos. I'll fucking send them right now.
Yo, what's up? Can I get y'all for a second before I go?
Go.
Don, I called your name, brother, and you embarrassed me
You
for everybody, dude.
Yeah, you did.
I didn't ignore it. It was like drama. I had drama going on.
I feel it. Okay, my bad.
But I'm like last minute getting ready for this event right here. This event in 20 minutes. It's probably 300, 130. It's going to be like 40 or 50,000 in the birth. Give me that. So
Get high first, man. It's the only way you're gonna be able to actually.
First place will probably be like 10 or 12,000, probably like 10,000. So cash out me $50. I'll give you 25%.
Wow. What are the plate like the places
players.
or whatever? What places get paid?
Probably 35.
You said first place is what? 2,500?
Oh, 10,000. Yeah, you could get a quarter of it. It's
you
like
need $50. You said?
Yeah. I'll cash up you the ticket, or I'll DM you the.
Yeah, I don't know why. I haven't slept, so you know, you could have said that you needed it for some other fucking reason, and I would have fucking.
I'm just saying, if y'all got money, y'all want to fuck around, cash out me $50. We fucking will motivate together.
Well, if somebody else wants to throw down, I won't throw down the full 50. But otherwise, like I'll throw it down. But yeah, just DM me with the
whatever ratio you want. Let me take a picture of the ticket here.
I don't care about the ticket, man. It's not like I'm fucking like I don't believe you. But you're smoking weed. Why am I going to fucking invest in a fucking dude who's
I smoke to get right, buddy. Let me here. I'll dox myself to you. You gonna keep it secret?
I'll keep it secret, man. But I mean, I'm gonna have to cash app you, and so I'm gonna have to. You're gonna. I think we've cashed app each other before, man. So.
Right.
Did like Venmo or something. I don't know. Yeah, but you have to actually win, though, dude. You know what I mean?
I don't know. I show.
Coach, so I'm consistently in the top 10 or 15%, like between, the average place will probably be somewhere around 23rd percent. You know what I mean?
What do you think 35th place pays?
We'll probably pay about 400.
Oh, wow.
So you get your money back. Like, you know what I mean? Like we'll get our money back plus a little bit if we make the cut.
I would like it back, and I would like double if you could afford it because you placed well enough. But if, of course, if I don't see it again, then we'll figure it out, dude. Because figure it out, dude. Send me whatever the thing is, dude.
Damn, easy money there, Don.
Yeah, no, I thought you were gonna say to me. It's like, yeah, exactly. Don, yeah. He's like, he wasn't even getting ready to fucking. Oh, he's like, yeah, I'll give it back. I'll give you exactly what you give me back. Like, what the fuck? That's my investment, dude. And offer me the same money I'm giving you back.
All right, I DM'd you. Anybody else want to take a shot at turning $50 into 2,500? Okay.
See, that's. I mean, I have to be honest with you, Don. But what you just said right now, you just said that out loud. You know that, right? You're saying that I have a chance to turn this into 2,500. Then
it's legal.
Well, that's fine. I don't care if it's legal or not, dude. I'm just saying you just offered everybody $50. They could possibly turn to 2,500. Yeah, are you saying that my $50 could also turn to 2,500?
Yes, I'm gonna pay you, Coach. So we're teammates now. Or DM me, everybody.
Right. So now there's 10 people in the room. We all give you $50. We're all going to win $2,500.
No. First of all, I can only take up to 3 people.
Okay.
Second of all,
I gotta pay my lawyer fucking $750 in 2 days, dude. So.
All right, Coach. So look, I just doxed myself and gave you my cash up.
I don't, dude. We've cashed up. You remember I was doing that that test? I need that GPS thing. I think you Venmo me or cash app me or something like that.
Oh yeah, no, you backed out of it. But look, the picture.
I didn't back out of it, dude.
The picture is. No, look, you're gonna be suspicious. The picture is of chemo, but that's my cash app. Okay.
All right, man. I gotta warn you that was suspicious that you just that's a fact that you just said that. So.
Oh.
Yeah, you know what, dude? This part of the Discord.
$50. You make 2,500.
possibly make 2,500. Meanwhile,
that much money. We have to win. Okay, I need team conscious partnership mind motivation. That's what I want. I don't need his $50.
What was that?
I don't need his $50. Trust me. Okay.
What was Sean Penn's name in Fast Time at Ridgemont High? What was his character's name? Remember?
Spicoli.
Yeah, Spicoli. Yeah, I feel like I just fucking giving money to Spicoli to win this fucking poker fucking thing right now.
Yeah.
All right.
Well, you slow. First of all, you ain't give me shit yet.
Dude,
so
I haven't slept. Dude, give me shit.
Damn. He's on you. He's hassling you.
I got 15 minutes. We start in 15 minutes. I'm right here about to walk in. I bought my ticket 2 days ago, yo. I'm ready for this. I'm telling you, I'm ready for this. What did they say, though, about two minds thinking together are as strong as 10 minds separately, right?
That's not true.
That's all I'm saying.
Kosho ain't going to sleep for 3 days just wondering whether or not how you've gone. Now, you've taken his last $50. His girlfriend needs it. He has to buy a ring. Don. Oh, he's going to buy a ring.
I don't even believe that. I believe everything that he's going to do, but I believe, like, that this kid is like a little busybody.
Yeah, I am. I'm doing some fucking real estate shit now, but don't worry about that, dude. Hold on.
Chronic likes coming around and talking about what he done did and all this. Kosho, Chronic didn't do shit I told him to do. Chronic just fucked around.
I bet, dude.
We're gonna do this, and we're gonna come back.
I bet you're not the best coach, dude, but I do suspect that you're a fair player. As long as you take this game seriously, like, don't fucking just be wild just because you just got fucking free money, dude.
Nah. All in. 7-2 offsuit. Don. Boom.
How many people are in this tournament?
It's be about 300.
300.
You at Turning Stone?
No, that's next week.
Oh.
You said that's a picture of Chemo. That's not a picture of Chemo.
Well, the face is.
Oh, maybe it is.
That's that gift with the fish chopping his head off.
Well, you guys got what kind of tournament is it?
Hold up a second, Don. You're gonna have to give me some real. Just send me the fucking name to send this to. I don't know what the hell it is you sent to me, man.
That's my Cash App. If you see Chemo's face, that's me. Pancakes in the morning.
Hold on, where's the picture of Chemo?
Hashtag.
Dude, just type out your freaking name, dude. Okay?
I'm gonna send you my Cash App too.
Never mind, you did type it out. My bad. I'm sorry.
Slide me $20 real quick.
Just look for me. Money sign, pancakes in the morning, Chemo face.
I see him. I see him.
I'm talking. Well, Jeremy, you could look too. Jeremy, you gonna send me 50 for 25%?
What kind of tournament is this that you're going to?
It's a 10,000 added, no limit hold'em tournament.
Okay.
I was gonna post my Cash App, but then I remembered you can dock somebody with that.
Fucking doc. Your name is Jeremy. Fucking dox yourself. What the fuck? Dude, if Kosho's already James Bond spy, he already knows who you are anyway.
James Bond. All right, hold up, bro. Oh, that is a picture of Chemo.
Kosho, if you share my name picture just on your own for no fucking reason, that's some. Please be safe, person. Okay.
Yeah, hold up.
You should have thought of that before you sent it, Don.
I thought about it. I don't care. You can expose yourself. Look, doors are gonna open in the universe for what's meant to be.
All right, gold. Godspeed, good sir.
Boom.
Is there a limit? What are the
25% get excited?
What are the player limits at each table? Like how many people can play?
I'm playing 8-handed.
Okay. Oof. It's not bad.
It's the easiest $50 Don's ever made.
Shut the fuck up, man.
Dude, I had a guy give me 600 last night. He didn't have a card he could hit in the deck. Put it in there without thinking, like instantly. And I think I had just switched tables. I was like,
man, you have to lose this eagerness fucking thing, dude. It's gonna blind your it's gonna block your judgment.
Let's get this. All right, Coach, we're not eager.
Every tournament I've ever won, it was when I was completely relaxed. You know, it's weird. Like if you want to win, you just like, I don't know, just works against you.
Kosho, I've won hundreds of tournaments. Let's do this, bro. Let's do it, man.
Hundreds.
Yes, probably 1,000.
1,000. From hundreds to 1,000. That went up pretty quickly.
Well, it could easily be. I mean, you think I'm kidding, Bandy? Like, I'm not kidding, bro. I mean, like, there's little. You think about it, you're like, oh, well, there's these little one table things, and you know what I mean?
Yeah.
Yeah, I mean, it's like, dude.
Oh, look, I'm not doubting your ability, Don. And if the conversion rate weren't so crap, I may even consider it myself. Like $50 American is like 2.5 million here in Australia at the moment.
Jesus, it's only a freaking tank of gas now. Not even. It's 10 gallons.
You seen our petrol prices? We're like $15 a litre. It's insane.
$50 a liter?
Jeez.
May as well, bro. It's crazy. It's going through the roof. Kosho. Through the roof.
You need to buy a Tesla, man.
It is. Well, 2 days ago, I paid $2.09 a litre, which is about $8.59 a gallon over there.
How much is $8 in American and you know regular money was?
Exactly. So it's probably even more than that. It's insane.
Either way, man, I feel for you, dude, but you're gonna have to fucking figure some shit out, dude. Like get a Tesla, right? Got a lot of Teslas in Australia.
They're becoming, the electric cars themselves are becoming more popular. Yeah, you see the charging stations popping up all over the place at the moment. So, but I live I live in an area. I'd have to get like a home charging system too, which I suppose
Do you know how to ride a bike?
No.
How weird would it be if you saw like a grown up like riding a bike with training wheels on it? Yeah, but
that's quite funny actually. Funny and sad all at the same time, actually.
Well, there's places where like rich people, it's socially acceptable for rich people to be riding bikes and shit. So.
Okay, Kosho, I'm going in, man. I'll probably. What do you want? You want me to stay in Discord and listen to you guys?
No. Just relax, man. Just relax. Just chill out. Yeah.
I'll come talk to you on break. I'll come talk to you on break.
All right. Good luck, man. Good luck.
Yeah, Godspeed, dude.
Damn, you'll never see that $50 again, Kosho.
You know what? I hope you're just as right about this as you are about most things. Okay?
Don, when you cash app someone, you can see their real name. Tell me what Kosho's name is in a DM later.
Guess what, dude? I have the same name you do, jackass.
It ain't a secret.
It gives you the last name though.
You know what sucks, dude? Well, no, I'm not gonna tell you that. But you know what's funny? There's only one no, there's the girls. I've met girls in this community, but the one person that I didn't, besides those girls, that knows my last name, the only person that was privy to it was Anthony Riley, the Sleeping Warrior, and I don't think he remembered that he actually had it, because we had a private conversation one time for like a couple hours, and he even made a comment about my last name because there was like a football player that he likes that's like the same name or something, and yeah, I don't know. He just we were buddies back then, so I guess he just didn't bother remembering it, because he became pretty nasty towards me at later time. So he could have doxed me all day. My last name's not in here, dude. It's just my fucking initial. My address is in here, though. What the fuck? Anyways, hey Jeremy. Oh shit, did Platypus leave? I was gonna ask you a question, man. We asked everybody else in here. Don was the only person who was such a dick. He didn't answer the question. But yeah. So we were just curious, like, so let's say there's like a secret Illuminati type of overlord, shadow government agenda, right? Like, let's say this paradigm is one that you currently hold, right? We were just going around and saying, like, what year was it that you first like came to this realization, or like had this paradigm shift where you did not think like that, and then you saw this these like overlords or whatever? Think of what year it was.
Or not? You're saying not flat Earth? You're talking about the
not
elites?
flat Earth specifically, but like just like like I said, I'm saying Illuminati, but you know what I mean, like this agenda. There's a secret agenda that these people are fucking doing shit behind the scenes.
At least over a decade, like the Bilderberg Group, Freemason type shit. At least probably 2 decades, if not longer.
Over 10 years, 2 decades, 50 years.
Yeah, it's been a long fucking time, dude. I mean, that's people been knowing about the Rothschild, Rockefellers, Freemason, Bilderberg. You know what I mean? Like, that's not new.
Bilderberg, yeah.
Bilderberg, you fucker.
You know, it's funny. Me and Merle and Crit fell into like the same pattern around the same time, like 2005, 2006, like zeitgeist shit. You know what I mean? Like you seen zeitgeist? You said it before, but you knew about that shit before that.
Yeah, way before that.
Whatever. You're one of the cool dudes, dude. You're in the cool club with fucking Bandsaw and Lemon there, I guess.
I mean, bro, the Rockefeller, Rothschilds, I almost said Bilderberg, you fucker. Those, that shit is like been, has been known that.
I guess there's been a bunch of shit, like, like Waco and all that kind of shit, I guess, You saw that shit and you saw that shit go down and knew what was up.
I kind of feel a little bit left out, to be quite honest.
About Waco?
No, just about all like, we don't really have any juicy conspiracies here in this country to get our teeth stuck
America, Most Americans, I think, don't even know Australia exists. We never hear jack shit about Australia.
Can I ask you, because I think it's a touchy subject with Kiwis, and I don't want to. I'm not suggesting anything, even though I think with the Port Arthur thing, I'm inclined to think that there's foul play, you know.
Uh-huh.
Anyway, so what do you think about Christchurch in reference to that then?
What do I think about Christchurch?
In reference to the Port Arthur, and do you think it's a similar thing?
Well, yes, I do, because you know how I said, you did have this crazy person just going around doing what they were doing. But the fact that it was actually streamed live on Facebook for, I think it was 22 or 27 minutes, one of the two, and nothing was done for that amount of time. The fact that actually Facebook even left it up for the whole length of time is suspicious in itself, right? You put a booby shot on Facebook and they pull it down instantly, right? So the fact that they even let this thing go live for 22 or 27 minutes, to me, is a huge red flag. A huge red flag. Now, whether or not the guy, I don't know, like, was he an agent? Was he a tool type of thing? Was he MKR altered or whatever the case may be? Who knows? But yes, I do think people died. I don't think they were paid actors at all. But once again, these things are used as tools to shift a narrative.
Was this one though? I don't remember. I thought I remember hearing that. I assumed it was, but that it wasn't. Like it.
Yeah, no, they also too had their gun laws revised as well. For what particular reason, I don't know. I don't know what the New Zealand gun laws were, or what the New Zealand gun mentality was. Like I said, Kosho, our gun mentality isn't like yours. Like, not every single person had a gun. It was basically farmers, right? Or if you're in a sporting shooters association, these were the sort of people that had guns back then. We could never back in the day buy the sorts of guns that you guys could anyway. Like, that we were regulated anyway. Like, you guys can buy just about anything off the shelf down at Kmart. Like, it's crazy. And the sort of
when I moved to Vermont once for a couple of years, and I always shot rifles and shit and had rifle. I mean, I shot handguns a few times, but then I moved to Vermont because you can't get a pistol easy in New York. You got to go through all kinds of legal hoops in front of judges and shit, get permits. So I moved to Vermont, right? And I'm in a gun store. That was part of the reason why I moved to Vermont. I knew their gun laws. So I go to Vermont, I go in a gun store, and I just walk out with a pistol that day, no permit, it's legal, nothing. I was like, yo, this is crazy.
That was me in Virginia. But I was at a gun show. I bought it at a gun show, dude. But you got to remember, Bandshot, like, we've beaten ourselves at war. You know what I mean? Like, we've beaten even ourselves, and you guys weren't able to beat flightless birds. So it's like, you know what I mean? That's like the kind of saving you guys from,
Yeah, if China attacks, you guys will be. China attacks, you'll literally be no help, Answer.
That's why we are allies with the one nation on earth that has the biggest guns, right?
Turkey.
We work smarter, not harder. We delegate, right? So
that's how you get shit done. You gotta delegate shit. I've been trying to tell Kosho that he's running around trying to do all this crappy stuff himself. You gotta delegate some of it. That way, maybe some of this shit gets done right.
Yeah, dude. Yeah, that's great, man. I should have listened to Jeremy a long time ago. I could have $5.45 by now or something like that.
Yo, go buy 13 cell phones right now, bro.
Dude, I'm about to make $2,500 dude.
Oh my god.
All right, dude.
Dude, you just lost $50 to Don.
I know, and we're all witness to it.
I mean, guys.
Don made the quickest $50 he'll ever make, ever.
I said, guys, you guys telling me this is like music to my ears, knowing y'all's track record. Okay, so it's good news for me. But I'm not gonna jinx it. So best of luck to him. If he doesn't win, no big deal.
I hope you win, Kosho.
Yeah. No, but so I was asking about the. Oh, right. I guess you wouldn't know about the Kiwi cops and their like if they carried guns or not. So, did they? Do you know?
No, I don't know, but I kind of presume they were like Australia and England, and, you know, the Bobbies. I don't know what the cop mentality is like now over there because,
like
I said, I have noticed, and everyone would have noticed, the huge shift that basically we have the military walking around our streets, policing us.
You know what's crazy? I was in Bahrain, okay, and just like your country, and just like your country, Bahrain was actually basically a agent state of England, right? UK and that kind of thing. And so they actually have the same sort of police system, because what they have is they have traffic police who definitely don't have guns. Some I think that the captain might have a pistol, but they don't have a gun. But because it was during the Arab Spring, they had a ton more what they had basically riot police that were there. Just so they're two totally different entities, and it just seems like I don't know if they're doing that in the UK, they're doing that in Australia, they're doing that in. I mean, is New Zealand technically also like an agent, like is a part of England, like Australia is?
Yep.
Okay. Yeah. So I don't know. Maybe
any country that has the Union Jack.
Union Jack. Yeah.
Yep. On their flag as part of the Commonwealth.
You know what's crazy? I think I think Hawaii has Union Jack.
What, still?
I think so. Yeah.
I thought Hawaii was now a state of America.
Yeah, it has been for 70 years or 6 years.
There you go. Damn.
Bandsaw, you should have heard it last night. I killed these guys, Coriolis. It's done, bro. There's no Coriolis effect.
History.
Earth-based Coriolis effect.
All
What's
over.
up?
It'll never come up again. We destroyed it.
Oh no, it's gonna come up again. You know, it's never really over. But
oh my goodness. Wow. You know what's really interesting, Jeremy? You know what's really interesting about refraction and the mathematics, right? Because I know refraction's been one of your favorite subjects because Kosho told me, right? But all these tests for refraction, Jeremy, they have done every single one of them in a planar environment, and they are applying planar experiments to a spherical object. Go figure. It's crazy. It's absolutely ludicrous. Absolutely ludicrous.
I thought this would be the kind of thing you'd be jumping all over, Jeremy, because it seems like Bandsaw just just had this huge breakthrough with some bullshit that I told him and said this is exactly the same shit that Jeremy's all over. What was that thing that you used to say about refraction? Like you wanted to see like a house or something. What did you want to see? You kept saying this some dumb shit. Like you want to see like a house moved out of position or something like that. Is that what you used to say?
I want to see magnification happen, atmospheric magnification.
That's what you wanted to see. You wanted to see something that was obstructed by a house, and then refraction make you able to see it still or something like that, right?
No, I never said that. It was like Democ or something.
I feel like it was you, man. But now that you said that, it's possible it was Democ. But I honestly, I think for a fact it was you.
No, it wasn't me. I know it doesn't work like that.
Dude, I remember being you. Because you literally said that we've never tested refraction out in the field. Like we did in the lab, we do this other shit. You used to argue that. Remember, you used to say that shit, didn't you? Oh, fucking like, you smoking weed right now, dude? Everyone's fucking sitting here smoking weed.
I haven't smoked yet. I gotta bring the kid to get a haircut. I haven't smoked yet.
All right, man. Anyways, yeah, you used to argue that, dude, and you used to say that you wanted to see in a real environment, you wanted to see like something basically that was obstructed by a house or something be visible again. Now that you mention it, I think that could have been Demok, dude.
It sounds like Demok.
It does, yeah, it does kind of.
I wanted to see my dick being refracted. You know, he's trying to say crazy shit.
I cannot believe, Kosho, that you think it's acceptable that these experiments are done over a planar surface. All right, you should be calling this stuff out, Kosho. As
Yeah, and when so
you are.
Give me your ideal, like in your head, the perfect world. You guys got your guns back. You guys beat the birds, and what? Yeah. So what would this test look like? What would this thing look like? Where we're doing it, the refraction test over some curve thing. Like, just describe it to me. Yeah.
What do you mean?
Like
why is it my job to perform a spherical experiment for you? Right? All right. So can I do a spherical test and apply it to planar geometry? Is that how it works?
You got to just do this in the real world. Like, the lab's not going to work for this because there's all kinds of shit going on over long distances. Magnetism affects the way light bends. There could be magnification affecting the way light bends. Like, you don't know. You got to do it in the real world, bro.
I love how this dude just woke up from fucking amnesia, dude. Like now he remembers fucking making this dumbass.
Yeah. Magnetism is the key one. Right, that's the key.
Those whales farts.
Yeah,
I think it's magnification.
Hey.
It could be, it could be magnification, magnetism. You know, there's a lot of effects going on out there over long distances. It's like just like how your water only bends at this little tiny bit over this. You know, 100 meters. Water's not really bending that much. It's almost immeasurable. That's what's happening with the magnetism or the magnification or whatever.
Dude. Like Bansa earlier said, yeah, you know, we got to account for the grass and the pebbles and the whales' farts. And what the fuck?
What do you mean, what the fuck? Jeez.
You got to get that optical corridor, bro.
That's right.
Let me tell you the way science works, guys, okay? Because I've done it before, okay?
I'll tell you how it operates. Not very scientifically. But anyway, continue.
Yeah, so if I want to find something out, like if I want to, I don't know, fucking grow some plants or something, and I'm going to bury these seeds and see how big the plants grow. I don't know what the fuck experiment I'm doing. But what I'm not going to do is worry about dumb shit that has nothing to do with what I'm experimenting. So let's bring it back to what we're talking about, refraction. If I'm testing refraction and refractive indexes and how refraction works and why it works the way it works and whatever, I don't need to worry about whales' farts or pebbles or grass or magnetism. I don't have to worry about any of that stuff at all because it's not related to what I'm doing. All I need to do is worry about how the light behaves in different density mediums.
Yeah, in different spherical or curved mediums, which you haven't done. Right. So look, I'll give it. Look, don't do it accounting for whale farts. I'll take that one off the table, even though you haven't accounted for them. But at least do them over a spherical or a curved surface where you have this nice consistent, right? This nice consistent, right, atmosphere, this density that is over a curved surface, and that density matches the curved surface, and then shine your light through it, then work out the refraction and exactly what's going on, and tell me exactly how the light's going to behave. Then, right, you might have something to argue. But until then, right, you are arguing, right, planar science.
Is that right?
100% right. Tell me where it's been done over a curved or spherical surface.
The video where the dude's doing it over a fucking methane tank, dude.
Oh, really? And that pressure, that density layer that is over that methane tank matches the shape of that methane tank. It matches it, does it? It's consistent. It goes in a nice spherical geometric pattern all the way around that methane tank, does it?
See, that's a problem, dude. You guys,
I know it's a problem. I know it's a problem.
Yeah, I'll tell you what's a problem, dude. Give me a second. I'm about to fucking. Remember I was saying earlier how I waste all my fucking time making these models and shit, dude? Give me a second, dude. What's funny is Jeremy talks so much shit. I made him some shit last night. You didn't even fucking look at it yet. You remember were you there when Jeremy was talking about his footballs yesterday?
No, I wasn't. No. I was talking about.
I'm gonna make this refraction thing, dude, and then we're gonna have to argue about something different, dude. Cause
okay. Oh, we'll continue to argue about it, I'm sure.
Yeah, I'm sure, dude.
We were talking about Tiger Woods and Coriolis.
Yeah, you know, I did the numbers. I told you.
2 centimeters. So WS got it wrong.
Yeah, I need to look at his math though and see how he did his. So what I did was, okay. Actually, you know what? Give me a second. It's not laughing matter, man. Okay.
So you're calling out W. How do I know your maths is right compared to WS's?
Because I'm not turning in. Yeah.
Well, he put all his workings out on the web page, and it seemed to be exactly the same for every single example he gave. So are you saying every single one of those examples, the football, the soccer ball, the golf ball, the tennis ball, all those calculations are wrong now?
No, so what I'm doing is, as a honest man, I'm taking back my homework because you said I haven't turned it in yet. And so I haven't turned it in yet, so it's not wrong or right. I'm going to check my work, and I'm going to send it back in. So hold on.
Okay. But anyway, right, even if it's only 2 centimeters, that is huge in golf. That is huge.
Okay.
That's the difference between coming first or 15th.
Is it really?
That is 100%. It is 100%. You know how
Have you ever seen a golf game?
I played golf quite a bit.
It's 2 centimeters can make that big of a difference for real.
Yeah. You only got a little hole to aim at.
Yeah, but if you miss it, you're only 2 centimeters away.
Yeah, and then you have to have another shot. You have to add another shot onto your score. And all of a sudden now, you have plummeted down the rankings. So from first, you've gone to 15th or 32nd or out of the ranking altogether.
Wow.
That's...
So one shot. So one, ball under one, whatever you call it, birdie. I don't know what you... Yeah, so one shot is going to put you in 32nd place.
It could, yeah, mate, quite easily. Yep.
My God, dude. The depths that you will allow yourself to go to. Give me a second.
The depths.
I got news for you, dude. I don't believe you for a second that one shot is going to put you in 15th or 32nd place. One shot behind.
Quite easily. If you are first, right, and you miss that shot by 2 centimeters, now you could be in second place with another 14 other people, which is 15th place, right? Or you can miss that second shot, right? And now all of a sudden you're in 15th place, right? For 15th, now you're in third place with another 50 people, right? So now you're in 71st place. See how quickly it accumulates?
Yeah, but I got news for you, dude. If you miss a shot from 2 centimeters away, you don't deserve to be in 15th place or 32nd. You don't even deserve to be there.
Hey. You may have missed it because of Coriolis that you didn't account for. So it's not really your shot if you're not aware of it.
It sucks when I make this dumb shit for you, Jeremy, whoever, and I you leave, do something else, and I save these things. I don't even know. I don't save them with normal names, so I don't even know what the fucking.
Well,
I
you
save
need to
my
have
work.
you need to have a file, right? And title it "dumb shit," right? And then label it all correctly under there. Here's Jeremy's dumb shit. Here's Bansaw's dumb shit. Blah blah. Whoever.
That's not a bad idea.
I know. I've
Found
got
a
good
diet.
ideas. I've got good ideas, just like planar experiments. It's a good idea.
Yeah. Okay. Hold on a second. Planar. Okay. Hold on a second. Look, 'cause I did all this math and I wrote these units. So let me see what this looks like. So I think what I calculated was, just gonna say this out loud because the difference in Earth rotation from where the ball was shot and where the ball hit looks like 433 meters per second. Hold on a second. God damn, this is actually kind of difficult. Oh yeah, that's right. Okay. Right. So it looks like. Okay, give me a second. So it might not be it might not be 2 centimeters. I think 2 centimeters per second is the difference in Earth rotation from the two locations.
Okay, and it had a hang time of about whatever
10,
the time was.
10 seconds, I believe.
There we go.
No?
Hang time of 10 seconds? No, nowhere.
If it's not 10
near that.
seconds, then you're lying to me because you told me the ball was, I think, 137 miles per hour, kilometers per hour, something like that.
Yeah, and it went 384 meters, and the Coriolis effect was 10 centimeters. Apparently.
Hold on.
Which we know it wasn't, but anyway.
But hold on, you said you just said just now 137 kilometers per hour, which, if I did it correctly, that's 38 meters per second. Okay.
You may have got it wrong. You may have got it wrong because you had to do conversions. You said.
Give me a second.
I didn't save the picture that I snipped. Sorry.
Yeah, but here's my thinking though. If you have a golf ball and it's going 38 meters per second. No, but yeah, 38 meters per second, and it's got to travel 384 meters, then that's going to take you 10 seconds to get there. No?
Don't know. I'm going to pull up the website again where it was on. Because I read it straight off the website. So it's 138 kilometers an hour. Right, 138 kilometers an hour. It traveled 384 meters at a latitude of 21 degrees, and the Coriolis effect was 10 centimeters.
Okay, yeah. All this checks out. You said, wait, what was 21 centimeters?
No, it was at a latitude of 21 degrees.
Yeah, so based on my math, which is, at this point, I don't even trust it. To be honest with you, 29 centimeters. 29 centimeters.
29, so it's like triple.
Yeah, this can't be correct then.
Damn, so it's gone from 10 centimeters to a foot. Just like that.
That is a foot, yeah, no shit.
Yeah.
Let me look at this card that you have here. Now that I'm more tired than I was when I first did all this math. Do you have it available?
Yeah, so it's a speed of. Oh no, where are we? Tiger Woods.
Shit, oh man, I brought my clothes in. Go ahead.
No. The speed was 38.4 meters a second.
Yeah, that's right. Yeah. So think about that. If it's 38.4 meters a second and it's going 380 whatever meters, then wouldn't you think it was in the air for 10 seconds? Wait a minute. Give me a second.
No, not at all. Not that long. No way. Would have been in the air for maybe 4 seconds, maybe 5. No, nowhere near 10. Nowhere near 10.
How does that make sense? So if it's going 38 meters per second and it has to travel 380 meters, how is it only in the air for 4 seconds and meanwhile it's going twice as fast?
Well, he said the actual speed was 138 kilometers an hour, and the distance was 384 meters. And in his calculations, he's got where I got to scroll down. The speed at 384
So I'm not gonna lie.
divided by 10 seconds equals.
Wait, divided by?
Look, here's his workings out. Hold on.
I appreciate it. I fell asleep, dude. Not.
Yeah.
I'm not saying it as a insult or
No,
something. I really did fall asleep.
no. Just there is what.
Okay, I see.
He
Time
did.
10 seconds. Distance.
Yeah.
This distance. Speed. Oh. Wait, is this your math? Is this your math, or is this math you got from the thing?
No. It's WS's, ain't mine.
Yeah. So somehow he has 10 seconds in there. Hold on.
But I'm saying the hang time would have been maybe 4 seconds, maybe 5 seconds hang time.
Let me think for a second on what exactly. Because I don't think I don't know. I don't think he's using the right units.
Don't know. But I thought he was pretty thorough, old WS. So we have.
Shit, dude, that's scary, man. You ever just like hit that wall? You know what I mean? Like you're perfectly fine. You know you hadn't slept in a while, but perfectly fine. And then just all of a sudden, I can't stop closing my eyes, dude. I got a whole bunch of shit I gotta do today too. I'll be back. Give me a second. I'm gonna be thinking about this while I'm getting my clothes out of the dryer. Hold on.
Yeah.
Seems like it's pretty quiet in here. Is it settled then? The Earth isn't a ball. We're not spinning. It's all done. We're good?
You missed it. You missed it, Bob. It got settled. Absolutely settled. It was amazing.
Well, it's about time.
I know. Whew. We can rest easy tonight.
What's up, babies? Guten Morgen, babies.
Was that you, Glory?
Yeah.
I thought I recognised the voice.
What you guys doing?
Not a great deal. What do you bring to the party?
Nothing right now.
Nothing.
Hey, Crit, did you ever look at those videos I sent you?
What videos are these? Are these LSC videos?
No, I sent him a Pac-Man Earth, one of the Pac-Man Earth models.
Oh, okay.
You heard of it before?
I've heard of Pac-Man Earth, yes. This is where basically something goes from one side to the other and then comes back to the other side miraculously. Yeah?
Yeah.
Yeah, in a nutshell, yeah. Yeah, definitely heard about it, but it doesn't, to me, that's very Matrix, I must say. Glory.
I was forced to look into them after I found too many holes in the original model.
Okay, then. The original globe Earth model?
Yeah. Azimuthal equidistant map and monopole stars and all that. I just, with what I know, was able to find too many holes. And then there's these alternate flat Earth models where they incorporate this Pac-Man scenario due to necessity for everything to flow and work. But yeah, besides the Pac-Man one, it fixes a lot of the issues that I found.
Yeah. Yeah, like that's if you like kind of need a model, I suppose, to make things sit comfortably with you, to give you,
Yeah.
you know, the explanations. Like you and I both know that you and I don't have the facilities, I suppose, to create our own model, so to speak.
We don't have what?
Well, probably the resources or the facilities to create our own model. I know people try independently to create their own model. I know Realm's right into it, creating his own maps and stuff like that.
In this case, when I say model, I know a technical, correct, accurate, and precise model is done on a computer, and every figure is entered precisely. I'm just talking about some simple visual that where we can at least get ideas of how things are working, type of thing. I can't post videos or pictures right now for some reason, but I would show you the one that I was looking at, and it's not a real. It's a separate video of a specific pattern of stars. Put over a different map projection.
For I don't think Jeremy or I have the ability to give you video posting rights. I think only Geo can do that. So next time you're in here and you see Geo, either DM him or ask him in voice if he can give you posting rights, because I know you can text, but the whole posting videos thing, I can't find a command for it myself, unless Jeremy's found it, but I can't find the command to give it to you.
Thanks. I'll ask.
This is what happens, man, when you got flat earthers running your server, dude. You can't do. Guys, man. Hey, did you know that this guy though, Glory, he's a concave earther, right?
I do know. I do know. His reputation precedes him.
You know, in the swingers community, they call like a young single woman who joins the community, they call her a unicorn. You know, the concave earthers are almost like the unicorns of the flat earth community, huh? Maybe just to me, I don't know.
I don't know. To me, and I don't mean this as a in any way, shape, or form as a dig at the concave, but it kind of seems to me to be like a little bit cheating in a roundabout way, where everything is just kind of reversed.
You know what, Ben Song?
One thing it does do, right? It does supply the container for the atmospheric pressure that we experience. I will give it that.
Does supply the container?
Well, it does.
Yeah, I guess. Fucking hell, dude. Yeah. Yeah, you can always see the bright side, dude. But you're right about that, man. I don't know if you've been reading Scott Veach's book on how to steal my ideas, but that is what my idea was, dude. I think I stole it from somebody also.
Yeah.
Anyways, dude, yeah, you're exactly right, dude. That concave earthers, that's the whole MO. Is just literally everything's explained by just working the way it would work on a globe.
Yeah,
not everything.
Yeah,
not everything, but yeah, I see what you mean.
Yeah, and that's not a crack at you, Glory, or anything like that, because you know.
Yeah.
You and I, we're kind of on the same team, except that we've got different ideas. But you and I are probably like on the same team, going up against the big championship team, trying to bring them down, so to speak.
Yeah.
What do you think about this idea, Glory? Right? What do you think about this idea that all experiments done, right, to confirm the globe Earth, they're all done under planar circumstances, all. all experiment, whether or not they're done in fish tanks or in vacuums or anything. They're all done in a planar environment. Don't you find that interesting? And then they apply planar science to a spherical model. Now that's kind of cheating, I think, a little bit myself.
And what do you think, Glory? You think that we do everything on planar fucking thing? You know, the thing is, you guys aren't on the same team, dude, because he's not a planar guy.
He's doing a Don on me.
Exactly. You know, I was kind of half suspecting that he might have given it up. Maybe he got the globe smacked back into him over in gems. Because I just noticed you just hadn't been arguing it as much as you used to argue it, Glory. So I'm not sure. Maybe I just hadn't seen you in a while. I was getting the idea that he was a Glober though, or now, you know.
Okay.
My initial main purpose for joining Gem Panda server was my first Flat Earth like Discord type server I ever joined, was because I wanted to share some of the info that made me start looking into concave Earth and get other Flat Earthers' opinions on it, on some of the holes, on some of the topics that that I brought up there. One was that track sun analogy you probably heard Koshal said like 5 times. Another one is the second pole. There's multiple things. There's multiple issues that I had solved with these flat Earth Pac-Man. I had no reason to look into concave Earth, or I had no reason to consider concave Earth, because all these holes that I'm finding in flat Earth, they're being solved in the Pac-Man Earth model. My issue is having to accept the reality or potential of this Pac-Man effect. I couldn't prove it, so I held that in consideration. Still remembering everything I know, and this horizon that doesn't seem to be dropping proportionally to as high as we're going up. And I looked into concave Earth, and I learned concave Earth a little bit. I thought it was interesting. And about less than a year ago, I had the opportunity to like not sit there and make an official decision, because I'm not down for believing. Like cosmology is just like 30% of my studies. The other massive amount is all sorts of esoteric works, ancient history, those kind of things. And I don't believe any of that, but I really think it could be real. I just don't know what the answer is.
Yeah.
So I'm not keen on rushing to a conclusion, because I know the negative effect that could have on us. Is that we could, if you rush to something and actually believe it, what happens is your mind starts clinging to it and will unconsciously pick back other ideas as a defense. I don't want to do that, because I know that can stop one's progression, and you could create a gatekeeper out of yourself by doing. So never once in Gem server or here or now have I said, have I seriously claimed that Earth is concave. What I do is, if anybody has questions, I'll explain how the main model works, how they lay their elements, and how they explain it. And if I have my own opinion on it, I'll add that. But that's the way I function. And everyone else wants to come and project their own method of perceiving reality and operating in reality, and project that onto me, and share false stories of their opinion. And I not here to. I don't care about that. I can't control other people's perceptions. I know this. I know how it's working through and out. So I also have a little compassion. So I'm not here to do anything but drop seeds and share a little bit of information that I think needs to be shared, and for the other person to have as like an empowerment type of thing for their own consideration. That's it.
Yeah.
And what's in it for me? I get to be around other intelligent people and hear of things I either never heard before, hear of things either explained differently, perhaps hear of things that I may have been doing wrong all along, and just being around different people. So that's it.
Well, it's, the I was gonna make a joke there, but anyway, I won't. But yeah, being around like-minded people, yeah, that's pretty cool.
What I just find interesting is the population difference between flat Earth and concave Earth, like the amount. Looking at it right now, I would say concave Earth has maybe 5% of the flat Earth community in terms of numbers, if that.
I was gonna
It's
say, yeah, that's pretty
it's
high.
it was a worrying amount of like a small population when I really consider it. There's like three or four, if that, concave Earth content creators. There's it's very, very, very most people when they think of concave Earth, they think of normal globe Earth, but with another civilization on the inside.
Do you make your own content, Glory?
No, the majority of content I share. What I've done is, because there is like only 3 to 4 concave Earth channels, I downloaded almost all the content to my computer, like organized. So if someone asks me a question and I find one way to help them, I can quickly share that video.
Yep.
But I know. So the main concave Earth guy. So you know the main concave Earth history with Steven or whatever, right?
Yeah.
Yeah, yo. So he died like 3 months ago.
I did hear a rumor. Yes, I did hear a rumor.
Yeah. So he died in prison for heart failure. In January or in December 11th, and he was the one that made almost all the models, all the imagery, everything he made. So right now it's just nothing's there right now. Oh, and yeah, there's just one concaver on Instagram. He's making some new stuff, but it's nothing compared to what Steven put out.
So you've got all your files all nicely organized and categorized and stuff, do you, Glory?
Yeah.
Damn. You need to speak to Kosho. Maybe you can give him a hand. From what I hear.
And it's not mine, but Google Drive for concave Earth. Got various in there.
Okay. Yeah, I did watch one video of his way back in the day. Where I think he was presenting whatever one of his videos, and I kind of found it a little bit interesting. Like the computer model that he did, it's just like, oh, okay, that would have taken a little bit to do that, or maybe. But yeah, it it still doesn't explain to me the because in either model, Glory, you've got curvature, right? Either model, right? Especially curvature of water, right? Which can't seem to be demonstrated, and this curvature of light that we see, which, as I said before, has only been ever experimented on in a planar environment and applied to a curved environment.
Well, the next few days I'm going to be
These are
here.
bugbears.
The next few days I'm going to be here. I'm going to bring up certain points on the mainstream model that can't be avoided. I'm going to present to you the holes that I found and how it's impossible. If you think the model works as the mainstream azimuthal equidistant map, centered around North Pole, sun, moon, and stars going around that, I can prove that it can't work. It cannot work that way. And this proof doesn't involve curvature at all. It just involves other easy to understand comparisons, such as a person running on a track. Like there's a sun track analogy that some people in here may have heard, that once the listener understands it, they immediately will realize under that model, it's impossible for the sun to work based on our observation. So that's one. The second one is the stars, which is not a fun conversation to have, but it's a real problem in terms of the southern pole or the southern axes of rotation.
Sorry, what was the
Again,
one you just said about the sun? Let's do one at a time, bro, so we don't get too much on our plate.
maybe I could talk about that one.
Oh, you want to do them both? You want to talk about them both at the same time? That's going to get confusing.
No, it's not gonna be a fun conversation.
Well, especially if we're talking about two things at the same time, right? We should probably do one at a time.
Yeah. Well, I'm not trying to talk about them. I'm kind of just giving an overview, like a bullet point.
All right. Well, whatever. If you want to talk about it, let us know.
I think it's important for you to have the awareness of noticing the other person listing bullet points and not trying to talk about two things at the same time, right? So you don't cut off and look like a dumbass.
Well, Jeremy's all about the bullet points. All about the
list your bullet points, and then we'll go over them. Go ahead.
Yeah, so that's about it. And beside that,
the second thing. What was the second thing?
Who's that asking?
Jeremy.
Jeremy, you're not gonna get it.
Why?
Because I said so.
All right.
Thanks.
Okay.
So, did you want to go over the first thing?
Nah, you know what it is that we've been talking about how like we don't care what they think. So now they're starting to hit us with the, it's not even gonna, like, they're always like a day late with the diss that we've been using for a week.
What's up, everybody? Cut out. Did you want to do the first thing, bro?
He wants to hear it, Glory. He wants to hear it.
Oh, that was all Glory. Yeah, what do you want to go over, bro? What doesn't work on the flat Earth? Let's hear it. No.
Okay. The floor is yours.
I mean, a lot of this shit these people come up with is like is based on them knowing how the sky works and where the actual positions of objects are and all kinds of stuff like that. So I mean, really, like the sky shit that you look up in the sky with, it's nothing. That's nothing to us.
Yeah, you know what's cool with the sun? I often think of it like, how you could like move light. Like, let's say if you had a flashlight in a mirror, you could move that light rapidly across the wall, like quicker than you could like moving the actual light. You know what I mean? Moving an actual light across the wall. So, like, within light of like the sun's movement and people knowing about the shape of the Earth, because there's no way that the sun could travel around there. That's to assume the thing you're looking at is a physical thing, when it could just be a reflection off something moving quicker than you may appear to realize, or at a regular speed to you, but at a different speed collectively. You know what I mean? Like, it doesn't have to be like a located source of light regarding, like, because when people talk about the sun, they immediately think of like the nuclear reaction in the globe model. So they immediately think of it as like a ball that's up there versus maybe something that's like a reflection or something to that effect. Because when people bring up, you can't have the azimuthal equidistant projection. I mean, I don't know. I think dark polarity settles it. You know what I mean? Like, if they
Just
get to
saying,
have,
like,
if they get to have
shit in
dark,
this. Go
we'll
ahead.
go on, Jim.
No, just shit in the sky is like whatever, dude. That shit's nothing. Like, go figure out how the sky works. Get back to me. Give me some actual positions.
Wait, and what too is real quick on the idea of standing on the shoulders of, flat earthers, is the idea that like the whole system of the stars was mapped out by flat earthers. So it's like, and then they're going to claim that, well, we perfected it because we got a little bit more observant. And it's not 4 minutes, it's 2 minutes. So therefore, boom, flat earth debunked. And it's like, what? Like, what? It's like, oh, he was wrong because we figured out 30 seconds he was off.
Because they don't know their model.
Okay.
The globalists don't know their model. The observations of astronomy and cosmology predate heliocentric by thousands of years. Thousands.
We are at least 27,000 years, right? Or at least or whatever it is.
Yeah,
right?
give or take a few
The
thousand.
eon, you know what I mean? Like, because it's interesting how, like, that they know that it cycles around, but they've never actually witnessed it. But they can, they can predict it based on it makes sense, but it also comes from the ancient cosmology. Sidereal time comes from the ancient cosmology. Like, they understood the precession of the stars well.
I know when they act like somehow they don't understand flat Earth. Flat Earth should have been their starting point. It was a starting point for science.
Well, it's like, again, I'm getting more and more just convinced and convicted on the idea of, it's like, look, like, in order to actually practically use anything, you've got to like take navigation or whatever. You have to use it off of a flat Earth model. They admit it openly, time and time again. Everything that's an extrapolation of that, whether it be right or wrong, is essentially useless. That's the difference. And it's like, if it's useless, what the hell? It may be interesting, but it's like, it's also useless and doesn't have anything to do with us trying to get where we want to go. Like, if you want to say that, a sniper's going to calculate Coriolis, that's fine, but he doesn't, so there you go.
Here's a hilarious thing right here. Lori types in the goal, it break the cycle. So he doesn't know what the context was. Because earlier they're asking, what is it? What is flat Earth? So I said the goal is, and I could have put quotation mark, break the cycle. They can't, and this guy's supposed to be a linguist, and all he does is trigger. I'm just like, I was AFK for a little bit. So
dude, I honestly just, literally, it's like this, dude. It's like, there was some interview with Jen Psaki, the press secretary or whatever. And now Hunter Biden's laptop has been confirmed to be his laptop, and it's not Russian disinformation. Like, the New York Post even had front page is a bunch of people who said that it was misinformation. Now that we know that it's true, and so they asked, Jen Psaki, hey, is Hunter Biden's laptop, blah 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 blah, wherein he got $50 grand a month from Burisma, which was which is a bank of a company in Ukraine that was made the year that the Ukrainian military took over the fucking thing and had a coup. Like, it's so interesting, and it all is going to come out. And they go to Jen Psaki, hey, what do you call it? What do you think about Hunter Biden's laptop? Because remember, Hunter Biden's his son, the president's son, who could be blackmailed. And she goes, oh, he doesn't work. He doesn't work for the United States. So next question. And it's like these folks are just trying, they're just trying to backpedal, move away, lie. They're like the serial killers in like Batman. You know what I mean? They're like the Joker in prison, like still living the lie, just still pretending that like it is what they made it up it was. And it's just like, all right, dude. But yeah, I don't know. I think
it's crazy. Like here's this other dude, that kicking chicken dude. It's like, so I tell him what my goal. That people are asking, what's your goal? What's the purpose for being on here talking about flat Earth? So I said my goal is to break globalist logic and stop the spiral. He says that's a straw man. I tell him what my goal is, and somehow that's a straw man.
Dude, I used to say you could tell one of these people like, I really like peanut butter and jelly, and they'll be like, no, you don't. You're a liar.
Yeah, you don't.
You know what I mean? It's like literally that's how, and obviously that's what's so good for us is that's what shows their hand. That's
I realize that too.
That's how we know that fucking if somebody's gonna take that position and just never address maybe an issue. You know what I mean? And I know you're gonna try to turn this back on flat earthers as being like denying of some fucking proof you're gonna bring up, dude. I get it, but it's not really even funny, and I get it. I'm 3 steps ahead of you, bud. But what would you like to say?
Glory, I didn't mean to piss you off earlier.
Oh, well, no, you weren't talking to me, were you, Jeremy?
No, Glory. Oh, Glory. I didn't.
I'm not. It's all good. I don't hold.
Forgive me. I might be
Everything's
interjecting.
okay.
I don't even know you, my dude. Forgive me.
Issa, you're always pissing me off. Relax.
Yeah, I know. Forgive me, dude. But yeah, it's like it's weird like that, dude. Like it's like but like I said, that's what gives people up. That's how immediately. It's like, oh, got it. Like, 'cause it's the same person that's like, you're a science denier, that's actually like a fucking science denier. Like you know what I mean? It's like, or like if somebody, I remember back in the day, if somebody said like, oh, this is how, you don't understand what this is, and then you'd explain to them how their model or your model works, and then they would like be like, see, now you're a liar because you know how the globe model works, but you refuse to back it. So now you're a liar because you know how it works, but you don't believe in it, or you're going to tell people you don't believe. It's like, what? Like, there's no sense of logic with any of it, man.
Bro, you should have heard what we went through. We did like a nice 4 or 5 hour Coriolis session last night. They got some real fucking problems, bro.
Dude, just sell them Coriolis insurance, bro.
In case the tree falls or something.
They're so fucking serious about it. They need coverage. That's what I've always
Listen to me. If you're I'm gonna just real quick break it down. If you're gonna fly a plane from city to city, right? You don't want to spend energy or whatever fighting a force that you don't need to, right? That'd be ridiculous. You want to have the most efficient flight possible with the least amount of energy. So if the Earth is rotating under the plane, like say you're going north to south, right? Say you're going from like Canada to Florida or Hawaii or some shit. You would aim the plane for where the city's gonna be by the time the plane gets there, instead of constantly having to adjust and use more energy for the Coriolis effect, right? They don't do that though. They aim right at the city.
No, yeah, but that's what you gotta remember, dude. It's too big because it looks so small. It's so small because it's so big. It's like there is no consistency with these people, dude. You know what I mean?
Yeah,
it's like, I can see the boat go over the curve, but you can't see the curve because the Earth is so big. It's like, dude, like, you can't have it both ways, but they're like, yes, I can. And it's like, they're just spoiled Asperger fucking people, dude. And I need to get told as much. Because it's like, like I've said before, it's like, look, like you people are destroying our society. You know what I mean? Like, you fucking suck. You're Bane.
You're the downfall of humanity, Coach.
They're literally warmongering in Gem Panda's server. They literally warmonger there.
There's that too. I mean, shit, dude, but the thing is, the best part is that they're just crabs in a bucket. Because, like, given an opportunity, they'll rip each other to shreds too. I've seen that.
You heard Kosho? Issa said you got crabs.
But like that, like, I mean, I don't even put Kosho in that camp because Kosho's pretty cool. And I think that if anyone, it's like, I'm going to start calling it the Witsit Dad's defense. If you come at me with that one, I got you back all fucking day. If you come at me with, well, God does whatever he wants. You know what I mean? If you believe the earth is a ball because, well, God does whatever he wants and that's just the way it is, then fucking right, more power to you. But if you're going to argue to me over the fucking existence of dark matter about whether or not fucking whatever, then I don't know. If you're going to base your fucking opinion based on that grounds, but if you just believe that the earth is a ball and you think it's a ball because that's just what makes the most sense to you, that's fine. I mean, if you're going to, but you got no right to creak it, you know what I mean? Like, I don't know. There's no reason to be, or I don't know. Like, what I like is that flat earth has its foot in the door kind of in society, which is cool. And that's all it's about. You don't need to tell anyone what it is. You can't. And how rude.
Mark Robert just dropped
Wouldn't the plane
video.
aim for this?
Now, of course, Jeremy, that makes sense, but that's not what we do. That's not what happens.
Oh yeah, they said.
But that's what you would do if you.
Oh, go ahead, Jeremy.
If you were trying to hit a fucking deer who's on the run, you might lead it a little bit. It's the same shit, but it doesn't happen. It's like, you know what I mean? Like, that's where, it's like the Coriolis effect helped that field goal. Like fucking Neil deGrasse Tyson said or something. Like, no.
Field goal last night for my example, because obviously the most efficient path, like say you had a field goal kicker that could only kick in straight lines, you couldn't curve the ball at all, and then you had a field goal post that was exactly as big as the ball, right? The guy would have to kick it at the field goal post, have to kick it where the field goal post is going to be. That would be the most efficient flight, because any other direction, like say you had jetpacks on the fucking football, if you kick it in any other direction, you're going to have to expend more energy for the ball to go through the thing. So if you're flying a plane, you don't want to expend more energy than you need to. Dumb. You don't want to be fighting a force the whole fucking trip. You want to shoot where the fucking field goal post is going to be, where the city's going to be. They don't do that, though. They start off with their heading right at the city. Like the Coriolis effect the whole time. These people wouldn't be doing that. They'd be like, yo, let's use this Coriolis effect to our advantage.
Don't let it drive you nuts, Jeremy. So you can't justify the unjustifiable, my dog.
We went over this for 6 hours last night. I spiraled about 10 times throughout the whole thing.
Here's this one I've talked about with that video. This is like over a year ago. Mark Robert made a field goal robot that kicks better than people, and it doesn't count for Coriolis. It's just a really big, hard kick, like a trebuchet or something.
I'm pretty sure that when you're drinking coffee, you should account for Coriolis. Like, technically speaking, the coffee cup is moving from one latitude to the next.
No doubt. You don't want to miss the cup. I hear that.
Sometimes I don't adjust for Coriolis effect, and that's when you you go to take a sip and it kind of spills out of your mouth a little bit.
When you go,
when you forget to it.
There's that, and then you just have a drinking problem. But what do you call it? If you have you get the milk and you try to pour it in the coffee and it you know what I mean? Like, that's the Coriolis. That's where I experience it the most.
If you go up in an air balloon, you can cancel Coriolis out.
Dude, I know it, right? The atmospheric pressure just levels it right out.
That's why you should look into that about snipers shooting from air balloons.
Dude, I think you're honest. I think they only shoot from air balloons.
I think this is where quantum mechanics comes in, and then you can have a superposition where the Coriolis effect both does and doesn't exist at the same time.
Sweet.
They used to call that Kentucky windage.
Kentucky windage, right on, dude. For our matter, we'll call it, what's the Kansas? Isn't that the flattest, whatever? Kansas windage.
A globalist that squawks and gets to squawk another day. You can tell it's a globe by how flat it is. You can tell it's moving by how stationary it is.
Well, you can tell it's moving because you don't feel it.
You can tell there's maybe life on Mars, but no, because Ukraine. They stopped all like whatever they're with Johnny 5 on Mars. They just gave it up because Marsha or Russia.
Dude, they took down I forget what country it was, but they're no longer going to play Tchaikovsky because of the Russian thing, because they're so scared of Russia.
There's like a new term, a new mental illness, Russia phobia.
Well, dude, they've been addicted to foreign germs for so long now that they, you know what I mean. I don't even know. People are nuts.
And
Right
maybe
now.
that's what they I guess they need that. They need a lot of Russian phobia to kickstart a space program. Like maybe that was a missing variable. There just hasn't been enough Russian phobia in the last 50 years. So they got to ramp up the Russian phobia and then elect some Nixon-like figure and then spaceflight.
That's not a bad point. What was there? Did you guys hear something about like the fucking Russians on the ISS were gonna leave up the U.S. guy?
Yeah, that was hilarious. Like people talk about the video game Among Us. They were actually playing Among Us in real life.
Oh right, I know the game you're talking about too. I know what you're talking about. That's hilarious.
Yeah, it wasn't my joke. I heard someone else say it. I was like that.
Yeah, that's funny. Playing Among Us. That's so good.
They took it to a new level. They actually like leveled it up. Like it's like reality TV, and then they're gonna bring the guy down, but then they were going to like not bring him down and bring him down again, and then Elon Musk challenges Putin to like a gladiator fight, pay-per-view or something like that. That he's going to build a rocket specialized to, pick someone up in space like a scoop bucket or something like that. But then decide, okay, he'll just ride down with the Russians one more time for old times.
You know what though? See, here's the thing, and this is where I don't mind the ball in that regard. Is that like also what Musk is doing? And I don't know his character, but he wouldn't censor his satellites. Starlink or whatever, he wouldn't censor them over Russia and Ukraine. Like he wouldn't pander to the, I guess, NATO and everyone asking him to censor Russians, which is kind of cool in the sense of like, because like really like, it's about ideals, and if you're going to talk about like, free speech or whatever, or like news, like actual information, like people should have access to information about the world around them, and to then deny them, that's like stupid. And like I just said, like they're literally canceling like Tchaikovsky, who wrote the Nutcracker. Like, are you fucking kidding me right now?
Yeah, it's really bad. I mean, Sugar Plum Fairy is probably my favorite thing ever.
Right, like pretty soon they're gonna like associate that with like Russians like being fucking like what are you even talking about? It's funny, like that's how I feel with like whenever I see like these like just the whole fucking lefty agenda out there on the news. Like I just feel like they're like, it's like how ballers are out here. They're just numb to any other information than what they've been programmed to talk about. And they can't answer a question because they're not there to talk about that question. They're to talk about this. And imagine if I have a rocket that's got a weasel on it, that's got a hamster wheel, that's going through space. Like, oh my God, like these examples and fucking, I can't.
The other day I was talking to an online friend, and I was making fun of how Musk dressed up as Wario. And I showed him a picture. He's like, "No, that's Photoshop. That's a look-alike celebrity actor." And I'm like, "No, dude. He actually went on Saturday Night Live and did some sort of cringe, like bully online skit dressed as Wario. He wouldn't look it up. He just wouldn't look it up. I'm like, okay, fine. I'll like let me see if I can find a clip on YouTube. I finally found one, and it was like even better. I had not seen it. I'd only seen the still images, but it's pretty funny. I mean, it's funny like to laugh at. Like, holy crap, he's a bad actor.
Yeah, like I'm happy with like even like I'd be happy with the ball earth and things as they were. If people want to believe all that, whatever. So long as like they could quit this other shit that's coming with all this agenda crap.
Yeah,
like dude,
totally.
it's like next level. Like all my, even old school, like some of the best people I ever met. It's like, if you said you were a flat earther, like they didn't care. They don't fucking. They don't care. Whereas, like, you trigger these fucking NPCs by not believing exactly what they believe. People used to like be able to disagree and get over it. Like now, it's like you're affecting one of my microaggressions. Microaggression about the shape of the Earth. There's got to be curvature. I looked it up. I saw it, and then that's the killer. That's why anytime that they bring up that they saw the curvature, you give them Neil deGrasse Tyson saying that there's no fucking way you saw curvature. And then you point out to them that, look, you've literally been so fucking brainwashed. You think you saw curvature, you dumb motherfucker. And there's one way, like in one sense, it's like, be nice to them and help them rationalize what they've done to themselves or what's been done to them, whatever you want to look at it. And fucking the other way is to like, throw it in their face because like they're disturbed by that. They become the science denier once they fucking still will fight you over that they've seen the curvature. And that's where you can't take it personal on. You got to point out that, hey, you need to take that up with modern science, dipshit, not with me. I'm just the one who told you that you're fucking nuts because you think you saw curvature. You know. yeah, I think it's like a qualifier for anyone like bringing up experimentation and shit. Like they need to add Dawn on a tricycle. Who's getting blasted off by a rocket, and how many fucking turns does it take for him to make an orbit? Something stupid, dude. Better involve Dawn on a tricycle, or else I'm not listening. You know, if Dawn was riding on a tricycle and he was 3 miles away, could you see the obstruction? How much of the tricycle would you see? You know, I might entertain one of those, but outside of that, shit's retarded. Or like if we launched Dawn on a tricycle from a catapult headed due to South America, what country would he land in if Coriolis was really happening? That would be cool. I wonder if they calculated like Coriolis back in like medieval times with the catapults. You know, like the castle's actually going to be over there, Edward. You need to adjust your catapult.
Yeah, like what was the term for Kentucky windage during the medieval times?
Well, they hated the French, so it'd be like King Louis windage.
Yeah.
You see, there's like 2 dudes on like the Women of the Year.
Oh yeah, about the swimmer that
Yeah.
I
Just
thought it was
you know, she got booed when they were giving her thing, or its thing.
Yeah.
It got booed. Like
And then the
everyone
other
cheered.
women.
Everyone cheered for the girl who was second place or whatever, and then for the dude, they were like boo, like fucking like. How are they gonna let that happen? Like, what a shame to do that to women, even.
Yeah, that's the thing too. What they could do to fight back against like this sort of sexism is all the women who didn't poor sportsmanship can get you disqualified. So they wouldn't stand on the podium with the woman who won. So they should be disqualified. You lost your medal.
Well, no, or at least one of the things I saw, it's like they were all on the podiums. I didn't know anything about that, or if they
Yeah,
did.
they stood down. They all stood together as a group on the third spot in a 1, 2, 3 order.
Oh, I don't know. I didn't see that. There was another thing then. I think there was another. Because I mean, I imagine the dude's winning every race he's in, right? You know what I mean?
Oh
So
yeah, because he played or she played
was a
in
swimmer
men's.
before.
Yeah, he had done some, not won anything, but had done really well in men's groups, and then transitioned to a woman and just crushed it. Like I'm talking about smoking, like winning by 2 to 3 seconds. From like second
I
place.
think like 30 seconds, dude. Like it's like there's a couple of things I saw. Because remember, they're always racing. And there was one race where it was like a minute, you know what I mean? Like fucking something stupid.
Yeah, and there's like even women who had won gold medals at the Olympics, getting crushed. But Mrs. Thomas, I guess, is I'm trying to remember the full name. Leah Thomas.
Like, how weird that it's gotten this far. Like, what the fuck is wrong with people? That it's
Yeah,
gotten.
Title IX. People warned said Title IX is written very poorly. It's vague. it doesn't make a lot of sense. It doesn't identify or doesn't define who's protected, who's not protected,
Well, no, it's
why they're
common sense,
protected.
though. Well, no, but also it's like you don't need legislation to whatever. It's common sense. It's like, you've got men pretending to be women playing women's sports, and it's stupid. And anyone who fucking defends it is a fucking idiot.
Yeah, but Title IX said that men and women's sports are completely equal in all
Right?
shape,
No,
manner, and
and that's
form.
I tell you what, and I want the law to look at it like that.
Yeah.
It's not the law. It's the fucking society that allows for it to be read and exercised as a dude can fucking pretend to be a woman and play sports. What I'm saying is like how stupid that how did it get this far? Like that's fucking ridiculously beyond stupid. Like I don't want the law or more government to come in and save society with this shit. This is a matter of society recognizing you can't do it that way. It's like electrical equipment, like we've talked about before. If you want to be an electrician, things need to work a certain way. The male part goes in the female part. If you want to go sit in your basement and pretend that you're making electricity by putting two male things together, that's fine. Just stay in the basement and away from society who needs fucking electricity.
Yeah, I know what you're talking about. The components, male and female components, have to be paired up correctly for the current to flow.
Right. No, if you're trying to heat a fucking house with a space heater because you need fucking heat, you don't sit there and pretend like fucking two pieces that aren't going to work are going to work. You want heat, so you do it the right way. And so because society wants to function, if you want to be a freak and not function in that society, that's fine too. Just shut the fuck up about the society that works. Go build your own shit or live amongst it, live with it, and fucking just deal with it. You know what I mean? Like,
okay, this is what I'm getting at. So just like a month or a month and a half, something like that. Earlier this year, the women's soccer team finally won the court case against the national, soccer association because they weren't getting paid the same as male soccer players were. But the male soccer player is way better than the female soccer player. I mean, like if they were to play together, like women's team versus men team, it'd be a blowout. It'd be like 9-0 or something like that. I mean, these guys are like, Greek gods, and these women's soccer players are. I mean, they're good, but they're only good in playing against other women teams. But now they said, well, the male soccer player and the female soccer player are exactly the same. So they're going to do like millions of dollars, like $30 million of back pay for all these female soccer players who have not been getting paid the same as men. So then they say, well, sure, if they're exactly the same, then a trans woman should be able to compete. I mean, it's the same pay, same everything. Then how is it any different? And then they'll see once you get some sort of trans woman as a goalie and that they can't stop, no ball can get past them. Well then, maybe there was something about this, that they're separate, not separate but equal, to invoke sort of Jim Crow, but there are different brackets, and these brackets are based on skill sets, professional level, and even gender.
Yeah, no, they're based on it's based on gender. It's women's sports versus men's sports. It's like they're not supposed to like you don't put like a women's rugby team up against a man's rugby team. You don't like have like a women's football team play a man's football team. Like, you know what I mean? Like, there's just no fucking way. And like that's what I'm saying. It's like this, the fact that it even has to be pointed out to people. It's like this isn't normal. This isn't natural. It's like it's so weird that like anyone's gone along with it, and fucking it's just so weird. I don't know. I think it's I don't know. I guess I'm just commenting on it. I don't fucking know.
Well, the thing is, it should have been addressed before some sort of really cringe podium stand protest was done.
It's just weird, like and then even like they're like it reminds me of, like Hitler was like Time Man of the Year, and like now it's like they got trannies as fucking Women of the Year. You know what I mean? It's like what the fuck is like it's like Time Magazine's like a barometer for the whatever. The fucking, well, they had Hitler. You know what I mean? Now they got trannies. And it's like, ugh, disgusting. But like to say like that's the woman of the year, like what a disrespect.
There it is. I found an article on NPR. So $24 million in back pay.
Yeah, and I think they had found initially it was like nobody watches it like they watch men's soccer or anything like that either. So it's stupid. Because that's what was getting the revenue. That's why they got paid as much as they did.
Yeah, it was actually you could follow, the flow of the money. If you've got like millions of people watching men's soccer and thousands of people watching women's soccer, that kind of explains where the money's coming from, the ad revenue.
Yeah, I just can't believe people letting it get this far. But I don't know. I think that'll come to a head. I think, like you've pointed out, even too, it's like like the future generations are probably going to be so conservative. Because as a backlash to this liberal nut job shit.
Yeah, people look back and this is like they'll think it's some sort of parody. Like that didn't happen. What? Like that was.
I hope, man. I hope, man. I hope kids. I mean, I think, given the chance, kids are fucking awesome, and they're gonna be great and figure shit out. I just hope by then it's like their parents have got them on fucking ADHD medication, and you're like, oh god, you know what I mean? I hope they get through.
I thought I read something recently too about ADHD meds being like recalled. There was they found out that it was damaging.
It's just meth for kids, dude. Sick fucks. Yeah, that's why I guess I even I guess I take out even my disdain for all of the shit that people have done on these Globers that come in and are I don't know. I feel bad sometimes.
All right, I'll be back later. Take care.
No peace, brother. Yeah, I'm a little busy over here too. Somebody take over.
Yo, I beat you, Kosho. You're done, dude. Are you there?
Yeah, what's up, dude? I'm
You're
done
done.
what?
You're fucking done. I got you. I was in the shower.
Yeah.
And I can't stop thinking about this plane flying, right?
No, yeah, you heard me and your wife. Damn it, dude. I thought you were going to catch me.
No.
Hey, oh, you are so sorry. Go ahead. The plane. What about your plane? I caught you. What are you talking to me? What are you saying?
I got you. You're done, bro. You're fucking done. Done.
I'm making fucking shit for everybody, dude. Hold on.
The problem is you Globers can't visualize 3D space in your head. There's like a word for it. I forgot. Whatever that is, though, you got it big time.
The problem is you flat earthers are just taking all the insults that you've ever gotten from Globers and pretending that they apply to me. Okay, that's cool, dude.
No, because it was you guys projecting on us, self-projecting on us. Listen, this is all not important. The point is, if you start off with a plane, right? We're in Canada and we're flying to Florida. If the plane starts going, aimed at the city, and then the city moves, the plane is not going to fly in a straight line. That's not a straight line, dude.
I got news for you, dude.
You're done.
You are just now catching up to where I was expecting you to be when I was explaining this to you yesterday, dude. But you're still not there yet, bro.
So you realized you were done yesterday. Why didn't you tell me?
No, dude. Listen, man. Let me describe to you the two scenarios, okay, dude? Look, did you see the thing I just posted?
I can't look at my phone right now. I'm getting dressed. The point is, in one of them is a straight line. That's the one in my scenario where you aim for where the city's going to be. That is the straight line. Your shit is not a straight. It's a straight line if you were comparing it to the ground or something, but in all actuality, in the air, it's going in a curved line. Be more inefficient. You're done. You're done.
I'm not gonna use a word you don't like, so I'm gonna say a word. I'm gonna call it rainbow frog. Okay. Basically, there's two rainbow frogs. Okay. And one of the rainbow frogs is gonna be called the inertial rainbow frog, and that's the one where the Earth's not you're outside of the Earth basically. And yeah, you're right. If you fly a straight line in this rainbow frog,
just use reference frames. I have no problem with them. I just don't know why. Well, I do see why you brought them up now, but
well, then I mean, might even apologize, I guess, because you fucking flew off the handle when it got brought up. But no big deal.
Yeah. I mean, it's kind of a red herring, but because in all actuality, you know that the object is moving straight in the inertial reference frame, and it just appears to curve from the ground.
Yeah, well, I got into it with Grim about this yesterday, and I don't want to do it with you again right now about what it's actually doing and what it looks like it's doing, because that is not how I want to say this, okay? However, regardless, though, you seem like this will make sense this time, okay? This is when it hit me yesterday. I was sitting there, I was thinking, and then it hit me. In one scenario, you have the inertial reference frame, the one where you're viewing it outside of the Earth, and you see the guy kicking the ball or whatever, but we're doing the plane. So you're flying the plane. That plane outside of the Earth in the inertial reference frame is flying in a straight line. And you're thinking to yourself, in this inertial reference frame, this plane who's aiming where he wants to go and he flies in a straight line, that's a short path in my reference frame. Wow, interesting. Now, going back to the airplane, now you're on the airplane, you're on the Earth, you're in the rotating reference frame.
Well, you need a reference frame fresh up.
Hold up, dude. Just hold up a second, dude, because this is the important part. You want to do the exact same thing you just did from the inertial reference frame when you viewed it. You want to be going in a straight path, but you know that now on the inertial reference frame and then not inertial reference frame, you are going to look like you're curving. So instead of doing that, you're just going to fly in a straight path, straight from New York to Florida. And what you're going to do is you're going to make constant corrections so that the path never deviates from straight. It always or it never deviates from straight across the Earth. So you're always flying directly south. Anytime you deviate, you adjust for it. And so what ends up happening is, even though the Earth's rotating, you made enough corrections so that you actually made a path that went directly south from the non-inertial reference frame. And from that reference frame, you're like, okay, well, this is the shortest path. And that's the dilemma. That's what I'm saying to you. The shortest path is different depending on which reference frame. And from the rotating one, you want to use the one that I described.
You need a reference frame refresher course or something, okay? Because we know that it's just an apparent deviation when you're looking at it from the non-inertial frame. It's not an actual deviation. It's actually going straight.
Did you learn
I know
this
you're
from,
scared to say the word actually, but it's actually going straight.
Did you learn this from Grim?
You need a simple reference frame refresher course. It'll take you like 5 minutes to figure this out.
That's fine, man. Well, I can post the same things I posted yesterday, but instead of doing that, I'll just simply remind you. What's a good example? Okay, the cruise ship, that one. I mean, I'm just gonna go back to the cruise ship, dudes. I have to. You're on the cruise ship. You're in the bay. You're fucking playing with a tennis ball, and you're throwing it to your son, and he's like asking you, "Dad, can you describe the path of this fucking ball, Dad?" And you're describing the path of the ball and the distance it traveled, whatever. Well, guess what, dude? Depending on if you're describing that from the reference frame of on the ship or the reference frame of just being in the open earth or whatever, you're going to be describing two different things. Okay? And it's because it's always going to be reference frame dependent. The path that it's going is going to be the path that's going in that specific reference frame. So that's just the way it works, dude. It's not an actual one and a parent one. I got news for you though. When I was doing research yesterday, I said there's no preferred reference frames, and I saw that for a brief period of time, Einstein actually did refer to non-inertial reference frames as being slightly less preferred than a inertial reference frame. So so all reference frames were equal as long as they were inertial, and they were all more preferred than the non-inertial ones. But that didn't last very long, because once he finished his general relativity, he went back to saying there is no preferred reference frame at all. So it's not the case that one is happening in one place, it's not happening someplace else, and it appears to be doing something somewhere else. It's only doing things in that reference frame. Like, it's only described in that reference frame. So bing bada boom. Dude, by the way, I'm looking at Don's chip stack, dude. He showed me some pictures of his stack of chips, dude. It's good stuff, bro. As I got done making this shit for Bandsaw, he's sleeping now.
So ran away. He's scared, dude. He knows he lost on this plane thing. A simple reference frame course. Not even a course. A 3-minute video from MIT will sort the shit all out for him. The ball's actually going straight. The deviation is just an apparent curve from the ground. We know which reference frame it's going straight, and he's acting like we don't know, or we can't know, or something. Or there's no preferred reference. It's just nonsense. I need somebody to model this shit out. Are any of you guys good at like 3D programs or anything?
No, you don't even have to. You just say that all motion is like.
I'm pretty experienced in Minecraft.
Yeah, you could only describe
is Minecraft
motion
rotating? Sorry,
mathematically.
Jared.
That's all right. Saying you
Yeah,
could
but
only.
I want to visualize it out for these guys so they can see that the plane is actually in their path when they start off with the heading aimed right at the city. That path is curving. Like they're taking a curving path for no reason. They should be aiming where the city's going to be, and that is the straight path.
Minecraft is rotating just as much as the real world, Jeremy. You can look at the sun and the moon and see that it's obviously rotating, clearly, and the stars. And it only makes sense that if all of those things up in the sky are that shape, that what's below
Do you have any of these pancakes,
we
babe?
must be moving when we're playing Minecraft.
Did you eat
It
any
only makes
pancakes?
sense.
Were they
What?
banging? Oh, my bad. I was hot micing. I literally did not listen to a word you said. Sorry.
I was just talking about Minecraft and how it's obviously rotating. It's rotating just as much as the real world. If you look up at the stars and the sun and the moon in Minecraft, you can see clearly, obviously, you on the ground must be rotating. The sun comes up, the sun goes down, the moon goes across the sky, the stars, they move. So clearly, it must be the character and the blocks below the character that are moving. It must be.
I need a way to show them visually that the plane paths that they're taking, because they're not accounting for Coriolis off at the start, are taking like a curved path, which means not only are they traveling a curved path, which means it's a longer distance than the path where you aim where the city is going to be, but they're wasting more gas because they're fighting the Coriolis the whole time to stay on that straight path. It's ridiculous. So they're fighting to stay on a curved path when they could just take a straight path, use less energy and a shorter distance.
Yeah. What are they saying that like that you're wrong about, or that what are they arguing that what you're saying isn't correct or whatever?
You're gonna believe how many times they brought up wind yesterday. I'm like, stop with the wind.
What?
They're like, well, they already got to account for the wind, and it's stronger than the Coriolis force. I'm like, yeah, okay, great. There's wind. We know this. We're just talking about the Coriolis. Like, they couldn't stop talking about wind. At least 6 times it got brought up. Maybe
Wait,
10. I don't even know. It was like
100 mile
nonstop.
per hour wind.
No, they're saying the wind's stronger than the Coriolis.
Well, yeah, but I mean, the Earth moving below the plane has to be hundreds of miles per hour, which would mean that the wind would have to be at least 100 miles per hour if it's supposedly stronger than the Coriolis, right?
It's not the point. The point was that we're focused on the Coriolis force, and we want to, you want to get there as efficiently as possible, go in the shortest distance, use the less gas.
To me, it seems like a pretty ridiculous claim if they're going to say that there's 100 mile per hour wind, hundreds of miles per hour wind, though. That just seems absurd. I don't know that they can demonstrate even 100 mile per hour wind, let alone multiple hundreds. At the equator, you're looking at approximately 1,000 mile per hour wind, which just seems ridiculous. Even like extra ridiculous, super duper ridiculous, mega ridiculous.
Yeah, if you visualize this, you can see it in your head. The plane's leaving from Canada. It's aimed at Hawaii. They're pointed at Hawaii. So as they're going, they have to keep adjusting for Coriolis.
Yeah.
And in the air, in the inertial reference frame, this is going to look like a curved path they took in the inertial reference frame, because they actually have to curve to adjust for it. You want to go in a straight path in the inertial reference frame. You don't want to go in a curved path. Hold on, I need to rethink this. I need somebody to
I get
put
the
this
idea.
out.
I understand. I was just addressing, like, if they're going to bring up, like, it's such a stupid argument for them. Well, they already have to adjust for the wind, so they might as well adjust for the Coriolis as well. Like, it's just, what a stupid argument to make.
Yeah. Like, we're already adjusting for one thing, so who cares if we waste more energy adjusting for this other thing? It's like, what?
Yeah, it's an entirely unnecessary waste. They could just not do that. They could just not waste all of that energy, all that fuel and time or whatever. Like, they could just not do it. And instead, they're saying, well, we're going to adjust for this other thing, so we might as well go ahead and waste the time and energy doing this too, even though it doesn't help at all, even a little bit.
It's sitting on top of the thing and spinning it with its feet. You know that thing he spins on?
I mean, like, sometimes when I'm driving in a vehicle, I have to adjust for wind. That doesn't mean that I take a longer path to my destination because I got to adjust for the wind anyway.
Yeah, you still want to go in the straightest line to your destination.
I could go hundreds of miles out of my way because I'm going to have to adjust for wind today, but I don't because that's retarded.
Yeah, the wind thing was huge red herring. Tons of red herrings yesterday. I never seen as many red herrings come up. That's when you know that you got them. When they pulled out every red herring that I thought was fucking possible. Even some shit I couldn't even think of. One of them was, it's not in free fall like the ball is. The plane's not in free fall. I'm like, what?
What?
That one blew my mind, yeah. What's up, kiddo? You gotta go poopy on a potty? So we're not hanging out in the bathroom. I don't know what you're trying to do in here. Happy that you're happy. Don't touch that, Jackie. Come here. Come here. What are we doing? You know what? Clap your hands.
Yo, Jared, no dice low.
What's going on with Dicel?
Oh, he had a funny story. He has like Dicelo has like a 8-year-old kid or something, and he took his 8-year-old kid to a university because there was like some sort of athletic competition there, and they were going past the STEM building at the university, and his little kid turned to Dicelo and said, "Hey, you should go in there in that building and talk to them because he always hears Dicelo on Discord talking about magnets and stuff." I guess kid doesn't know it doesn't work like that.
Yeah. At the end of the day, I don't think any of this really makes a difference. I think it's the big lesson we could learn from all this is that, you know, people have different beliefs and you just got to accept it.
Listen, I got a homework assignment for anyone that's on TikTok. I've been doing it. I was doing it before. I started doing it again. If you want to fucking help out, get on TikTok, go to all the flat earth stuff, and just leave in the comments, you know, search flat earth or search Earth Awakenings in Discord. We talk about this kind of stuff all the time. If you want, it would help.
So you post highlights on TikTok?
No, I just post that in the comment section of other flat earth videos.
Should say lowlights and highlights. But TikTok, does TikTok the TikTok app, do they want to know your phone number? Is it one of those phone number apps?
I don't know, maybe. They never called me though.
Oh, you don't remember putting in your phone number information?
I don't remember, yeah. I don't know. I don't think I did. I'm not sure though.
I don't get what TikTok is. Is it a video? Is it an app where it helps you create video, like video editing, and then you just post your video, and then people will eventually scroll through it?
Yeah, pretty much.
So even if your video sucks or whatever, somebody will see it.
I don't know how the algorithm works. I know it works good though because I subscribe to a lot of flat earth shit, so my feed is like a lot of flat. They push a lot of flat earth. It's like before YouTube changed. It's working correctly. They're actually giving people what they want to see. Got him on this plane flight thing, dude. There's no way. There's no way you would aim at the city to start off if you were going on like on a north-south flight. You would aim where the city's going to be. That way you can fly in a straight line without having to fight the Coriolis all the time.
Don't planes do that? Don't they go a little to the left, to the right?
Oh.
Do planes fly in a straight line? Generally.
It's literally impossible to have something angled at a moving target and stay in a straight line if you want to hit the target. It would have to curve. It has to change its angle. To make an angle change, obviously the thing is moving. These guys lost on this shit big time.
Maybe you should run this one by Zanuck. We'll talk to you for about a half hour about it.
No, dude, I have DMs from Xana going back about 2 years as reference frames. Me and Xana have been talking about reference frames for 2 years straight. Like a lot. Like he loves reference frames. If you even say that word one more time, he's going to appear out of nowhere like a fucking genie out of a lamp.
Most of the time, that's all I ever hear him talking about.
I think like my first DM to Xanac was like, you don't understand reference frames.
Thing is like they want to describe all motion mathematically, so you could use that against them. You could say, well, you could only say mathematically that the Earth is moving underneath the pendulum, but there's no objective way to know which one is moving because there's no such thing as a preferred reference frame. So you could just reverse it all and say that everything is moving around the pendulum. And then they're completely stuck. There's nothing you could do after that. But at the same time, you then can't say that the Earth doesn't move. You got to give that up. And then, and then they'll give it up.
Yeah, I need to retract what I said earlier. You could fly in a no, you can't. There's no way it could be a straight line. If you start off aiming at a target and the target's moving, the projectile or whatever is going through the air can't go in a straight line. It would have to curve. That would be a curved path. There's no way.
Unless the path of the target changed or went all the way around. So like that would be the two scenarios where it wouldn't have to curve then.
The target path changed?
Yeah, so like let's say it was going to the right and you line up straight with your projectile and fire. If the target basically continues right, but then comes back to the left, it changes direction.
That's not happening. Yeah.
And hit it.
I got you on that. Or it goes around in a circle. That's not happening either. Yeah.
Right, exactly.
Neither of those are happening. Yeah, right. Am I right, Bob? Or am I wrong? Tell me if I'm wrong.
No, that's right. That's right. That would be the two scenarios where it could stay in a straight line. But other than that, pretty sure it would have to curve. Or at least angle.
At least what?
Angle. It would either have to curve or it would have to like sharply
change angles.
Angle. Yeah.
Change angle. Yeah. The change angle thing, that's not happening. Saying they need to fly in a straight line.
A bullet or something that would involve like most likely like bouncing it off of something or whatever. But if you're talking about a plane, like what would that even be? Yeah, that's not happening, obviously.
Yeah, the angle thing's not like, they claim that they're flying in a straight line, and if they're flying in a straight line and they take off with the heading aimed at the city, Earth's not moving.
There you go.
Fun fact for the day. We just debunked Coriolis effect. Nice work, guys. I thought of this yesterday. I just thought of this. They were talking about the football or something through the field goal. And I'm like, well, if you had a field goal post the size of the football, so the only way you could make it is you would have to kick it where the field goal posts are gonna be, right? If it was exactly down to the micro nanometer, right? You'd have to kick it exactly where the field goal post is gonna be, which would be the most efficient route because that would be a straight line path. The ball's not curving; it's in a straight line, and the Earth rotates underneath you. So that straight line path is the most efficient path to aim where the field goal post is going to be. So I just related that to a city on Earth and an airplane. Like, you can make all kinds of excuses as to why it's not relatable or analogous. Bullshit, and they're all red herrings. Because when it comes down to it, you'd have to be making a curved path with the plane, which would be more inefficient. Not only are you making curved path, you're fighting the Coriolis effect the whole time, which uses even more energy. So you're using more energy to stay on this curved path. It's like ridiculous. Now, unless that airplane fuel hoax is right, they wouldn't do this. So either the airplane fuel hoax is correct or fucking Earth's not rotating. Pick one. I don't care.
Forgetting option 3, which is that you have a misconception about how this stuff works.
Yeah, I don't understand. I heard all that bullshit before. Why don't you come with something real next time?
No, I'm just saying that's the third option. You can't leave that out.
But I do understand it. Can you point out how I don't understand it?
Reality is real.
I want to point out what I'm not understanding.
We spent all of yesterday trying to point out how you're not understanding it, and we got nowhere.
Because, based off what I just said, what's the problem with what I just said?
Because it's not true that, for example, that you'd need to keep fighting Coriolis. That's not really how that works.
So you don't need to adjust for Coriolis effect?
Not in the way you're saying you are.
What do you mean? I said you need to adjust for it. Adjust for it.
You adjust. Go ahead, left lane.
No, it's insignificant, man. It's said over and over and over. The Coriolis effect is insignificant to the flight of an airplane.
So Coriolis is insignificant, and they don't have to adjust for it.
Well, I mean, if you want to count a 1 mile an hour crosswind, it's significant. I mean, it's not.
Sure. Do you want to fight a 1 mile an hour crosswind the whole time, or no? Wouldn't it be better to not do that?
Maybe
you're cutting out the left lane.
You're robot in left lane. Yes or no question. Would it be better to not fight a 1 mile an hour crosswind?
You're expecting there to always be a 1 mile an hour crosswind.
Whatever the numbers is for if you're going north-south.
And what we're saying is, sure, on average, over every day, like on average over all days, you'll have an average of like a specific due to Coriolis. That's not what you'll experience in the moment. In the moment, you're experiencing weather conditions as they are in the moment. You don't experience averages. You experience as they are in the moment.
What?
You care, well, as you're flying past there, you don't care about the average wind. You care about the current wind. When we're talking about Coriolis and how it affects the massive wind patterns of the entire Earth over massive periods of time, then yes, we care about averages. That's the part. That's the point.
Yeah,
You don't
when I'm
care
talking
about
about
Coriolis in the moment.
when I'm talking about Coriolis, I'm talking about where the city is now to where it's going to be by the time you get there. That's all I'm
And that
talking about with Coriolis.
change is so insignificant compared to the wind corrections you make.
Oh, here we go with the wind. You hear it, Bob? Wind.
Yeah. You can't ignore the wind in an airplane, Jeremy. How many times do we have to say this?
the wind and the wind, the windy wind.
How are you gonna try and ignore wind in an airplane? Like,
I'm
do you
not
not
trying to
see
ignore
this? Do
It's
you
a
not
separate
see
issue.
this?
The wind's a separate issue, dude. We're talking about the actual the rotation of Earth and where the city is now and where it's going to be by the time you get there. That's a whole different thing than the wind. It's a separate issue.
What does wind do?
All he's
to an
saying,
airplane?
all he's saying is, if you have a flat tire, why do you try and ignore the gasoline? Why? Okay, we realize you want to fix your flat tire, but how would you possibly get anywhere without the gasoline? Why would you try and fix the flat tire and just ignore the fact that gasoline is used by the car, Jeremy? Come on now.
No, I'm not. I'm saying, why you don't have to care about the little pebbles in the road. You have to follow where the road is going. Stop caring about the pebbles. Follow the actual big road.
But
that's what I'm
but
saying.
if you could have a road completely devoid of pebbles instead of having pebbles on the road, why would you choose the road with pebbles? Why not just have a road without pebbles?
Oh, we can't choose whether we take the road with pebbles or not. It's either there or not.
Exactly.
And we've
But in the
noticed
case
from
that Jeremy
experiment that
talked
there
about, you
are
can
pebbles
literally
on the
choose
road.
Hold on. One at a time, guys.
We noticed from experiment that there
Geo
are
wants
pebbles
me
on
to
the
keep
road.
it more.
Exactly.
Geo
There are pebbles. Exactly. But in Jeremy's, in what he's talking about, you can literally choose the road with no pebbles. You don't have to account for Coriolis if you just aim the plane right. So why don't we?
That's not. So if you so if you account only for Coriolis, then you'll be fighting air currents. You won't care about air currents, which is the fully that's way more inefficient because the air current are the bigger factor. So
there are air
simply
currents that are hundreds of miles per hour.
so locally, the difference is the Coriolis, the 100 miles an hour, for example, that'll be over many degrees of latitude. That'll be many hundreds of miles, like, while the wind speed is right there in the moment. You're conflating a wind speed in the moment with a change in speed over many hundreds of miles.
I'm
They're
not
not
complaining.
equivalent.
It seems like you're claiming that one is more significant than the other, which seems it seems like you would need winds that are hundreds of miles per hour force to even compete with Coriolis.
And what I'm saying is that's not true because that 100 miles an hour change is over a huge distance.
The wind. Don't get
Change
into it with the
over a
wind.
distance. If you spread a change over a distance, it's going to be a small change over a small time.
Yeah, don't get into it with the wind with them. It's a separate issue. It's not even relevant.
I know it's not. I'm aware. It's a stupid argument. I get that. I guess maybe it's too much to hope that they'll actually realize how dumb it is.
It's too much hope to realize for you guys to realize how wrong you are. Like, do you not see that this goes two ways? Do you really not see that?
What goes two ways?
You believe that we're the ones misunderstanding, but you never see
no,
the
I don't think you're
possibility that
misunderstanding.
you're misunderstanding.
I don't think you're misunderstanding at all. I think you're choosing to mentally retard yourself. I don't think you're misunderstanding.
Okay. But even then, you're saying that that's the only possibility. There is no possibility that you're misunderstanding. You're not leaving that possibility open, and that's
No,
why.
I don't misunderstand how the world works.
This is what I'm saying. You'll claim that right now with such confidence.
Yeah, because I live in the world.
In reality, you're actually misunderstanding. But you'll still sit here and claim you never misunderstand.
No, I'm not
This
misunderstanding.
is the problem. But this is the problem that I'm telling
Listen,
you.
I've
You
adjusted for
believe
wind
you
before.
understand. You're
I've
deluded
adjusted
into
for wind
thinking
before.
you understand.
It's really insignificant when compared to the path of the place I'm trying to get to. So anyone who's going to argue that wind is somehow a significant thing to worry about in the path for where you're trying to get to, that person is obviously ignorant or they're mentally retarding themselves. It's pretty simple.
What would it take for someone to convince you that you're wrong on this, that you have a misunderstanding?
Oh, to demonstrate it. That would be really easy. Just demonstrate it and then I'm good.
But what exactly is it that you want demonstrated?
Whatever the claim is.
Because a lot of these claims are conceptual ones that you have a problem with on a conceptual level. How do we prove something or show you something that is conceptual?
Well, if you have an issue proving your claim, that's your problem, not mine.
No, we don't have a problem proving our claim. We have a problem explaining our claim to you as you're misunderstanding it.
I don't think you have a problem explaining it.
Well, if
I
I
don't
talk
want an
to another,
explanation.
if
You
I
explained
explain it,
I don't want an explanation. I said I want a demonstration. If you can demonstrate that being a significant issue, then I'm fine with accepting that it's a significant issue. If you can't demonstrate it, then I'm not interested in your stories.
well, I can explain it on a conceptual level to another glober, and they will understand. I explain it to you, and you do not understand. That is
No, I
you
do understand.
problem,
You can tell a
not
story
a
to
other
another
person.
glober, and they'll accept your story. If you explain your story to me, I'll understand it, but I won't accept your story because I'm not interested in your story.
We're not
I
talking
want
about
demonstration.
stories. We're talking about concepts here. You
We're
keep
talking
going
about
to
your
stories. These are
story.
concepts.
We're talking about your story for explaining something. I'm saying I'm not interested in your story. Demonstrate it, and then I'll be interested.
So the concept is that a change of 100 miles an hour over many hundreds of miles is insignificant compared to local winds. That is a conceptual thing that you seem to not understand.
Yeah, that's the story you're telling about the importance of wind and the importance of Coriolis or the significance of it. That's your
If you want
story.
to keep calling it a story,
that's yeah, it's a story.
It's a concept, not a story.
Demonstrate that it's significant, and then we can talk about it. Just demonstrate that it's significant, and I'll be satisfied.
That's your claim. Your claim is that it's significant over that, even over that distance. That's your claim.
No, I'm not
You
claiming
haven't
the wind is
demonstrated
significant.
that.
You are. You're claiming the wind is significant.
Yes. Are you saying the wind is not significant to the path of an airplane?
Not more so than your alleged Coriolis. No, of course
And
not.
that's your claim, that Coriolis is just as big of an effect. Please prove that.
No.
Show that to be
maybe
true.
you're misunderstanding. It sounds like you're misunderstanding. I don't claim Coriolis at all. You do. So that's your claim.
We claim
your claim isn't matching your other claim. That's the problem.
What our claim is an airplane will frequently match their or not match, correct because of wind. And even though there is Coriolis, because you're already correcting at such a large scale for wind, Coriolis doesn't need to be individually corrected for. So my claim is that Coriolis is not corrected for.
That would imply that you're correcting for wind independently of Coriolis.
Which you do. You don't correct for...
So you don't worry about the path of the airplane. You just correct for wind, and then everything lines up just fine, independent of Coriolis.
That's how you correct for wind, is by lining up the airplane and looking at the path you're taking, the angle of path you're taking, the angle of the location, speeds and all of these things is taken into account. The exact same things you would take into account when accounting for Coriolis, you account for when with wind, but at higher magnitudes and with more chaotic.
Okay,
like
so just to be clear, you independently account for the wind separate from Coriolis, and you're still able to get to your destination, right?
You act as if it's completely separate from Coriolis. No.
Okay, you're the one.
not
That's why
what
I'm
that-
clarifying. You're the one saying that you corrected for wind independently of Coriolis. Are you doing that or not?
You're correcting for your plane going out of course. That will happen due to things like wind and Coriolis, but at the scale of this, wind is such a higher magnitude that that's what was going to seem like is pushing you off course. And when you correct your course, you're not correcting for, oh, this was because of wind, this was because of Coriolis, this was because that little this little bird was flying in our path and we had to steer off. Like, you don't do that. You just correct the course.
Right. You correct.
You don't care about the cause for you steering off course. You correct your course.
And you're saying
like
the bigger force is the wind,
identify.
right? You're saying the
We don't
bigger
have
force
to
is the wind, right?
Yeah.
Yeah.
We don't. When we're flying the plane, we don't have to identify why we're thrown off course, just to correct it. That's all.
Yep. Keep going.
I don't see how this is so hard for you.
Oh no, it's not hard. This is great. This is great. This is fantastic that you're saying these things. This is awesome.
Okay.
I don't see why it's so hard for you to realize that in actuality, when you start off angled at the city and you start flying at the city that you're going at, and the city moves from that straight line path, you're actually taking a curved path. You understand that?
Jeremy,
on a spherical Earth, you're always taking a curved path.
Not curved up. I'm talking about curved left to right. Another red herring. I know.
He already gave it away. He said that you don't have to worry about the thing that you're adjusting for. You make the adjustment and you're still able to get where you're going. It doesn't matter if it's the wind or Coriolis. They adjust for the wind, and that takes care of the Coriolis. He already gave the game away. This is fantastic.
These guys are losing, dude. It's constant red herrings. He just said you're on the globe. You're never flying in a straight path because of the up and down effect. It's dumb, dude.
It's not just because of the up and down. Even if you could not follow Coriolis, just follow the ground trajectory, and you don't care about the up and down effect, because the Earth is rotating. The three-dimensional trajectory it's creating, it's still going to be a curve. So it's more complicated than that, because
on top of that, even if Earth wasn't rotating, because we have wind, you would also be curving your path constantly because of wind.
Let me just respond to his first point. Hold on.
Let me just finish the whole point.
What do you mean? Let me finish. You went, then he went. Now you're going to go again. All right, go ahead. You guys can go back.
I unfairly interrupted him. That's back to you. The concern.
Yeah, I made a pause. I wasn't finished, but thank you. Yeah, the whole thing is that you can't just look at the surface as a plane and expect to make precise statements about the trajectory, because that's a complicated three-dimensional trajectory. The Earth's rotating, if the Earth's not rotating, just because it's a sphere, and on top of that you have it rotating, that creates this complicated trajectory that cannot be simplified as if it was a straight line or not a straight line. That's why it's not constant red herring. It's just we're trying to bring back the precision so we don't get to wrong assumptions in the way.
So you're telling me if I fly the plane in a straight path at where the city is going to be, I'm not actually going in a straight path.
Yeah, in 3D space, no, because Earth is a sphere and it's rotating. It's going to create a curved path.
We're not talking about up or down curve. We're talking about left to right.
Yes.
Okay. So if I fly in a straight line, where the city is going to be, you're telling me that's not a straight line somehow. That's dumb.
Yeah, seen from space, the Earth's rotating. That's going to form a curve. So when you say actually doing, or because when you're talking about Coriolis, we're talking about two different reference frames, and we can't just forget that in the middle of a sentence, because if you do, you're gonna make wrong assessments about it, and that's why we keep bringing up every time you simplify too much it, because if you simplify too much it, you're changing the premises of the scenario, and it's not red herring. It's just that this isn't very easy, and you can't just forget things because it makes more complicated because they're important.
There's a field goal kicker, and field goal post the size of the football, and he kicks the ball where the field goal post is going to be. Did his football go in a straight line?
No, I mean, from which reference frame? I think from no reference frame it would be going in a straight line.
The only reference frame would be a non-inertial one that's accelerating perfectly with how the ball's moving.
Which means the frame of reference of the ball.
Yeah.
Yeah, the ball is the only reference frame in which it's not making any curve.
Which is the trivial solution. It just is. It doesn't matter. It's always going to be like that. It's like saying the ball is the ball. It's just as useless.
Yep. Hey, what's up, Brenda?
Ellen, Brenda. Your name is, or I assume it's your name and not just your pseudonym or whatever. But it could be.
It's weird because she used the name of Ellen, but everyone calls her Brenda.
Yeah.
There's like
Well,
Lemon.
I assume. By the way, we can't hear. I'm not sure if you're speaking or not, Brenda. But I assume Ellen of Zarina is her like just like online name. Brenda is her real name.
Yeah, I had an account with Brenda, but I forgot the password and couldn't recover it. So I just made up a new one.
But you can call this Brenda as well, right?
Yeah.
It's messy for newcomers, I guess. At least that's how I felt when people have a certain name that they're called and that doesn't match their nickname on Discord. And
Well,
I'm
Bacon,
always lost.
you know what's even more confusing is that my real name is Jeremy, and so like talking to Jeremy or other
Right.
people talking to him.
Right.
Now that's a bit of a, especially in jams, because I mean Kosher's name is Jeremy, Jam Panda's name is Jeremy, and we have
Kosher's
this
name is Jeremy?
Jeremy. Yeah.
Wow.
And so like I think we have
So many
4
Jeremys.
or 5 Jeremy like in jams that could be on at the same time.
Right. But yeah, it was very confusing for me in the beginning because like people called not by thesis. They called Travis, not Copernicus. They called
Yeah, exactly.
they called Pete instead of Dodo, and so on and so forth. And they called Left Lane Howard.
Oh, I didn't know that.
Yeah.
I've always heard him referred to as left lane.
Yeah, sometimes they call him Howard. And sometimes they call Eggshells Harry. Did you know that Eggshells is in an Indian movie? And he's like one of the main characters?
Really?
Yeah.
That's cool.
And the whole movie is on
I
YouTube.
didn't know that.
Let me show
I
you.
didn't know that.
Yeah. Let me show you. I'm not sure how to find it anymore. I think he have DM'd me one second. Yeah, how much do you understand about refraction?
You seem you're asking me. I feel like I have a pretty damn good pretty damn good understanding of it, both on a
Right.
conceptual level and on a mathematical level.
Oh, you know how to like to derive the Snell's law that can be
Yeah,
used in the gradient?
yeah, the differential form of Snell's law. I looked
Right.
into a paper that described it and stuff, and
Mhm.
yeah, so I've looked into a bit of that stuff. Like
Right.
I looked into what's his name? Guy that made a refraction simulator. I forgot the
Walter Wiesner?
yeah, Walter Bischlin. I looked into how he made the refraction simulator as well, which gave me some information on it as well.
Right. Yeah, I can't find the video. I like it's on, I think, the movie. It's on
Yeah.
the old Eggshells account, and I can't find it. And anyway, if you see him, you can ask him if you're interested in seeing that.
Yeah, I probably will if I remember next time.
Right. But yeah, the reason I'm asking about refraction is like I'm curious about the reason why it's treated as an R value, right? Because to me that sounds like just at best an approximation, not how it actually should work.
Well, yeah,
Is it?
that's literally just essentially what all that's saying is that the average standard refraction on the surface of Earth makes it so that Earth seems 7/6 like radius bigger. So 16% bigger than what it actually is what
Right.
that's all that's saying. On average, refraction makes Earth seem 16% bigger.
Right. Oh yeah, that makes sense.
Yeah,
That,
like
that
it
summarizes
says.
more than I expected.
Yeah, it says very little about actually like what refraction is or does. All it literally says is that's
Sure.
how much. If you take a measurement without accounting for refraction, you'll get like Earth being 16% bigger.
Right. So right.
Would I be able to ask you guys a question?
Yep.
So this is for both of you, Bacon or Gummy Bear. Do you guys have you guys looked into or do you know anything about the sextant?
Yeah.
Yeah, quite a lot.
I even getting one myself.
Oh yeah, he's gotten one sent
Okay,
on the
so
way.
once you find your angle, what do you do with it?
It's a great question. So you have your guess position. Well, there's more than one way to fix your position, but the most
But
common way.
hold on. What if you just don't know where you're at? Does it become useless, the sextant?
No,
If you,
it just takes longer to figure out your position.
Are you saying you have your angle of elevation and you know what star it is?
are you asking me?
Yeah. Well, I want to
No.
know what information we have.
Right.
Yeah, well, that's
I assumed you had the base
let's say
information.
someone plopped you in the middle of the ocean and you don't even necessarily know what ocean you're in, never mind where you're at in the ocean.
Right. Yeah. Like there's no standard way
Mhm.
to solve for that because that's never the case. But you can still figure out your position without a starting position as a guess. That's how
What's
the app I developed work. You don't have to input any guess position. You only input the angles to the stars and it gives you your coordinates without
what
any starting point.
what's the process for that? Like what's it practically, what's it look like?
Yeah, well, I did it using an algorithm. The
Hmm.
way the algorithm works would not be very practical. It requires like thousands of calculations. But the more practical way you can do that gives you the same answer that my algorithm does is just to draw those circles on the sphere and see where they intersect. That gives you a very, very close approximation. And then you can use that as your guess position and then increase your precision. Because if you're using like a physical ball.
Well, I mean, the almanac will have information about the sun and the moon. So whether it's day or night, you can use either of them to get a nice ground or basis of where you are.
Yeah, hopefully I'm not moving the goalposts on you, or hopefully you don't
No,
feel
that's
that's the case. But like I'm saying, you got a sextant and a boat, and someone put you someplace.
I hope.
Pardon me?
And you have to have a clock as well.
What kind of clock? Any clock?
You need to know the time.
Any clock that you know the time zone of the clock. Like
It's
without
called a
a clock,
chronometer. It's called a chronometer, I think.
actually, any clock will do it. But you need to know what time it is, and the time zone of that clock. If you have that, then you now can decide your position.
Why is the time zone important? Because the time of day is just the time of day.
Yeah, because you want a universal.
Depending on the time of day, the GP will be different for each star and celestial object.
Right. So basically, you want to know. So that it's a little bit. You are trying to find your position in a sneaky way. So my example was, you're put it, and maybe the answer is just simply you can't figure it out, and that's fine too. My example was you're kind of put in some place where you don't know on a boat, you don't even know which ocean or whatever, but you're wanting a clock which tells you a time zone, which basically gives you an indication where you're at, right?
No, it's not that you need to know the time zone you're in. You just need to know the time zone of the clock so that you can refer it to universal standard time, because that's what usually the almanac will be in. You just need to know what time you're in reference to the almanac.
Okay,
for example,
go ahead.
Just to make that more clear, if to me it's 2 p.m. and for you it's 5 a.m., it can still be the exact same time. So we don't have an almanac for each time zone. We have the almanac for a single time zone. So if you know yours, you can convert your time to the time of the almanac. That's why the time zone of your clock.
So you're adding a clock and an almanac. Like I'm talking, you got a boat and you have. I'll give you the clock for now, but you have a boat, a clock, and a sextant.
And you need a map. And you need a map to draw your circles on, right?
You don't. Not necessarily. Most people don't use maps. They just do it mathematically.
Well, if you wanna,
you don't need to make circles of equal altitude.
Usually no. You.
I thought that was a crucial point in celestial navigation, was these circles of equal altitude.
They are a crucial point, but they're conceptual. You don't actually draw them.
You don't have to draw them. Drawing them can make it easier. You don't have to.
So how would you do it if you don't have those circles? If you don't have those circles, how do you do it without the circles?
Oh, I'm very glad that we passed the angle measuring stuff and went to the trilateration. So here's how it goes. You have your guess position. That's how people do it.
So how do you guess? Okay, wait. I don't want to be pedantic, but I want to slow it down a bit. So you're put in the middle of nowhere. How do you guess your position? What's the technique to guess your position? Like literally, you don't even know what ocean you're in.
What time is it? Is it? Just
I'm
quickly, is this during the day or during the night time?
Well, it's pretty hard to use a sextant in the daytime, I guess, right? So let's make it nighttime.
No, it's easy if you're sighting the sun. I mean,
we can.
What time? I don't care. Whatever time you want, really.
Right. The thing is, the reason why I was saying I was referring to the guest position is that Jeremy was asking how it's done, and no one does it without a guest position. I can explain you how it could be done without a guest position, but let's do the way it's actually done first. I think that's at least to answer.
The way it's actually done is with circles of equal altitude, right?
They're not drawn. They're conceptualized, right?
So they do it. People do it in their mind. They just do
No,
the circles in their mind and they're not drawn?
The circles of equal altitude are an explanation of what's going on. And when they're fixing their position, they're not going to draw those circles. They're going to try to solve for those circles, but they don't actually draw them. So let me
So how do you
explain.
know where your point? How do you know where the circles line? Which dot the circles line up on if you don't draw the circles?
Yeah,
This is
that's what
weird.
I'm
This
trying
is
to
really
explain.
weird that you're saying they don't need
No,
circles of equal altitude. This is
I'm not saying
honestly,
I
this is
never.
crazy.
That's a strawman. That's a strawman. I didn't say they don't need that. I say they don't actually draw it. That's what I
If
said.
you don't draw them, how do they know what point they're on?
That's what I'm trying.
You
I'm going
can
to describe it if you
calculate.
allow me.
Yeah, you can simply calculate your longitude, latitude, and then map that to a map.
Yeah,
You don't
if
have
you're
to
trying
draw it.
to if you're trying to find the latitude and longitude that matches a distance to a point, you're trying to find a point on the circle that has that as a radius. That's the exact same thing. But you don't have to draw the circle to do that. If you can draw the circles, that's easier. That requires no mathematical effort. You just draw the circles and see where they intersect. You can do that with a physical ball. That doesn't give you a very big precision on your position, but it gets at least very close that you can use that as your guessed position and then increase the precision of your position fixing. So answering your question, so you have three stars, right? Let's see, and you also have you can use also the sextant to get the azimuth of them. I think. And then if you know the direction of those three stars, you can plot them around a circle on a paper. And the point,
So
the
you do
center
need
of
the circles. So you do need the
no,
circles.
no. That circle isn't the circle of equal altitude. That circle is just a circle around your position. It's just
How do you
represent.
how do you decide
So
the stars and the directions?
Hmm?
How do you decide the stars and the directions they're at in relation to you?
Oh, you pick the stars that you can recognize, and preferable the ones
By
that are highest.
constellations and bright one.
So you need this prior knowledge of
Yeah.
that. Then. Okay.
I'm not sure. I think some almanacs has in like their last pages a picture of the constellations. So we can use that if you don't know them by head.
I mean, not most people, but a lot of people can usually find, if we're in the northern hemisphere, can find the northern star.
Right, and they usually don't find it by just looking at it. They usually find a constellation that is the closer, and with reference in that constellation, then they can find the North Star, because the North Star is quite dim. It's like
what if you're in the southern hemisphere? You don't know what hemisphere you're in.
Or you'll know as soon as you look to the constellations. For example, the Orion constellations. Yeah, it's pretty recognizable, and it's all, more or less above the equator. So it rotates around the equator. So if you see that on the north, then you're in the south. And if you see that in the south, you're in the north.
How do you know which way is north or south?
Well, you can just wait a little bit and see the stars rotating because they're moving in the sky, right? So if you sight them, you sight a star that is closer to the horizon.
So basically, you have to have a good knowledge of the stars, then.
Yeah, if you're doing celestial navigation, of course.
Okay, go on.
Right. So the way I've seen it being done, which is not exactly how I do it, but it gives the same results as far as I tested it, is that you plot the direction of the stars on a chart that you cited, and then you have the angles you measure for each one of those three, and now you use your guess position to calculate what should be the angle.
Sorry to interrupt, but you're telling me now that the way they do celestial navigation is they wait and see which way the stars are moving?
No, you usually have a compass as well, but God's scalpel said, "What if you don't know?" That's one way I could figure it out. I don't know how people would figure it out without a compass, but that's one way. That's the easiest way it came up in my mind. There might be an easier way than that.
No doubt. Let me just All right, just God Scalpel. I wouldn't take what these guys are saying too seriously because they think you can do it without circles of equal altitude. Anyways, go on. Go ahead,
No,
guys.
Jeremy, I
That's a
just
strong one, Jeremy.
it's more. I'm not here to argue. I'm just here to understand their
Yeah,
perspective on their side, right? You know what I mean? Like I don't.
no doubt. What they're saying is just that's not how it's done. So I don't even know what there's. But hey, go ahead. Go
It
ahead.
is how it's done.
No, Jeremy, if you want to say what you want to say too, I'm all ears. I'm
The way
curious
it's
at
done is with
different people's
circles of equal
positions.
altitude.
Have
Yeah,
you
the way
ever
it's done
seen
is with
someone
circles
doing
of
it?
equal altitude, and they're saying you don't need to do the circles of equal altitude. So that's but that's
Have
how
you
it's
ever
done though. So
seen?
I don't know.
That's not
They're
true,
not
Jeremy.
like
Where did you
telling
get
you the
this from?
right.
Jeremy, where did you learn this? Have you ever seen
The
someone
circles of
fixing a
equal
position?
altitude. Where did I learn the circles of equal altitude?
No, where did you learn that they draw the circles of equal altitude
Yeah,
to fix their
where did you
position?
learn that you have to draw them and there's no other way of doing it?
So
There
that's how
has to
they
be
do it.
circles of equal altitude, right?
But you're saying that we
I'm
have to
Does there
draw
have
them.
to be circles of equal altitude?
No, you said that's how they do it. I'm asking where did you see it?
Yeah, there has to be circles of equal
So
altitude,
you
right?
didn't see it. You're
Does there
concluding that
have to
part.
be circles of equal altitude?
It depends on what you mean. Like conceptually, yes. You
Go
don't have
ahead,
to draw
gods.
them.
Go ahead, gods.
So
Scalpel.
you're just being dishonest
I'm
because
just
you're
letting
saying
them.
like
Yeah.
you're saying as if you've seen they doing it, and apparently you're basing that your claim on your conclusion, not in something that you actually learned.
If you want to
So then-
answer, if you want to answer them, I'm all ears to just listen how it goes too. Like
Sure.
Jeremy.
Yeah.
No, I'm telling
I
Jeremy.
don't.
Yeah, if he wants to.
All right.
They won't answer
All
me.
right.
They won't answer me on if you need the circles of
I
equal
answered you.
altitude or not.
I
You said
did.
sometimes. What did you
I
say?
did.
What did you say?
I said conceptually yes, but you don't have to draw them.
So do we need them though somewhere? They have to be somewhere, right? Because those are those circles give us the point at which you're at. So we have to have the circles of equal altitude for this to work, right?
Yeah. What is having the circle mean to you? Does it mean drawing? Then no, you don't have. You don't have.
The circles have to be somewhere, right? These circles have to exist somewhere, so they know where all the circles line up, so they can tell where they're at, right?
Here, let me help you.
I can't do this, guys.
No,
These
no, no,
guys
no,
are
no,
so,
no.
so,
Just listen. Hold on. Hold on. He said a specific word that I'm going to hang on to. What does it mean? You answered Jeremy by saying conceptually, yes, you have to have the circles. What did you mean by conceptually?
Right, because when you're doing the math, you're trying to solve for those circles. So you know the radius of those circles, and you know the center of those circles, right?
So Jeremy is right with what he's saying. It's just you're saying I'm not going to draw the circles on a piece of paper. I'm going to look at it through the eyelids of math, but they're still circles.
Exactly.
Yeah. So Jeremy's right.
No, Jeremy's wrong because he's saying I'm saying you don't need the circles. Oh, I'm not saying that. I'm just saying you don't draw them.
Yeah, but you need So now you're just talking past each other. You do need the circles, though.
Yeah.
You're just not drawing them. So you're saying I don't need them because I'm not drawing them, but it's almost double speak because you are using them. You're just not drawing them.
You see how long it took me to admit that you actually need the circles? I can't do this with these. Go ahead, guys. You go.
No, it's fine. I don't mind your input, dude. I like to see a little bit both sides.
There are ways to look at the same math and not seeing circles there. For example, let me give you a very easy example. So if you know, let's say, let's do it in Cartesian play because it's easier. So if there's 3 points, and you know the coordinates for those 3 points, right? And you don't know your coordinate, but you know the coordinates of those 3 points. And you know how far you are from each one of those 3 points. One way you can figure out where you are is to draw circles using those distances as radius and see where they intersect. Another way is that you can.
I'm hoping you're not using this example to segue into the sextant, though, right?
No.
Okay, good. I'm just making sure.
I'm trying to
just
justify
making sure.
my reasoning. Right.
Yeah.
So the other way you can do it is that you can try to.
But hold on. I'm sorry to interrupt you, man. I don't mean to, but basically your example is a non sequitur then because it doesn't apply to the specific topic.
We didn't know what I'm getting with this example.
Oh, okay, sorry. Go ahead.
No problem. So the other way you can do it is that you can try to play with your position, like you measure how far you are from them. That's what you know, right? But you don't know your position. But you know, like, oh, if I'm at this position, you just pick a random position, let's say, then I would be closer to that point than I actually am. So you can correct for that position, picking a position that is actually further. So and you can
But
keep.
once again, this doesn't segue over to the.
It does, because the way I'm describing now is actually how they do it. And you can
So
say, well,
what's
the circles are there, but they're
what's
not
the
actually
known?
doing circle math. You know, they're not doing math.
What's
of
the
circles.
known? What's the known? Yeah, you basically are. Like, I don't know why you just can't give it to Jeremy. I think you're just
I
not
think
being. I don't know
They
why,
probably
but
saw the
whatever.
video. They probably saw the video of the debunk of this, so now they're gonna try to get away from these circles. That's my thinking, but
But either way, what's the known distances when you're placed in the middle of nowhere and you're using? Because you're talking about, being on a Cartesian coordinate system and 3 known distant points. You don't have that with your.
You do with the sextant.
How's that?
Yeah, because if the star is at your zenith, you're at the GP. The distance between you and the GP of the star is 0. As you get further from that GP, the angle drops linearly. So if you can read the angle of a star, you can know how far you are from its GP, and that's the distance you know, and the GP is the position you know, which you get from the almanac and your clock.
Yeah, but you don't have an almanac with you.
Oh, if you don't have an almanac, then I can
No,
help you.
I gave you the clock, but I said initially it started with you're in a boat. I put you in the middle of nowhere, and you have a sextant, and then you started or whatever, and then you wanted a clock. So I said, yeah, okay, I'll give you the clock. That's fine. And so now you have a clock, a sextant, and a boat. But now you start bringing in almanacs and distances that you don't know.
Because I was explaining how it's done. If you want me to solve without an almanac, then I wouldn't be able to do it. I would just guess which
Fair enough.
hemisphere. I mean, like I would look to this. I'll see if I can recognize any constellation. I'll wait a little bit just to see how it's moving in the sky, and then I could figure out where north
Yeah,
is,
you know-
where south is, but in which hemisphere. I mean,
you,
but I
you know how
wouldn't
if you
get
buy like
much
a
more than that.
you know how if you buy like a dresser or a bookshelf or something, and it says this is the tools you will need to assemble this. God Scalpel basically wants that list of tools. You're on a boat. What do you need to do?
No,
Right?
I gave him. No, actually, it's sorry, Jeremy. It's a little bit the opposite. I said you need to build this dresser, but you don't have a screwdriver. But the screwdriver was in the list. Is more what happened. Yeah, I want it because ultimately, I guess the point is that an angle by itself, you can't do fuck all with an angle.
If I could interject, Bacon, it sounds like you were trying to explain how you get a transit measurement, and I don't think we're ready for transit measurements. We need to stick on a stationary measurement at this
Kool-Aid.
And who are you to decide this, Kool-Aid?
I'm the
that's
guy
a
who
boat.
used the sextant to actually navigate the Earth. Who the fuck are you?
That's the boat.
Who are you to decide?
I'm the guy who's used the sextant to navigate the Earth. Who are you?
So what's
do
your
you
point?
do you need the circles of equal altitude, Kool-Aid?
Bacon explained it very well. Yes.
Yes, you need those circles. Okay, and are those circles?
You don't have to necessarily draw them, but you will at some point derive them.
So where are they?
What Bacon was trying to illuminate is
hallucinate.
Yeah, sorry. He was trying to explain how you do a transit measurement, which is the actual way that sextants are used, because when you use a sextant on a boat, you're not in a stationary position. You're moving. So your measurements aren't from the same spot.
Where if you drop your anchor? You're not moving?
Yes, you are.
Oh, are you?
Yes.
Where are you going?
You will spin around the anchor. You will bob up and down on waves. You will be pushed to and fro on the anchor chain. There is no way on an
But
anchor.
you're not moving along the water. That was my point. You're not moving from point A to point B.
Yes, you are.
Oh,
Well,
yeah?
the thing is, what I was explaining, I think would also work on a stationary position, right?
I might have missed that part. I apologize.
Yeah, we can simplify. We don't have to make it so complicated, Kool-Aid. Do you want to make it complicated?
They need to make it.
That's what I was recommending. Is we do a
Make it
single point
complicated.
measurement rather than a transit measurement. Because
Do you
a
come in
transit
here and say we
measurement-
should do exactly what we were doing? Is that your point? Because you're so fucking smart? Huh? Why don't you shut the fuck up?
I was actually trying to. I was trying to be on your side and say Bacon needs to simplify. I misunderstood what he was doing because from the
Yeah.
part I heard, it sounded like he was doing a
Next time,
transit.
just listen a bit before you come in
So
here.
why don't you just shut the fuck up, Dog Scalpel? Because
Why
you
don't
don't
you
know
shut the
shit
fuck
about
up?
this.
How
Have
do you know
ever
what I
even
know
picked
or
up
don't know? How do you?
Because so far you've
How
shown that you
exactly?
don't know anything.
Really? How?
Mm.
How have I shown what I know?
Okay, hey, Dog
Didn't-
Scalpel. Here's
Did
a
I
question.
not tell?
Here's
Hold
a
on,
question for you.
hold on, hold
No,
on, hold on.
Answer my
Did
question.
I not tell Jeremy?
my
Did I
question. You
not
think-
hold? Shut the fuck up for a second. Did I not
Oh, what's
tell
the matter,
Jeremy?
Dog Scalpel? You little bitch.
Yeah.
Come on, dude.
Just
Why
shut
don't you
the fuck
try-
up for a
Hey
second.
guys, can we
Answer
chill
this
out?
question.
Just
What
guys,
is-
hold
what
on.
is
Let
the
me.
Let's
What is the
Hold on.
angle measured
Shut
from?
up.
What
Shut up for a
horizon is
second.
the angle measured from? Just answer
Did-
that one question.
Did I not tell Jeremy that I was
Oh,
just
it's like
asking
you know
questions?
the answer. You
Why don't you
gotta
shut the
keep
fuck
talking
up
because you
for a
can't
minute, dude?
answer.
Hold on.
go
I think I
ahead,
got
guys.
bars
Hold
in
on, guys. Hold on, guys. Guys, we gotta go one at a time, bro.
Mhm.
One at a time, please.
So the one guy said, I'm curious how he derived what I know or don't know. Because when Jeremy, you started talking, I had told you that I was just asking questions and I was curious of what their perspective on things was, right? Do you remember that? And I said
Yeah.
I wasn't really weighing in on any sides. So if that's a fact, how the fuck does that show what I know or don't know about the situation by asking questions? Whoever said I don't know anything and it proves what I'm saying proves that I don't know anything, can you explain to me how what I've said during this conversation proves anything one way or the other when I've clearly stated that I'm not picking a side, I'm just asking some questions to allow people to talk about their perspective? Go ahead, whoever that was. No? That's it? Okay. Now, what the
Doc
fuck's your
left.
problem, Kool-Aid?
He left, I think.
Yeah. Because he's the bitch, not me.
Anyway,
I don't know why they're saying all of a sudden you don't need these circles. This is
Yeah,
crazy.
it's easy if you pay a little bit of attention in the answer and stop repeating the question as if it wasn't answered. You might know it.
No, I think we already crossed that bridge, though. Like, basically, Jeremy Bacon has said that he's using the circles. He's just not drawing them down. They're just, like, basically data points, if I'm right, Bacon, on what you're trying to
So
tell
they
me.
do need the circles.
You're using
you do
a
need the
coordinate.
circles.
You're using a coordinate in a radius that forms a circle, but you don't have to draw the circle. You don't have to do anything in the circle. You just want to know the position that matches that distance. That's all.
So no circles are getting drawn. Nobody's drawing circles.
Yeah, no one draws the circles. Yeah, you can if you don't have it. Like if you're in the scenario that God Scalpel described, which is something very rare. I'm not sure if that ever happened, but if that ever happened, then you would be very useful to draw the circles.
You'd have something to draw them on.
Yeah, but we need the globe to do that.
You would draw this. So you would draw the circles on you would have a spherical globe with you, and you would draw the circles on that.
Yeah, you did that. Yeah.
They wouldn't.
Whoa, wait a minute. Did you just say, Bacon? I'm not sure you know what you just said. Did you just say that you would draw the circles on a spherical globe?
Yeah,
dude, they definitely saw the debunk video of the circles, bro. No question.
I actually don't know what you're talking about, Jeremy. I'm talking about what I'm saying is things I've tested. So if you go to my app, the one that you can input star sites and it gives your position, you can see those circles plotted in a map, in a 2D map. They never form a circle in the 2D map, and you can hit the 3D visualization button and that's going to give you a 3D sphere with the circles of equal altitude drawn on that sphere, and there would be circles. And actually, Prototype did a position fixing using, like, actually drawing circle on a globe, and that was
You can't draw a perfect circle on a globe without cutting through the globe.
You can. There's something called what's the name of that? One sec.
So wait a minute here. You're telling me that the circle loses its radius then?
No,
Or
it's the radius over the surface.
Then the radius line is no longer a straight line.
Yeah, it isn't. So what?
Hold on, you got a circle where the radius isn't a straight line?
Yes,
That's
you're
what he's
using
saying.
exactly. You're using
No.
the circle over the surface. You're not using, let's say, the half of the chord line of the circle. Yeah,
This
that
is
is
spherical.
actually how it's
This is
done.
spherical geometry right here. You're saying?
It's not. It's non-geometry, is what it is.
No, for example, if you have, you know the distance to the GP of the star, and that's a surface distance. That's not a straight line distance, right? So let's say that star is exactly at the equator in Greenwich line. So it's at 0, 0. That's the GP of the star. Let's say that's the case. If you measure, say 80 degrees, right? You measure 80 degrees of elevation angle to the star. It means you're 600 nautical miles from that star, or you are 10 degrees on the globe to that star. So you just pick that. I'm not sure if compass is the word to describe that tool, but it's that tool that has like two pointy edges that you can adjust their distance. You know.
By definition, the radius of a circle is a straight line, dude.
Okay, so that's not the radius then. But just give it another name if the definition doesn't fit what we're talking about.
Well, then you can't have a circle without a radius. That's how a circle is drawn, with a radius.
Yeah, no. You're drawing the circles based on the distance to the point on the surface. So that's not going to be the same as the radius of the circle if that's how you were defining it. But
Well, that's how a circle is defined. It's not how I'm defining it. How else did you define a circle?
It's a two-dimensional shape in which every position is equidistant to the center.
That'd be a straight line.
That would be from the equal distance.
Yeah, but
so
we're talking
from one
about
point, the distance comes from one point to another. It's the shortest distance, which is a straight line.
But in selection navigation, every time you use the word distance, that is a surface distance. That is not a straight line 3D space distance. So it is in spherical geometry.
What do you do?
So in that geometry, the points have to be.
Where?
Jeremy,
you have to mute when you're. Never mind. So in selection navigation, you have the distance over the surface, right? So if you know there's a point on the globe, and you know there's a distance.
Well, your model afflicted though. You're taking.
There's no contradiction
hold on.
here.
Yeah, there is definitely a contradiction.
Where?
You're taking known definitions of geometric shapes and you're perverting them like fucking crazy. Right. I'm glad you could agree with it. Well, you're the one that called it a circle.
Yeah, because I don't.
Okay, well, you can't call it a circle if you don't have a straight
to be
radius, dude.
Circles don't have to be circles only in Euclidean geometry. Circles are circles. And if you draw,
well, dude, circles have a definition. It's like it's like you saying, well,
that's a known point. That's completely irrelevant because
no, it's very relevant because you're using language that you're trying to You're using a language that doesn't work, dude. You're trying to steal from a definition.
You're objecting to my language. Now, forget
Come
about
up
the
with your
words
own shape.
Scalpel, shut up for a second. Let me answer you. So if you just pay attention on what I'm describing to you that I'm doing. So if you just listen to what I'm doing with the globe, right? You can object to the word circle. You can say, well, you can use the label there. Fine, I'm not going to call it circle then. If you look at it, it looks like a circle. But if you don't want it to be called a circle because it's
It
not drawn
looks
on
like a
paper,
circle, but it's
I
not.
wasn't finished. If you don't want to call that circle, even though it looks exactly like a circle, I'm fine with that. That's annoying, but I'm fine with it. But that doesn't change what I'm doing to figure out my position. It's a complete semantical thing you're doing now. It's
No, it's
completely
not.
irrelevant.
No, it's
Yes.
not.
Okay, so I'm not gonna use the word circle anymore, and I can still describe what I'm doing, and that still matches a globe, and that's still how people do it. And so the fact that
Yeah,
it
but
matches,
except that a circle, the rate. Listen, man. The
I don't care,
reason
man.
why.
That's
The reason.
that's semantics. I
Okay,
don't
listen.
care
You
about
told
that.
me to shut up earlier. Now I'm going to tell you to shut the fuck up for a second and let me finish my sentence. Okay.
Fair enough.
Good. Thank you. So a circle, its definition is based off a straight line. Now you want to tell me you're building something that looks like a circle without sticking to that definition and telling me it doesn't matter. You're pissing down my back and telling me it's raining at this point.
Yeah, but that's irrelevant. Let me
Like I
give
said.
a. Okay, let me try to see how you describe it then. Say I have a sphere in my hand, just like let's say a basketball, right? And then I pick a string that has, let's say, 5 centimeters length. Then I stick one tip of that string on the basketball, and then I attach a pencil to the other end of the string. So the pencil and the is at 5 centimeters away from that point over the surface of the basketball. That's not a straight line. That is a distance over the surface of the basketball. 5 centimeters over that surface. Now I'm going to slide the pencil around that point, right?
Okay.
And that's gonna. Okay, so
I got what you're
radius.
saying. So hold on. I got what you're
Call
saying.
that
So
if that's not a circle.
let me explain you to this. What I would say is you don't have the right radius to that shape you drew on the ball. So let's say,
what shape is that?
Hold on. Let's say I said you don't have the right radius, the proper radius. So in other words, your math is wrong. Because
I'm not using that radius.
Hold on, just slow down. Let me explain why I say that. Okay? So you draw this supposed circle on this ball using your bent line, your string, right? I can completely picture what you did, right? So let's say how that string you said you want it to be 5 centimeters, right? Okay, so you drew a 5 centimeter radius around a point on this ball, right? Let's say you pick up that radius. So you did it. You instead of drawing it, you used, I don't know, some material that it was like 3D printer stuff. So as you drew the circle, you printed you put the plastic around the ball. So now you can take that, what you call a circle, off the ball and put it on the counter. Are you with me so far?
Yeah. You put it on what?
On the counter or whatever, like, the table. Put it on the table. Right. Okay, so now you got this circle that you drew on the ball sitting on a table instead of on the ball.
Yep.
What do you suppose the radius of that circle is?
A little bit smaller than 5 centimeters.
No, it's going to be larger than 5 centimeters.
No, it's going to be smaller. The chord line is smaller than the.
Yeah. You're right.
That's not actually the.
So it's going to be smaller than 5 centimeters. So the true radius of that circle that you think you drew, like, the point is you're saying this shit doesn't fucking matter and it's all semantics and blah, 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 blah. But I'm telling you it does, because the way you describe making this circle, if you will, is based on what you would describe a 5 centimeter surface, because you inscribed it on a fucking basketball. What I'm telling you is you don't actually have the proper radius of this supposed circle.
Yeah,
so
I agree with that.
So the numbers you're using, this stuff does fucking matter. The numbers you're using then aren't accurate. They're not
they
right.
are accurate.
I
but
can
they
tell you that the difference. Hold on, Bacon, just quickly. The difference between the actual number and the number he'll be using is different by 0.27%.
Congratulations.
That's irrelevant.
You're using faulty numbers either way. You're perverting the definition of the definitions
Yeah, I
of
accept
real
that.
world geometry. That's what you're doing. And then you're saying, oh, it's okay. We'll just figure out the percentage in which we're wrong as we pervert definitions of shapes and geometry.
Actually, that's I don't agree with Gummy Bear's response, because we don't actually use the radius you're referring to as the true radius. We don't care about the radius. We care about the surface one. You're saying, well, but that the surface one is different than the straight line one. Sure. So what? What's the problem with those two radiuses being different? What's the problem with that? How is that?
Well, I already told you what the problem is. You're perverting real geometry.
Yeah, so give new labels for them, and then tell me what's the problem.
Okay, go ahead. It's your system. You go give new labels for them, and you go do all that shit. It's not for me to do.
Well, it's usually enough for people to understand the context, and when you say
because they're lazy and they want to agree with you because they think you're right, but you're not. You're perverting
because
what
they're
a circle
capable. It's because they're capable of using the word circle on a sphere.
You don't draw a circle by a curved radius line.
You do in celestial navigation. You do in celestial navigation.
It's a perversion of real geometry.
But that's semantics. That's just semantics.
Like I said, that's what you say. You're pissing down my back telling me it's raining. I get it.
Yeah, what you're calling semantics is actually you just imagining up some sort of fake thing that doesn't actually exist or isn't real. Like, you can call it semantics if you want. You're just describing nonsense. That's all.
Yeah. It's like saying gravity. It's like saying it's the same idea as saying gravity is not really a force, but we must apply it as a force. You could say that's semantics, which by all means I think it is semantics, but they're outright saying it's not a force, but you need to look at it as a force or use it as a force or apply it as a force. It's the same shit you're doing right now. Yeah, I understand this.
It's not what I'm doing. You're the one objecting to
real world geometry, but this is the way we want to apply it anyhow. So it's all right.
You're the one objecting to definitions.
Well, because I know what the definition of a circle is. I understand how to.
Right, but the thing is,
how to make a circle.
The thing is, whenever if you look it up, how to do celestial navigation, you're going to see them using the word circles, and it's going to be used in the same context that I'm using. When I looked it up, I had no problem on using the word circle. It didn't confuse me because
I'm not confused, dude. Don't think for a second.
I'm not saying that. I'm not saying that.
I understand the way a circle's
made. I'm not saying that. I wasn't finished. So it wasn't a problem for me, right? And it's not a problem for most people. So if you think we shouldn't use the word circle in celestial navigation because we're not using a straight line radius, that's just completely nonsense. Because even though you're not using that radius, it still would have that radius. It's just not the one we're using, but it would still exist.
That's still not matter. What you just described
make shit up. It doesn't matter if we're 10%.
We're not making shit up.
Use it incorrectly. Do you have a definition that describes a circle, the line making a circle, bending in a third dimension? Do you have a definition that describes a circle in that way?
No, the circle can be very well the 2D plane that cuts the Earth. You could say that that's the circle. I'm fine with that.
Okay, so you don't have a definition describing what you're talking about. You're saying that they use it that way. You don't have a definition that describes it that way. You're just
no, but wait. The way you come up with the circle is different from the definition of the circle. For example, if I come up with an object using a hammer, the definition does not have to mention hammers, right? So if I came up with a circle by using a curved line to create the circle, that curved line is not going to be the radius, right? Because the radius is a straight line, as you guys see. That doesn't make it less of a circle. It doesn't make it less of a circle.
You didn't understand the definition. Hey, hold up. Describe something that isn't one.
Oh my gosh. All right. So
that is a circle.
Hold up. In mathematics, okay, a circle is 2 dimensions. If you have a 3-dimensional object, you can use 2 of the dimensions out of the 3 in order to draw a circle or
well, then you can't have a curved fucking radius line.
That's not the radius line.
You used an unnecessary qualifier when you said
that's not the radius line.
You said that's how you're doing it in your example. You're putting a pen
but that's not the radius. That's just how I'm drawing the
string to a center point, and you're making. Well, that's the fucking. So that's my whole point. Then you're still not using if you're going with that for your celestial navigation, you're not using real world numbers.
A circle of equal altitude will often not have, if you define that circle within 2 of the 3 dimensions for that sphere, it does not have to share the same radius as that sphere. Because if you're only going to use 2 of those
What are you
dimensions,
talking about,
one of them might,
RC? It doesn't have.
hey, listen, one of them might not be the entirety of the center of that sphere to the outside of the sphere. It could
What
be
are you
actually
talking?
just the top part of it.
RC, you're just fucking rumpusing at this point. Nobody cares about the radius of the sphere.
They pop in with bullcrap that has nothing to do with what we're talking about, explaining things that have nothing to do with what we're actually talking about.
No, I'm actually. You asked for a definition of how do I do it? It's 2 of the 3 dimensions.
How do you do what, RC?
Yeah,
I
we
didn't
didn't
ask
ask
you
that.
fuck all. Nobody asked you one question.
I don't care if you want to.
Okay, well, you
understand it,
just
then
said that
need-
you were
Hey,
asked.
just because you're emotional about it, guys.
I'm not. I'm hardly emotional, dude.
So then calm your tits. So
Can we pause for a second?
Just because you have man tits doesn't mean I have man tits.
Let's pause. Let's pause for a
ask
second. Let's pause for a second. So in this example of the basketball, right? Even though I'm coming up with the basketball using that curved string to do so, you still agree that I can remove that circle from the basketball, lie that on the table, and that's still a circle. So you can actually create a circle using that curved line. I agree with you.
That wasn't my argument. The
Okay,
argument
so let me
is the
finish.
curved line is not the radius.
Yeah,
The
I'm agreeing
radius,
with that.
I said.
I am
I
agreeing
initially
with that.
said the radius has to cut through the Earth in order to know the radius, and you said no, you can do it. Let me tell you an example, and then you came up with the ball example and said the curved line was the radius. Because initially, Jeremy,
No, I
if
can
you're
agree
still
with you
here,
that that's not the
if
radius.
you're still here, Jeremy, initially, you said that a radius can be a curved line. That's how this got started.
Yeah, because that's how people use it in celestial navigation. But if you want to take the definition of a straight line, then I'm fine with that. And then I'm saying, okay, then that curve isn't the radius, but it's still how you come up with the circle. And Bob though was saying, well, that's not a circle then, because you have to come up with using a straight line. No, that's not true. You can come up with whatever way you want. If you end up with a circle, that's a circle. It doesn't matter how you came up with.
Yeah, I never said that. I don't know why you're using other people's arguments against me. I
No,
never
because no, not you, Bob though. The
I don't
last guy.
fuck who's Bob Dole.
Yeah, so I was answering him.
Oh, I see. Well, he didn't say you couldn't make a circle. I don't think. I'll let him
No,
talk.
he was saying he was asking for a definition that in a circle can be you can use a curved line to create a circle. If I can find a definition for that, and what I'm saying is, well, even if you define the circle as having a straight line radius, you can still use a curved line to come up with. Just like in the basketball, we end up with a circle.
You seem to be misunderstanding what just took place.
Right. So clarify, please.
You implied that we misunderstood what a circle was, because we misunderstood what the definition of a circle was. So now that would indicate that you have a definition implying that you can do that. You have not provided one yet.
So tell me what I'm wrong, and then I'm trying to.
Yeah, they just circle back around.
You're wrong about us misunderstanding the definition of a circle. It does not include what you're.
Actually, no. Actually, no.
We're so far away from. Hold on, just listen. What he's saying is right. We're so far away from what started this conversation. It was you saying that the radius of a circle could be curved. That's what started all this, and we're so far away from that.
Yeah, that's how people use it in celestial navigation.
Okay, show us the definition of a curved radius then to make a circle. Do you have that definition? That's what the real Bob Dole, I believe, is asking.
No, I didn't look up definitions of circles. I just look how they use it.
You're making shit up.
No, I'm not. That's how they use it in celestial navigation. They call it circle, even though they're
you made the claim that a radius can be
the
curved.
word wrong is not proof for your side. They can use the word wrong. That's fine.
They're using that curved distance to come up with the circle. If that's considered the radius of the circle or not, depending which geometry you're saying that circle, because that circle exists in both spherical and planar geometry. If you look at the circle in planar geometry, that's not going to be the radius of the circle, but on the spherical geometry, it will.
There is no curve. Yeah. Show me the definition of a circle, a curved radius for a circle in quotation marks spherical geometry. Do you got that in your
Yeah,
back
I'm not
pocket?
sure where to find that, but it's pretty.
Yeah, probably pretty hard.
Under spherical geometry, every distance is a curved line, right? And the definition of a circle, is that every point around, on the shape of the circle is at the same distance to its center. If you do that on a sphere, right, and on spherical geometry, all those distances are going to be curved lines.
All right, you know how we have rules for like Euclidean geometry and all the axioms and stuff and all the rules and definitions and how it works. Do you guys have anything like that for spherical geometry? Like, where's the book?
What they say, Jeremy, is it's all the same except for axiom 5.
Euclid is the person who actually developed spherical geometry initially.
Yeah, and when he very good, and when he defined a radius, it's a straight fucking line.
So you're saying the rules for spherical geometry are in Euclid's, all Euclid stuff for Euclidean geometry?
Not in his books.
Where's the
Euclidean.
rules? Listen, I asked a simple question. Where is the definitions and rules and axioms and all that shit for spherical geometry? Where is that stuff written down at?
Okay, you can just look for the circle of a sphere that defines how a circle is on a spherical
You know what
geometry.
you know what an axiom is, Bacon? He's asking for axiom.
The definitions, the rules, all the stuff that you would need to have some kind of geometry system. Where is the one for the spherical one? We know where the Euclidean one is.
You actually can use Euclidean to do that. The way I did was using Euclidean. I don't use the spherical.
The only way you can use Euclidean is if you cut the radius through the Earth. Is that what you did? Because you started.
That's actually how I did.
Let's not forget this conversation started because you tried to tell me I gotta keep mentioning this because it's important. You told me straight up that a radius line of a circle can be curved.
Yeah, in spherical geometry.
Okay, so this is really simple, and this should take care of the conversation. We can find a definition right now, very quickly, that describes a radius as literally a straight line. Can you show any definition anywhere from any source whatsoever that isn't just you and your buddies here that says a radius can be curved?
I'm telling you, I didn't look up for definitions. I'm just telling you.
Where did you get this idea from?
I wasn't finished. I wasn't finished answering.
I don't care what you have to say. Go get it.
Well, you don't get to allow me to speak or not if you care not what I'm going to say.
Go get it. Go get the definition.
But hold up.
Definition of what?
Oh my gosh! Can you wait?
It describes a radius as being curved. Go get it.
Let RC get it. Go ahead, RC. What do you got?
I think what you guys are getting confused with this idea of radius is the idea of
We're not confused. He said radius.
Hold on, Bob.
Shut up, Bob. Though.
Hold on, Bob. Guys, if anyone's getting crazy, I'm gonna get the room out of control. If 10 people pipe up when the room gets out of control, that doesn't help me at all.
It's the idea of having an equal. It's called a circle of equal altitude. Okay, circle of equal altitude you can say has a radius. Okay, you talk about the line that goes from the zenith point all the way, like in 3D space. That zenith point as a ray, indeed, would serve as a radius if you just look at the two dimensions. But the point is that's why we use these linear curves of 1 degree per 69 miles. That definitely maps out what would happen on a curve, not what would happen if we were actually using triangles to try to do this, because it's not about
a circle is defined by its radius, dude. That's how a circle is defined. I'm sure you know that, right?
That's why you were talking about a circle of equal altitude. Because what we're doing is saying there is a curved surface, there is a zenith point on that curved surface. Hey, wait, stop.
There's no different types of circles.
Allow me to finish my sentence.
RC, you took your turn, dude.
There's no different types of circles, RC.
In the middle of, oh my gosh.
You're making this idea, a circle of equal altitude. As if we go around carrying about the attitude of a circle. Come on,
guys,
man.
Hold on, guys. Come on, please, one at a time.
He's just talking
I
nonsense.
think.
Scalpel,
I think.
you're
One
over
sec. Let me
over
try to get
talking
back
me
here.
because you're scared of the answer. The point
Okay,
is
let's
that you have
go
a
back to the
zenith point.
discussion.
Right.
The
Yeah.
zenith point. The
Can't go back
zenith
to the
point. Oh
discussion.
my gosh! The zenith point that is on the surface of the Earth. You create a ray that goes from that zenith point all the way through the Earth and everything else. If you would draw a line in a two-dimensional space from that circle of equal altitude to that zenith line, yeah, you could make a radius out of that. But that's not what we're talking about here. Okay, what we're talking about is that zenith point along the surface of the Earth with that circle of equal altitude. That 1 degree per 69 miles that we measure, that's what we're talking about.
Okay, are you done spouting off about bullcrap we don't care about and aren't discussing?
Yeah, can I go back to what I said probably almost literally 10 times by now? This whole conversation started by Bacon saying that the radius of a circle can be fucking curved, RC. The rest of your bullshit, I don't
already
fucking
took that
care
back.
about it.
Why are you insisting on that?
Did you? Oh, okay, sorry. Good.
Like
So
because
we
you don't
know that
have
the
to.
radius is straight.
Yeah, you can use only Euclidean geometry if you want to. So you don't have to care about any definitions of spherical geometry. Because
There
the way
is no
I
other
did.
geometry, dude.
Okay, I'm not gonna discuss that with you. I don't care about that discussion. The thing is, you're asking questions about how celestial navigation works, and the way I developed it,
we've gone past that,
was
I think.
only using Euclidean geometry. So you don't have to appeal for any definitions of spherical geometry because I'm not even using that. But you were asking how people
But you're
actually do
telling
it.
me
At least Jeremy was.
You're telling me we're gonna do this whole celestial navigation thing using only spherical geometry, or sorry, Euclidean geometry.
I'm saying you can. I'm saying that's how I did it. But if you
no.
Hey, but Bacon, man, this is where I'm going to criticize you for this. Like, dude,
So you're gonna
this is
upset
not
people
about.
now,
Hey, hold
Bacon.
up, Bacon. You have to freaking back off this whole Euclidean geometry thing when it comes to this, because people can, in this conversation in flat Earth, continuously confuse this idea of a curved versus straight adjacent. When you invoke Euclidean geometry, people start thinking right triangles and everything else. You got to
Yeah, because you can't have fucking right triangle.
but you can do actually using that.
No, that is
not the
not
way
what we're
they
talking.
describe it.
Celestial
I know, but
navigation. Hold up, Bacon. Listen to me, man. Celestial
Listen,
navigation
Bacon, you need to listen
is
to your
about.
handler telling you.
No, would you shut up, Scalpel? You're not helping anything.
It's awesome.
So, Bacon, what I'm trying to tell you is that, like, all we're doing with celestial navigation is simply finding a freaking angle. That's it. Okay?
And you need straight lines.
so that's the first step. That's not actually the context. We're talking about the trilateration. And when you have
and that's fine. We're not trying to invoke Euclidean geometry, though, when it comes to
You need two
trilateration.
straight lines for an angle, right, Darcy?
Oh my gosh. And that's why I'm trying to tell you, we're not trying to invoke Euclidean geometry when we're simply finding a freaking angle.
Which kind of geometry? Which kind of geometry are we using so we know which axioms and rules we're going to follow?
What are the axioms for
to find an angle?
Hold on, gods.
Find a
simple question. What kind of geometry are we using so we know the rules and the definitions and all the stuff?
The people who do it the way I did it.
I don't know. RC just said we're not using Euclid. Like which type of geometry are we using so we know?
So here's what Bacon has correct about this. Okay.
Actually,
no, I haven't. Why can't you answer my question?
Hey, stop sidestepping.
Actually, both are used.
He's got a question for you, RC. Answer his question.
Both are used.
I'm trying to, but everybody keeps interrupting.
All right, go on.
What Bacon is saying is correct. That is correct is that there is a process that we go through. It is not just simply about invoking Euclidean, non-Euclidean, spherical. The point is that celestial navigation is based on a sphere, but uses principles that you can actually find in all types of geometry, such as finding a freaking angle. Okay? And that's all I'm trying to tell you guys is, like, don't just say I can just use Euclidean or just use whatever. The entire point is, how do I use each of them?
Yeah, and it's actually both
so you
are used.
still didn't answer Jeremy's question. Just wait. Sorry, man.
I did. I said both.
Yeah,
that's the third time I'm answering.
RC did not answer Jeremy's question.
Well, he wasn't trying to. I have already answered Jeremy, and then RC said something else.
No, that's
so
not an answer.
So we're using both types of geometry. We're just going to mix them up, and so I'm going to need to know the rules and the definitions and stuff for the spherical geometry, so that when we are using, spherical geometry, I know all the rules and definitions and stuff. Is there like a book or something?
I don't know. Probably, but the thing is, you only have to know.
How did you learn it? If you don't know, how did you come up with it?
Because it's pretty simple. You don't have to know all the definitions. You only have to know the definition of the things you're actually using. So, for example, like the definition of the distance of 2 points on spherical geometry. It's just the closest. It's just the closest path between the. I wasn't finished. So the definition for the straight line in spherical geometry is just the closest path between those 2 points, and that's easy to understand. There's a formula that gives you that distance.
But that's a perversion of the real definition of a straight line, though.
No, but Jeremy's asking what is the definition for that on spherical geometry. If you're saying that actual definitions are only the Euclidean ones, okay, that's your point. That's not the conversation we're having now.
Well, it kind of is, man. Like,
no, it's not.
You're basically saying, oh, we like Euclidean geometry until it doesn't exactly work for what we want it to work for, and so at that point, we're going to
No one's saying that. That's a straw man.
We're going to pervert what it is.
That's a straw man. No one's saying Euclidean doesn't work. I actually said many times that you can use only Euclidean if you want to. The thing is, what you're doing in celestial navigation is a very well understood process, and there are parts of it that is easily done if you're using spherical geometry, and some part of that's easier done using Euclidean geometry. So you use both. The thing is, you're not changing the scenario at any point. You're just alternating between geometries when it's convenient, and which makes things easier to be done.
Yeah, but this is what I'm trying to say, Bacon. Like,
you're not allowed to say that, Bacon.
Like, okay, so number one, I doubt anybody in here, or very many people in here, have taken actually non-Euclidean geometry classes and know anything about it.
Here we go.
That's why also the one
According
thing
to Bacon, they might not even exist.
Oh my god!
I didn't say that.
You apparently have no idea.
Oh my gosh! Can you shut up?
RC wasn't finished.
But Bacon, what you were saying.
Go ahead, tell us what we don't know.
Oh my gosh!
All
right,
we don't need to hear him talk about more.
Bob, I know you're scared of it too. Can you just shut up?
I'm so scared. Why would we give you any fucking?
Here we go.
Any respect? Hold on. Why would we give you any respect? Yeah, that's right.
Guys, we gotta go one at a time.
Any respect? If all you're gonna do is insult right before you say anything.
No, all you're doing is freaking interrupting, Scalpel.
All you're doing is insulting, poisoning the well before you make your point. Stop
what I'm trying to say is that what Bacon is saying is correct, that there is a procedure that you use. If you want to understand how those procedures work, you're going to need to understand various types of geometry. Okay?
And who voted you the arbiter? Who voted you the arbiter whether or not Bacon is correct? Who made you the boss of Bacon?
Because I know how to do celestial navigation.
Does Bacon work for you, or you guys?
Sources for what
he's just saying that he thinks I'm correct. You can say whatever you want here. It's just a conversation about what we think about it.
He's coming in like he thinks he's some authority.
The only thing I criticize from what Bacon is saying is trying to speak with nuance without giving specificity.
Who cares what you criticize about Bacon?
He doesn't know anything about spherical geometry.
Nobody cares what you think about Bacon says.
What I'm trying to tell you is that the process for celestial navigation is based on the fact that the Earth is a sphere. If you want to invoke celestial navigation, you are admitting the Earth is a sphere.
Well, yeah, no doubt it's in the
story. You can tell, sure.
Well, the thing is, it should be clear at this point. I don't know what else is on the table to discuss. Actually,
yeah, we can say the same thing right back to you. Just insert the other one.
Oh my god!
Celestial navigation requires a flat.
And that's where you're just
demonstrate it. That's just
if you use celestial navigation, you're admitting that the Earth is a flat horizontal.
That is
wait. Let's check that. Let's check that.
Hold on, I wasn't done. Here's the problem: You haven't provided anything to back up your side. We at least provided a definition for the point we are arguing, or can provide, that a radius can literally be straight. It has to be straight.
That's not backing up your. That's not backing up your claim.
The very specific thing that shows that the Earth cannot be flat is the fact that we have 1 degree per 69 miles. Okay, that is impossible to get that particular lapse rate, 1 degree per 69 miles, without having every one of your freaking altitudes change every time you move any distance.
Yeah, that's a story you can tell. Sure.
You're,
It's not a story.
invoking how
If you want,
you're invoking how the sky. You're invoking
no, you're not
how the
invoking how the sky works.
You're
I'm
invoking
simply
how the.
showing you
Hold
that
on,
the
RC.
law of
RC, hold on a second, bro.
I'm simply showing
when you
that
guys.
the law of signs is correct.
Okay, so when you invoke this 69 miles per degree thing and say the Earth has to be curved,
No,
you're basically saying. What's up?
I said no. What I'm saying is that if you have 1 degree per 69 miles, then the law of signs, if that were truly showing a flat baseline, then the law of signs would be proven incorrect, which it's not.
Okay, so you're basically saying that those stars are in their actual positions, and that's it. But you don't know that. You're just invoking how the sky works and claiming that this is how the shape of Earth is based on us assuming how the sky works.
No,
Doesn't make sense.
I'm not assuming how the sky works. All I'm simply saying is that a place called a zenith, or a place where a zenith angle to that star exists, and if it is 1 degree per 69 miles, that violates the law of signs. If it's violating the law of signs, either the law of signs are wrong or the Earth isn't flat.
Sorry, what does a zenith have to do? What does a zenith have to do with the 69? Okay, we get under a star and there it is, and then we move, and now the star's in a different position. You're acting like that's the actual position of the star.
No, I'm saying that if your base from 69 miles, that you get 1 degree of dip from where you are to where you're looking at that star is, then that would mean that once I move 2 or 3 or 5 or 7 degrees, every single time.
Well, you're assuming actual positions of stars. I know. I don't know why you're trying to deny it. You're assuming that. You're assuming that you have the actual positions of stars. I don't know why you're not.
I'm not assuming anything.
Actually, I think Jeremy's right here. Like
I am right. No shit. Thank you, Bacon.
Yeah, when you look to a star, we are assuming the star is at that direction. That doesn't sound like a crazy assumption to me. But yeah, it is.
No, you're not assuming.
Oh, you got shot down, RC. You got shot down by your own side.
So Jeremy, you're not assuming
dead
that
wrong.
a star. Hey, you're not assuming that a star is in a particular direction. You're looking at the star in that direction.
Yeah, and assuming that that's its actual position. Your own side just shot you down. Just give it up, bro.
No,
Give it up.
Jeremy, I've done celestial navigation for literally 20 years. All right, dude.
Okay.
I'm not being shot down by this. And no,
address how Bacon just shot you down.
By Bacon saying that is an assumption is directly going against the idea that looking at something is assuming that it's there.
Exactly. That's
because but Bacon, that's not an assumption. Observation is not an assumption.
No. How did you observe the distance to the star? You didn't.
You never
that's
invoked the
irrelevant,
distance to a star.
Yeah,
You never
the
invoked
distance
the
isn't
distance to a
relevant.
star. It is not assuming something, Bacon, to say that
Yeah,
you
I
are
know.
observing it. Those are two different words.
Yeah, but when you're invoking geometry to tell that should be on a spherical surface, now that you're using a straight line
Bacon, you are confusing people by saying assumption with this. You are freaking just observing it. Observing something is not an assumption.
I understand that, but I still think that that's an assumption. It's just
I know you do, but I'm trying to show you that observing something is not assuming something.
Yeah, I agree with that part. Observing is not assuming.
Okay, great. Then we're done.
That's not where the assumption is.
And so, Jeremy, now that we know that observing
No.
is not assuming something,
You need
we're
to
not gonna get
stop.
wrecked.
You need to
We're not
stop here.
done. You didn't address the point. You addressed some other point that no one was making. Can we address the actual point now instead of your fake one?
I already addressed the point.
No, you addressed a fake one that doesn't exist that no one made. Let's address the actual point that was being made now, okay?
That was the actual point.
No, that
That we
wasn't
are
the
not
actual
assuming
point.
anything when we are looking at a star.
Yeah, you are. You're assuming that star where you see it is the actual position instead of an apparent position.
You're not
So
assuming
the
that.
atmosphere
No.
has an effect on stars.
You're not assuming that. No.
No, not when you're observing. That's not where the.
So Bacon, that's the
You heard it, guys.
the
RC
period.
said it. The atmosphere does not affect how you see things. Good job, RC.
Nope,
It's
that's
not what
not what I
RC's
said.
saying.
What I said was that when you're observing it, you are not assuming it. Thank you.
Yeah, just observing doesn't imply on any assumption. I
But
agree with
Bacon,
RC there.
then the period is done.
No, because the claim wasn't just that you're observing stars, but
Yeah, no,
how
you
the
addressed
geometry
the
of
point.
their
There's a
angle and distance
fake point
relate
that
to.
doesn't exist,
And
that
to
no one
make
made.
one sec, to make a geometry assessment between distances and angles, you're using straight lines to do so. So that is actually assuming the light to be going in straight lines.
You just got debunked by your own side, RC. Suck it.
I think RC isn't here.
Thank you for being honest. Thank you for being honest, Bacon.
Bacon's not going to get his raise this year from the government if he keeps this shit up.
Dude, I'm just trying to be right.
It was a joke. It was a joke, Bacon, because RC
I
was
know
telling
it's
you
a
what you
joke.
can
I
and
see
can't
what-
say. Don't take it too serious to heart.
That whole 69 miles per degree shit, and then making a geometrical claim on the shape of the ground based on where the stars are, determines that you know the actual position of the stars. Bacon, thank you for backing me up on it. I appreciate it.
Yeah, I think Bacon's one of the more honest ones around here for sure. And keep that up, Bacon. Don't let them bully you around when you think something.
Well, even though
Like
it's
you can,
not. Okay.
you can debunk that whole 69 miles per degree shit. That's why I don't put too much stock into this celestial navigation shit, because it's all based on the 69 miles per degree, which is nonsense when it comes down to it, because you would have to know the actual position of the stars to make any kind of geometrical claim on the shape of Earth.
So are you saying the stars aren't where we assume?
Like you don't have to assume exactly
At
where the
zenith,
stars are. The only assumption is that the light come in parallel.
no, the assumption is the actual position of the star when you're looking at it.
No,
So it is in the actual position. So the claim is the stars are in their actual position.
What like do you mean position in 3D space, or do you mean their direction?
I'm talking about when you look at a star, that being is its actual position.
Like the direction, like it's at that direction.
The spot that it's in, its position.
Position is
do you not understand?
One sec. So for example, if I tell you what's the position I'm seeing, the apparent position, I'm gonna give you that in degrees. So it's how much it's higher from the horizon, and let's say how much it's east from north. So that gives you the position in my field of vision. It's a position in my field of vision. It's not a position in space. A position with space would also need the distance, right? So if I tell you it's in that direction at some amount of miles, that's now not just the position in my field of vision, but it's position in space.
I don't know why we're sitting here debating over position. You look at something, you see it in a position.
Because there are two meanings of it.
Is the position I'm talking about.
That's not giving enough information.
It absolutely is. You look at something, you see it in a position, right?
Right. Are you talking about?
Okay. Hold on. Can I walk you through this? It's going to take like 2 steps. I'm just going to need some quick answers. When you see something, it has a position, right?
Yeah, that has many positions. It has a position in my field of vision. It has a position in space. Which of those one you're talking about?
When you look at something,
Why can't you clarify your question?
I am right now. When you look at something, you see it in a spot, right? You see it. It's there in a spot, right? Okay. You're assuming that spot is its actual position.
Its actual position in my field of vision or in space. You're not. That's the thing you're not clarifying. You're clarifying how I'm looking at it. I understand how I'm looking at it. I'm trying to understand what you mean by
something.
position.
You see something. There's a spot that it's in. That's called a position. The spot that it's in.
Yeah, in space. Is that what you're referring to? The position in space.
I don't even know what you're saying at this point. What's not clear? You see something. It's in a spot.
Yeah,
is that
I understand
clear?
that.
That's clear.
Yeah.
Okay, that's clear.
That.
Okay. Okay, that's clear. We understand. So you're assuming that spot, that position, is its actual position.
When the thing is, when you use the word position, like there's two meanings you could be using there, and I don't know which one you're using. And when I'm
spot
telling
that
what
it's
is,
in, the spot. Okay, I'm not going to use the word position
spot
anymore. We're done using the word position. You look at something, you see it in a spot.
That's not helping you. It's this spot.
You look at something, you see it in a spot, right?
It's this spot on my field of vision, or this spot
you see it in
space.
a place.
Oh my god!
You look at something, you see it in a specific place.
Right. I think I can give you an example then that would distinguish.
Yeah, I don't know.
I think I can give you an example.
I don't need an example. I don't need an example.
Jeremy,
I'm clear.
Jeremy.
I understand what's going on here. You don't.
Well, we're not answering my question, and the example I'm gonna make is so you can answer it. So I'm looking to a star, and let's say that's the actual position of the star, right? If the star gets further, is the actual position of the star changing?
Is it in the same spot you see it in?
Yeah.
Then no, dude. I'm talking about the spot.
Right.
You see
so you're
it
talking
in.
about
what the fuck, dude?
So it's
I can't even deal with
now
you
I
guys.
know.
Honestly,
Now I know your answer. Now I know your
They're
answer.
trying to clarify. That was what. Yeah. I mean, Jeremy, I don't know.
Dude, the spot you see it in, dude. What the fuck is wrong with you guys?
He said position, so we could be.
Yeah, position, the spot, the place.
Yeah,
no,
it's the place you view it in.
No, it's not the place.
Jeremy.
The place would be the 3D, the position in space.
To be fair, Jeremy, I get his point. Like he's saying, you said position. You see a star. Maybe it's 1,000 miles away. Maybe it's 2,000 miles away. But from your perspective, you can't tell the difference. But it would be a different, technically, position.
I know.
Right?
I clarified it though. After several times with the place you see it in, the spot that you see it in. It was I made it very clear, and these guys be playing games and shit.
When I ask it, is that like the direction you're seeing, or is it a position in space? You could just say, well, it's the direction you're seeing it.
Dude, you see something in a spot.
You said
you see something in a spot.
You don't have to repeat yourself. You all heard you saying that 4 times.
You're assuming that well, then how do you not understand? Because what I'm saying is you see something in a place. You're assuming that place you see it in is its actual position.
I understand your point, Jeremy. The thing is, you repeat. There was missing a little bit of clarification there.
Hey, can we move past that?
This is what they do.
Please.
This is what they do.
I'm not
they
trying
like
to
get
keep the
bogged
discussion
down.
there, Jeremy.
This is what they do. They like to keep the discussion bogged down with stupid little details. You'll notice it every now and then.
Right. So when you say its actual position, I'm going to take that as the direction. So yes, that's
the position you see it in.
Right. So in that sense, yes, we assume you. So yeah, the answer would be yes. Then we assume we see that it's the actual position after we account for refraction. Because if we assume that right from the start, we wouldn't correct for refraction. Like we assume what we're seeing is very close to its actual position. We also work under the assumption of a little bit of refraction close to the horizon, which is something that matches how fast they move in the sky. It's not something completely out of nowhere. But yeah, you could call that an assumption. I understand it.
And the 69 miles. Hold on a second. And the 69 miles per degree is based on that being its actual position or spot you see it in, or however you want to fucking play pedantic games over what that means.
I believe that the fact that celestial navigation actually works would say that's a fair assumption.
Maybe
No,
not.
no. That's I mean, if you had the sky on a flat surface to produce the same observations that they would produce on a globe, the same math would give you your position. You'll be working under wrong assumptions, and you still gonna get to the correct spot. That's something like you would happen in Trullo's model, for example.
Exactly. Thank you, Bacon.
But I don't think anyone should take that model seriously, because in that model, as you travel north and south, your body stretches, and you could surround the whole Earth with your nose if you went to Antarctica.
Yeah, we've already debunked the fact that just because something works doesn't mean the premise or the things that came before it is true.
Right.
We know this, right? Yeah.
Right. All I'm saying is both of them will work, but I would say Trullo's model is a
I'm not.
way
No, don't
crazier
try to
reality.
strawman me. Yeah, don't try to strawman me with
Sure,
the crazy model. I never even seen it.
I'm not actually trying to address you. I'm just adding that.
All right. So you heard, Left Lane? Just because it works doesn't mean that that's what it is.
Well, I think the point that it works shows that our math is actually working, and that its assumptions can be correct. So, but for example, if we, it can be correct. Not that they are correct. So, for example, if we assume
based on false things, absolutely.
If we assume light to travel in straight lines, and we are on a flat surface, that assumption wouldn't work. That would not give you your position. So one of those has to be wrong, right? So either light is not traveling straight lines, or the Earth isn't flat, right? And when you assume that the Earth is a sphere,
that's a weird that was a weird dichotomy. Say that dichotomy again.
Yeah, if you have those two assumptions and the conclusion is false, either one of your assumptions have to be false. So either light is not traveling straight lines, or the Earth isn't flat. It's either of those.
So if if light travels in curved lines, then Earth is a sphere.
No.
Well, say the dichotomy. Can you phrase your dichotomy?
I think he's saying if light curves, Earth is flat.
No. It could for the Earth to be flat, the light will have to curve.
That's what I just said.
No, you said you said if light curves,
light curves, Earth is flat.
No, that's not
It's not the same thing.
Yeah, it's not the same thing. Like it could be curving in many different ways. Only one of them would give you a flat surface. So, for example, in the globe model, it actually curves a little bit. So in both of them, you would have light curving, but they are curving in different ways. One of them gives you a sphere, the other would give you a flat surface. But a straight line would... Sorry, go on.
That's right. I was just going to say the contrapositive to what he said is that if light doesn't curve, Earth cannot be flat.
Yeah, exactly.
That's what you guys think?
If light travels in straight lines, then Earth is flat. So light doesn't travel in straight. So light doesn't travel in straight lines.
Or the Earth isn't flat.
We already know that. We already know light doesn't travel in straight lines. What you said was just worthless, pretty much. Sorry.
Are you saying that logical statements are worthless?
That one was because we already know that the light curves. So what's the point?
But even so, the whole point is that, okay, so we have a globe, and that gave us the equations for celestial navigation. And then we figured out that the equations work.
You guys make it sound like there was no such thing as navigation before the globe was discovered.
No.
So then what's your point that you came up with another system to navigate? Because there was navigation before that.
If you wouldn't have interrupted me in the middle of what I was speaking, I would have gotten there.
Okay, let's go. Go ahead then. Go on.
So, because it's a globe, we made up some equations. We then tested those equations when we did the slash navigation, and they work. That isn't the same as saying that it is completely true that the Earth is a sphere. All that shows is that the equations work, giving us our location correctly. However, it is quite suspicious that we cannot get those equations from a flat Earth. We're only getting them from a globe Earth.
You can get them on a
That's all I
flat
wanted to
Earth
say.
if you don't assume the actual positions.
How are you getting the equations flat Earth? So using a flat Earth, how do you get these equations? Please explain.
Yeah, you just say the sky is working in such a way that it causes the stars to appear to drop 1 degree per to drop 1 degree per 69 miles over a flat Earth. Boom, all set.
Yeah, good luck with that equation.
We just did it. The equation is that if Earth is flat and light bends in such a way that it causes the stars to appear to drop 1 degree per 69 miles.
Yeah, that doesn't sound like an equation to me.
No, hold
The
on.
equation is the light bends so that the stars drop 1 degree per 69 miles, and we don't have the actual positions of them, like you guys think.
That's fine. Okay.
That's the reasoning, yeah, not the
Now,
equation.
very, very importantly, how does it do that? How can it possibly have that linear relationship on a flat Earth?
I don't
Probably too
claim
advanced for you, but
I hear you. I don't sit here and make claims on knowing how the sky works. I was just showing you guys that your claim on knowing how the sky works is ridiculous, and you don't.
As long as you say that that's just how it works, you don't necessarily know
Yeah.
how or how, if it's even possible to do so, but that's how it works.
Our assumption isn't ridiculous. It matches observation.
The observation of the stars being in the actual positions that you don't know if they're in or not.
Yeah, it matches observation. Every time you look at something, that's very close to at this thing's position. So this is
you're
our
saying
observation.
your observation matches what you see. That's what you're saying. It's
No,
dumb.
no. That's not what I'm saying. I'm saying I have a sight to something that gives me a direction that I'm seeing it. And there's also let's say the straight line direction from my eye to that object. And in all of our experiences, or most of our experiences, those are either very close or they're the same. So, for example, if you aim at something and you shoot at it, and your bullet hits the target, right? Then you're actually the position you're seeing is actually the position that it is. So that is very very common in our experience, right? And so we're not assuming anything crazy. We're not assuming anything ridiculous. I think our assumption is pretty well compatible with observation.
All your
John.
Oh, sorry, man, Jeremy. Sorry. All your observations are in a straight line. Bacon.
No.
Yeah.
What do you mean?
All your any tools you use, all your observations, they're all straight lines.
Yeah, you repeated that, but what do you mean? For example, if I'm using a theodolite, right?
It's all straight lines. Straight lines.
But if I'm taking, like, if I'm aiming at something that is very close to the horizon, it's very far, I know its position changes depending on the weather, right? So the light isn't making a straight line to me, is it?
Well, what kind of distance are you using this tool at in your example?
I don't know. Let's say 6 miles.
Yeah, my understanding is you don't do that.
Yeah, but if you do, you're gonna see.
Listen, my understanding is if you're a professional using these tools, you would
That's
never
the claim.
use the tools in that way.
That's irrelevant for the claim. We're not talking about.
It sure is relevant to the claim because obviously there's a reason they don't do that. What would that reason be, I wonder?
It's the point I'm making. That's the reason. That things
The reason
aren't
would be that you're not
always.
seeing the actual position at that distance.
Yeah, it's not always a straight line.
Right, so, yeah, well, you say it's not always a straight line, but it is because you don't make those measurements at those distances.
Because they're not straight line. If they were, you could do them, right?
It's not my claim that they're not straight lines. I don't know if they're straight lines or not, but the point of the matter is everything that you're doing that has any value at all comes from straight line.
Yeah, if the light is traveling straight lines, you have more precision, of course. Yeah, sure.
If it has any value, it's in a straight line. All these angles you talk
actually,
about and tools, like whether it's a theodolite or whether it's a friggin' auto level or whatever it is, they're all straight line instruments. They all create a straight line.
That has a very that's a very loose claim. They make
Is
straight
it?
lines because the make, like if you're referring, for example, to a horizontal plane created by an auto level, right?
Mhm.
That's a straight line. But what you're seeing actually that might be seen on the plane might not be actually on the plane. So one thing is a straight line, which is the side of the auto level.
Yeah, but hold on. All the measurements are based off that straight line, which is that plane that you're talking about. That's a straight plane, straight
Sure.
line, straight plane. So
I'm not disagreeing with that.
all the measurements are based off that plane. All your elevations and all that are based off a flat plane.
Yeah, the horizontal plane. Yeah, sure.
So you agree with that then?
Yeah. I'm not sure, but I can agree with that. I had no problem with that claim. Like, I'm not a surveyor. I won't claim things that I don't know.
What?
But if that's the claim, I'm not gonna reject it.
Perfect.
You were a surveyor.
Sorry?
Nothing, man.
I'm glad you could agree with that. That all the elevations are based off a straight line, a plane of reference. Perfect. That's all I need.
Well, some angles, some elevation angles are measured from zenith, so it's from a line, not from a plane, right?
In both cases, I mean, you're fine in doing that. That's why I posted that picture. It's you can make an angle from the zenith, 2 straight lines. So you can make an angle from the horizon and 2 straight lines. There's no issue.
So, Kosho, are you also in agreement that elevation comes from a plane of reference?
Yeah, in my picture, I've actually drawn a plane of horizon. It's basically the horizontal from that point.
No, in the picture, it looks like you drew a what's that called there? It intersects a circle.
A tangent.
Yeah, a tangent. You created
you're right.
a tangent.
You're right too. It's a great observation that you made because actually, I would consider the point that's the line that's tangent from your position that you're standing, and the horizontal that you're creating are going to be 2 parallel lines. So,
say that again.
The horizontal that you create, whether it's from your eyes or from your feet or wherever it is, it's going to be parallel to the tangent from that same position.
Sure. Yeah. But so would you agree the horizontal you make that's tangent to, or that's parallel to the tangent, that's how a surveyor determines elevation change?
I'm not sure about surveying or elevation change, but I know to tell the elevation angle, you could use the plane of the horizon, or you can use the zenith angle.
Let's say a surveyor takes out his auto level and he creates a plane of reference doing foresight and backsight, let's say for a mile. And at the end of that mile, he determines there's a change of 12 inches a foot. What would that surveyor call that 12 inches? Would he call it elevation change based over that mile or what?
Yeah, that would be elevation change, yeah.
Okay. And so that's based off of the horizontal plane of reference that is parallel with your tangent. Would you agree with that?
Wait, you said that he used the horizontal to determine that? Let me think. Actually, yeah, hold on. If he was making a horizontal and he got an additional 12 inches or whatever, then 12 yeah, actually, I think that's just drop, isn't it?
Just drop. What does that mean?
Like if you're making a horizontal and then there's more drop when you get to that mile away from the horizontal that you started with. It's not elevation change; it's just drop due to the Earth's curve.
So you're saying that it would be 12 inches of drop due to the Earth's curve after?
No, I'm not saying it would be 12 inches. I'm saying this is what I would say that whatever the difference was, I'm not saying what the difference would be, but you just described. You gave me an arbitrary number, so I'm just saying.
Yeah, I just pulled it out of my ass. But what I'm saying is the surveyor goes out with his auto, his or her. Let's be politically correct here. The surveyor goes out with his or her auto level, does foresight, backsight like industry standard, most likely within 50, 75 meters max. Usually industry standard's 50 meters. Does the foresight, backsight for a mile, gets a change of, let's say it's only 3 inches. What does the surveyor call that 3 inches?
Like I said, I don't know what he would call it, but if what you're describing is the horizontal that he's created, and he's seeing that there's a deviation or it's 3 inches less on one side than the other, then I would consider that to be the drop.
What if it's 3 inches higher from point A to point B? What if it's 12 inches higher on point B than, like, point B being a mile down the road? You start at point A, you do your foresight, backsight to point B, which is a mile away, and it's 12 inches higher. What would the surveyor call that?
He would probably not call the 12 inches the elevation, but he would realize that there is a higher elevation there. I'm sure he would measure the elevation more accurately, though.
More accurately? How would they go? What would be the practical way of measuring this 12 inches more accurately?
I mean, something similar to what you described, but maybe with a water level, so that you were actually, measuring the points that were level at that same distance, and to see what the difference of that height is based on that.
Yeah, I gotta be honest, Kosho. Like, I've talked to a lot of surveyors actually, and I don't claim to be a surveyor, but I think I have a decent understanding of it all. And the last thing I think a surveyor would do after doing foresight and backsight for a mile is think to themselves, I need to come up with a more accurate way to figure out if this 12 inches is right or not. These are the tools that are used to measure elevation changes.
Horizontals are used to measure elevation?
Well, they're used to measure elevation changes, but they're based off a plane of reference.
Can I ask a question?
Go ahead.
Are these surveyors that you've talked to, are they all saying that the elevation, like the Earth is, the water is on a horizontal plane, that there is no curvature to water?
I don't know.
Oh, okay, fair enough.
Yeah, when the hypothetical that you gave me, I wasn't trying to hire somebody and task them to do one job and then tell him to come back and do it more accurately. I was answering your question, like how about measuring the elevation change. I'm just saying I wouldn't have done it the way you described if I was looking to measure the elevation change. I wouldn't have measured it using this foresight and backsight of the auto level and make
how would you do it?
I told you the water level would be probably give you a more accurate idea of where the elevation was, the consistent elevation, right?
So if you were a surveyor, you'd use a water level to figure out elevation change? Not to say that you can't, but I'm just wondering that's the tool of choice for you.
Hold on. The water level, the auto level makes a horizontal, right? And you're saying the auto level, the tool makes a horizontal. You're saying the water level makes a better horizontal than the auto level.
No, I'm saying I would.
You said that's how you would do it more accurately.
Yeah, but I'm not. No, that's not what I said. What I said was to measure the elevation.
It sounded like that.
I know that you have something to say, but I'm just going to correct Jeremy real quick so he's not confused with what I said. I didn't say that this is a more accurate way to calculate a horizontal. I said if instead he was worried about the elevation, which was what Godscalpel had asked about, the elevation, I would instead do a different method, which I would say is more valuable for elevation change, which is a water level. Yeah. But the horizontal, I wouldn't be worried about horizontal at that point.
But Kosho, the elevation change is based on the horizontal plane of reference. So I get what you're saying, but also what Jeremy's saying in default would also be correct. You would be saying that somehow or another the water level would make a more accurate plane of reference in which to refer to calculate in quotation marks your elevation change.
And so you're claiming that the horizontal is gives you an say it again. What you said, an accurate plane of reference.
The way an auto level works, it creates a plane of reference, and based on the difference of that plane of reference, that's the way you would calculate your elevation change between point A and point B, right? So by you saying it's more accurate to use a water level to do that, I think it makes what Jeremy said accurate, because by default you would be saying that the water level can create a more accurate plane of reference, horizontal plane of
I
reference.
wouldn't be worried about a plane of reference or a you said use an auto level to give me elevation, to measure elevation. I don't think that's the most accurate way to measure elevation.
Well, I'm not sure anybody claimed it was the most accurate way anyhow, but what do you think is the most accurate way out of all the tools? Do you say water level?
Well, the water level would be decent because it would be, it'd be accurate in, keeping the same consistent elevation. Like you would know, if you had the same water height at, all ends of your water level, and you kept moving it down, you would know that those were all the same elevation. So if you wanted to measure elevation change, that would be probably the most accurate way to do it.
You're not conflating elevation change with the horizontal plane of reference, are you?
No, I'm actually not bringing up the horizontal. You keep bringing up the horizontal plane of reference. I'm moving away from that because I'm saying that's not what I would use. I would use a water level and the elevation, and compare the elevation of wherever I was, as I move along to the surface or whatever, and I would use that to compare the elevations.
Okay, this is interesting. So how, with a water level, how would you practically use it to figure out your change of elevation?
Well, I mean, it depends on the range, right? But
well, we've been talking a mile, so let's stick with that. There's no sense of changing that.
Well, if you want to do over a mile, you just got to make a lot of trips. But if you're up for the job, you just take two ends of it. We take one at one end, and take one to the other. Put it at a you'd have to use a what do you call that? You would use not the auto level. Use the auto light, wouldn't you? No, you would use auto.
No, well, you're saying an auto, or you're saying to use unless, and I think I'm in the same boat as Jeremy, unless we misunderstood you. You said that the water level was more accurate than the auto level, and I'm not agreeing or disagreeing. I'm just kind of exploring where you're going with it.
I'm not talking about making it for a horizontal plane, though. I'm talking about using the water level to mark elevations.
Sure, and I said, how would that practically look? How would you do it? Like, what are the steps?
Well, I mean, I'd have to talk to an actual professional, but I would from just doing a crude method. I just use those two ends of the water level. I would make sure that that it was one. So I would start where it was like one elevation, right? One height. The water was coming up to some height, and then I would make sure that the other end, it was the water basically would be coming up to the same height wherever that was. So I would know that those two places are the same elevation. From there,
I honestly, I don't mean to insult you at all, but I don't think you have a fucking clue what you're talking about at this point.
Oh, you must be confused. I'm not a surveyor, dude. I was just answering your questions about surveying for some reason.
But you're saying, okay. Why would you make this claim about how a water level is more accurate to depict? Once again, I'm not agreeing or disagreeing with it. I'm just trying to figure out where you're coming from.
It's fine. I mean, you're learning. We're all learning. But yeah, it would seem that a water level, which is actually comparing elevation, whereas, or keeping consistent elevation, so you can make a comparison. Whereas a auto level, which is making, and you said doing foresight and backsight, so you're making a consistent horizontal plane. If you were to go to one end of that horizontal and compare the Earth beneath it, or different elevations of the land in reference to this horizontal plane that you've established, I don't think that you would be correct in saying that this was elevation, considering that the Earth would be curving, and that would give you false.
Just so you know, the surveyors would harshly disagree with you. The people that do it for a living and use these instruments would disagree with you.
Yeah, they use a mile long horizontal and measure elevation based on that.
Yeah, for sure. When you say mile long, though, it's front sight, foresight based on 50-meter sections.
Yeah. If you're doing a 50-meter section,
they don't stand
fine,
at point. They don't stand at point A and look to point B, being a mile down the road, and somehow or another make a horizontal plane of reference like that. That doesn't work.
Well, then, the mile is irrelevant then. But the 50 meters,
no, it's not.
It would be irrelevant in the case of what we're talking about if you're not if you're not using the full mile horizontal and comparing one end to the other end, then it doesn't matter then. But you can just
you don't. They never would do such a thing.
But you're the one who said that. That's why I asked you what range.
Well, I'm saying that they would create the horizontal plane of reference over a mile with the technique of foresight, backsight along that mile.
Yeah, well, if you were only comparing the range, 50 meters or so, then
it's 50 meters front sight, 50 meters back sight.
Yeah, I know,
which is total 100 meters.
When you're measuring and comparing the elevation now, within that parameters of 50 meters, you could you could easily use a auto level or whatever, because the horizontal is not.
That's what we're talking about as an auto level.
Yeah, but okay, listen, because you confuse the whole thing by saying that you're doing it throughout a mile. And yeah, you can add each of these together in each section, compare the elevation stuff. But I wouldn't compare the elevation at one end to the elevation at the other end of the mile with this horizontal plane. And if it was 12 inches off, I wouldn't call that elevation change.
That's the way surveyors do it now.
Yeah, but you just said they don't. You just said they compare it within the 50 meters.
No. I'm saying that if they do foresight, backsight, if they start at point A and they use the technique of foresight, backsight with an auto level and go out 100 miles with that technique, with that technique, and they get to the other end and there's whatever the distance is, they'll call that elevation change. I won't ask the question. I'll tell you what they do instead now. They'll call it that's the elevation change.
How accurate are they in that 50 meters? Like millimeter or 0.1 millimeter?
In the 50 millimeters or the mile?
The mile.
Oh, the 50 meters. No, the 50 meters.
Oh, you just said after the mile they'll call that elevation change.
Yeah, whatever it is, it'll be elevation change. Pardon me?
Can they be off for like 2 millimeters in that 50 meters measurement or establishment?
They can be within a quarter of an inch over a mile, dude.
Within a mile. So for 50 meters, it's less than 0.001 millimeter?
No, it's not. That's not entirely the way it works. If with the technique properly done, it's a plus or minus per measurement.
Sure. So for 50 meters.
So the one measurement, the one station could be plus. If it is, the next station, the surveyor would do the opposite. If it's close to a number, they'd split the difference the other way, or eventually they'd equal it out. But if they do it properly, they'll be easily within a quarter of an inch or even closer after a mile.
But it all depends on the 50 meter sections, because they don't do 100 meters. Well, the 100
Well,
meters.
it's 100 meters total, but it's 50 meters front sight and 50 meters back sight. So it ends up every station would be 100 meters, but the front sight, back sight, it's divided in two because you're in the middle of the front sight and the back sight. So it's 50 meter, let's say, sightings.
If they, let's say that they do it for a mile and they're off for 1/4 of an inch, then they do another mile, they're off another 1/4 of an inch. When is it horizontal? Because it sounds like it never is.
No,
It's always
that's not the way. No, that's not the way it works. They'll be even 2 miles. They'll be within a 1/4 of an inch. It doesn't matter. They can go like that forever, and still maintain that accuracy.
I don't see how if they do it in 100-meter sections.
Well, that's not my problem that you can't see that.
Well, okay.
Why don't you go talk to a surveyor? I tell everybody they should go talk to
I've
surveyors.
spoken to
Ask them.
some surveyors, like
Oh yeah,
Norway
off Discord. Yeah. I know there's some people that are in this argument that say some things, but I'm saying go call some people. Don't talk about the shape of the Earth. Ask them about their tools, how they use them, what's more accurate
And if I
techniques
ask,
they would use.
and if I ask them where do they measure elevation from, they're gonna say that it's WGS84, and that's the vertical profile. They're gonna say that the Earth is small.
They don't need a map. They don't need the WS84. Dude, that's the whole point.
Well, they do because they use GPS to get the elevation of points.
Yeah, they can use GPS. You know why they use GPS?
Because it's fucking accurate.
For accuracy?
No, it's not for accuracy. Actually, the reason they use GPS, if you go start talking to surveyors, you'll find out pretty quick. The biggest reason they use GPS is time and cost. When someone hires you to do a job, if you can reduce the time that you're on site and the cost to the customer, that's the way they're going to do it. If you talk to them and just like without, causing any kind of reasons why you're asking, like, is the Earth flat or shit? If you talk to them and just simply, through conversation, ask them which is more accurate, GPS or using an auto level can actually be more accurate. The reason they don't use the auto level is, I'll tell you why right now, from the surveyors I've talked to do a mile with an auto level could very well take all day. Or some of the surveyors I talked to said they'd have to come back for half a day the next day. They asked me why would I ever want to use an auto level when I can just come in there with a GPS and be done within a couple hours. So
well, what's
the
how do you know
motivation, huh?
Yeah,
what's the accuracy? What's the accuracy of GPS? Do you know that?
It's like similar, but not as good.
Yeah,
I don't
because
know
I
the
think
numbers off heart. It's been a while since I've
I
looked
think
into
it's
that.
within a millimeter for any given position. You get it with sub-millimeter measurements.
Yeah.
The surveyors I've talked to said they can do it, just as good or better than GPS with an auto level. But they're, coming from their perspective, and that is 100% right. Why the fuck would you want to use an auto level? If it takes all day to do a mile, what if you're doing 10 miles? You're going to be on the fucking job site for 10 days. Nobody's going to pay for that kind of manpower when you can go there with a GPS and do it all with
But the problem,
10 miles.
I think the problem is that if you use GPS for 10 miles, you know that it's curved because you get the WGS 84.
No, the auto level will give you the same elevation changes as the GPS will, with that technique that I described.
Sure, because you don't
So it has
establish
nothing.
one single level. You do it in 50-meter sections.
No, it creates a horizontal plane of reference, and you talk to them, they'll tell you
Yeah,
that.
for 50 meters. Yeah, for 50 meters at a time.
No, for the whole mile. What do you think the elevation change comes from? Are you saying in a mile of 100-meter sections that they lose 8 inches every mile? What about over 2 miles? Did they lose? What is it? What would it be? 16 inches or whatever?
It's
No, not
more,
16, 24 inches.
Obviously, because every time you establish your horizontal, you do it because you get it from vertical.
No, if what you're saying was true with the auto level, then it would create a slope, not a curve.
Sure. I mean, not a slope, but a curve. But
it would create a slope, not a curve. If what you're saying is true.
50 meters, on a 50 meters or 100 meters, is it well within the accuracy or the error margin of the machine for the curvature? Would it be?
No, not even close.
Okay, so how much would it be off on?
Or no, under 50, over 50 meters, you said? Oh, I don't know. Whatever,
Yeah,
I don't
because
even know what it is. I don't worry
that's what
about
you do.
curve because they don't. When they use the auto level, they're not thinking about it.
Sure, yeah, because they do it in 50-meter sections.
So
And
why?
every time.
So why would
No,
I be concerned about the curve?
Yeah, yeah. They don't because
Well,
they know.
okay, so whatever. Yeah, we could just go around like this all day. The point of the matter is they operate off a horizontal plane of reference. I know that bothers you, but that's the
No,
way
it
they
doesn't. It
operate
doesn't.
off.
No, it doesn't. I mean, obviously, a horizontal plane of reference, you get that only from a vertical. And when you establish
Well,
a
it's
vertical,
okay. They don't operate. Hey, quiet. They don't operate off 10, like over a mile. They don't operate off of 10 horizontal plane of references. They operate off one horizontal plane of reference. Do you know what the difference in what I just said would be there?
no, they don't. They establish it every 50 meters.
No, they don't.
Oh,
For
sorry, every
starters,
100 because they have the
no, they
stick.
don't. That's not true. Like I said, it's the same. Like you think there's a new horizontal plane of reference every 100 meters. That's what you think.
Yep, it is.
That's not true.
Okay, how do they do it?
I'll tell you what. Why don't you do this? Why don't you call up a surveyor, right? Any surveyor, pick one out of the phone book or the internet, call them up and say, hey, listen, man, I'm working on a project. And what I need to do is set 2 posts in a field, and they're going to be a mile apart. And I'm going to mark on one post a 4 foot off the ground mark. And I need you to create a horizontal plane of reference to that other post a mile away, regardless of what the height of the mark is when you get there. You think they can do that with an auto level?
With an auto level, with one shot?
Yeah. No, not with one shot.
Oh, why not one shot?
Because they won't do it with one shot. That's not the way you do it. They'll laugh at you if you think you're going to do it with one shot.
I would do it with the water level. I mean, that's the best thing to do.
No, that's not what I'm saying. I'm saying call up a surveyor and ask them if they can use an auto level to transfer this mark so that it creates a horizontal plane of reference from point A to point B a mile down the road. When they tell you that it's no problem to use an auto level, ask them how would they do it?
Sure.
And then when they're done explaining it, ask them, when you get to the other end, would it be a good idea to turn your auto level back the other way and look from point B to point A and just confirm your measurements are right and see what they say?
I mean, and then I would take the auto level, point it from the post to the other post, and I would see that.
Ask them if that's a good idea to do that, and if that's a standard industry practice to do something like that. Go ahead.
It isn't, because obviously the Earth is curving and light bends down.
You're pretty funny.
I mean, that's what the surveyor would say. So, I mean, you're laughing at surveyors now.
Actually, they wouldn't.
Okay.
They wouldn't even bring up the shape of the Earth, dude. I know because I've talked to lots of them. They would never. They don't bring up the shape of the Earth when they're talking about this stuff.
Obviously, they don't, because I mean, they're not stupid.
Well, you just said that they would.
Yeah, if I asked them why won't I do it with a one shot for a mile, they would say, yeah, because the Earth is curving and light is bending.
No, they wouldn't necessarily say that because I've asked them that question. They never said that.
Oh, what did they say? What did they say when you asked, can I do it for a 1 mile shot?
You can't do that. It's not the way the tools work. It's a silly.
So
they basically just laughed at the idea.
Why? There must be a reason why they laughed at it.
Go talk to a surveyor and ask them, see what they say. That's not on Discord. Go ahead.
Yeah, sure.
Let me know. Because I've talked to lots of them. They don't bring up shape here.
Are you saying that it can't be a geodetic surveyor because they use theodolites for longer distances?
Does a geodetic surveyor know how to use an auto level?
They use theodolites, I think, for the.
Okay. Does a geodetic surveyor use an auto level? Do they know how to use an auto level?
I would think, I think you'd first be a So the planar
You-
survey and then to geodetic one.
Well, then you can ask them. Ask them if it's possible to transfer planar reference from point A to point B over a mile with an auto level. Then, and then when they say yes, ask them how they do it.
Sure. Yep.
Maybe if you want, make sure you guys understand what a planar reference is.
Yeah, we know, and you should know what a vertical, the elevation profile is. Like the WGS84.
I actually want to hire a surveyor, multiple surveyors, to actually come make this horizontal line for me.
I had one surveyor that said he'd come out and do what I wanted for a case of beer because he was so interested in what the results would be because he was so intrigued with my idea.
Yeah, I'd love to hire a surveyor. You should have taken him up on that case of beer. Holy shit, that's way cheaper. And I thought,
And then they all stood up and clapped.
The unfortunate part was that particular surveyor that I was talking to was 10 hours away from where I live. Otherwise, I probably would have took him up on it.
Yeah.
Because I called
man.
lots of them from all over, man.
Yeah.
I gotta hop off. Just came home. I'll catch you later.
Later, moment. See, this is what I like. Nice, calm conversation. We got to try to keep it like this, guys. Please, if shit starts getting out of hand, five people don't need to jump in. I'll take care of it. I promise.
But Jeremy, you do know as well is that it's usually very specific people when they join this channel. It goes berserk.
Yeah, but when they do, I'm gonna take care of it. Don't worry, I got this. If 10 people jump in, it makes it that much 10 times harder for me to get control of the room.
Believe
You mean people? You mean people like RC Meisty and people like that?
If that's who you want to point out as doing it more, that's fine. I was thinking of some other people, but that's fine.
Oh, I don't know. I know when he came, the conversation was quite calm before he got in here, and then when he came, it went to shit for a while. That's all I know.
I think Rumpus' style isn't very productive.
No, it's not.
A lot of your best guys are terrible at communicating with other people. So it makes them like not your best guys. I don't know. It's weird.
Best, depending on what sense you're saying, the best guys.
Unless it's their job to be terrible.
Do you even consider to be our best guy?
We'll see. I think some of your smartest guys are some of your worst at communicating with people. So like they would be the best if they didn't if they had better people skills. Like the Rumpus.
Like who?
Like the Rumpus.
You think Rumpus is smart?
As far as knowing all their globe stuff, he's pretty much got it all down pat. All right, he knows the whole globe model and all the ins and outs and shit.
Doesn't pretty much most flat earthers know all the globe model down pat?
No.
Yeah, pretty much.
A lot of flat earthers claim to know the globe model, but I would go as far to say as a lot of them, a majority of them, a misunderstanding of the model.
See, that's another thing. Oh, sorry, Jeremy. Go ahead.
I was going to just say the good ones do know the globe model because you have to know thy enemy, right?
Well, that's another thing I noticed in these conversations is when someone disagrees with a glober, they just say you don't understand. But it doesn't necessarily mean they don't understand. It just means they disagree with what's being said.
So, Scapple, if I asked you this, if Earth was a sphere with the radius we say it is, would boats disappear the way that we see them disappear bottom up?
Oh, I don't know. I don't know. Optics, I don't know. I don't know much about optics.
Oh, okay.
How would you know?
I personally
Oh, sorry.
Yeah, I
Jeremy, go ahead.
personally think the optics can make it look whichever way, either way. Just like
Yeah,
the star,
I don't know.
69 miles per degree with the stars, could be just like you guys say, and it's their actual positions, or maybe it's not their actual positions, and your whole shit's wrong, but it still works.
Yeah, but the thing is about
Oh,
the thing
go
is
ahead.
about light bending in that fashion that would produce that observation. That light would have to bend specifically in an increasing radius according to your position in a very specific manner, which I think would be difficult to illustrate.
Maybe.
I mean, yeah,
I don't know.
Yeah,
I
dealing
always
with
thought.
optics, like when you're dealing with optics, it gets complicated when you're dealing with different indices of refraction, mainly when they form a gradient. So you have like infinite layers of different indices. So you can one thing you can do is just say, well, that's too complicated. That could be doing anything. If I can't account for it. The other thing you can do is like try to understand how that works, and then you can narrow down what can and cannot be true. So if you don't know anything about refraction, just though it can bend light, then sure any observation can be the correct one. Like you can match any model if light can bend in any way. But as soon
does
as you try to
magnification?
understand,
My bad.
as soon as you try to understand it, it starts to narrow down what the possibilities.
Who asked me that question? Was it Left Lane?
Yeah. Yes.
Yeah. So, in my opinion, I think optics and all that stuff is kind of a shitty argument from both sides of the situation. I mean, that's always been kind of my stance.
Yeah,
But
optically.
maybe that's because I don't understand, right? I don't know.
No,
That's the way I feel.
you're right. You're right, guys. I do understand it, and it's not a good argument for either side.
Like even the Black Swan shit and stuff, you'll never ever hear me make any of those kind of conversations or arguments. I just don't really care about them one way or the other.
I think the Black
Jeremy,
Swan was good that it showed people that it could look either the things aren't in their actual position. That's what the Black Swan showed us. And to make a geometric claim about things' positions and the shape of the ground underneath it, you'd have to have their actual position.
Oh, Jeremy, you mentioned the best guys from the flat side understand the glow model, right? Is there any one of those here that you'd say understands the glow model?
I think you wanted to say bacon, Jeremy.
Oh, the flat guy.
I mean,
I'm not a flat earther.
Oh, you said
flat earther, you're saying? I see.
Yeah.
I understand it pretty good. I don't know. I would have to assume a lot of these guys do. I think Elbow does. Paul does. Bob Dole probably does.
What do you think? Right? Can any of you guys tell me why do we have an analemma in the glow model?
Who's Seek and Find? I don't know
Sorry?
who that is. Seek and Find, I don't know who that is. Or Woodsy. He's muted anyways.
Right. So can you tell me what do you think the explanation for the analemma is in the glow model?
When you take a picture of the sun at like noon every day.
Yeah, you take it the same time every day.
And why does
Isn't
it
that,
make the shape it does?
Yeah, isn't that from the sun traversing between the tropics?
Oh, why does that happen?
It's in a different position as it goes from day to day upon its course
Right.
throughout the year.
What does it form an eight sign, like an infinite sign? You know?
Why does it form an 8?
Yeah.
I'm not sure.
Okay.
Why don't you tell us?
I was expecting.
I'm sure I've heard
someone...
it 10 times. I forgot. I probably forgot though. It's really not. I've never seen that as a good
It
argument.
isn't
So
something you memorize. It's something that like you just think about what's going on in the solar system, and then that makes sense. All right. So we know the orbit of the Earth isn't a circle; it's an ellipse,
So
right?
there are
All right.
2 factors, right, Bacon?
Yep.
Does that help you at all, Jeremy?
I don't know. Just tell us. I don't know. I forgot. I'm not trying to visualize this thing in my head. I have something I'm visualizing with the Coriolis effect already that I don't want to lose. So I'm not about to get into this. You guys are
Tell
getting
us about
roasted
that.
on Coriolis.
That's another thing I think you misunderstand. So tell us about what
Yeah.
you're picturing of the Coriolis.
I went over it 100 times yesterday. I need someone to put it down in some kind of 3D model or something. I would ask Kojo. He's totally unreliable though.
He didn't prepare for today's test, Kosho, or not Kosho, Jeremy.
Oh, the Analema. I've never even seen that as a good argument for, it's more stuff in the sky that you may or may not have an actual position on. Who knows?
Yeah, but it must happen on the globe Earth.
It's all
It's not
optic.
something we just have to account for. It's something it must happen. Like that the sun gets bigger and smaller across the year. That would imply we're getting closer and further. And we have seasons. That implies a tilted axis of rotation. Both together will have to cause the sun to form that 8 in the sky.
What's
So the sun
the?
changes. Oh, go ahead, guys.
Oh, sorry. I was just gonna ask, what's the percentage that you get closer and further away from one end of the year to the other?
The percentage. Let me Google it. I don't know from the top of my head.
Oh, you don't?
No, those are values, right? Like knowing values is not crucial to
I
understand.
think it's about 3% because it
Is
gets
that what
3
it is?
million miles. It gets 3 million miles closer in the southern summer. So it's 3 million miles to 93 million miles. That's like a little over 3%. So the sun should be getting 3% smaller throughout the course of the year. Is that what would have to happen?
No, the percentage in
Why?
distance doesn't relate linearly to angular size.
I don't know. One
Well, how
thing,
much
if
smaller
he's
would it
right
get?
about. Wait a second. If Jeremy's right about the 3%, you'd know more than you about it, Baker. He's
But
winning the test.
no. The question wasn't about what the value is.
I know, but he knows something about it you don't know, though. So
Yeah, a value.
I guess my
Scalpel,
point is
scalpel. That's relevant because he's
well,
stating
it is
relation.
irrelevant. It is irrelevant. The
all
point
right.
is that to sit here and play games of trivia doesn't necessarily means he understands it or doesn't as good as you.
Oh yeah, if you want to play trivia games about the globe model, I'll fucking roast anyone here,
Right,
probably even
but
Kojo.
the question depends a lot. Like if I'm asking for values, that doesn't tell you anything about how well you understand the model. If I tell you how the model explains this, then you have to understand the model to know how the model explains that. The question I asked Jeremy was how the globe model explains the Analema. You don't have to cite any value for that. You just have to understand what happened in the solar system. That doesn't require you to memorize any value. And if you ask how far and how close the sun is to the Earth, that's the number you have to memorize. But you can't know that without understanding the model. So I think it's not fair to make them equivalent. They're not.
And it is a bit more than 3%. Yeah. Yeah.
It's less than 4%.
So it's 3.4%.
Oh, anyway, what was the?
You gotta. I just want to say to Jeremy, you gotta up your game, man. You're out by 0.4%. Smarten up.
So how much is the Earth or our model per shape? How much bigger is the radius or the circumference around the equator?
Hold on. So if something gets 3% closer to something, how much bigger or smaller does it need to get?
Exactly.
Yeah.
Yeah, it doesn't. The size and the distance do not follow a linear relationship.
Yeah, it's the double distance, half the size rule. So how much smaller would this if it's 3%? What's up?
More or less that. Yeah.
That's the rule, right? That's the law. Double the distance,
No,
half the
actually,
size.
no. That's
No?
approximation for. I mean, the size and the angular size are different things. If we're talking about the size, depending on the camera, that does hold. But if you're talking about angular size, and that doesn't matter what camera you're using, and that doesn't follow like half the distance. You double the distance, half the size.
Aren't we talking? We must be talking about a solar filtered sun, right?
No, I think
Just
he's
You're
a
talking
telling
about
me
distance
the
in general.
you're telling me the distance, the law for it's perspective, right? Double the distance, half the size.
Yeah, in a
So I
rectilinear
think
camera, yes.
aren't we? Hold on, aren't we
Yeah.
conflating the two? Like one is if you look at it with a solar filter, and the other is just looking at it with the amount of light you get normally. These two will have different effects.
You guys always be trying to make shit more complicated than it really needs to be all the time. I
No,
don't know why you guys do that.
it's not how.
Just because we want to look at the full picture doesn't mean we're.
You brought up actual size and angular size. Now you're talking about rectilinear
Yeah.
lenses and shit.
And
Like, dude,
angular size doesn't really tell you fuck all anything. Doesn't mean anything.
That was the
angular
question.
size.
Like how big it looks, is defined by its angular size.
Well, angular
Because
size doesn't mean
how much
anything.
do you think?
It
How
does
much do you
mean.
think the actual amount of light the sun gives us changes during those? That's not going to be 3%. How much is the angular size? The solar filter, that should be 3%.
Would you
The
guys
angular-
agree?
The angular size on solar filter? No, that would also
so
not
you're saying with a solar filter, the sun should get 3% smaller if we get 3% closer to it.
Actually, it depends on what we mean by or where the 3% go. It's not 3% area; it's 3% angular size.
No, you
That's
wouldn't
all.
increase
That's all
3%
things
angular
are when you see them as angular size. Obviously, you don't see actual size.
Well, hold on, Bacon and I seem to be
Why
disagreeing. What do you
do we
mean?
even talk about? Why would you even bring that up? Like, that's totally irrelevant.
Hold on, Bacon is disagreeing with what I said. What's wrong, Bacon?
Right. For example, if you're looking to a building and it's 45 degrees above your line of sight, so it covers 90 degrees of your field of vision. So it's I mean if you would mirror the building, you would get like a 90 degrees. But we can just stay with the 45. I think that's easier to visualize. So if you're sighting the top of a building that's 45 degrees above the line of sight, if you go twice as far, that angle doesn't drop to half of 45, right? Like you're 100% further, and the angular size doesn't drop 100%, and it also doesn't drop to the half of that.
But if you double the distance, it's half the size.
Oh, not the angular size, right? Because that's not gonna be half of 45 degrees.
You only see angular size. Why are you even talking about that? Why would you even bring that up?
No, because there's two. No, actually, no. There's two ways you can measure how big something looks. For example, if you take a picture, the size of the thing on the picture doesn't necessarily match its angular size. Those are not the same thing. Like that depends. For example, the camera doesn't change the angular size of anything, but it changes how big it looks. So, for example, the angular size is about the field of vision. So if it covers.
So now you're talking about wide angle lenses and rectilinear lenses.
Yes,
but
that changes how.
If we were going to measure the size of something, we would use something that wouldn't distort the size of it. I mean, this is like totally irrelevant.
No.
Yeah,
Because
angular.
Even when you use
mean
anything.
Jeremy, even when you use rectilinear lens, that still doesn't match angular size. Isn't supposed to match angular size.
Whatever we use to measure the size of an object with, that's what we're going to use. We're not going to use anything other than what we're going to use to see what the size of it is. Why are you even bringing this up? Is beyond me.
Because I'm not getting you what
this
what
is. I can't.
Like,
just go ahead.
You're never. I mean, every time you're ambiguous. Every time you're ambiguous with something, you don't want to clarify that. That's not on me.
Yeah, the angular size really doesn't matter, especially if you don't know the actual size and the distance, right? So
the question is what happens if something.
Yeah, that's what I was trying to say. Angular size doesn't mean shit, really, in the end. You can do nothing. Yeah, except for maybe to compare size. That's all you can do. Really,
I mean, but you will have to actually know the actual size and the distance. Other than that, you're making assumptions.
You could only really, you can just use it to kind of compare it throughout a year or something if you're looking at the same object.
The distance, and no, the question is if you get 3% further or closer,
Listen,
much
you
that
don't
affects.
even know why the angular size. You got to make assumptions to even know why the angular size is changing. What if the object literally changes in size and not distance?
What I'm talking about, I'm picturing buildings, right? I don't think the actual size of buildings are changing when I get further closer.
What? Beauty? Who's beauty?
Buildings.
Oh, buildings. Okay.
Yeah.
Okay. Oh, buildings.
Sorry
Oh,
for.
buildings. Yeah, it sounded like you said beauty.
Yeah.
That's, I was like, yeah,
Right.
it did sound like beauty. I'm like, what the fuck is he talking about? Beauty? Who's beauty?
Yo, dude, Don's doing pretty good, man.
Anyway, like when you're saying like how big it looks, you can be usually we refer to the angular size when we're talking about that. It's often what we refer to, and that is not.
The difference about a building though is it's something that, like, you're taking a concept where
You're
we can
breaking up.
like. Can you hear me now?
Oh yeah.
But doesn't the change in angular size from July to December, and doesn't that angular size change match the model? Is that right?
I never checked that actually.
I don't know, Left Lane. How much angular size should it reduce in from
Well,
when we're 3 million miles closest to when we're 3 million miles farther away?
yeah, I don't
Do you
know.
know? Me neither.
I've been in on a conversation where the 93 million is the average distance. It's actually, maybe at 91 million to 95 million or something like that to get the accurate numbers. But the calculations were done according to what's published. I've
It's
not measured
91
it.
million to 95. It's
Either
91
way.
million to 90. Oh, go ahead, guys.
Oh, just sorry, man. I didn't mean to interrupt you. I just want to say, either way, regardless if it matches or not, there's really no way to actually confirm. The sun could be closer and bigger. The sun could be closer and smaller. The sun could be farther and bigger. The sun could be physically changing size or not physically changing size. It could be changing in distance. You can't. How you gonna confirm any of that shit? You really can't, truly.
That's what I'm saying, man. This whole shit's based on them knowing how the sky works.
You just agreed with that? So what you could do is you could employ Occam's razor, and it would be very interesting if the sun was both moving closer and getting smaller, and then moving further away and getting bigger, just to fool us. But it's probably fair to say that that there's no reason to suggest that that's happening, right? So you can rule that out unless you have evidence for that, right? That's pretty fair.
Occam's razor. Yeah. Listen, just very quick, Kosho. Occam's razor is cute and everything, but that doesn't make it right in all circumstances.
Yeah, of course.
Just because you might think it's a little bit too complicated for your worldview doesn't make it false.
No, it's not too complicated for my worldview. It's a very unique coincidence that has no there's no reason to suggest it. It was something that you came up with that gives it has a possibility. We might want to keep that in mind, but it's not really
equally as valid as it isn't. It's equally as valid as it isn't in my mind, as far as I'm concerned.
How is it equal? I mean, if they're both possible.
Well, the reason why,
one requires a coincidence with no justification. The other doesn't.
There's no coincidence. It doesn't have to be a coincidence. You're labeling it as a coincidence. That doesn't make it so.
It's a coincidence. There's two things happening. It's getting further away and bigger at exactly the rate that.
No, what I said was it could be getting further and closer, or it could be getting bigger and smaller. Not both, but I suppose that's another option. But it wasn't one that I was.
But it also matches like the speed in which we see the sun going around the Earth. So when it starts to get bigger, the days get shorter, and we get smaller. The day gets. I think it's the opposite. Yeah, it's the opposite. So when it gets bigger, the days get shorter. And when it gets smaller, the days are.
Yeah, that's another assumption as far as I'm concerned. It's going around. The idea
that's not an assumption. That's measurable. That's measurable. If you look at the analemmas, you can check that. Yeah, you can check that with the analemmas because
Yeah,
those
if you
pictures
say
are
so.
taken. Those pictures are taken at the same time of the day. So if the sun is higher or lower, then you can know if days are getting shorter or further. So I'm now spoiling the answer for the analemma, right? And that matches. And for that to match, if the sun is just getting
Oh,
bigger or
you're misunderstanding what I said was an assumption. The idea that it's orbiting the Earth is the assumption, not that that's getting bigger, smaller, days are getting longer or shorter.
right, but you have those two things matching. Like you have the size of the sun matching with the position on the sun in a way that would like it matches the Earth orbiting the sun, right? And if that's
Yeah,
not the case,
simply matching to your worldview about it, / your understanding / your story of it. Yes, sure. That doesn't make it true, though. Either
yeah,
way.
I agree, yeah. But
Yeah, that's all
strong
I'm saying.
evidence, like
Yes, sure. I'll even give you that. It could give you your conclusion could be reasonable. I'll give you that. How about that?
all right, yeah, that's fair.
But that doesn't. I'll also say in the same breath that doesn't make it necessarily true. It's
Right, yeah,
just
I agree.
reasonable. Okay,
I
that's it.
agree.
And Don's doing pretty good, dude. Oh yeah, I was just doing some research because yeah, I figured that you were just trying to learn from surveying. For me, for some reason, I don't know why you were asking me those questions, but yeah, I saw an actual decent way to measure elevation that the surveyors use with the backsite and the foresight and the I think they use a site level though, and they use like those rods. And ultimately, though, you're not really comparing you're not creating a horizontal that extends this whole way and comparing anything. You're taking elevation readings, the entire segment of this whole thing, right? So every segment you're getting an elevation reading, and yeah, you can go ahead and read them all off later and say, okay, this is how the elevation is changing over this distance, but it's based on each of those local, the foresight and backside things.
They need those elevations to maintain their horizontal plane of reference in which they work off of. That's right.
But I don't think it's not gonna maintain a horizontal plane of reference.
Yeah, well, go talk to some surveyors, and I don't need to argue about it. Go call some surveyors in your local area. Get off Discord. And go
Well, I mean,
talk.
I'm not like trying to apply for a job or something like that. No, I mean, I was doing some research to see like what a technique would be. Yeah, the foresight backside thing. They don't necessarily, like I said, that doesn't create a horizontal throughout the whole place, though.
Yeah, it actually does. Yeah. They extend the horizontal every time. The plane of reference.
Yeah, but that's so whenever the what's his name, the person with the sight level, I guess the turning point or whatever, whenever he gets to a new position, it's not necessarily at the same elevation as it was prior. So
Yes, you're 100% right, Kosho. But the assumption is that new plane of reference is parallel / horizontal with the old one. It maintains the plane of reference. It could be at a lower elevation. That's correct, or higher. You're right. But if it's higher or lower, it's parallel with the old plane of reference. All the way along, they're all parallel. You still there?
no, I'm still there. I'm looking at what I was looking at my notes, and I'm thinking about because I'm thinking about when they move But one guy's looking that way, then he turns, it looks the other way. So definitely for that one reading, that's horizontal from there to there. As the guy moves though, and he makes his new position, I don't think that there's any reason to suggest that he's horizontal. That he's at the same horizontal, right? I mean, that would imply that they're. Hold on, let me see. Let me draw it out real quick. Yeah, I'm gonna go ahead and maintain that. Yeah, that's not. It's not gonna keep the same horizontal. I don't think it really needs to.
If elevation of the tool has been unchanged, it will most definitely keep this exact same horizontal.
Yeah, but why would the elevation standard change?
Why not? You never heard of a flat surface before in your life, or what?
Well, I mean, the ones that I was like I was like trying to see how you would do elevation change. The surveying place they were doing was specifically a place that does have elevation change. So,
so you don't think there's places that don't have elevation change? So, is that?
I mean, sure. Of course there is. And if there's no elevation change, then of course it would keep the same horizontal. But
perfect, I agree.
Yeah,
I 100% agree.
Yeah, but if you're keeping if you're measuring elevation and there is elevation, then you won't have a horizontal.
Well, it depends. There could be elevation change, and you could still maintain. What if it's 6 inches elevation change or a foot? You don't think you could adjust your auto level that difference to maintain the same horizontal plane of reference?
I just don't think that it's likely that would happen. I think that it's not necessary or
really?
likely. Yeah. Like you'll aim your sight level back at the rod that you were on the other side of it before, and you'd look at it from the new side where you put it. But there's no reason to suggest that you're there's no reason to suggest that it's let me think real quick. Yeah. There's no reason for it to be parallel, or at the same horizontal as the last one. Because all you're doing is comparing.
They are the same.
I don't think
Go
so.
ahead. Listen, call up a surveyor, ask them this specific question. Can you take 2 posts in a field? Post A, it's the starting point, and you'll mark the datum on post A what you want it to be.
Yeah.
And transfer that line from post A 1 mile down the road with an auto level so that it creates a horizontal plane of reference.
Wait, you're saying that with that one, so just you saying 1 mile? Yeah,
sure.
Yeah. You're not talking about doing foresight and backsight. You're talking about just doing it just like with one.
No, they'll use the technique foresight backsight to do that.
But foresight and backsight doesn't keep the same horizontal though.
Okay, so how are they going to transfer that horizontal to create a horizontal plane of reference for you? How are they going to do that if it doesn't?
I'm not sure that they are doing that. From what I saw, they didn't.
Well, I just told you. Call up a surveyor. Like, go online, pick whoever you want, just any company. Like, assuming it's a fairly reputable company. Ask them if you can use a auto level. They might call it optical level in North America. I know the word auto level gets used a lot on here, but the guys I talk to call it an optical level. level, most of them. So, ask them if you can transfer that plane of reference 1 mile with an auto level or an optical level. And they might say, well, why would you want to use an auto level or an optical level? And oh, why? What would you use? And they'll most likely say GPS. When you ask them why GPS, they'll tell you because it's faster, cheaper. And then say, well, I'm actually interested in kind of learning. I'll be there and learn some shit. And they'll be like, yeah, sure, we could do it. See a lot more. And then you say, well, money's not an option. Go find your own answers, Kosho. That's why
No, I have.
on here.
I have. I'm posting a picture right now. Hold on.
Look,
Hold on.
I don't need a picture, dude.
Well, no,
Sorry,
I have
I
a
don't
question
need a
for you
picture.
based on something that I was reading, but I just want to make sure because when you say, like when I say that it's not going to keep the same horizontal, I mean that they're not going to be parallel with each other, right?
Yeah, I know the way your mind thinks because you have the model
I said those
mind.
words.
I'm telling you right now, these people don't think that way.
Well, that's what I'm asking you. I'm posting a picture that's from this thing I was reading, the foresight and backsight and all that stuff. But are you saying that they would all be in the same horizontal? Because this thing that is showing that it doesn't have a horizontal.
If they're not in the same horizontal, they'll be on a parallel horizontal at a different elevation.
Okay, that's fine.
Or a different level or height or however you want to understand it in your mind, the language.
No, I mean that this is how I understood it. This is what I'm saying, that I don't think that it's not one horizontal to where you can talk about one end and the other, but you can at each section you can take the elevation and look at the whole thing, each separate section.
The elevation could be the same all along the way. Possible. More than possible. Matter of fact, if you believe what's that called, the Hadron Collider or whatever, it's 2 miles long, it's all one elevation.
Yeah,
there you go.
They use GPS for that though.
Yeah, I already said, of course they would. They honestly, Kosho, it would be stupid to use anything else besides GPS because it also works, but you just can't confirm the method. That's why you go to this idea of using an auto level or an optical level, because you can confirm the method and understand it. GPS, just some numbers come out of the sky.
I think they use it for the accuracy though, because the accuracy is needed in those cases.
No, they use it for the cost and the efficiency.
I mean, it's not that they don't state that at all. They say specifically that those applications require the GPS because it's the only way to get that accurate.
Well, I don't know why the surveyors I talk to would tell me different. Then maybe you should talk to some surveyors. See, maybe we could have a conversation. Go talk to 10 surveyors and see. Maybe you'll get different answers. I don't know.
Yeah, that would just be confusing to me. I mean, I'm fine just, understanding it the way that I understand it now.
Yeah, you don't want the truth. That's why. You just want those cartoons that you believe in. He's telling you.
I'm fine with the way that it's understood.
Okay. I
and
wasn't
explain that it's for precision and accuracy.
Kosho, it's all right. We hear your voice all day, every day, Kosho.
That's fine. That's fine. So when I start speaking, then
I wasn't done speaking, Kosho.
Yeah, you did. You stopped speaking. I was replying to you.
I'll go on mute when I'm done. That's how you smart guys can know I'm done.
Yeah, that's how I'll know.
So I've also talked to surveyors, and they've told me the same thing that he's saying his surveyors have told him. They can create this horizontal plane. They do create this horizontal plane, and they can use optical tools to do it, and it's very accurate. They don't use GPS for the accuracy. Vertical change in elevation is not the most accurate way to do it using GPS. The most accurate way is to use the auto level, which we call a transit. Basically, an auto level can be a laser, so we don't really use auto level like that. but the transits are very accurate when
And all
using
the
these methods.
Oh, sorry, man. I was just gonna say all the guys I talk to call it an optical level. So yeah, it does go by different names.
Right, it depends on the area you're in, the people you talk to. But Kosho just summed it up for himself, going, "I'm not going to do that because I'm comfortable in my belief." Right? You're telling him a way to question or to find out further, gain knowledge on the subject, and he could care less. That's why it's chimed in.
Yeah, they just want to talk to Larry the Cable Guy or try to find some picture online, and they know this is what we believe, man. It's got to be right. Don't fucking call the people that do it. Whatever you do, don't call them Kosho. Do not talk to people off Discord. That's dangerous shit.
He's silent now, ain't he?
He did come in a little hot and heavy, but I enjoyed it.
Well, I wasn't done. I mean,
I
he was
know.
cutting you off the whole time, and I wanted to say I opened my mic for the first time. I always go on mute when I'm done, and this smart guy that knows everything about every subject can't figure that out. Yeah, it makes me angry.
No, I know. I'm just bugging.
Y'all have a good day.
No, don't go.